They get fired.
Oh, you forgot about cops. They can pretty royally fuck up sometimes. Like the guy who killed that guy in Albuquerque. Oh no, it wasn't Albuquerque. It was New Mexico. So the guy in the hallway laying down, completely surrendering to the cop, and the cop, kills him with a rifle. The cop, I think he got fired or quit his job, right? And then because he had PTSD from killing the guy, right? He gets hired back and then gets full benefits of retiring. So what's the incentive for a cop to do a good job if every time he fucks up royally, he gets a paid vacation or early retirement with full benefits?
Or they can go to another department.
Yeah, and become a gypsy cop.
Yep, exactly.
I don't have any problem with good cops. Don't get me wrong. I'm not anti-cop. I don't want to chase criminals with guns at 3 o'clock in the morning, right? That's not me. I don't want to do that. But the good cop's worst enemy is not auditors. It's not people who stand on their rights. A good cop's worst enemy is a bad cop. But a cop can't do anything about that bad cop because if he tells on his brother, right? Because the cops are in that blue line brotherhood. Most of them are in the blue lodge in masonry. If they tell on their brother, it's not like you snitched on somebody like cops do, right? You ratted out your brother, they're going to get blackballed and nobody's going to want to work with them. So the only people that can affect change in the police force is people who are actually making lawsuits and complaints. So the cops literally are incapable of governing themselves. They have to be governed from without.
Yeah, and those two or those three positions have so much weight over your life. A doctor, a lawyer, and a cop. It's crazy.
Well, they got a lot to lose, The cops in big cities like Los Angeles, like they make like $200,000 a year. I mean, I guess it's expensive to live there or whatever, but it's like that's a hell of a lot of money. But basically, everything that's going on in the courthouses all across America, they take a trillion dollars a day from people. So if they get a lawsuit for a couple of million because they beat up a guy who was not resisting, or they kill somebody who was illegally camping and unarmed and complying, which I can show you source after source after source, like it's not a big deal to them. Like, and they often say we investigated ourselves and found no wrongdoing. Motherfucker, we didn't ask if he did anything wrong. We wanted to know if it was illegal.
Yeah, I just said.
So I'm an old fashioned guy, right? My thing is like you don't shoot unarmed men, right? If somebody slaps you, you don't pull a knife, right? If somebody, is beating the tar out of you with their fist and is about to knock you out, then you can pull out a knife, right? So the way that these cops they have the exponential force doctrine, I get it. You can't take the fangs and the claws away from the sheepdogs, but when the sheepdogs are acting like wolves, it's like, wait a minute, aren't you supposed to be a sheepdog and protect us from the wolves? Hmm. Well, the Supreme Court says they have no duty to protect you. So the answer is you're supposed to protect yourself, right? But I'm not inciting violence. I don't think you should ever fight a cop on the streets. I think if you ever get pulled over, put your hands up, and one of those hands better have a cell phone with it recording. That's just my opinion. Like if they arrest you, okay, under threat of arrest, yeah, I'll get on the ground. I'll kiss the ground, no problem. So honestly, for a few years now, I've been wanting to do First Amendment audits, stuff like recording on a sidewalk, recording in a public building, right? Things that are completely lawful to do. But I can't get somebody to record my backside so I don't get accused of resisting arrest, because if I get convicted of resisting arrest, they'll take away my gun rights. Like they actually
Yeah,
take
I
away
like
my
those.
guns.
I do like those First Amendment auditors on TikTok and shit.
I
You know,
don't
some
like
of
the
them are.
belligerent ones. Go ahead, bro.
Yeah, some of them are good. Some of them.
Yeah, some of them are
That
walking
one guy,
around with
Long Island.
fucking with a 9mm, and not to mention he's carrying an AK or an AR-15 around with him
Is
on
that
the
illegal?
street.
Is that illegal?
Yeah, well, it's not illegal, but you walk around the streets with an AR strapped to your back, you're going to get attention, man.
That's right.
Yeah.
That one
You
guy,
can
Long
expect
Island.
the conversation. Go ahead, bro.
That one guy, Long Island auditor, is really good. He's always trying to de-escalate shit. He's cool with the cops and shit. But yeah,
So
there's a few ones that are good. I don't like the ones that try to get them all riled up and are mad aggressive and shit.
yeah, I don't like that
I
either.
agree.
So,
I
so
agree.
my thing is though, is that we need the bad auditors too, right? Because the cops are going to deal with belligerent people in their everyday life. So they need to be stress tested, just like anything else. So the people like James Freeman who are like talking mad shit, he has the right to talk shit, right? So I don't condone his actions, but I think it's necessary and proper in a free society to weed out the bad apples because the cops can't do it themselves. So yeah, I would model my interactions a lot like Long Island audits or accountability for all. I would act like that, kind of like how I act in here. Like I try not to cuss. I try not to get, verbally abusive. I would just, peacefully and friendly, how do you say that? Friendly, exercise my rights in public. And I would just want to educate people of the actual law because I know that there's a Karen and Darren out there somewhere who like basically wants to fight people for having a camera. But if you look around, there's cameras everywhere. I'm looking at 1, 2, 3 cameras right now, not to mention the 5 cameras in my pockets. In my pocket, how many? I think it's 5 cameras. Anyway, 1, 2, 3, 4. Is that a camera? I'm not sure. It looks like 5 cameras.
You only got 5 cameras in the back of your phone, you peasant.
Look, I use my phone quite a bit, so I have a pretty decent phone, and I'm trying to build my credit. And this is just another way to make consistent payments. And besides, I don't have time to carry a telescope everywhere I go, but I can take pretty decent pictures of the moon, with my cell phone. And, I think that's pretty cool. Yeah, I think I need to do the manual mode when I take a picture of the moon. Because people are complaining my moon is out of focus. But, I can't see that good. So I get a real good close up of the moon. And I've spent most of my life like delivering pizza at night. Well, I say most of my life, half of my life. So I enjoy being outside and looking up at the stars and the so-called planets and all that stuff. And I really enjoy stargazing, but I don't have much free time on hand. So every once in a while, I'll just like stop for a second and post up on the roof of my car and get a real good shot, get some real good images. As far as I'm concerned, pretty good for me. I don't think NASA would be impressed as much as the guy. Yeah, so back to the cancer thing. What they did to Dr. Brzezinski, in my opinion, should be a criminal offense because they weren't just doing it to the good doctor, right? They were doing it to the people that he was trying to save. So, in my opinion, people should be held accountable for stuff like that because if your actions directly interfere with someone's right to life, that's a violation of the Constitution. And I consider it to be treason, right, against your countrymen if you're stopping them from seeking medical assistance that they need. And there's actually something out there because the Texas Board of Health, their complaint wasn't that it wasn't effective. Their complaint wasn't that it wasn't safe. So what was the fucking problem? They didn't want to have that in the courtroom. That they say when it was brought up, the testimonies were not held as evidence because they weren't claiming that it wasn't safe and effective. That wasn't their fucking problem. So to me, that's disgusting. I can't think of anything more disgusting than what they did to that doctor's patients. And I think people really should be held liable for that. They should be held financially accountable. And Dr. Brzezinski, man, you talking about a man. That's one stoic son of a bitch for everybody to just talk so much mad shit about the guy. He could have just took the money and disappeared, right? But he fought it like for 40 years, basically. He fought the bullshit for 40 years. And I think when, history is written, right, I think he'll be considered a hero, but probably not in his lifetime. But that guy's a fucking hero in my book. And I really like what the other doctors had to say about him. Like the other doctors were being like straight up honest. Some of them anyway. Like they were basically saying like this is like a gold mine, right? But they weren't talking about financial. I think like the Japanese doctor, he said if you find something that fights cancer, like you discovered like a gold mine. But if you find a bunch of different things together that fight cancer, like he did, because it's not just one thing. He was basically saying it's like a gold mine, but I don't think he was talking about like finances, right? I think he was talking about like knowledge, because treasure doesn't have to be gold and jewels, right? In my opinion, that's not the definition of treasure. Like treasure is knowledge. That's the real golden nugget. I think I'm talking to myself now. So I guess Harry Johnson said $5,000 for a hyperbaric chamber. This place is full of fun facts. I guess he's never looked at the used market for hyperbaric chambers.
Yeah, he attacked me for what I said, like I said something stupid. I didn't say anything out of line, just some rudimentary information on cancer.
Yeah, that dude's a dick. Anyway, yeah, so several years ago, when I was actually looking into buying these things, um, and just letting people use it for free, I didn't realize that it could be harmful with people with like heart conditions, and et cetera, et cetera, et cetera. So I was like, that's an awful lot of liability. So I would have to do some sort of private member association and get them to sign one of those contracts, put all liability on them. And then I thought, who would actually do that? Because I'm just a pizza guy. Like, who's going to do the research and realize that a hyperbaric chamber is used in football games because someone can get injured in the first quarter and come back in the second half after spending a little time in the hyperbaric chamber? It's like, yeah, if it's good for, you know, cell damage for football players, why wouldn't it be good for other people with cell damage, like diabetes, neuropathy, sores and wounds on the feet?
Yeah, they use hyperbaric chambers for diabetes with peripheral vascular problems.
As far as I'm concerned, it's a wonder treatment in my layman perspective.
Just hyperperfuses the tissues, gets oxygen where maybe you're having trouble getting oxygen to.
Right, and we know that, the number one cause of death is uh, basically congestion or bad circulation. So it would make a lot of sense to me that, you would want good circulation. And if you can't get good circulation, the next best thing would be to oxygenate the area, because that's what circulation is all about. And the more oxygen rich your body is, the more based and less acidic it is. And apparently, cancer has trouble growing in acidic environments.
That seems similar to a treatment called
Hi there.
orthobiotomy.
What you want? You want this? There you go. There you go. I think he's a little offsided. It's gonna go. It's gonna go sideways. There you go. There you are. Thank you very much. Have a good one. Thank you. Sorry about that. I didn't realize the hot mic. What'd you say, North Star?
Yeah, have you ever heard of orthobiotomy? It's it's a bit different. You know how people get treatment for back pain or joints, they get traction. But this is kind of the opposite of that. Orthobiotomy it was used in martial arts years ago. And so what you do is you find the joint that you're having the problem with or whatever, and you get it in the easiest relaxed position, and you press the joint together, and you hold, and then you release that, and they get more mobility of that joint. And I think the same principle you're speaking of the oxygen and the blood flow, that comes into play.
I'm about to look into that. I think my son has gout in his toe. He's always wanting me to pop it. And I'm going to look into that. I can't write it down right now. Probably couldn't spell it. Orthobiotomy?
Orthobiotomy.
Biotomy. Okay. So just press the joint into itself like a gentle Gentle push.
Well, if the joint, if they're feeling some kind of lack of range of motion, right, in the joint, what you would do is get it in the least painful angle, you know, the least painful position, and then you press that together just about as hard as you can, even if you're a 200-pound man or more. I mean, just kind of, but be stable with it and just push it together and hold it, you know, and you can hold it for 30 seconds or longer if you desire, but then relax it and see what the range of motion you have. And yeah, it's been used in martial arts many years ago, and yeah, it's pretty good.
Is this like for an injury or for like arthritis or something like that?
Well, if you have any lack of range of motion,
Is that? Where's your mom? She up there?
Barrel
Yeah, who is
rider,
it?
not my king.
Arrow Rider.
Yeah.
Okay.
yeah, from what I remember, is you know, any old injury you've had, and even if you got scar tissue buildup, any of these things, if you have a lack of range of motion specifically, you will increase the range of motion after just 2 or 3 treatments. I mean, just 2 or 3 times, and anyone can do it, really.
So you're saying find the most comfortable position and apply pressure? Like what kind of pressure? Lateral? I mean, what? Can you be more
Like,
specific?
okay, let's say it's the knee that's giving you trouble, right? So you're going to stabilize the femur, the upper leg, and you're going to grab the tibia and fibia, or the shin bone, what people call the lower leg, and you're going to push the joint together. And the least, and they're holding the joint in the least painful position where there's no pain at all. Because we know some people find comfort in putting a joint in a certain position. Once they put it in that position, then you press that joint together upon itself, and you hold that. I mean, you can hold it. You might want to look into orthobiotomy. Maybe 30 seconds to a minute is how I used to do it. And after that, relax it. You know, don't let them start just jerking it around, but see the range of motion you get after you do that, the before and after of the range of motion. And it always increased for me.
Nice. Thanks for that. First time I heard that.
So ortho meaning bone, bio meaning life, autonomy the study of. Maybe. Did I get that right?
Yeah, that sounds right, man.
Yeah, I just haven't seen the word written down yet, so I'll pull over in a minute. Try again.
Ask if anyone want to play chess.
I'm working, bud. Sorry. I like chess. It's definitely
Guys,
a good game.
guys getting ready to watch Flat Earth Sunday Roast?
Who's getting roasted? I don't know what that is.
Jem's Flat Earth Sunday Roast show.
Oh, is Jem doing it this week?
Yeah. Started here at 5 Eastern.
Well, I guess that's fair. You guys get one day a week. I've been roasting the globe all week. The standard model of cosmology. How dare you? Hank, you just don't understand. This is just one guy's opinion. Well, many papers have been written about it, but it's only one guy. Trust me. So I've, kind of stumbled into other rooms that there's not a flat Earth globe Earth debate. And, I kind of played it cool and didn't really give away my position. And I would just go in there and talk to people, kind of little rapport, right? And as I'm talking to people, I might discover, like, this guy's a third-year physicist student, so he's about to become a physicist. And I would talk to him about these things, and they're the exact opposite of Glover's. Like, we didn't disagree once. There was no controversy the whole time I was going over the cosmological constant crisis from the physicist student. But the other people in the room, they wanted me to cite my source, which is reasonable. So I did. I did cite my sources. And then they were kind of reading it and quiet. And then they came back and, they were like, well, I don't know if this is true. Like, I don't know if this is a good source. And it's like, well, you got to do your research. I can't just expect you to believe me. That's why I cited the source, and you can check out what these experts are saying. But the whole time I'm talking, the astronomy student, the pre-grad, he was like on board 100%. I just don't get why the anti-flat earthers are so vehemently opposed to this. And, I don't think they're physicist students.
Why would anybody disagree with you that there's a discrepancy between the values? That doesn't seem like a likely scenario that played out.
Well, I wasn't exactly exonerated at Jim Pandas from all the accusations I received.
Okay, I don't know what that's in context to, but I'm responding to what you just said about bringing up the cosmological constant crisis and saying that people didn't believe you that was the thing. We didn't believe you that there was a crisis.
I'm always told by ballers that I don't understand the words. Right? I'm misconstruing it. I'm strawmanning it. I'm just a dumb pizza guy. And that, that number with 120 zeros, it's actually 60 orders of magnitude. Like, that makes it better.
Okay, so that's actually not the same problem then.
The cosmological constant?
Yeah, you said there was a problem because the crisis with the cosmological constant is the two different measurements. It's nothing to do with the 120 orders of magnitude.
Oh, so here we go again. I guess I'll post the Harvard link, and then this is the part where you tell me I don't understand my words.
Well, I understand perfectly clearly that you're talking about two different things. I know that one of them is the problem with the cosmological constant, and that's the one that is in regards to the two measured values, right? But that's not the same thing as the other issue with the 120 orders of magnitude. That's something different.
Really?
That's what the
vacuum catastrophe, an elementary exposition of the cosmological constant problem. Quantum field theory predicts a very large energy density for the vacuum, and this density should have large gravitational effects. However, these effects are not observed. The discrepancy between theory and observation is an incredible 120 orders of magnitude. What were you saying?
The thing you just named, say it again. The vacuum catastrophe?
Vacuum catastrophe.
That's not the same thing.
Sorry, hold on. You just asked me a question.
Problem.
you just asked me a question. Vacuum catastrophe, an elementary exposition of the cosmological constant problem. It's right there in the title, bro.
Yeah, the cosmological constant problem is something different. That's the issue between the two measured values.
Right, between the prediction and reality.
No,
between quantum field theory and gravity,
There's two measured
Go ahead.
values. That's it. There's no prediction. There's two measured values for it, and the two
Well,
different
go
methods
correct
of measuring.
Harvard then. Go correct Harvard, because obviously they're
I'm
wrong and you're
trying
right.
to inform you that this is probably what people disagree with you on, because the cosmological constant problem, that issue is just regarding two measured values, two values that were measured that are slightly different but very close to one another. And the one you're talking about is a very big difference because it's a very different problem. It's the issue with it's actually not a real issue, but it's the like you said, the vacuum catastrophe.
So you're saying the vacuum catastrophe has nothing to do with the cosmological constant problem?
No, I'm telling you that the cosmological constant problem is something different. That's something different. It's what I just said it was. It's the two measured values for the cosmological constant.
The thing with the thing with the catastrophe in its name, though, you said that's not a problem.
No, it's not. It's not a problem with cosmology. It's a problem with somebody's prediction. So it's not based on like predictions that the model itself is predicting. It's predictions that somebody making assumptions is predicting.
So when Michio Kaku said, see, in cosmology, we have a crisis, was he talking about this?
He was being quoted in that movie, The Principle, and he was talking about this specific test that I'm telling you about. There's a test where
when they use the word crisis,
somebody's making predictions
real quick,
based on their assumptions.
Real quick, when they use the word crisis, that's also not a problem.
No, the cosmological the crisis in cosmology, which is the one with the cosmological constant, that's just the two measured values for the cosmological constant.
Yeah, and that's not a problem. Even
That's
though
a problem because it's not there's not an agreed value for what that is because of the two measurements.
So it is a problem.
That is a problem. That's right. That's not what Hank's talking about, though. What Larry's talking about. He's talking about the vacuum catastrophe.
So there are problems with your model, though, with this cosmological.
The vacuum catastrophe is not a problem with the model. Again, this is what I'm saying. It's not. There's no part of the theory that you could identify and say that prediction is made by the theory and it's wrong for whatever reason. That vacuum catastrophe thing is a specific team's assumptions that they're making, and they're correlating what should. So they're talking about the vacuum energy, and they're giving a value to it, and they're basing that value off of things found in quantum mechanics. And these are just assumptions that team's making. It's not an actual prediction made by the model.
See, I never had this conversation with a physics student, right? So I don't mean to be personal, but have you taken any physics classes? Have you took physics class?
Yeah. What did the physics student tell you? Because
he was in
I
agreement.
just told you there's two different crises that you've mentioned, and you're now saying you're talking about the vacuum catastrophe, which is not the same one as the cosmological constant problem.
So you're telling me that Harvard titled this vacuum catastrophe article an expose of the cosmological constant problem? Like those two things don't have anything to do with each other, but they're right there in the title of the document that I just posted.
Yeah, I've just identified for you what the actual cosmological constant crisis is. It's the problem of the measured values. So I don't know how much more I can say that, but that's what that problem is. Well, if they put in this vacuum catastrophe another problem, they put something in there about the cosmological constant, is because it has to do with the cosmological constant. The cosmological constant is involved there. It's because the problem is the vacuum density or the vacuum energy density. The prediction that they're using quantum mechanics to predict, like the energy in the vacuum, they're equating that to the cosmological constant. So there's a discrepancy between those two ideas, and that assumption is not based on the model. It's based on what whoever wrote this paper is using to make that prediction.
So you're claiming that
it's the problem and the excuse and the constant not right numbers, right?
So you're saying that it's not about the model, right? So after I read the 120 orders of magnitude, it goes on to say there's generally no accepted explanation for this discrepancy, although numerous papers have been written about it. It usually stated that the problem requires knowledge of quantum field theory and general relativity, topics not normally studied by undergraduates. We have tried to make the problem accessible to undergraduates by using only the simplest ideas of quantum theory, such as the uncertainty principle and the theory of harmonic oscillation, and classical gravitation theory, which would be Newtonian. We believe that such simplifications is not only amused pedagogical exercise, but clarifies how basic the conflict between quantum theory and gravitational theory. We do not here discuss various proposed solutions to the problem beyond the trivial, unsatisfactory one of assuming an ad hoc canceling term of the Hamiltonian or field equations. So basically what I understand is the subject of this is the quantum field theory and gravitational effects, or what Einstein was talking about, and how that's the subject of the first sentence. Then it goes on to say, however, these effects, what effects? Which effects? Gravitational effects. However, these effects are not observed, and the discrepancy between theory, what is a theory? Something you postulate, and observational science, right, is an incredible 120 orders of magnitude. So what part about that did I not understand?
Probably the whole thing, but we'll just go with the first sentence to
Right.
keep it
So
simple
what's
for
the
everybody.
subject? What's the subject
Larry,
of the
I
first
waited for you to
sentence?
finish reading that.
Go
You're
ahead,
reading
bro.
the whole thing for some reason. I'm going to go ahead and explain to you the very first sentence and how exactly what I just said is stated there. It says quantum field theory predicts a very large energy density for the vacuum, right? Which is something that quantum field theory predicts for the energy density for the vacuum. And then it says, and this density should have large gravitational effects. This is a assumption made by the person who's writing this about how gravity should have an effect in the with that energy density. What they are then doing is, out that assumption, making a comparison between what the energy density is and what the cosmological constant is, which is the acceleration, expansion of the universe. And they're equating these two things because they're, for some reason, assuming that one thing is the other. But that's an assumption that's not in either model, but only of
Where
this
did they
person.
assume that?
That's all. Why else will they be equating it? Why are they making?
They're not equating
Why are
it.
they making these two things equal to each other when there's no
They're
reason?
not equal. Where does it say they're equating it?
They're comparing the strength of the cosmological constant to the energy density. Why else would they be doing that?
So it's not equivocation, they're comparing.
Yeah, well, okay. Well, if they're not equivocating it, then there's no issue, right? Because the fact that their orders of magnitude different than each other makes no difference because they're not the same thing. So that's my point. Is that that's an assumption they're making. If they're not saying that they're the same thing, then there's no issue.
So you guys just spent all day talking about how in science we have observational science based on predictions. And then when I show you where these predictions are not observed and it's still okay?
I don't know if you didn't hear what I just said, but there's no reason. Those are not conditions in either theory or either model. Those are just them. This person who's writing this paper comparing the two models and for some reason assuming that one thing is the other. So if they're not the same thing, then there's no issue. That's
Where are they saying that quantum field theory is the same as gravity?
Nope. That's not what I'm saying. I'm saying that the energy density for the vacuum is the same thing as the cosmological constant. They are trying they're trying to say that they should be the same thing, and since their orders of magnitude different, then or 120 orders of magnitude different, there's some issue. But that's not an component of either theory. That's just an assumption that this person and probably other people are making for how these two things relate to each other.
So if it's an assumption, then there's no problem.
That's right.
Some guys assuming it. So there is no cosmological constant problem.
No,
it's just an assumption.
That's something different. That's what I'm saying. That's an actual problem, and that's something different. That's the issue.
Does anybody else see where my thinking is flawed? Can anybody help me understand better? Does anybody see where I'm making a mistake besides Coach O? Does anybody see Coach O's misunderstanding where he's not understanding?
I mean, I'm hearing a lot of things called crisis and catastrophe and problems, but I mean, there is no problem.
With this
No
thing,
problem.
there's no real problem. The only problem is with the assumption that's made by the person who's making it. With this thing.
Right. So,
But
so the assumption.
the cosmological constant problem, which is a real problem, which is two different methods for measuring the cosmological constant, are coming up with two different values, and it's outside the margin of error. So they're obviously two different values, and they're not sure which one is the correct one. But they're
So
not
this is an
very,
actual
they're not very
problem.
different. They're
10 to the 120th, right?
no,
And
they're
it's
an
not.
actual.
outside of the
They're not
margin of
off by
error.
120. No, the two
No,
This
measured
is
10 to
an
the
values.
actual.
120th.
The two measured values are within one or two. If one is like 71 kilometers per megaparsec, and the other one's like 68 kilometers per megaparsec. So they're fairly close, but they're just different.
All right.
You're
So this
double
cosmological. So this cosmological constant thing is an actual problem with your model.
Yeah, well, no, it's a problem with the measurement for the cosmological constant, but that's something different than what he's bringing up, though. Is what I'm saying.
Okay, but is this cosmological constant thing a problem with your model?
No, it's a problem with the measurements. The problem is
You're measuring two different things that don't match in your model.
No, they're measuring the same thing in two different ways. They're not getting the same value. One of those ways is wrong. That's what's happening.
So it's just a problem with the ruler.
It's a problem with the method for measuring it, yeah. And they don't know
You have
which
two
one-
different rulers. One of the rulers is wrong.
So there's no problem here. There's just a problem with the ruler, and they call it the cosmological constant problem.
Yeah, they call it. I don't remember the exact.
Why wouldn't they call it a measurement problem or a problem with the tool they used or whatever? Like, why would they say there's this problem if there's not?
They're not naming it and thinking of flat earthers.
So here's the two subjects of the first sentence: quantum field theory and large gravitational effects. Are those the subjects of the first sentence?
The thing that I read and explained.
Yeah, no. That's not what I'm saying. The Harvard link that I posted. The first sentence, we're looking for subject and predicate. Let's go back to the second grade.
I went over the whole first sentence. That's all I went over.
So the subject of the first sentence is quantum field theory and gravitational effects. However, these effects are not observed, and the discrepancy between theory and observation is an incredible 120 orders of magnitude. Now, I don't know if you're talking about 67 parsecs or 72 parsecs, but
You're
this
not paying
says...
attention, dude. You're clearly not paying attention.
How am I not paying attention, bro? You're saying there's no problem.
I discussed the paper.
There's a problem with the measurement?
I discussed the
How
paper.
do you know it's a problem with the measurement, not a problem with the theory, bro?
Dude,
How
pay
did you
attention.
determine that?
Just pay close attention, dude. I went over that first sentence. I went over how this thing is this person's assumption. I then talked about the actual cosmological constant problem, which is not in this paper at all. That's the problem in the measurement. That has to do with the 68 kilometers per megaparsec versus the other value, which is very close to that. That's not the same thing as this. That's the real problem with the cosmological constant. This is just this person's assumption or this team's assumption or whatever. It may be a fair assumption, but it's not one that is in either model. So it's not a problem with the model or the theory. It's just this person trying to put these two theories together and equate those two products of it, like the vacuum energy density or whatever with the cosmological constant, where there might not even be a reason to do that.
Yeah, because if you have two theories that are not lining up with each other, you just assume that they both work anyway, and it's our measuring of these things that's the problem, right?
What are the two theories?
The quantum field theory and Einstein's theory, gravity. It's in the first sentence. That's why I kept hammering on the subject. I mean, I don't see how this could be read any other way. Like, I'm speaking English here. Quantum field theory. Okay, so this theory predicts a very large energy density for the vacuum. And this density should have large gravitational effects. So the prediction is, if quantum field theory is true, there should be a very large energy density for the vacuum, and this density should have large gravitational effects. So what are we looking for? Large gravitational effects. However, these effects are not observed. So where's the gravity that they should be looking for that they're predicting? So the discrepancy isn't, outside of the margin of error by a little bit. Right? It's an incredible 120 orders of magnitude. So that's a number that is so large, you probably can't fit it on one piece of paper unless you write really small. Is there anything with English that I was incorrect about in my statements?
That's a number with 121 characters. So it's not very large. You can fit it easily on a piece of sheet of paper. And
oh, really? Where's the decimal at? Is it all the way to the right?
There's no decimals. There's
no decimals. So it's 120 characters. So they could be ones and nines and fives, right? But I could just round up and say 120 zeros, right? Or 121, right?
Yeah, 1
10 to the 120th?
Let's go with that.
You can write it on
it's a big number.
It's a big number. We'll go with that.
Right. So the discrepancy, it's not just outside the margin of error, right? It's a big fucking catastrophe, if my English is correct.
I don't know how else to say this, dude. The only problem here is that the assumption being made is that in one theory, you have quantum field theory, you have the vacuum energy density, and in the other theory, you have the mass energy tensors that are used to describe the warping of space-time. And so what they're doing is they're equating the what's it called, the cosmological constant, which exists supposedly everywhere, and the vacuum energy density, and comparing these two values. And for some reason, the fact that they're off by this value, 120 order of magnitude of 120, that means that there's a huge problem. And so what that tells you is that they're equating these two things. They're saying they should be equal for whatever reason, but it's their assumption. It's not anything that comes from the actual theories or the models themselves. These are just somebody trying to put the models together in probably an incorrect way.
Right. So basically, this is describing the period before 1998 when they come up with the dark energy, right? And they noticed that the universe was expanding faster than it should, or faster than predicted, right? Because after they added all this dark matter, the expansion should have slowed down because of the gravitational effects. However, the universe increased in its expansion, according to your interpretation of the red and blue, or also known as the Doppler effect, the lights in the sky. So this is a catastrophe because after you add 26% of the universe of dark matter, and the universe is now expanding even faster. So this is the problem where it says these effects, what effects? Gravitational effects, are not observed. Where's the gravity from all this dark matter? That's been my question for the past 70 years. So, 7 years.
The gravity for the dark matter, that's all that's seen. The only thing observed about dark matter is the gravity that it creates. So that's actually that's the only observation that's there.
So
This is not relating to dark matter, though. This is about dark energy, which is the cosmological constant, and the vacuum energy density, which is from quantum mechanics.
So you're saying that this cosmological constant problem doesn't have anything to do with dark matter? Is that what you're saying?
I'm not calling this the cosmological constant problem.
Right, some guy from Harvard
I'm saying that the issue is between these two things, not from the gravity that dark matter should cause. Because
then why are they looking for gravitational effects?
They're not. Okay, that's what I'm. This is getting confusing because what you're saying about dark matter and looking for gravitational effects, the gravitational effects of dark matter is the reason why they know dark matter is a thing, and the amount of it. That's all that they see is the gravitational effects.
Okay, what they see is that the galaxy should be flying apart, but it's actually not. So they're assuming, because we know gravity works, that there must be some sort of matter in the galaxy that we can't perceive. Let's call it dark matter, because we know gravity works. And this is a really far stretch here, but what if gravity actually doesn't work at the galactic level and dark matter doesn't exist? Is that a possibility?
Well, if it doesn't exist, you still have to come up with an explanation on why the everything's
Well,
moving.
You haven't
the way it
explained to
shouldn't be
me where
moving.
my presents, where did my Christmas presents come from if Santa Claus doesn't exist? You haven't explained it to me. Who brings the children of the world presents if Santa Claus doesn't exist? I want to know.
Okay, I don't know what that means, but whatever.
Right. What it means is that I refuted the argument, right? And you want me to automatically replace it and come up with a new theory because gravity has to work. I'm sorry, that's not how that works. If your theory is found to be wanting, you trash the theory and get a new theory, right? But
Right.
you Einsteinian people, you say, well, if the evidence doesn't match your theory, right, then you get new evidence. That's not how science works, bro. That's religion. If I found out that Jesus really didn't exist, I wouldn't be like, hey guys, I found out Jesus never existed. I need a new Messiah. Can you produce one? That's not your job. If you debunk Jesus, then I need to get a whole new theory, right?
So
I don't expect you to debunk Jesus and then replace my Messiah. Come on, bro.
So you're saying you have debunked this, and you're asking the scientists to come up with something else. Is that what you're saying?
No, bro. I'm saying that this has never been proven. It's a hypothesis at best. It's not even a scientific theory.
So should we come up with something else, or just ignore it altogether? The observations, that is.
Look, here's the thing. When I talk to the
Maybe you
physicist
should
student,
interpret it a little differently.
Okay,
Who, me?
how do we interpret it instead? If we need to interpret
Maybe-
different, how do we interpret it instead?
Maybe you shouldn't assert yourself upon all existence to be sustained by particle interaction rather than that of field dynamics.
What does that have to do with what he said?
I don't know what that means. So we interpret it as they're moving too fast for the amount of material that we see. How should we interpret that instead? Gravity
Maybe you
doesn't
should.
work. Let's interpret it different. Now what?
I'll explain what he said. Maybe the theory of gravity is bunk, and the quantum field theory is actually correct. How about that?
Okay, how does that explain how we see these things moving too fast?
The field. The field.
Yeah, but the
There's a background medium.
dark matter observation has nothing to do with quantum mechanics. So it's not about picking one over the other in that case. And in the case of the dark matter observation in the first place, the reason why it's a mystery and why it's not known what it is because there's not a firm conclusion. So when they say that there's some matter out there, there's some exotic matter, that's only one possible conclusion. The other possible conclusion could be that there's flaws in the gravitational theories. So there's neither one of those things are ruled out.
Do you think dark matter fits within the understanding of how we define matter, Kosho?
What? Do I think that matter is? What are you asking, dude?
Do you think dark matter fits within the colloquial confines of how we determine matter to be? What is matter, right? And does dark matter fit within that description?
The answer is we don't know, because as
no
he
one knows
just
what it
said,
is.
we don't know if it's actual matter, like protons, neutrons, and whatever, or if it's a modification of the theory of gravity. So the answer to your question is we don't know.
So if you don't know, why do you teach it to children as if it's fact in science class, and the children know that science means knowledge?
What the fuck? Dude, no one is teaching kids that dark matter is a fact. It's an observation.
I was talking about gravity. I was talking about gravity. Are you saying they don't teach kids about gravity?
Dude, I mean, you talk about this stuff so much, I feel like it doesn't have to be explained to you, dude. But dark matter is not some other name for gravity. Dark matter
Have you heard
is
the dark
simply
gravity
an observation, and the cause of the observation is not yet known. That's all it is.
Have you heard of the dark gravity theory?
Yes.
Okay, let's not get
it's
on
a competing theory for dark matter, right?
Well, dark matter is not a theory, but yeah, it's a hypothesis.
Okay.
It's one of the hypotheses for
right.
solving it. That's right.
Right. So if dark gravity is a competing theory for dark matter, it's obviously pointing out that there's a problem at the galactic level when it comes to what we see and what gravity predicts. You guys are all about prediction in science and observational science, right?
Dark matter is not a theory. Okay. So
Okay, it's called a hypothesis,
there's many
untestable hypothesis. Okay?
hypotheses trying to explain what dark matter is, and none of them are, none of them are theories, and so they're all going to be tested and all that kind of stuff. But they're not. I don't understand what the problem is. We were admitting that there's plenty hypothesis for what dark matter is.
What's the difference between dark matter and matter?
Matter is understood and known, and you could describe it and all the different aspects of it. Dark matter is something that no one knows what the hell it is.
It's kind of a
Dark
placeholder.
matter is just a placeholder name.
So then how do
placeholder
you
for what?
how do you
Placeholder for what?
you make a claim that 90%, 70 to 90% of all the universe is comprised of dark matter? How do you think they came to
26.
that?
26%.
Because that claim is a claim about the matter energy or the mass energy. So if you were doing like a Einstein field equation, the matter energy that would be causing the dark matter is accounted for in that value, just like the rest of the number, which accounts for the other part of the 96%.
So you're
is
saying
the energy caused by the dark energy, and these are just values that represent what that energy magnitude is.
are you saying energy and matter are fairly synonymous?
I'm saying they're used as one and the same in that variable that I just used, mass energy. So like in Einstein field equations, they're used as one and the same, mass energy tensors.
So are energy and matter synonymous?
I just answered that question, man. If you didn't like the answer, then I could use different words. But then that equation, just like gases and liquids are not synonymous, but if you use the word fluid, it's understood that you mean both gases and liquids. In this case, when someone says mass energy, they're not saying those things are the same thing. They're saying that this thing that I'm saying includes both these two things.
Energy creates matter and matter has energy. I don't understand what the problem is.
That's fine.
So, okay, so when we're saying that 70 to 90% of the entire universe is comprised of this dark matter, and we understand that matter and energy are fairly synonymous, then what you're saying is 90% of the entire universe is comprised of potential matter in a state of an energetic background. That's literally what's being said.
It's not.
Okay, so it's 70% is dark energy, and 26% is dark matter, and less than 5% is, the periodic table of elements. So 26% is dark matter, right? And it was the first theory that they came up with, right? Because Hubble discovered that galaxies were spinning. Thank you. Hubble discovered that the galaxies were spinning, right? And this galactic thing later became a problem that they were spinning 10 times too fast. So they came up with a theory. I think it was a Catholic monk or a particle physicist, however you want to look at it, coming. And basically what they proposed was that, there's probably some dark matter at the galactic level that's, responsible for the gravitation required to keep these galaxies together because they're spinning 10 times too fast. So then they noticed that, wait a minute, that should mean that the expansion of the universe should slow down if there's all this extra matter. And what happened, it actually sped up, right? So dark matter and dark energy were kind of competing theories. And they said, well, let's just add more dark energy so that we can make the math work. And when they did that, the math still doesn't work. So when I say that the theory of everything, string theory or M theory, like the math doesn't work, that's what I'm talking about.
Yeah, but these are not theories. I don't know how I'm more to stress that. Neither of those two things
I'm
are
not
theories.
calling them a
Both
theory.
of those two
They
things
call
are
them a theory,
observations.
bro.
Hold on, Hank, Larry. Both those two things are observations. One of them is an observation without an explanation, so they call it dark matter. The other one is an observation that there is obviously an acceleration, and accelerations acquire a force, and so they give that the name dark energy because they don't know what's causing that acceleration, but it has to be something because it's obviously happening. These are just two observations. They're not theories. They're simply observations.
Yeah, I know that. I know that they're not theories. I've already addressed that, right? But when everybody says the theory of dark matter, I understand that the nomenclature is when I'm talking about this thing, if I want people to understand what I'm talking about, if I say the hypothesis of dark matter, they're not going to know what I'm talking about because when they research hypothesis and dark matter, they're not going to pull up what I'm talking about. But if they type in theory of dark matter, it's going to pull up exactly what I'm talking about. I've already addressed
Yeah, but they're not
this.
theories or
And I do
hypotheses.
not.
They're neither
I
of those
know.
things.
I agree with you. There's no contention. It's not a theory. It's not a scientific theory. It's an untestable hypothesis.
It's not even that. It's an observation. And so these observations can't be competing with each other because they're just observations. They're not two different ideas of what's happening. They're two different unknown things.
Okay, I know that they're
You're
unknown.
making sense of it.
Yeah, I don't know why you keep insisting on using the term theory of dark matter. When you just say dark matter, everybody knows what you're talking about. Just say dark matter. It's that easy.
Okay, if it offends you guys that much, I won't say theory, even though it's known as the theory of dark matter.
It's not.
Okay, so if I find one paper that says the theory of dark matter, are you going to recant?
No, I'm going to tell you that this person is probably just as confused as you're trying to make everybody in here. But that's the reason that no one's upset with you.
I'm not trying to confuse people,
using the
bro.
term
You're
dark
acting
matter
like a
theory.
lawyer and you're trying to
We're not-
debunk one word.
We're not upset with you using that term. What's upsetting is that you're using it and you're using it to make this confusing argument. When you don't use the term, the argument doesn't become confused anymore. There's not two competing theories because there's no theories. There's no hypothesis.
So I can't say theory of dark matter because it confuses you and you're projecting
If
that
you
onto the
put
whole
up
room.
your theory and hypothesis, what are the two competing things? Well, how are they competing with each other?
Dude, a hypothesis is a postulation for a test that could be done in the scientific method, right? So it's not even a hypothesis because you can't test dark matter. So stop using the word hypothesis.
I'm the one saying it's not a hypothesis. I'm telling you that.
No, you're saying it's not a theory, it's a hypothesis.
I'm telling you, I said it's not either, is what I said to you. I said it's not a theory, it's not a hypothesis. That's
so
what I'm
what's
saying
it doing in science class?
It's an observation.
What's it doing on science form?
12 times.
Okay, so you observed dark matter. It's too dark to see it, but you saw it, right? You observed it. You observed something that you can't observe.
We observed
You observed something you can't observe, right?
We observed the effects. We observed something that we can't explain.
So then I guess we should call it the dark matter effects, right? Because you didn't observe dark matter.
We see the galaxy spinning too fast or whatever. We don't know exactly why. There's not enough material as a placeholder until we can figure it out at some point in the future. We will call it dark matter.
Fair assumption.
A rose is a rose by another name.
So what's the difference between dark energy and dark matter?
Dark energy is a not hypothesis, not theory, to describe the redshift. What they observe is that it's expanding and the expansion is increasing. Now, you would expect after a Big Bang that it would lose energy over time and space, but the opposite is happening. So in order to describe this phenomenon, they come up with this thing that they call dark energy. Dark matter, whatever that is when they're trying to describe the gravitational effects that would be required in order for the galaxy to behave the way that it does. And I say required because these gravitational effects at the galactic level, there's not enough gravitation to create that much gravitational effects. There's not enough gravitation because there's not enough matter, right? Or mass, you might say. So in order to come up with a solution for this discrepancy of gravity not working at the galactic level, they said, well, maybe there's this dark matter that we can't see, but we can see the effects of. It's a placeholder.
That was a lot of words to say that dark matter is attractive and dark energy is repulsive.
That's one way to sum it up.
I mean, that was a lot of words. Yes.
Well, I try to go into specificity for people who are asking
I mean,
questions.
it wasn't necessary.
Yeah, because the rotation rate, and so the idea the dark energy is, and this is a fair assumption. There's no way, saying that this is a conclusion, but it's a fair assumption that since they're spinning so fast that the centrifugal force should fling them so that they're farther apart or spread out more. There's some gravity there causing them to stay intact, and that gravity is caused by something that is not doesn't behave in the electromagnetic field, so it doesn't create light. Light doesn't affect it, that kind of thing. And so that's that's the assumption, but that could very much just be, there could be some other solution to that has nothing to do with that. But that's just
what you said, Larry. I was dealing with the kids when you were giving the difference between energy and dark matter. Sorry, dude.
Yeah, dark matter is repulsive. Dark matter is attractive, and dark energy is repulsive.
Okay. I mean, that would be like saying that there's two different types of magnetism.
I mean, okay.
You have repulsive and attractive.
Yeah, but they're
not really true.
The north and south pole are, one in the magnet. They're not separate. So
yeah, but these things don't. Otherwise, they don't behave the same way. So those are just two attributes. They're two effects. That's a simple way of explaining it. But they're two different unknown problems. The problems with unknown solutions. One
right.
is
I would say there's
extra attraction in the galaxy.
I would say they're two different effects of one and the same thing.
No, they're not. There's no reason to assume they're the same thing at all. That's what I'm saying.
I just told you why.
Yeah, no, but that's what I'm saying. When an extremist said that, he was saying that's a simple. It's like it's easy enough to say that, but the truth is, one is the attractive. One has an attractive property because it's showing that there's gravity in a place where there doesn't seem to be enough mass to create that gravity. They call it dark matter. Dark energy is the accelerated expansion of the universe, which no one knows exactly where that energy is coming from or why it's happening.
It's no different than the centrifugal and centripetal convergence within a magnetic field. You got things that are coming together and things that are moving away, but it's all due to one thing being the magnetic field.
Okay, I got to say this. So Kosho keeps saying the assumption is that dark matter exists. The actual assumption is that gravity actually exists, and it has to work. So we know, or assuming that dark matter has to be there because we know gravity exists. The base assumption, right? The foundational assumption is that gravity works at the galactic level, right? And because they're assuming that, right, they're claiming that, well, this is assumed, so we know gravity works, therefore dark matter has to be there because we see the galaxy behaving like this, even though we would predict that it would behave like kids on a merry-go-round and spinning 10 times too fast.
It said that, dude.
Well, so we see the galaxy.
You didn't say that the assumption is that gravity exists. You said the assumption is that dark matter exists.
Yes, and that's based on gravity being correct. That's one solution. I said another solution would be that the gravity, the theories of gravity are wrong, or they're incomplete. That's another solution. There's several solutions.
We see the material in the galaxy. It's spinning too fast to keep it together. We can calculate the mass of the galaxy. Now, there's a couple of possibilities. Number one is there's some extra mass somewhere, which would be as dark matter could be some sort of particle, basically. Or the other possibility is gravity acts different. And the mass is what we see, but somehow it's attracted different on larger scales. Those are the two main possibilities. I think there's some other ones.
More fair ones, but right now the solution is just unknown. There's no clear conclusion to it, which is why it's still Mystery.
Dicelo brought this
A
up.
problem.
If
That's
there's
why
no
it's
clear
still a problem.
conclusion, how are you using it? If there's nothing but a problem with it, and it's always a problem, and there's no solution to anything, and it doesn't make any sense, how are you using it?
I'm
Every
not
time.
using it.
Yeah, you guys are. Cosmological constant, gravity, dark matter, all of it. It's all worthless.
The cosmological constant is used in Einstein field equations. It's used because it works. And dark matter is used in the cold, whatever, dark matter model. They
So a
use
thing
that for
you call
redshift
a
and stuff, and they
problem
use that because it works.
works for what? To be a problem?
Just in solving those equations.
So
It's literally incoherent versus coherent, and depending on which is going to have a different field modality, no different than a laser versus a light bulb. One's more powerful than the other, but they're both still light. I mean, you guys are just making a distinction without a difference.
So Dicelo brought up an interesting point earlier in that, and this is something I've wondered, is there a relationship between dark energy and dark matter? I mean, you have the relationship between regular energy and matter, E equals mc squared. So is there some sort of relationship between dark energy and dark matter? I've never heard the answer to that.
Well, I mean, in order to ever get to a grand unified theory, there would have to be, and that's why I say that you guys are doing the opposite of what you claim to be doing. Like, the ultimate crux is to get to this unified theory, but you guys are doing the opposite by dividing all these fields into all these unique things and never looking for the fundamental premise that everything's predicated upon. And the one thing that's inseparable from any phenomena said, which would be that of a magnetism. And that's the key component to everything that you guys want to just bastardize.
But the problem is that's not true.
Yeah.
Show me one phenomena.
Provable, not true, because
show me one phenomena without a magnetic component involved.
Didn't Jace go over that earlier with the weak?
He tried.
The electro weak.
The nuclear force.
When they're not isolated anymore.
Oh, I was going to specifically say that if electromagnetism is specifically the only force involved and everything else is some sort of manifestation of that, then how is it that if you've got a nucleus and you've got protons of positive charge, why don't they just repel themselves?
If all atoms are held together in their respective locations due to a magnetic component, then how could you assert that there's no magnetic component involved in a certain phenomena? I mean, you can't have matter without it. You can't have light without it. You can't have electricity without it. You can't have any phenomena without a magnetic component involved. This should automatically tell you that that's the fundamental premise of all phenomena, but yet you guys want to dance around.
I'm going to say what I said again. You have a proton, a nucleus. It's got some protons, positive charge repel. Why does the proton, the nucleus, not repel itself apart? If all of these, multiple protons, positive charge, are bound together, why doesn't it just push itself apart if magnetism is the only thing governing it?
Doesn't believe in nucleuses.
Well,
particles.
I never said that.
You
I don't
did tell
believe
me
in
that.
the electron.
I think that's Witsit that actually says that. I don't.
Yeah,
That's told me that.
No, I never denied the nucleus. I actually say that the nucleus of hydrogen is the fundamental particle of all matter and what everything's built upon.
Well, that's a little bit weird. But anyway, so back to what I said.
Okay.
You've got something that's got 8 protons, 8 positive charges repelling each other in this little confined space. Why don't they push themselves apart?
Because they're held together due to, in the respective location, due to a pressure mediation between that magnetic and dielectric component, and that's what gives it that three-dimensional S curve as a vector of containing itself.
So there's a stronger force keeping them together. what is the source of this stronger force if only magnetism is the source of everything?
Well, that was Ken put together a formula that I posted several times in the chat that talks about that. Essentially, it's just temporal polarance,
Temporal
which is
polarity?
essentially, yeah, temporal polarity, which is essentially that gives any atom its physical structure.
I mean, the word temporal includes some sort of, it implies some sort of time meaning. What is that? I don't know what that's weird.
Well, you'd have to look at the formula. I could see if I could post it again if you're interested.
I mean, why not? But
Okay, I'll post it in main chat here.
To me, I'm still a little lost on, you have only magnetism, which repels like charges. You have some protons with 10, 20, 30 protons, a nucleus with 10 or 20 or whatever, some number of protons plus charges. They're staying together. That would imply some sort of force greater than magnetism keeps them together. What is the source of that if magnetism is the only force that is there? Some force outside of magnetism, or maybe something that magnetism causes greater than itself, is keeping it together. And on top of that, there is a limit to this, because as it gets to 100 or maybe 80 or 90 protons, eventually whatever this force is that is there is now weaker than magnetism. And now all these little protons basically push themselves apart, and the nucleus falls apart essentially at that point.
I just posted a link about physics outside the standard model, physics beyond the standard model. And it gives a list of these problems, matter, antimatter, or the baryon asymmetry. There's quite a few problems in the standard model. The cosmological constant is just one of them. Another one that's not on this list would be the helium catastrophe in the Big Bang. Dr. Eric Lerner talks about this. And his book in 1991, I think it's called something like The Big Bang is Wrong or something. But yeah, Dr. Eric Lerner, he's an electric universe guy. It's one of those things to where we kind of need to just reformulate and go back to what we can prove instead of all these, postulations, because I don't want to say theories.
Related to what you posted, I actually just posted an article of not all, but a list of unsolved problems in physics in general.
Right.
Not necessarily related to astrophysics, but just,
We should be able to talk about these problems without using the words like, you don't understand, you're a pizza guy, right? Because if these are acknowledged, then what's the fuck problem?
Calls yourself a pizza guy, man.
The problem with
I can't go to Jim Panda's without somebody reminding me of my occupation. Even though every time someone says, you're a pizza guy, well, review the London cab driver study. How's your hippocampus?
My issue is, though, that just because there's these problems, unsolved problems, catastrophes, whatever, that doesn't mean that these theories are wrong. I mean, we shouldn't just start over. You can't, I have a hard time saying that, well, we don't know what dark matter is, so let's just scrap gravity.
That's where the orthodoxy lies. We can't just start over. That's the orthodoxy.
So you're saying we should or we should not start over?
I'm just saying we shouldn't be orthodoxical in science.
How do you find commonality between everything while subdividing everything simultaneously?
So generally speaking, if you have a theory or an idea or whatever it is, then progress is basically made by your idea explains everything we know now and also builds on and explains something else we don't know. Now, most of the time, that doesn't usually mean we start over. Most of the time, you build on previous ideas. Even the idea that Einstein, repurposed, or I shouldn't say that word, but whatever, supplanted Newton, the it's not like that. It builds on. I mean, it's a different description of it, but in the end, Newton was right, and his was just a more generalized, or I should say, Einstein is a more generalized description of what Newton did. So they kind of both describe the same thing, if not in the same method.
Except for one is 3 space and one is 4 space.
Well, that's kind of what I meant about. I mean, the idea, Newton's mechanics are simpler, but they basically give the same answer. Is the point I was making?
Right. Yeah, in most cases, Einstein's equations will simplify and give the same result as Newtonian mechanics. But
yeah,
but
except for Mercury.
No, that's exactly what I'm saying, dude. In extreme cases, it doesn't. So you have to find. That's why it's called special relativity, and then he came up with the general idea. But only in these extreme cases do you have to use these equations. But regardless,
our everyday existence.
Did you see the formula I posted extremis's for you? The P equals FC to the third power.
Our everyday experiences, Newton. I mean, that's why there's Newtonian mechanics, and that's still literally a physics class taught in most curriculums is Newtonian mechanics. Most of our experience fits within that. There are special cases where you have to use other things. Einstein.
Yeah, special cases, but also when extremists posted that thing list of unsolved problems in physics, problems there is used in the way it's used in math, like solving a problem solving. The same. It's the same thing that is being said in the thing that you posted, Larry. Like these problems in cosmology, they're not problems in the sense that they're rendering what we know about cosmology as incorrect. They're problems being that we don't have the answers to them. So that these two things they're very different in meaning, if depending on how you're using that term. But they're not problems that disrupt what we understand.
I have a problem where I can't find enough unicorn shit, but I know unicorns exist.
And flat earthers have a problem with unicorns, and I think that I said this yesterday that if flat Earth went away, I think we'd end up with a bunch of bronies.
Oh, there's already bronies, bro. Something called Equestria, something I heard about once that really threw me for a loop. It's like mixing My Little Pony brony baloney bullshit with what Fallout something. What's the weird fucking world we live in? Yeah, My Little Pony Equestria or some shit. It's a weird world we live in.
That's funny. Well, anyways, I just because maybe it's just a common thing you guys do, but Jeremy brought it up like 8 times yesterday. The other day, I heard 3 people bring it up, but you guys bring up unicorns so much, man.
Well, we don't actually believe in unicorns, just for the audience. We use it as an analogy because if unicorns exist, there should be, unicorn shit, and it's a real problem that we can't find the unicorn shit. So, it's just a mathematical problem. It's the lack of unicorn turds, but we know that they exist because unicorns.
Yeah, bending of space-time is essentially just saying you can, bend a unicorn fart.
Yeah,
it's
really.
just a magic problem. I mean, a math problem. Sorry.
Well, here it's like this, dude. I don't want to turn this into a whole different thing, but when you bring up like the thing that Witzig's been focusing on with Michelson-Morley and Lorentz contraction and all that kind of stuff, like that was something that was assumed. They assumed the ether. They came up with this problem from doing this test, and Einstein came up with a different idea, and they tested that idea, and it turns out that idea, whether it's true or not, explains the observations, and you can use it to make predictions about other observations. And that theory could be wrong, and it could be silly, but that doesn't change the fact that
real quick,
explaining things correctly.
What is an explanation supposed to be based upon?
That's what I was about to say. I could have good explanation why there's a dead body in my trunk, and I have the murder weapon in my pocket. as to why I didn't kill the person in my truck. Any good lawyer could come up with a good explanation. What we need is verification, right?
Yeah, but does your explanation for whatever it is, whatever story you can come up with, does the explanation allow you to make predictions that you can use in reality? Predictions that are based on only that theory or idea and not based on seeing it and then seeing it again, but based on the theory and then seeing if you would see that and then going out and actually seeing that. Like that tells you
And
that tells you that it's powerful.
You didn't answer the question. An explanation is supposed to be based in logic. And the second that you go against logic and you start describing things that are illogical to support your explanation, quote unquote, you don't have an explanation.
Which part is illogical about anything we've been talking about?
Are you kidding me?
I think you're using the word logic when you probably mean a different word. Because they're all logically sound. There's nothing outside of logic with those theories.
I would also say that quantum mechanics is actually kind of illogical. It just doesn't make sense.
Bro,
yeah,
when
you guys say logical, you're probably being intuitive or not comporting with like preconceived ideas of reality. But once you add these premises, like the premises of relativity, for example, special relativity, there's only two premises. One is that all reference frames have the same rules, and that light is the same speed in any reference frame. Those two premises lead to all the conclusions of special relativity.
Yeah, that's a problem.
That does logically follow.
That's a problem, though. That's that. What you're saying is that you would have to be outside of that reference frame to validate that, and you can't do that. So it's unfalsifiable.
You can do that. That's how they test it.
They went to the sun. They went to the sun and looked back at the Earth.
No, they measure these things in different reference. Like for example, that test with the plane was actually a powerful, inexpensive test in that they were able to test general and special relativity both in one go with these three different scenarios, planes going east and west, one on the ground, and measuring the clocks from all three. I forget the question, but right. So
the only thing that actually proves that time changes when they take plane rides.
Well, no, but that wasn't the question. The question is not does time change when we do plane rides. The question is these theories correct? And so the predictions are based on the theories. So the amount that time would change in the eastward plane and the westward plane and the stationary plane are all different based on general, special, and
presupposing
relativity. And those
rotational Earth.
Those predictions that were based on those theories were correct. Right. So it's not this they change. They change according to those theories.
They were off.
Yeah, but I can predict. Sorry, go ahead, bro.
No, you're fine. I just wanted to say that they weren't 100% correct, right?
I can predict something like this. Like if the government is not corrupt, then inflation is going to keep happening, and the price of eggs is going to keep going up, right? But does that make it true?
Well, it's not a very powerful prediction.
Right. We're getting back to explanation, which is what I asked you, Coach.
What's coming true?
What's the premise of an explanation? It's supposed to be rooted in rational, logical, cohesive explanation, not something that's just fucking fairy tale stories.
No,
and that's what you're feeding us.
I just explained to you how there's only two premises to special relativity, and all the things that follow from that come from just those two premises. That's perfectly logical. It's actually a what do you call it? Is it valid or sound? I guess it's both valid. Valid and sound logically. And the only thing that would have to you'd have to check is make sure that follows from those logical premises, and they do.
Yeah, but you're presupposing.
No, there's not. It's not. There's no presupposition.
Begging the question when you
saying that, what are we doing?
You're basing this off of a rotational Earth.
Okay, so we did that. We based it off a rotational Earth. We made the measurements. Now, hold on. Before you, if the Earth is not rotating, and we made the measurements or the predictions based on a rotating Earth, should those predictions match or not match the actual observations?
You would have to show that it is and validate that for starters.
Can I
which you haven't. Go ahead.
can I offer a possible, plausible other explanation?
I mean, sure.
Right. So you're assuming rotating Earth, right? And we see the effects that we see. What if we assumed that the Earth was stationary and that there was a moving quasi medium across the surface of the Earth that had different values with increase of elevation, plus it also went from a easterly to a westerly direction as far as rotation was concerned? Would this be another plausible explanation?
Be one you could test. Yeah, you could come up with an explanation, and then
Yeah.
you could test it doing a Michelson-Morley in an airplane, seeing if there's anything different than doing it on the
Well,
ground.
well, the
But,
Michelson-Morley on the ground works as is with these ideas, right? So the Michelson-Morley was initially, firing, light in different directions to try to see speed differential, but it was also to test the sun's rotation. The Earth's rotation, orbital rotation around the sun, right? So if we have an interferometer, we have light that is affected by the flow of ether across a stationary Earth. And then we set up something like the Michelson-Morley to detect if there is any other type of effective movement, and we don't find any. All that we have is the sidereal rotation. Wouldn't it stand to reason that it's plausible that we have this medium or quasi-medium substance that seems to affect light and things within electromagnetism, and possibly even things at the atomic level? If this medium is moving across the surface of the Earth, you would have different effects going with it or against it. And then you would also have different effects as you increase with elevation.
But that's the problem. Is Michelson himself said that the results of the Michelson Gale test, like, you can't have both things be true at the same time. Like, if there's no ether wind and the Earth's stationary, like they get results in the first test, then they shouldn't have gotten results in the second test either, because it's the ether stationary, the Earth is stationary. But if the ether is moving around the Earth and you get results in the second test because of that, then again they should have gotten results in the first test because of that. So the both things can't be true. Like, you can't use an explanation in one and not the other. So it's just I don't think that could be the case with both if you include both tests.
Can you explain
It's
the
like
difference
kind of like what
between
you
the
guys
two?
did.
Right, exactly. Can you explain the difference between the two and how that's relevant to what you just said?
Yeah, because according to what you said about the ether being on the Earth and moving, the first test was a simple interferometer, which should have shown that there are actually different distances it's traveling, or different speeds it's traveling at these distances, because they were the same distance, just perpendicular to each other. They should not have ended up at the finish line at the same time, because there would have been this ether affecting it in one of these directions. And the difference between that and the second test is the second test was much bigger, with a much different configuration for the interferometer, such that like, if it's just like Coriolis, it's like if there are two different latitudes, then the Earth spinning around is actually spinning at different speeds, which is causing it to go different lengths. It's kind of confusing to explain the configuration, but there's a shorter length. There's like three arms and two sides connecting them, and so the middle arm and the very long arm should not end up at the same time if it's moving, and they didn't. So. And so basically what I'm saying, the whole point is that if the ether is moving and creating the effect in the second test, and it's not rotating or spinning around or whatever, then
I think
it should have created an effect in the first test as well.
I think you're missing the point here, right? Because if this test can indicate that the Earth is moving, then it would assume that the medium would be stationary, right?
Yeah, that's right.
Okay. So if we find that the converse is true, meaning that the Earth is stationary, then it would stand to reason the effects that we're seeing within this experiment would show that the medium, quasi-medium, whatever you want to call it, is the thing that is moving, right? Because the same results can give you two different options, especially when it comes to a test like this, right? There's two possibilities.
But there was no, in the case of the Michelson-Morley test, neither of these were observed though. So it wouldn't, so the conclusion there, it wouldn't have
What do you
made
mean
sense.
neither of these were observed? The
Like the Earth,
Michelson-Morley was not to deal with the sidereal rotation, you know.
No, that's,
right?
yeah, the Michelson-Gale, that one was, but I'm talking about the Michelson-Morley. It wasn't
Correct.
observed that the ether, we were moving through the ether, and it wasn't observed that the ether was moving through a stationary Earth, because there was
No,
no at all.
there was a result within the test. It was just way smaller than what would be needed if the Earth was actually orbiting the sun.
Yeah, right.
Because that was the motion that was trying to be detected. So if there was no detecting of the motion of the Earth around the sun, but we use a similar type device to detect sidereal rotation, what was done within the Michelson-Morley that eliminated the Earth's alleged sidereal rotation and only isolated the orbit around the sun. And like I said before, if we get a null result of the Earth going around the sun, that can simply state that the motion of the ether is strictly the sidereal motion that we see, and there is no other oscillation or movement or vector or anything like that of
That's
the
what I
ether.
say. They want to have their cake and eat it too by wiping away the ether and adding the rotation of the Earth all in one fell swoop, which you don't get to do that.
Yeah,
The rotation of the Earth and the orbit of the Earth around the sun were givens in the experiment. They weren't tested for, and they weren't in question.
And that's a problem.
Correct.
It's
That's
not a
what I
problem
just
at all.
explained.
It's not a problem at all. The Earth is orbiting the sun and is rotating. That has been verified by other means. So therefore, they were givens in the experiment. It was strictly an experiment looking for the ether.
Wait. You think that the Michelson-Morley was looking for the ether?
It was looking for the effective ether on light, yes.
Oh, man. Why is it always the case that, like,
because
no
you
matter
don't
how many times
understand
we
the
have this
experiment, and I
discussion,
doubt
it's
you've ever
always
read
the
it.
case.
Because you don't
Well, I
understand
have.
the experiment, and I doubt you never ever read it. You know about as much about that experiment as you guys do about the Antarctic Treaty.
Cool story, bro.
Verifiable story, bro.
So you've read the Michelson-Morley, and your conclusion is that it was trying to detect the ether.
I think that's definitive. Like, that's absolutely the case. I don't.
Then
think
how can other people read it, like myself and Witsit and Dyslow, and come to a completely different conclusion?
Do you think the Earth is flat?
That's non sequitur.
No, it is. It most definitely is
It's non
relevant.
sequitur.
If
You're
you
just
believe
trying
that
to
the Earth
divert.
is flat, I really don't think you can understand something as complex as Michelson-Morley or basic Newtonian motion.
Stultification
just to let
tactics
you
are used to just.
Hold on, Larry. I just want to let Bob know that we, in this channel, we don't insult people, whether directly or indirectly. So if you want to,
It's not an insult. It's not an insult.
maybe
It's a
want to
statement of fact.
rephrase.
It's not an insult. It's a statement of fact. I don't think that you have the background to read something like the Michelson-Morley experiment. You struggle with basic motion, basic Newtonian motion.
Oh, I do?
Well, yeah.
He was right about the part where he said he don't think.
Yeah, if you assert yourself upon thoughts, man, then you can think anything you want. Doesn't make it true, though.
Yeah, I'm not going to
Do
engage
rockets
with
work
this
in
guy.
space? Do rockets
You
work in
guys
space?
can handle him. I'm not going to engage with this guy. He's
There's
incredulous.
nothing fruitful.
Hey,
Yeah,
Bob,
nothing
when you
fruitful that
put
comes from
clocks on
Bob.
airplanes, what does that prove? That the time changes on airplanes?
I don't
What
know.
does that prove?
Depends.
Yeah, what does that prove?
I don't know.
That
You
prove
tell me.
that prove that the
No
Earth is
question.
spinning? Did you manipulate the Earth spinning to see if it stopped the clock's time from changing?
So it's the
No,
old
you wouldn't do that.
trying to
You
do the
wouldn't do
seventh
that
grade
because
science
that's
test. I got you.
science, right? You don't like science. You're a science denier, aren't you, Bob? Does science prove things,
Oh,
Bob?
you're trying to reduce the scientific method and science
Does
to a
science
checklist. I got
prove
it.
things? Can you prove a hypothesis correct or incorrect, Bob? Can you
Oh,
do
that's
that with
right.
science?
We got some famous Bob quotes last time he was in here. I'm trying to remember exactly
Oh,
what it
I
was.
got some
No, you
Bob
cannot,
quotes on
Eric.
my channel. They're really good. So, Bob, can you prove things? Like if you had a hypothesis and you actually tested it by manipulating variables, can you prove that hypothesis true or false?
I'll play no. I think Bob's on
Bob, you
mute.
still there?
Come on, Bob. I'm just a pizza guy. Surely you can answer my petty questions. My
Hello, Bob,
If I
you
pathetic.
still
choose to,
there?
I can. Yes.
Okay, so can you prove a hypothesis true with an experiment?
Bob, you still there?
See, Bob's a science denier. He doesn't want you guys to know that, right? That's why he's like backpedaling right now because he was very assertive a minute ago when he
No,
was
I'm
using
still here, of course.
stultification. Sorry, could you not speak when I'm speaking, Bob? It's very rude. So Bob wanted to use stultification tactics off the top because he doesn't want to address the argument head on. So he's always going to be chop blocking you, right? You're a flat earther. What do you know? Well, you're a globe earther. What do you know? See how that works? It's real stupid, isn't it, Bob? It's
How
like
things
really
work in the
low
world and
level.
how to navigate. Those are things I know as a globe earther. How about you?
Yeah, do you use a globe to navigate or do you use a flat map like everybody
Absolutely.
else? Oh, you navigate with a globe? Well, that's the only ball
Absolutely.
you got, right? That's the only balls you possess.
Why are you so afraid to answer
Notice
his
how he
first
immediately
question, Bob?
goes to personal attacks
Well, I'm
and
just matching you,
can't deal
bro.
with
You
the
said
argument.
that you said flat earthers can't really match, you're into it, right? So I'm just matching your
Flat
energy, bro.
earthers can't comprehend basic sciences. That's why
You
they're
don't
flat earthers.
understand quantum mechanics, bro. And if you claim that you do, you don't, right?
Don't need to.
You don't use it. You don't use scientific experiments
I don't
dealing
do
with the
anything with
quantum realm.
quantum mechanics,
You don't do
and
anything with
either do
science
you.
either, do you? You don't do anything with science, do you? Well, I use computers, Bob. Isn't that using quantum mechanic technology? Come on, Bob. Try to keep up.
Do you even know how they work?
No, of course not. I just
Didn't
plug
think
it in
so.
and play it like everybody else, bro.
Yep.
Why would you try to get me to explain something that I don't know how it works? Is that
What did
another
I try to
tactic you
get you
use?
to explain?
Yeah, you
Basic
said you know
Newtonian
how they
motion?
work. Oh,
Basic
come on, Bob. I
Newtonian
don't
motion?
understand relative
Yeah.
motion, right?
What if we
I
Do
remove
don't,
the
rockets
magnet out of
work
your
in
computer,
space,
Bob?
Larry?
Would it still work?
Do rockets work
yeah,
in space?
well, I guess they do now. Now that since 2019, they've admitted that the moon is in Earth's atmosphere, like the flat earthers have been saying for 4 years. Try to keep up, Bob. Try to keep up. They finally admitted it that the moon is in Earth's atmosphere.
Yep, they did.
Come on, Bob.
There
Try
you
to
go.
keep up. You wouldn't even know about
Well
the
done.
Antarctic Treaty if it wasn't for flat earthers, Bob. Because
You all
what
right,
would
Bob?
you do in your field that had anything to do with the Antarctic Treaty? You never would have came across that information. And I know that you're a skeptic, right? Aren't you a skeptic, Bob? You're real skeptical of flat earthers, right, Bob? Are you skeptical of your own standard model, Bob? 95% of the universe is made of dark matter and dark energy, but you never thought to question that, did you, Bob? Because you don't think
Bob, you still there?
according to your own paradigm. According to your speech, you don't think, Bob.
Of course, I'm still here.
What's dark matter, Bob?
Is it a theory,
What's the
Bob?
difference? What's the
Is
difference
dark matter a
between dark
theory, Bob?
matter and dark energy, Bob? Do you know that?
Oh, come on. I'm not going to berate him. I'll let you go ahead, sir.
You could explain it using Newtonian physics if that helps you. I don't know. Go ahead, Bob.
And in circles we go.
Well,
Notice
when
how I
Bob
break the
starts the
circle by not
merry-go-round,
giving them the attention they want.
oh, I wanted attention for Bob. That's what my heart desires.
Yep.
Please, Bob, give me some more attention. I need more. I need more Bobby in my life, damn it, Bobby.
By the way, is Kosho out there?
I'm right here. About to go.
Redid your math from I redid your math from the other day. Given the variation of 50 feet and going and doing that over the period of 1 minute on the aircraft flight, it adds 1 mile to a 1,000 mile trip.
Yeah, that makes sense for 50 feet. I was only using the 4 mile range. Somebody at one point said 4 miles, a 4 mile column, 4 mile wide column.
That's the lane. Yeah, that's the lane, and that's not a problem. But I did recalculate it based on correct figures and realistic variations in flight path, and it comes out to about 1 mile per 1,000.
Yeah, I've said this to him before. I actually argued that with him a long time ago. I just I was giving him the most extreme example, which somebody would have to be doing in order for
Okay.
it to be
Okay.
correct.
All right, I know. So you're traveling. You said you measure these straight line distances every day, and then you gave me a corridor in which you bounce back and forth and not the straight line distance.
You made the assumption that it bounced 4 miles each way, and that
I
was
never made any assumptions, sir.
Well, that was what the math was based on, and I very clearly stated the flight path didn't vary by more than about a wingspan.
Okay, so you told me you were measuring these things that you've never actually measured because you've never.
What do you mean I've
traveled
never
on it.
measured them?
You've never
I
measured
measure
the
them all
straight
the
line.
time.
You've never traveled the straight line distance. How did you measure this thing that you've never done?
I just told you.
By
The
bouncing
variation
back,
is about
by
1
bouncing
mile
back
per
and forth in
1,000.
a corridor. Yeah, I heard you. That's what I
Yeah,
was just
so that's
explaining
all
that to the audience.
that's well within the margin of error, so I don't really need to go any further than that.
Yeah. So you bounce back and forth in a corridor. Maybe you're 1 mile off. Maybe you're 4. I wish those maths had. I mean,
1 mile per 1,000 miles of flight.
My mic. Oh, hold on a second. So I was just pointing out that you told me you measure these straight line distances every day,
All the
multiple
time.
times a day, and come to find out you've never actually traveled on one of these to measure it.
I travel on them all the time.
You've never traveled on one because you're traveling in a corridor, bouncing back and forth.
By 50 feet, yes, and it
Oh,
adds
that's
1
that's the
mile.
claim. Now
It adds 1 mile per 1,000, which is well within the margin of error of that measurement. So I don't have any further. I don't need to add anything further to that.
Sure, that's the claim, and now we're just bickering on how much that you're not traveling these straight lines by that you
No,
said you were
what you're
actually
trying to do is
that
you're
you
trying
said
to
you were
find.
actually measuring.
No,
I'm trying to
Jeremy,
point
what
out to
you're
the
trying to
audience
do
that
is
you
you're
said you
trying to
measured these
find.
things.
Jeremy, you can't just keep talking over me. What you're trying to do is you're trying to find any excuse to deny the fact that a great circle distance is considerably shorter than a triangle distance on a flat plane, and therefore verifies the fact the Earth is a sphere. And you're trying desperately to find some way not to believe that.
No, just pointing out to the audience that you made a claim that we measure these straight line distances every day, and you've never actually traveled one because what you're actually doing is traveling in a corridor and bouncing back and forth on it in between
By
the
50
corridor.
feet.
So
And
now
that
we're
does
just
not change it
yeah.
significantly.
Please don't interrupt me, Bob. I'll let you finish.
Show me where that changes.
Bob, I let you
significantly,
finish,
Jeremy.
right? You can't do it. You can't do it though.
Show me where
Is this
your
your
claim
tactic?
is significant, Jeremy.
Is this one of your tactics?
No, I'm just not letting you go on. Show me that your claim is significant and changes the result.
I don't even remember what I was going to say now. Forget it.
See, the
Probably
thing
the
with Bob,
smartest
he
move
only
you-
has tactics. That's all he has. He doesn't have any head-on actual arguments.
Do you want to
other
try
than,
me, Larry?
I think clocks on planes
Do you
prove
want
the
to
Earth
try
is
me,
spinning.
Larry?
Yeah, show me
What
how you
topic?
manipulated the spin of the Earth and prove that it's actually spinning. And don't talk about clocks on a plane, because all that proves is when you put clocks on a plane, the timekeeping rate deviates.
What topic? Specific topic you would like to
The
have
spin of the
go
Earth.
at me with?
The
Okay.
spin of the Earth, sir.
Okay. So, how would you test for the spin of the Earth?
Stop it from
Oh, Bob,
spinning,
tell him
and
to
then
wait.
when the
Change the
sun stops
latitude.
moving through the sky, then you know that the Earth was spinning.
Okay. So you think that the sun moving through the sky shows that the Earth is spinning? Could the sky be spinning?
That's a possibility.
How would you tell the difference between the two?
You can't. Don't
Sure
you
can.
understand general relativity? Or sorry, classic relativity?
Yeah, I absolutely do. There are three possibilities if the sun's moving through the sky. The sky's rotating, the Earth is rotating, or some combination of both. Design an experiment that would tell you the difference.
Right, so all you have to do is stop one from happening, and you've got proof. right?
Is that possible?
Nope. So
Then
it's
we're
a
not going to
null
go that way.
hypothesis.
You have to
Right.
give
So you
me
can't prove it. Exactly, Bob. You got it, bud.
absolutely you're wrong. So since you're trying to name something that cannot be done, we're going to disregard that. We're only going to do things that can be done. So
Wait a minute.
design me an
You're the one
experiment.
that's
Design the experiment to test which is the case it is that we can do. How can we measure the rotation of the Earth versus the rotation of the sky?
see what you just did there is a burden of proof reversal
Not a
fallacy
burden of
where
proof
I need
reversal at
hold on,
all.
let me speak, Bob.
Design
Sorry,
of an
Bob. Sorry,
experiment.
Bob. Now it's not your
Please don't
turn.
interrupt. Yeah, don't interrupt. Even if you don't like what he's saying, just let him finish because we're letting you finish. It's only fair.
Go right ahead, Larry.
Egypt,
Right.
you suck.
So what you said is
No,
that I
I'm
need to
just getting
formulate a
started.
hypothesis. Sorry, what you said was there is I need to formulate a valid, viable hypothesis to prove your claim. That's not how this works, Bob. If you have a claim and it can't be tested scientifically, then it's not a scientific theory, right? It's just a postulation. So you're postulating, right? You're saying, I believe the Earth is spinning. You need to stop it from spinning so we can see a cause and effect relationship so we can verify the Earth is spinning. So I need you to please validate your claim that the Earth is spinning. Give me something that I can actually work with, and don't use another tactic because I'll point it out.
Okay, Larry, so since you haven't been able to figure out what I'm actually doing, I'll explain it to you. The hypothesis is that one of three things is happening. The sky is turning, the Earth is turning, or there's some combination of both. We can predict findings on all three if we design a measurement that we can take of those three. So I asked you specifically, how would you and I measure as the Earth as to whether it's rotating or not doing something that we can actually do? That's not a burden of proof reversal. That's the design of an experiment. I've already made my claim. Now we're trying to figure out how to test it. So how would we test that, Larry?
So you
I
need to
don't know,
come up
bro.
with
It's
a
your
test for
claim.
his
You tell
claim.
me.
Yeah, no, you needed to come up with a test for his claim, Larry. Don't you know how this works?
No, you have to give me a way that you would be able to do that yourself using equipment you have access to, because I'm not going to sit down and say, okay, well, I did this. Well, I can't do that. Therefore, nah. You have to give me a test that you will accept that will tell the difference between those. So what is that?
I don't think it actually exists, right? That's why I said all you have is a postulation.
I don't care what you think. I'm asking you how we could test it to your satisfaction.
He just said he
can't-
doesn't think it's possible. I'm pretty sure he made that clear, right? And you know, the likes of Einstein and others have stated similar things. So
Well, no, they haven't. But okay, so you say that you don't think that it can exist. And I gave you three possibilities, and your answer was they can't exist. Well, obviously,
No, that's
something
not
is
the
turning. So therefore, it does exist. So you have to try again. So let's come up with a test that we can do to test for the rotation of the Earth, the sky, or both.
Well, first of all, I have to refute what you said. I never claimed that all three can exist. What I'm claiming is that this is not a viable hypothesis that we can test to demonstrate that the Earth is actually spinning because all motion is relative. Is that true, Bob? Is all motion relative?
So you do acknowledge that one of those three situations does exist. I'll wait
So I
for
guess
your
you're
answer.
pleading
No
the
problem.
fifth. I asked you a question, you answered it with a question. So I guess you're pleading the fifth.
No, I'm saying
Don't
that you therefore agree that one of those three situations does exist. The sky is moving, the Earth is moving, or some combination of both.
Do you remember my question, Bob?
We're not getting to your question until you answer mine.
Oh, you're pleading the fifth. Well, I asked you first, but I guess ladies first, right? I'll be a gentleman. Ask your question again, and I shall answer.
Why don't you just tell him about the weight change with latitude experiment you did? Remember how we had an effective weight change with latitude, and then you went and did an experiment and you just measured weight change with latitude and told me Earth was rotating? That was a science, and that was a science denier. Remember that, Bob?
You still there?
He's
I'm
digging in
patiently
his
waiting
bag
for his
for more
answer.
tactics. He's digging in his bag for more tactics. Ask your question, I shall answer it.
I already
You
have.
still suck.
Jeremy, since Larry can't seem to remember a question that I asked very clearly 2 or 3 times, would you be kind enough to give him the 3 possibilities?
He wants to know what is a test we could check for one of these 3 possibilities. He wants you to come up with a test.
Oh, he must have some form of amnesia, right? Because I already said that there is no viable test that we could do. Because what we would actually have to do is completely leave the solar system and get a third point of reference outside of the 2 bodies in motion to see which one is moving. And since we can't do that, that's not possible. We can't go to space, right?
Okay, since
And
Larry
there
and
is no
Jeremy
answer
both.
to your question. Sorry, sir. There is no answer to your question.
Okay, so since Larry and Jeremy both weren't paying attention to the actual question that I asked of Larry, I will be kind enough to ask it again. Larry, I'm asking you this directly. Do you agree that that of the 3 possibilities, the sky is moving, the Earth is moving, or some combination of both, that one of those has to be true in order for us to have the sun go across the sky?
I answered that already. Yes, one of those has to be true.
Obviously,
Okay,
duh.
very good, very good. You're advancing somewhat. So how would we
Write that down. I've
test?
already answered that.
So how would we test to be able to tell which of the 3 situations is correct?
You can't.
Okay, so you say that you can't test
No, I
for the
said you
rotation
can't.
of the Earth.
You can't test it, right? That's what I'm
Okay,
saying.
so
I'm claiming you can't test it, sir.
I have, but that's okay. So you don't really
How?
understand how to make the
How?
test. So if you don't understand how to make a test, there's really no point in going on because you won't understand the results of the test.
No.
Gee,
Because you
this
don't
is
understand the
ridiculous.
test
Like
to begin with.
literally it
I
got
can
back to the same point. Like there was 10 minutes of Bob wanting Larry to answer a question to just get back to the
I
exact
can
same
give you
point that Larry had already gone across.
the
Like
thing
what?
is I can give you Larry's experiment if you want for how we know Earth is rotating. You see an effect of weight change with latitude change, then you go measure that effect all at different places, different latitudes. You come back, find that that was your test, the measurement of the weight change with latitude change. That was the experiment. Now you now have science, and you know the Earth's rotating.
Actually, that's not the test at all.
Oh, what was the test?
The test, just to help you out, Jeremy, the test was if the Earth was rotating, centrifugal force would change the weight by X number of grams per thousand based on a change of latitude of X number of grams. I changed latitude by X number of grams and then measured the weight. So that was
So
the
the
test.
thing you did for your experiment was you measured weight change with latitude.
Absolutely, and compared it to the predicted
That was
weight.
so your experiment was you measured weight change with latitude. Yeah.
I
And
measured
how did you make the
rotation by
correlation?
measuring the effect of centrifugal force. And there are
And
multiple other ways that you can do the same thing. So
how did you make the correlation of weight changing at different latitudes a causation of the Earth spinning causing? How did you make that gap?
I don't use your little
Oh, so
checklist
it's
or your
correlative data.
definition.
Oh,
I
you
don't
don't like
use your
math. I
checklist or
forgot.
your definition. So take it as it is.
You have to have faith. Because you got to have faith.
I think what Larry is
Lord.
saying is he's
Well,
asking
that's just a
for the
basic
causal
misunderstanding
mechanism.
of how science works, is what
Well,
Larry's exhibiting.
no, Larry is basically asking you for the actual science, right? The cause and effect relationship. He's wanting you to prove the cause of the effect that you see, not assume that this is the case and then go measure and then say, okay, it must be the case based on my assumption. He would probably prefer if you figured out a way to maybe do some sort of manipulation to your independent variable to prove it to be the cause of the effect?
And I did.
That
So
would
how
be
do you
my
test
assumption.
a hypothesis?
How did you
How do you
you're
test any hypothesis?
right? So how do you with the centrifugal force of the Earth?
Okay, all right.
How
I
do you
asked you a
manipulate,
question,
Bob?
and then you
Dude, if
started
you don't
out.
allow
How
me to
do
get
you?
Can I
words
clear
out,
this up quickly? Can I clear this up quickly? Larry thinks the independent variable is Earth rotation. It's not. Independent variable is
centrifugal
latitude.
force.
It's not the
Yeah.
cause of that? Okay, I
Thank you
agree.
very much
No.
for clearing that up.
Thank you. It's not the cause. Because the independent
Thank you
variable
very much
is
It's
the
for
not
clearing
cause
the
that up for
in a
us.
independent
scientific
variable.
experiment.
It's
So
not
Sorry,
the
Ruhip
sir.
independent
Are
is
you?
variable.
claiming
Go
that
ahead.
it's not the cause. What about you, Bob? Do you think
It's
it's the
not the
cause?
independent variable.
Is the independent variable typically your cause within a scientific
No.
experiment?
No. The cause of centrifugal force is Earth rotation. We design an experiment in which the independent variable is latitude. That's Larry's misunderstanding. Anyway, back to you, Bob.
Thank
So
you.
changing the latitude is the cause of the weight change. I can agree with that.
No,
Well, no,
latitude
that's
is
a
the
Yes.
independent
misunderstanding of
Yes.
variable.
what's being done.
Yes.
Yep.
Yeah, you
Because there
change
could be
latitude.
something else taking place within your change of latitude that is causing the effect that you see.
What does the
Right?
change of
I could
latitude
say that
do?
it's a variation in the substance we call ether. As you increase or decrease your elevation, it affects weight. And then I go
Design your experiment for
measure
that.
weights. All I have to do is do the exact same thing that you did, and it would prove my hypothesis, would it not?
Nope.
That sounds subjective. Like, Bob, can you come up with an experiment that's not subjective and is actually scientifically objective?
Oh, of course I can.
Right. You do understand that correlation isn't causation, right, Bob?
Well, according to you, but I
What do you
don't
mean, according to me?
necessarily
You
agree
think
with
I
that.
made that up? Do you think I
Yeah,
made that up,
I
that
think you did.
correlation is not causation? Okay,
Yep.
it's never been written anywhere before. Just remember that, guys. Larry, the pizza
Well, I'm sure
guy,
you can cherry
invented
pick something.
correlation isn't causation. Just remember
Dude,
I'm
that.
I
sure
find
you
it
can
funny
cherry
that
pick something,
Bob is
Larry.
demonstrating how much of a science denier he is. Like, he is really avoiding doing actual science, really trying to prove the cause of an effect. He's going
Actual
out of his
science.
way to ensure he's a
People
science
who
denier.
understand real science know exactly what I'm doing, and they agree with me. So I really don't care what you think in your attempt to deny it. Now, what is the
You're a
cause?
science denier. What is
All
science to
right.
you,
So
Bob?
what
How
did
would you
my
define it?
experiment do? Give me the breakdown of my experiment. Tell me what my experiment demonstrated.
Your
And test it.
experiment, I don't know if you actually did this, but if you did and those were the results, that would show that there is a correlation between a change in latitude with the effect of weight, or
Okay.
what we
Why?
call weight.
Why?
Why
What's
is
it
what you would have
measuring?
to prove. You've
Why is
got
it?
some
What is it
results.
measuring?
Now
What
you
is it
need to
measuring?
prove how those results, right? The cause of that effect that you're seeing.
Okay, so you think that the change of latitude was the cause of the weight change. Is that what you're saying?
Nope.
Okay, what are you saying then? What do you think my experiment was designed to demonstrate?
I don't care what you think it was designed to demonstrate. What you
I'm not
did
asking what I
proved
think, I'm
that
asking
there
what
is
you
a
think. What did you get
correlation
out of the
between
experiment?
weight and latitude.
Egypt, you suck at this.
All right. If you guys are going to
That
talk,
wasn't too bad.
I got to eat it.
Okay, so you see, you don't understand the experiment. So how do you interpret the results?
Taking crazy pills, like you guys are repeating the same shit, and you guys are not understanding.
No, it's just the same repeating over and over. Oh, you don't understand.
Well, you don't.
Changed.
What did my experiment? What was my experiment
Send
designed
me
to
all of
test?
the information. I'll review it and I'll get back to you. You can DM me.
Bob,
Why?
you're making a correlation and then correlating that to a theoretical idea. That's all you're doing.
You think so, Gio?
You're
Yep.
forcing the
Okay.
hypothesis.
What did my experiment test?
Didn't test anything because you didn't isolate anything.
What did I change in the experiment?
Your latitude.
And what did that do?
Cause the weight to change. So we have a cause and effect relationship. So how does
Okay,
that
you
have anything
think
to do
that
with the spin of the
simply
earth? That's a
changing the
non sequitur.
latitude in absence of anything else changed the weight. That's what you think the experiment
Well,
demonstrated.
that's the result of your so-called experiment. When you change the latitude, allegedly, according to Bob, it changes the weight of the object. That's all it
Okay,
proves.
what
If it
does a
even proves
change in
that.
latitude change other than weight?
I don't know, the hypothetical spin rate of the Earth that isn't spinning at 1,038 miles an hour. It's one rotation per day. Double speaking, motherfuckers.
Okay, so would a spherical Earth have a that has a rotation rate of once per day? Would the linear speed of the rotation and the centrifugal force change if you changed latitude?
All this is hypothetical non sequitur. Can we get to the facts? Can we get to the meat
There you go.
of the argument?
Well, you haven't been
Please.
able to figure out the experiment yet, so how
You
can I
don't
explain
know
it to you?
what science is, bro. Can you please be scientific literate when you come in here?
All right. Well, Larry, I'll tell you what. If you would like me to tutor this, I can put the PayPal for the donations to the observatory dome in there, and for $50, I'll spend an hour with you and try and explain this to you.
Sure, I'll do it for $100 million, Bob. Do we have a deal?
Sounds like a good deal.
That's a good deal for me.
Absolutely. I'll
you,
go
Bob?
ahead and I'll
Oh,
put the
Bob,
PayPal in
do
for
we
you, and you
have
can
an
donate
accord?
to the observatory dome.
Do we have an accord, Bob? Am I going to pay you $50 for an hour worth of your time, and you give me $100 million, Bob?
No, the $50 is basically the tutoring fee to
Right.
tutor you in
And the
basic
$100 million
sciences.
is for me to put up with your nonsense babbling.
Well, then I guess we don't need to talk about it anymore.
Well, don't make offers if you can't back it up.
Well, I can. I'm more than happy to discuss it with you and teach you for an hour. I'm not going to guarantee you're going to get it, but you're still going to owe the $50, and you're going to do that in advance.
Right, I'll pay the $50, no problem, just so long as you give me the $100 million to put up with your nonsense.
No.
Do we have an accord, Bob?
No, we do not.
Wait, Bob's got to pay you?
Yeah, to put up
That
with
doesn't
his
seem fair.
nonsense. Well, I
Kojo,
guess that's why he disagreed. He thought it wasn't fair.
do you agree with Bob? Do you think this is a scientific experiment, Kojo?
Well, nobody's really laid it out.
Yeah, I'm with you. You clearly didn't commit that it is, because it obviously isn't, right?
It's also mean like Bob is asserting that his hypothesis has to be true regardless, just because it was proposed.
Oh,
Well, you see, Matrix, that's where you guys fall flat. You don't understand how you test hypotheses. The first thing that you do when you make a hypothesis is, yes, you assume it is true. And as a true hypothesis, you make a prediction with it. Then you test that prediction against reality. So of course you assume it's true. That's how you test it.
Yeah, but you have to isolate all the variables and manipulate the independent variable independently to establish a cause and effect relationship. Anything else is inductive reasoning and therefore not scientific, according to Karl Popper.
I did manipulate.
You manipulated the
independent
spin
variable.
of the Earth to demonstrate that the sun going across the
That's
sky.
not the independent
That's not the independent variable. Sorry.
Right, it's not the cause. I agree.
It doesn't have to. The independent variable
It's
does
not
not
the
have to be the
independent
cause.
variable.
Well, then it's correlative data at best, Bob.
Yet it still is far better than anything that you have, and it is a proper experiment.
So inductive. How about this? I saw that your blank wasn't a church, therefore your blank is a whore, right? That's inductive reasoning, right? Is that what you're using?
If that's what passes for inductive reasoning for you, go for it, man.
Yeah, that's inductive reasoning. If you think that's sound logic, then your blank is a whore.
You know, it's I don't know if you want to respond to that, but this happened a long time ago with Quantum Racer or Nathan or some one of those guys, where they made this claim about cause and effect relationship between the independent variable and the observation. But the actual statement, or the true statement, is that the relationship is between the independent variable and the dependent variable that you're choosing for the test, is that the independent variable has to influence or change the dependent variable. But it's not a statement on what's the actual cause of the phenomena. This is just
Then how do you have knowledge?
Okay, so here, let me go ahead and show you.
Sorry,
your
hold on,
problem
not you,
here,
Bob.
Larry.
I wasn't asking you. I was asking Kojo. How do you have knowledge if you don't manipulate the cause and see the effect, Kojo?
No, but you are manipulating a cause of or the independent variable to get a change in the dependent variable, but that doesn't always mean that's the cause of the actual phenomena. That's
I'll
just
give you a classic example of it,
Well,
Larry.
hold on,
I
hold on,
press
hold on,
down on
hold
the
on, Bob. I'm not
accelerator
talking to
of
you,
my
Bob.
car, and the car moves faster, which I measure on the speedometer. So, does pressing down on the accelerator of my car cause my odometer to read a higher reading, and is that the cause of me going faster?
Indirectly, yes.
Very good. Very good. So when I measure centrifugal force by varying my independent variable of latitude, you understand that indirectly that demonstrates the
But
Earth
you
is
didn't.
rotating. Very
So
good.
You didn't measure
the
it in
reason,
fuel force.
hold on. The reason it's a false equivalency fallacy is because we can measure your foot on the pedal, and we know how cars work,
Go back and
right? But
remove
you
the
have,
fallacy crap from it.
hold on. You have
No,
circular
you
reasoning
go
in the
back and
sense that
remove
you're
the
assuming the
fallacy
Earth is
before you
spinning,
talk any
and you're
further.
looking for confirmation bias because of your sunk cost bias, right?
You
I'm
got to
not
start
going to
out.
address anything where you mention the word fallacy or
Shoot.
even imply it.
Well, we'll just stick to your confirmation bias then. How about that, Bob? Can you make an argument without using 4 or 5 bias and fallacies in one argument, Bob? I've yet to see you do that the whole time I've spoke to you.
Yeah, instead of responding to the question of whether it was a fallacy, I guess he just chose to overtalk you and run a tactic instead of actually addressing it.
Actually, Gio, I'm not responding to his statements until he removes the word fallacy from them.
All right, then don't respond. But he's allowed to speak without being interrupted.
I wasn't. I was
So what I
literally
do,
on mute.
what I do when someone accuses me of a fallacy, I immediately address it and ask them to explain, and I weigh to myself and for the audience to decide whether or not this fallacy has adequately been proposed or whether or not it isn't, right? But Bob always does the bullfighter maneuver. Olay, I'm not going to address the fallacy that I just committed or may have not committed. I'm just going to olay the bull and then do more tactics and stab the bull in the ribs while he's running past. That's what you do. You're a bullfighter. But in this case, actually, I think you're the bull, right? And with all your bollocks. But that's just my opinion.
Why don't you go ahead and tell us what a fallacy is?
Well, that's basically when you say that you don't understand what you're talking about, therefore you're wrong.
No, a fallacy, I'll correct you. A fallacy is claiming that something is wrong because it contains a logical fallacy. You can have a correct result even in the presence of a logical fallacy, which is why logical fallacies are not used in science. Evidence is used in science. You still have to prove the claim wrong, not just by claiming it's a fallacy.
Burden of proof reversal fallacy. You can't ask me to back up your claim, Bob. That's inconsistent with reality.
That's not a claim to ask you to back up my claim. That is a claim that it's not even a claim. I'm stating for a fact that if you want to counter a conclusion, you have to present evidence to counter it, not just claim it's a fallacy. That's a fallacy.
I was wrong about the fallacy. You were correct, Bob.
I know. Most of the time, you guys don't even know how to use the fallacies that you try and
And
spout
most of the
out.
time, you guys never admit when you're wrong, Bob.
You just repeat things you heard on other YouTube videos. You don't even know what these fallacies mean most of the time.
I only watch audit videos, Bob. I don't watch flat earth videos. I haven't in years.
Then why are you trying the tactic of claiming something's a fallacy as if that proves anything? You have to present actual evidence. You don't understand this experiment. We've already demonstrated that. You don't know what the independent variable is. You don't understand the fact that you can indirectly measure an effect such as increasing the speed of your car by pressing down on the gas pedal. What happens if the engine is not on? Or if the gasoline tank is empty? If you press down on the gas pedal, is it going to change your speed? No. But you can use a independent variable of depressing the gas pedal with a dependent variable of measuring the speed of the car to test the engine. And the pressing down the gas pedal is not the cause of the change in speed.
I really appreciate your insight on automobiles, but what does this have to do with
Good.
the Earth thing, Bob?
$50.
500 million. We got a deal?
I don't pay to tutor people. I'm sorry.
But you do have to pay for someone to put up with your BS most of the time, right?
No, I don't.
So people put up with your BS for free? Man, they should really start charging you for that, Bob.
So, Bob, what makes your thing that you're proposing as an experiment not a correlation with an effect and actually isolates what you're saying that it actually isolates? How do you think it's done that?
Have you seen the video, Gio? Gio, I asked you a question. Did you see the video? Well, I'll go ahead and post it for you anyhow. So when you've watched the video, if you have questions after you've watched it, I'll be happy to address specific questions related to the video.
See, you can probably tell by my inflection that I dislike Bob. It's not really that I dislike Bob. I dislike the tactics. If we can have an honest conversation, Bob would probably be one of my favorite people because I like honest conversations. But when I get nothing but tactics, it's really frustrating to have a conversation with somebody, and that's why I demand $100 million.
Yeah, Bob, I asked you something directly, and you redirect me to a video. Do you not want to respond to my thing because you don't have any answer for it, or you just want me to watch some random video?
Well, if you want me to address the video with you, it would be, or if you want me to address the experiment with you, it would probably be helpful for you to know what the experiment was.
I already know what it is. That's why I asked you a question about it. I don't watch your videos.
Well, that's on you. So specifically, what is your question concerning the content of my video outlining my experiment?
This never was about a video. You brought an experiment to the discussion today.
And that is the experiment, yes.
Something you're calling an experiment, I should say. Now you're talking about a video.
Yeah, where the entire experiment is written up and outlined. Yep, and demonstrated with all the data. So far, nobody's been able to even demonstrate, other than Ruif, what the videos or what the experiment's about.
Yeah, you conflate the things weighing different, or the clock going at different speeds, right? And you conflate that with some sort of evidence of the thing that you presumed in the beginning, which is the circular reasoning thing. You got that problem. But yeah, we don't know what you're talking about, Bob.
All right. Well,
correlation isn't causation.
Let me see if I can clarify it for Gio, because I don't mind explaining it to Gio. He's a decent guy. So what I did was given a spherical Earth, which is a given, it's not in question, we can tell whether or not that Earth, we can tell whether the Earth is rotating or not, because if the Earth is not rotating, there will be no effect of centrifugal force. If the Earth is rotating, there will be an effect of centrifugal force. So given that framework, if you move from north to south in the northern hemisphere, if you move from the pole, from towards the pole to towards the equator, you will have a change in centrifugal force, which will be manifested by a change in the weight of a reference mass. Now, I tested that by going to a different latitude by two different routes. And I tested it going down and I tested it coming up after predicting what the change in weight would be. And I found that my change in weight matched the predictions of a Earth rotating once a day with a radius of 3959 miles. So by demonstrating by demonstrating reality matched the predictions of the hypothesis, I have strong evidence that the hypothesis was correct.
So it's begging the question and affirming the consequent, both in the same.
Not begging the question, not affirming the consequent.
It is both.
Don't try logical fallacies with me, Gio. I don't.
Neither of those are correct.
Deal with them.
and you're using them incorrectly.
Yeah, because you use them, so you don't want to respond to them. Because
No, I didn't.
that's where the fault is in your entire what you've laid out. So if you want to hold some confident position, you can't actually face the fact that it's logically fallacious.
Okay, so
Not logically fallacious.
the only response that you can make to this, Geo, is you can say, all right, well, you did get this change in weight with latitude. You're claiming that it is due specifically to change in the effective centrifugal force. I claim it is due to this, and here is my evidence of my claim. So what is your claim, and what is the evidence for your claim that accounts for this effect?
I think the confusion is pretty clear here. I mean, you can present. Well, do you have a hypothesis? Can you walk us through your hypothesis, just real quick? What was your hypothesis when you moved latitude? What were you trying to prove? What was your hypothesis?
Is Earth is a rotating globe. That's the hypothesis. The experiment to test that is to do the weight change with latitude. This is where Larry and you guys get confused. You confuse the hypothesis with the experiment.
No. Well, the hypothesis, the experiment is a hypothesis test, right?
Yes.
So yeah. So you brought up dependent versus independent variables, and these are included within the hypothesis. Should be.
No, they're not.
No, so they're not included in the hypothesis.
Right. Absolutely not. Within the experiment.
They're claiming that seventh grade science is wrong, and the teachers taught us the wrong thing, and that's not how science actually works. So by their own understanding, sorry, sir. By their own understanding, the teachers lied to us in the seventh grade. Thanks.
No, maybe you misremember.
That's fine. I'm walking through their understanding. Okay, so maybe I misunderstood science. So Ruhif, what is an independent variable versus a dependent?
It's the thing you wiggle to get the expected or whatever result in your dependent variable.
And let's say you said your hypothesis is that the Earth is a globe. Now, how does your experiment? How does your experiment that's manipulating an independent variable prove your hypothesis?
Okay, I didn't say the word prove. You said the word prove. Cool.
Well, and what's the whole point of testing something if not to prove something? Your hypothesis, your postulation, your prediction. So you're trying to prove it to be correct.
We can only test whether it's consistent with our prediction. All right. If we said that proves it, that would be affirming the consequent. Right. That's why it's not. That's why when Geo said it's affirming the consequent.
Oh, so it's only begging the question.
Not begging the question. It's neither of those are true.
No, but you actually earlier you said that. You said it's only begging the question, not affirming. No, that's exactly what you said.
It is not what I said.
You just said that.
Did not say that at all.
Actually, he did not say that. He said
did not say that at all.
I mean, Bob's entire thing started with begging the question. He said, "Well, the Earth is a sphere. That's a given." That's what he said. The Earth's a sphere. That's a given. So and he went on from there.
I wasn't testing the shape of the
something
Earth,
is
so
true.
It's not a begging the question fallacy. It is a condition of the experiment.
You're assuming the conclusion before you've even started.
Oh, Jesus. Okay. Let's write a logical syllogism that says, "Oh, I'll get there." Yes.
Well, Ruhif, actually, what you're saying is you're not proving anything. So who cares? Right. Like if you're not proving anything, who gives a shit what your little so-called experiment is doing if it's not proving anything?
Okay.
Like, who cares?
You have
it's in line with what you think. Well, that doesn't make any it doesn't add any value to anything. Like, okay, so you thought something works that way, and you used a so-called experiment that aligns with that thought. So what? What is that?
Exactly. Used a phenomenon that correlates with an initial assumption.
Right.
So what does that do? What does that do for anyone in the discussion then?
You have heard us say that science doesn't prove things, right? You've heard us say that a million times. Is science useful?
Yeah, for validating.
Well, actually, in the context of not. Yeah, in your context of not proving anything, no, it's not useful.
Well, I think science doesn't prove things. I think science doesn't prove things, and I think it's very useful, science. I can hold those two positions, and I do.
Well,
hold
the
those
only thing
positions.
it's useful,
if it doesn't
the
prove
only thing
anything?
it's the
Because you
only thing
can't.
it's useful for is affirming your beliefs, right?
Listen,
Or your
with
little.
science, you do a hypothesis test, right? And with this experiment, you get a 1 or a 0 as an answer to the test, right? So you've either verified a hypothesis to be true or untrue. That's not
Yeah, you've
really
disproved something.
arguable. It's subjective.
I
Yeah,
agree.
if you
You,
disprove
you've
something, then
disproved.
ipso facto, you prove the opposite to be true.
Yeah, that's just semantics, right? But when we say disprove, you're saying
Yeah,
that
it's not
latitude is
semantics.
not the
It's
cause
called
or
the
not
law of
the independent
non-contradiction,
variable.
bro. It's the
Yeah,
law of
I
non-contradiction.
understand,
That's
but
not semantics.
semantically it is, because when I say disproof, right, where the hypothesis is a positive claim, right? If we get the null result for our experiment, we have rejected the hypothesis of a
And
rotating
you've
ball.
proven it not to be true. That's proof.
Yes.
Like, but you
Yeah.
say, yeah,
Correct.
but you're
But it's a
saying,
disproof, right? A disproof.
yeah,
So
proof, disproof is the same thing. You're proving something either to be true or
Fine.
false.
Yes, but it's a
So
semantic
So, but
issue.
here's
you
where the
said
rub
it.
is.
It's not
Just real fast.
semantics.
Just
Yes,
real
it is.
fast. Here's where the rub is. Enough heat and enough time will cause water to boil, right? I can demonstrate that to be true. Therefore, it's proven to be true. Now, the
Well,
science
hang
has
on,
never
no.
settled.
Stick
Hold on.
it
Don't
into
interrupt.
a
Don't interrupt.
logical
Don't
syllogism.
be rude. Don't be rude.
Okay.
So I'm not saying that there could not be another possible cause, right? At any time, you could come up with a new experiment and say, low pressure also causes water to boil. That's why science has never settled. But you do actually prove a hypothesis true or false if you have a proper experiment and you control the variables, manipulate only the cause, and then you see the effect. Thanks.
You cannot prove a hypothesis to be true. I've challenged many people to this. Write a logical syllogism, right, that proves the cause of an effect, and DM it to me.
He just
Write
gave
it
you
and DM
one.
it to me.
He just gave you
Write
one.
it
Like,
and DM it
he
to me
just
in a
gave you
formal
one.
logical syllogism.
I don't know why you're like he just gave you, literally. He just gave you one.
Write it down and DM it to me.
That's not a response to he just gave you one.
It wasn't a formal logical syllogism. He just said if you heat water, it'll boil. I agree that if you heat water, it will boil.
That's not what I said. I said if you add enough heat and duration to a water, it will cause it to boil. Anybody could demonstrate this.
Write
A
it in a
caveman,
logical syllogism and DM it to me, and then we'll go
a
through it.
caveman can prove this.
Jesus Christ. I agree that if we apply a lot of heat to water, it will boil. I agree.
If there's enough
A
time.
lot of heat?
Yep, sure. A lot of
Yes,
heat,
a
a lot
lot
of
of heat.
time, whatever, it will
That's
boil.
subjective. What's a lot?
Whatever it's subjective, that's fine. Please
Well, you're the
write
one
a
who's talking about
scientific proof. Please write a scientific proof in the form of a logical syllogism and send it to me via DM.
Lack of
If you don't
vitamin
want
C
to do
will
that,
cause
that's
scurvy.
whatever.
Lack of vitamin C will cause scurvy. How about that?
What?
Vitamin C, excuse me, vitamin C.
I
Lack
know
of
you're
vitamin
just
C will
quoting
cause
QE.
scurvy.
I understand that you're just reeling off QE's list. That's fine. Please write it in a syllogism and DM it to me.
I'm not going to write anything
Oh,
to you. I
really?
just said
Of
it
course
to
you're
you.
I don't know
not.
why you're dictating.
Of course
Yeah,
you're not.
you're dictating why we should write shit to you. I mean, water will boil at 100 degrees Celsius.
I agree. Thanks, QE.
Yeah, hold on. At 1 atmospheric pressure.
Yep, I agree that will
Hold
happen.
on. High
Please
consumptions
write
of
it
sugar will cause
in a
diabetes.
scientific proof.
If what like a what, are you saying an if
Just
then?
using formal logic, premises, conditional premises, conclusions. Please write it in a formal logical syllogism.
I'll do it for $1 million. How about that?
Of course you will.
Rotting food will cause
I'm going to
alcohol.
play golf.
You guys like Karl Popper. You guys bring him up sometimes, but you understand that this is the distinction Karl Popper was making. Was the claim that you made about water doing that? In order to be able to make that statement like provably, you'd have to have done it every single. You have to have done it every single time it's done, right? When it's impossible to make an observation it's impossible to make every observation that will ever be made about water. Boy, you know what I mean? So you can't make that statement isn't a scientific.
That's why the science is never settled, Kosho. At any time, someone can do it 1,000,001 times, and if it doesn't happen on that 1,000,001 time, right, then it's wrong, right? But until you can show me enough heat and enough time not causing water to boil, then until then, I'm going to say it's verifiably true.
That's
and it has
fine,
been proven so.
Yeah, but in saying that, you're admitting that you're saying something incorrect.
It's a malformed question.
I just don't understand why you guys are so adamant about predictions and observations, right?
That's
And that's
science,
100%
Larry.
true. Hold on, bro. But you're fine with all this theoretical, hypothetical postulations. But when it comes to an actual scientific experiment, you're like, oh no, that's not good enough.
We're just saying that it's the statement of it being proven because you tested it. It's just not. It's not a correct statement to make because just like you said, you can do another test that shows that it's not proven. So it can't be proven at one point and then disproven the next point. It was never proven.
Exactly. That's why. Well,
then
yeah,
give your
that's why
test that
my
disproves it.
my syllogism that Ruth wants me to write down for some reason. I don't know. I spoke it. I said water will boil at 100 degrees at 1 atmospheric pressure. This is always
Is that a
true.
syllogism? Is that a premise or an entire syllogism? So far, you've said one statement. You said water will boil at 100 degrees.
Well,
That's not a
you want me to
syllogism at all.
walk you through it?
Why,
Okay,
why
so
are you hung up on this?
water
Because
will
you're saying it proves things. The way to do things is write a logical syllogism.
Heat will cause water to boil. Okay, that's the first premise. All right.
Okay. But that's your conclusion, isn't it?
No.
Isn't it? What's your actual trying to prove then?
That
What's
it
your
boils at
conclusion you're trying to prove?
100 degrees.
We're trying to prove that water
1
changes
atmospheric
phase,
pressure.
right? We're trying to
So
prove
that's
right?
your fucking premise, isn't it? That is begging the question. Having a premise
See, it's
as your
astounding to
conclusion.
me that you guys call yourself skeptics, but when it comes to actually being skeptic of your own model, you have no skepticism whatsoever.
We're trying to teach you logic here. Anyway, I'm going to play golf.
I don't understand how that was a response to.
Have a good one, Roof.
Oh, I'm playing Discord golf. You can join us, Bob.
So are you guys claiming that water doesn't boil at 100
Gotcha.
degrees Celsius at 1 atmospheric pressure?
No, we're claiming you can't prove it.
So you can't prove it. But if I do it right in front of you, isn't that proof?
No. That's evidence that it's happened.
But you guys accept dark matter and dark energy, but you can't accept the fact that heat causes water to boil.
Hank, I'm not trying to call you
Larry.
dishonest, but you're being blatantly
You,
dishonest.
you are
I'm
being
being
dishonest, Larry. Please,
Okay,
please
sure.
read my response to you in DMs about dark matter. You just said I accept dark matter and dark energy. Please read verbatim my DM to you.
No.
No, okay, I'll read it. Okay, I will read it just because you're a prick. All right, my response to you saying I accept dark matter, dark energy.
It was the cloak we use. The world doesn't revolve around you. Bro.
I said, I agree that dark matter and dark energy is simply a placeholder. I have never used it in any flat earth debate. That was my response to you, Larry.
Well,
Right,
if you could just
said a
take
minute
that
ago
information,
that I accept dark matter and dark energy. That was a lie.
It
Anyway,
was the
I'm
proverbial
out.
you, bro.
I'm playing golf.
Right? Why don't you take that information to Jim Pandas?
The problem is, Ru, if you're trying to conflate logic with science.
That's literally what you guys are doing.
No.
Yes.
That's not exactly what we're doing.
Proofs don't exist in science. They exist in
logic. Give me a logical syllogism for that and write it down and DM it to me.
I'm not going to do that.
Though. That was
I know you're not going to do it. I was being sarcastic.
If you did, okay, good. Because if you understood that, then it's perfectly clear. That logical proofs are a thing. Scientific proofs are not a real thing.
Oh, so you can prove things within logic, but not in science. That's your question.
How can you prove that? How can you prove that statement?
No, I think what Ruif was demonstrating was the fact that you like to talk about logic, but when you try and actually write out a formal logical proof, you can't do it.
That's
I would like to
the point.
see.
We were talking about
So
science.
just go ahead and do it.
That was my whole point. Well,
I would like to
that's
see a
exactly my point.
demonstration.
Did you listen to my point? Why are you conflating logic with science? We were talking about independent and dependent variables, and then for some reason you just flipped it on writing a syllogism, a formal logical syllogism, which is completely off topic. We're talking about science and independent and dependent variables. So why are we talking about formal logic now? It's weird.
Because Dr. Bob is here.
Yeah, but
That's why we're talking about fallacies.
Because you guys
I would
think you
like
can
to,
prove things with
I would like to
science.
see.
Show me how
I
you
would like
prove
to
something.
see.
Write a
I would like
formal,
to see
logical
water.
proof of anything scientific, of any scientific hypothesis.
Mike, check.
Well,
Actually,
you
I'm out.
already.
You
Sorry,
want to keep
George.
playing golf,
Oh,
Jojo, or are
sorry.
you done?
Yeah, Ruif, you already like kind of conceded to her earlier by saying you can disprove things
Right.
using
Yes.
science, which is,
And I think
and
it's
then
a
you called
pretty,
it semantical,
yes. I
which
think
is
it's a piss weak thing
by
to say to
no,
prove a negative.
yeah, you are proving something by
Yeah, but you're
disproving
disproving,
something.
right? We call that a disproof. That the
Well,
hypothesis is a positive statement, right? It's a positive claim.
exactly.
Hypothesis.
That's how science proves things. That's one of the ways.
Yeah, you can call that proving that wrong, right?
Yeah, and I don't call it that.
Yeah.
Well, that's that. Who's being semantical here? Like you're.
Yeah, I'm saying it
funny.
is a semantic thing. It is a
No, but
semantic
it's
thing
not.
to say disprove.
It's not. It's not a
Yeah.
semantical
Okay,
thing.
how about I
By
say...
disproving, but hold on. By proving something to be true or false, you are proving it to be either or.
Let's be more
It's
exact.
not
And
semantical.
you can't prove true a positive hypothesis.
Really?
Why
Are
not?
you for real?
Oh,
man?
hold on. Wait, hold on,
What?
George. Why not? Why not?
Because when you do an experiment, you say, if my hypothesis is true, I expect to see these results in reality. All right, I go and do an experiment and I do get those results in reality. You can't therefore say my hypothesis is true. That's affirming the consequent. That's the whole point.
No, it's not. No, it's
yes,
not.
it is. I literally
Like,
gave you an affirming the consequent.
Yeah, I'll tell you
No,
why.
you-
I mean,
you have
it's only
experimentation,
that
man.
because again, like you earlier kind of confirmed that your hypothesis does not include your cause and effect relationship. That's your disconnect. In my version of science, your hypothesis must include the independent and dependent variables.
Yeah, and it's wrong.
Within your
hypothesis.
Well, opinion. I mean,
Okay.
yeah, like unless you can show me some citation that disproves my claim.
Karl Popper.
If I show you a citation that says the Earth is a globe, will that help?
No, that's not
No,
what I
of course
asked
not.
for.
So what's the point of
that's not what I
citation?
asked for. No, Ruif, come on.
Yeah, what's the point of a citation?
Wait, what citation did I ask for?
Oh, for that the hypothesis is not a independent variable, dependent variable relationship.
Yeah, that's the hypothesis.
So you can bring
the citation I asked for. Why are you bringing up Earth as a globe?
Then you might find a citation that says something like that, like your position, right? And then we just have dueling citations.
That's fine, and we can disagree, and you can call my. No, that's. I mean, you don't want to engage then.
I don't do dueling citations. No, it's pointless.
That's fine. Therefore, I should just believe what you say, and then you not believe what I say, and then we go on this.
Sure.
Yeah,
we can demonstrate things.
Yeah.
They just need to demonstrate water to be 100 degrees Celsius and not be boiling. Yeah, that's what they need to demonstrate. Water to measure 100 degrees centigrade, yeah, and not being boiling. This is what you need to show.
Yeah, at atmospheric pressure.
You guys,
yeah, at 1 atmospheric pressure, but that is a constant. Yeah, but
I'll turn George up if he
I give them
retracts
that
his
because these
statement
guys they don't know what they're talking about.
that the celestial sphere is not a sphere.
Yeah, correct. It's not a sphere, no.
Yeah,
celestial sphere is not a sphere. That's correct.
Okay.
Yeah.
So that's
why are we going off on
down.
a tangent? No. That's not a reason. That's not what we're talking about, Ruif.
No, I
Don't
agree.
go
I'm
off
just
on
explaining why I
tangents.
don't have George audible.
That's your personal preference. You don't want to engage, then put yourself on mute. That's fine. But that's
I'm
what
not
we're talking about now.
Instead, he's muting me.
Yeah, Egypt. Are you familiar with Karl Popper, because a lot of flat earthers bring it up, kind of, and the whole black swan it has the namesake from Karl Popper's argument.
Yep. What
You
about
understand that? I mean, if you understand Karl Popper's argument, then everything me and Ruth are saying it should make perfect sense. This is what he was arguing.
well, walk me through it. I mean, that's not enough for me to go off of. Like, I know Karl Popper, therefore what you say is true.
Right. He said you can't you can't make a proof statement or like a statement that like a claim like all swans are white. Or no, what was it? Yeah, all swans are white. Because that statement, oh no, that is a scientific statement. All swans are white. That's right. Because it can be disproven, right? Well, maybe I'm not thinking about it correct. Hold on, let me.
Can I interrupt for 1 second? Then
Yeah,
I'll
yeah,
go.
Yeah.
I forgot that I actually made a
The
video
globe
about QE saying
has
that
a
science proves
claim.
things using citations.
Yeah, but
So I'll drop
the
that video
globe
in the chat.
the
If
globe has a claim that all
Egypt wants to watch it, that
the
would be
swans are
great.
white.
It is entirely on topic.
He has
All right, Kosho,
muted.
where are you?
That's why
There you go.
I
So
cannot
this is about QE's citations about science proving things. Anyway, I'm going to take the kids to the beach shortly. So that's all me.
Enjoy.
Yeah, watch the video.
Yeah, but
Egypt.
I don't appreciate how you just, again, muted George and just plugged
Hey,
yourself.
Well, if George is going
and
to
your
say
video.
something like,
No, that doesn't
Have
work. Like
you
just
found
go to the
the
beach, man.
yeah, if
curvature
you
of
don't like that I've muted
the
him,
earth?
I've given my reasons for muted him. He says the celestial sphere is not a sphere. He is not worth engaging. Anyway, I'm out off to the beach. See you. Watch the video. Bye.
Later.
Enjoy the beach.
That is correct. It is not a sphere.
Yo, is Bob still here by any chance?
Well, I mean, I'm still here, but I'm not sure you're talking about me.
No, I was talking about the science guy.
What's that supposed to mean, Jeremy? What's that supposed to mean?
Somebody that actually knows something about science.
Boo.
The fallacy guy. I don't know. He goes by a different name
Well,
nowadays, isn't it?
I mean, did everyone hear Bob's method? We make a prediction. We have an effect. We make a prediction on what causes the effect. Then we measure the effect, and if that effect happens, matches our prediction, then we have now experimented for this cause that we didn't test for. Everyone's cool with that?
Say it again.
That's how we're doing science. The way
Apart
Bob
from
just
measuring,
detailed.
Let's say it the way you said
apart
it
from
again.
measuring
Weight
the
change.
effect,
Weight change with latitude. Weight change with latitude change. Right? We get an effect. Weight changes with latitude change.
so
We're going to make a
latitude
prediction.
changes weight.
I can't hear you, Jeremy. Say it again.
Go ahead, George. George, go ahead.
No, please, just say your thing again. Yeah.
I'm just
Not usually.
asking you to clarify what is the claim
I know that's
that latitude changes
That's
weight.
what we're getting at, man. Because I'm trying to hear from him. Yeah.
Yeah, we're gonna get there. So Bob claims that weight changes with latitude. I would agree. I would probably agree with that. Maybe, I don't know. Whatever. Let's just say that is true. Then let's say that I make a prediction that if Earth's rotating, this is the weight change I would expect with my latitude change. Then I measure the weight change with latitude change. That is the experiment. And we've just done science for Earth is rotating.
Yeah, did you
Are you
involve
cool with
the
that?
predictions?
Why?
Okay.
Why?
Involve the
You would
predictions?
let it go this far.
I didn't hear you.
Once
I
it
didn't hear you.
says latitude or longitude, it's welcome to flat Earth. Straight away.
Perfect statements. But what did you involve the prediction part, Jeremy? Of Bob's test?
Yeah, you have an effect. You make a prediction. You measure the effect. It matches your prediction. We've now done the experiment for something we didn't test for.
I don't think that's what he said. I think you see an effect, then you have a hypothesis based on the Earth rotating. You make a prediction based on the Earth rotating and what effects that would cause when you change latitude, and you test it. Yeah.
Yeah, I think the whole point is that your hypothesis does not include the effect you observed, nor the cause of it. You actually, both of you and Ruhav actually conceded to that the hypothesis does not include nor the independent or dependent variables. So you have that disconnect, and you call us wrong for including both, and we call you wrong for discluding them, and that's where the disconnect is.
Yeah, you're wrong.
I
You're
would
wrong
say.
for thinking that that's necessary, but it's actually not necessary that that's included. It is just necessary that whatever you're attributing, that your independent variable is attributed to. It's basically is happening because of your hypothesis. Your hypothesis.
Well, yeah, I mean
What's that?
that's the
What
way
is
I
that?
hold on, George, just take a chill pill. Kosho, what I'm saying is that's the disconnect between when we say science proves things and you say it doesn't. In your paradigm, yeah, obviously, if you're not including in your hypothesis neither or the independent and dependent variables, you're not really proving anything. But in the context that we're presenting, and the way we're presenting science should be, it does prove or disprove things.
That doesn't make much sense. The independent variable and the dependent variable are chosen so that they can show that whatever your hypothesis is true. So in the case of the Earth rotating, that's the hypothesis. The test we're going to do for that is, in this case, change latitudes and notice that weight's changing. And
nothing to do with the phenomenon.
The part that's missing is that prediction is based not randomly, but it's based on the fact that if the Earth were rotating, we can include using the centrifugal force to determine a weight change. So
not random, but on a bias.
Man.
Yeah, a bias. But
it's not a bias.
See, yeah, it's not. There's no control. Like how you can make up anything and make it fit that narrative.
No, you can't.
And yes, yeah, you can. Yes, you can.
No, I do. The whole hypothesis is that the Earth's rotating. And the rotating
His question is what is causing Earth's rotation. It needs to vary and manipulate whatever causes the Earth to rotate.
George, it's becoming like you're kind of like just walking all over everybody. Just I'll let you speak, George, but just let Kosher just finish his point, and then you can. Yeah.
All right, George, and me.
Yeah. So once you have the idea that the Earth's rotating, the things that follow from that are things that you might already know about reality, like rotation and what that includes. That includes centrifugal forces. So the fact that you know that, you can include that in a test that you want to propose. And in this case, you're doing that. You're proposing that the centrifugal force would be involved in your movement around the globe, since you're changing your distance to that rotation axis. So this is just a natural conclusion that follows from that hypothesis. The test is changing latitude, because you know that that's going to have a relationship in your centrifugal force. So all that stuff follows.
See, I think there's a difference between a hypothesis.
Hold on, Fundy, hold on.
George and me, then Fundy.
Yeah, George, you want to say something?
Yes, of course, because it started by saying that they are studying the rotation of the Earth. So if that is the phenomena, what is called that? Isn't that the independent variable? Isn't that the phenomena? Now the next question is, what is causing that phenomena to happen? Now you need to vary and manipulate whatever you think causes the Earth's rotation. Not latitude lines. Don't bullshit. Don't deviate to something else. It's cause and effect relationship we're talking about. If Earth's rotation is the phenomena, you need to try to find the cause of that phenomena. Not bullshitting. Over.
I think Jeremy's next, but the phenomenon really is the sun moves across the sky. Ultimately, they're extrapolating that the Earth is rotating. That's a begging the question right off the bat, which is why I had said that. Yeah, go ahead, Jeremy.
I mean, his experience. His thing was, this is supposed to show us, this is the science that Earth is rotating. He never had it anywhere in any experiment or hypothesis or nothing. All he had is weight change with latitude change. He never actually did anything to verify that the Earth was rotating in this so-called pseudo experiment.
Okay. Well, to respond to both you and Gio and George, actually, in one fell swoop, that's exactly what is happening. That's the purpose of what we're talking about is, let's say, Gio, like you said, you see the sun moving across the sky. You have a hypothesis that the Earth's rotating because there's a counter one that it's not rotating. The sun's moving around the sky. So to test that hypothesis, you then say, okay, well, if the Earth's rotating, and then everything I said earlier, the centrifugal force, how you would test that, changing latitude, how the independent variable would be you changing latitude, and the difference in the centrifugal force because the radius is changing. So yeah, all these things follow.
Look at the question,
But
man.
it's based on the question: are we rotating?
No, it's based on begging the question.
So it matches a mathematical model that you made up beforehand and never verified, and therefore this is the verification of the next thing. Like you're living in a house of cards.
No, dude. Let me ask you a
Can
question.
we see the model?
Let me ask you a question. You have what's wrong with the so if you have the question, we have the observation, the sun's moving across the sky. You then have the question, is the sky moving or are we moving? That's a valid question. Okay. You want to then do science to figure out the answer. It's also valid to test the hypothesis we are rotating. And that is a perfectly reasonable test to test the hypothesis, since that test is based on the what would happen if the Earth were rotating. All that stuff is fine science.
What about the other way around?
The question, are we rotating? The question, are we rotating, is not a hypothesis. That's just a what is the Earth rotating?
Right.
Yes
Yeah,
or
that's
no?
the question. The hypothesis is that the Earth's rotating. The question was before the hypothesis.
It's not a hypothesis.
No, I know. The question was, is the Earth rotating or is the sky rotating? The hypothesis was the Earth's rotating.
Yeah, it should be cause and effect.
Well, did you test the other hypothesis? Did you test sky is rotating hypothesis? Do you have any tests for this hypothesis?
I mean, I suppose.
Or does it work one way?
Well, no. This test will make a distinction between the two. It's either one or the other.
Wait, no, it's not. Because in your version of science, you only disprove things.
Sure, and we've disproven, we've disproven the fact that we're not rotating. So
how? Well, walk me through.
There's a centrifugal force that you can predict.
That's not disproving anything.
Well, then, I mean, you'd have to explain why that can be predicted and what happens.
No. Yeah, I mean that's proving. Well, in your case, it's not proving. It's just in line with your hypothesis.
Right.
So you neither disproved anything or proved anything. So
you've held it up.
Well, yeah, I mean that's what you're claiming. You have. It's just this claim that you do some test that is in line with. It's not proving your claim.
That's right.
Because if you are proving your claim, that would be unscientific because science doesn't prove things.
Yeah, you're right.
So,
You're not
really, yeah, exactly.
You're not proving it. You're just showing that it's most likely the case that it's true.
If my hypothesis with the same test, like, can I perform the same test with the opposite hypothesis that the sky is rotating?
Can you assume that the sky is rotating as your hypothesis and then use the
No.
True? No, you can't.
No. The sky is rotating is not the hypothesis because you already said the Earth rotating is not the hypothesis.
No, I didn't say that. I said that was the hypothesis. I said that's the hypothesis. You can choose. You can pick which hypothesis you want to pick to test it. You know what I mean? Like as a scientist, you're allowed to pick what you want to be as your variables, your hypothesis, all this stuff.
Mind if I hop in here?
Yeah. Go ahead, because you're.
Yeah, go ahead, Fundy. Yeah, I don't want to.
So
go ahead.
To me, the whole you know, what you're calling an experiment or whatever with the latitude change and involving centrifugal force and stuff like that. To me, it's equivalent to saying there are intangible, invisible unicorns who poop rocks. And if I go out in the world and I find a rock, it verifies that there really are invisible, intangible unicorns that poop rocks. Because I found, you know, the results of them doing that.
Well, I'm not sure if I'm not okay. So I'm going to explain this in a way that, like I've said this already, so I just don't want to repeat myself. But what I said was, first you come up with the idea, the hypothesis that the Earth's rotating. That's the hypothesis.
Okay, unicorns poop rocks. Then I go out and look for evidence of that, and I find rocks.
Yeah, but hold on.
Therefore,
That hypothesis doesn't follow from anything. So as I'm saying, this hypothesis follows
wait,
from
what are you
an
talking
observation.
about? Wait. Hey, don't you assume what I do or do not know about unicorns in my research. I've dedicated my life to this, and I have lots of reason to believe in these unicorns.
Right, but you haven't stated any of them.
I can go through this with you, but it has an extensive background.
You
of
haven't stated
investigation.
any of them, is my point. So the reason why we saw that the sun was moving around the Earth, so it follows that the Earth's rotating or the sky's rotating. There's other hypotheses you can go down the road of, but these are the ones that make the most sense. So we choose one of them, and then once you choose, you see.
Now it's just subjective at this point, based on whatever your background and whatever thoughts you currently host in your mind, and lean on and think are likely and plausible. Yeah, you can cling to your beliefs, but it's not science at that point. It's just speculation and confirmation bias.
No, yeah, the thing you said, that's true. But the thing you said is true. But as I said, when you have the observation that the sun's moving, you can explain perfectly how it could be the case that the Earth is rotating or that the sky is moving around it. Both those things
I can explain perfectly how rocks get there.
It's not a stretch to make that claim once you have the observation. So in order to have a hypothesis that you can have a valid test for, there has to be a logical path to get there. Like you can't make it.
Yeah, like I said, don't assume what I do or do not know about these unicorns I'm talking about. Okay, I've put a lot of time into researching them.
First of all, I'm not making any assumptions about what you know about unicorns. I'm assuming that you know a lot about unicorns because you're a flat earther, and flat earthers are obsessed with unicorns. But what I'm saying is,
I got
in this
fossils
conversation, you
discovered.
haven't stated
I
it.
got
So
Flat actually will ask you, where did you get R from for your rotation of your sphere? Where did you get the R value?
That's not being tested here.
Well, you are saying it's a sphere. To be a sphere, it needs an R value. Also, to be rotating, it needs to have an axial point. So we also need an R value for that.
Yeah. So the test is
listen,
meant to test if we're rotating.
For you as a scientist, hold on a second. For you as a scientist to impose this question, I mean, you're showing your true colors. You are really bad scientist. You didn't do the proper research, have you? Because the Earth has been measured to be flat and stationary. It's used for celestial navigation for many, many, many years. Yeah. So for a scientist to come to a different conclusion, that would be to ignore facts that we still use today for navigation. No scientist will even do a test without researching first. I mean, this is so stupid. I mean, we've been so alluded to it. It's absurd. Just stop it. You don't have an R value for your model. Show us the model, please. Hello? Mic check?
Yeah, you're coming through.
All right. How can you have a globe without curvature? I'm still to find out how it's possible. I don't think it's lost in translation. We're just pretending here. We need to stop pretending and behave like adults. We're just sharing information with each other. It's not a fight. It's not insulting people. It's just sharing information. We should be grateful for it.
Can't believe I just paid $70 for a fucking eighth.
For a
For
what?
what?
Oh, for an eighth?
Yeah. And it was supposed to be 30% off with a first time patient or whatever the fuck, discount or whatever the fuck. And yeah, I'm like, I feel like I got ripped off right now.
I sold the eighth for $100 4 years ago. That was a while ago.
Yeah, I mean, I'm the same, but I'm
Come
just
on,
saying,
guys.
like,
We're going to have a raid.
I'm in California, dude. I'm at the mecca
I mean,
of
on
fucking
Discord.
this industry.
Oh, damn, that's crazy.
Yeah, dude.
Wait, why can't you get it somewhere else then?
I mean, I'm just going to these legal places and shit, you know. But yeah, like if I were to hit somebody up.
No, I mean in
What's that?
California, I thought like all places were like legal. Like there's a bunch of legal places. I thought.
Yeah, well, you got places that are under Prop M, which is Adult Use Act, and then you got places that are still operating under Prop 215, which is the CARE Act. So they're kind of like slightly different. So essentially, like if you're a patient, then maybe it might be slightly cheaper, because I don't think they're taxing as heavy on that. But then you have to have a patient membership, which costs money every year. Which, you know, there's really no point to have that unless you're just trying to get that discount. But
Yeah, I've never been there and bought it, so I don't know.
I mean, normally, like, all right, so prior to the Adult Use Act, Prop M, everything was like pretty competitive. So you had like a lot of places that were popping up, like 35 per eighth places, like they called it like 35 no cap, and then you had places competing even further, so they were going basically down to $25 an eighth.
Yeah,
and then the top shelf was typically like 40 an eighth. But now, since this whole Prop M came about, now the top shelf has gone from 40 an eighth out the door to 70 an eighth out the door.
Wait, what does Prop M mean?
Adult Use Act. So like you just have to be 21 and over to essentially walk into that particular dispensary.
And why did that make the prices go up?
Because the taxes.
Oh.
Yeah, the taxes is like pretty steep on that for whatever reason. And yeah.
I just thought it was cheap all around, but I guess not.
No, it's not.
Maybe it's in Colorado. Colorado is pretty cheap all around, I think.
Maybe they don't have the Prop M. Maybe they're still under Prop 215.
Also depends on if it's indoor or outdoor. Indoor is usually like twice as expensive as outdoor.
Yeah, sounds to me.
Yeah,
guys,
I could have bought some shitty quality.
Yeah, you're complaining about inflation. Pretty much.
I think you're saying it's a tax thing.
Yeah, basically the industry's been heavily fucking monopolized. So,
oh really?
In order to legally operate within this industry, like you have to have a license, obviously, and in order to obtain a license, like you have to have significant funding.
You can't.
So they, yeah, exactly. So they kind of created a monopoly to a degree, and now they kind of set the standard as far as price goes. Like all these competing parties, which are, you know, heavily backed financially, so they don't really have any reason to drop the price.
Wait.
The only issue is the black market that they're competing against, and the black market's been pretty beaten down lately. So there's like very few places that you can go to that are like black market dispensaries, essentially.
Wait, can't you grow it yourself though?
Well, you can. You can get like a license and grow up to X amount, but then you're still under the scrutiny of law. And
Yeah,
I've
like
already
6
been there and
planks or
done that.
something.
Yeah, I already been there and done that. Like I got the proper licensing to do all that stuff and was doing it. And when they come kick down your fucking door, you know,
Why
then
would they?
it's up to what's that?
Why would they?
Well, the reason for me was they claimed that I was creating a safety hazard from the amount of power that I was drawing.
What?
But yeah, I was drawing some significant amount of power. But it was still like nothing was malfunctioning. Like I wasn't blowing transformers or nothing.
Wait, do you have? Is there
So
a law there that says anything about that though? Like about how much power you're using?
Yeah, I mean that's the way they did it.
right.
I'm not talking
Because
about in order to find out if you're growing weed or not. Because if you're legally growing weed in your state, then it seems like there would have to be a law that says like you can only use this much power. And if there's not, then
Well,
this.
so the way yeah, you're right. I mean, there has to be some more clarity on that because they use that as probable cause to come into my residence and shut me down. And the way they perceived it is like if you're within the maximum capacity of the legal limit, you're only going to draw X amount of watts.
Oh.
So that was kind of how they like essentially got the judge to sign off.
Yeah,
yeah,
so you're saying
which in the world of cause and effect doesn't really follow, right? Because you could be growing 25 plants and draw out, let's say, I don't know what the wattage would be, but for argument's sake, 100 watts, and then you can draw 1,000 watts growing just 20 plants. It's
Well, the
there's
funny
no
thing
correlation.
was,
Like it's not even a
funny
correlation,
thing was when
let alone
when
cause and
they
effect.
came through, there was no plants even growing because I already anticipated them coming, so I tore everything down, and so there was nothing even growing, dude. All they had was dry flower that was being trimmed, which I was able to have in my possession legally. So they really had nothing, dude. But I don't know. I wasn't too happy about the deal I took, but at the end of the day, so that's the gist of it,
Yeah.
Kosha. That's why I'm not growing my own flowers.
Yeah, I mean, there's the law on paper, and there's the way the law can be used against you. Like in reality, it's different.
By the way, Coach,
But,
on the last topic, I was going to say, like, with the centrifugal and centripetal forces, aren't those also dependent on your assumption of gravity? Because centripetal and centrifugal would work differently if there was no gravity. Everything would fly off the ball way more dramatically than a tiny, teeny, weeny bit of weight change. So the entire thing is built upon begging the question fallacy of not only a spinning globe, but how this gravity theory and idea works with centrifugal and centripetal forces.
It's very involved.
So it's like
Well,
an
yeah, that
assumption. It's like a
strengthens-
begging the question built within a begging the question to even start the whole thing off.
Yeah, but that strengthens the whole. That strengthens the whole thing actually, because the idea of the radius and the idea of gravity are both independent of that rotation. So let's just pretend that those things were measured first, and by measure I mean, like you guys would say, assumed, or some assumptions, whatever. But the measurements and the ideas for the strength of gravity, the mass of the Earth, and even the radius of the Earth, all these things can be discovered independently of the rotation. So now that you have that, the rotation that you're using to predict this test that we came up with, but the one we're talking about, we're using simply the movement of the sky, because the sky is rotating once per day. So that's what we're using for the rotation. And so using those facts alone, once you decide that that's your hypothesis, the centrifugal force can be, just simply comes out of the information you already know. And you just use that information that you already assume to be true. You're using that to make the prediction of what the centrifugal force is. So it's independent from gravity, but you can test it. So when it's part of your test is using all
So
those
much
facts and
for the
true.
question, man. Why are you bringing the Earth to be a
Is
sphere again, man? I already asked you. You don't
is
have
a
a rated
magnetic
value for it, man.
is a
You don't have a
magnetic
value.
field
You don't have a
centrifugal in
radius.
nature, Kosho?
You don't have a sphere, man. What are you talking about? Stop it.
I know that in your
Is a
idea
mag
of it, Dyslow, it does involve centrifugal divergence and centripetal convergence, one of the two.
convergence, right?
Right, yeah. I don't think so, but
I mean, you can see it. You can see it blatantly within the field, within the geometric expression of the field itself. So therefore, you don't need to have like a rotational body to have such a force when it's already present within the magnetic field itself. You understand?
yeah, like I said, I understand the way you guys express it. I just disagree. This whole.
Disagree? Did you disprove it?
No, I disagree with
were-
the conception of it because I know that when Isaac Newton described centripetal force, the formula, it involves an
Just be
object.
careful when you say "you guys."
The
Yeah.
it involves an object orbiting or rotating around another object, being tethered to it somehow, and that's all. That's all it's describing.
Right.
So I wouldn't.
So when I invoke the magnetic field and I tell you that it has a centrifugal divergence to it and centripetal convergence, and that's all expressible within the field dynamics of it, that wipes away the notion of having the necessity of some orbital body to have this centrifugal force to begin with.
Someone asked if Kosho had disproven something. What is it he needs to disprove?
The centrifugal force of magnetic.
I don't. Outside of this Discord, I don't know that it exists.
Well, it does. You can clearly see it, and you can also get the same reaction when you have magnetic attraction. You have this this movement in such a way to where it's not A to B, rather than in this curvilinear fashion, which should necessitate this centripetal force vector. And centrifugal. That's what creates this toroidal force vector in motion. It's observably witnessed, and I mean you can test that, you can verify it. I mean, it's not anything that's disproven.
Yeah, I think Kosho's rebuttal was simply that the description of centripetal and centrifugal involves objects. Therefore, in a magnetic context, it does not apply.
Well, no,
am I right?
Well, no, not quite. I was saying that Isaac Newton, the one who described centripetal force, he described it like he was specifically talking about. It's the force. It says a force between which bodies are drawn or impelled in any way tend towards a point as to a center. So, like so there's some force compelling them around this other object. That's all that.
Yeah. So Dyslow's point applies, right? Well, no, it doesn't.
Well, even Jace said it.
Wait.
Even Jace said it earlier. He said nothing moves in a straight vector. It's always following this curvilinear fashion, which accounts for this magnetic, repulsive, and attractive field.
He was talking about gravity, though. He's talking about general relativity.
Yeah, I understand. He was. Yeah, I get it. That's what he was calling gravity. But like I said, you guys have never accurately defined gravity, and that's why I was saying like it doesn't have to be this particle or this mysticism. It can simply be accounted for with dielectric acceleration, which is pertaining to magnetic fields.
Like I said, I'm not going to argue with your idea of the centripetal and centrifugal, divergence, convergence, whatever. I know that these are where these terms come from. I just I disagree with them. That's all. So, I understand what you mean when you say them. I don't think that it's like I'm not confused by what you mean when you say it, because I know what you mean about the like if you look at the lines, like the field lines, they indeed look like they're either like coming in to the poles or spreading out from the poles. So I understand what you mean. I just disagree with those terms. Yeah.
Yeah, I mean, and you can even see it, like if you were to do a demonstration yourself with like a steel ball bearing and a disc magnet, the ball bearing always precesses around the outside edge where the plane of inertia is. It never just comes to contact with the magnet and stays directly on the surface of the magnet. It always flies off the edge and precesses, and analogous to things not necessarily coming together from A to B, but always seeking this equilibrium between the two objects, which would be that null pressure point, respectively, to both. And that's why I say you guys got gravity a little confused. It's just incoherent magnetism.
I have opinions about that too, but unfortunately, I can't share my opinions right now because
I mean, gravity
emissions.
is not a unique autonomous field modality, so you'd have to account for that.
Can you expand on that? I can't respond, but I'd like to listen to what you have to say about that. Like, elaborate a little bit because I don't really fully understand what you mean when you said that. Like I said, I'm still listening, but
and responding, but you said you can't.
Well, no, I was just making sure that I don't know if he left or something. I was just saying that I'm definitely interested to hear, you know, the expansion on that because, like I said, I didn't fully understand that, but like I said, I just don't expect me to be able to respond for a whole short period.
That's fine. I was just fucking with you. To me, I mean, I don't necessarily subscribe to the whole dielectric. Yeah, go ahead, Dicelo. I was trying to fill your answer. Go ahead.
Yeah, I was just talking about the point source and field coherency. So, like when you look at either side of a magnet, you can see that the centrifugal divergence and the centripetal convergence, and when you examine that under like a magnometer, you could see a spirograph design of light and dark, and wherever you see the light, that's the magnetism, and wherever you see the black, that's dielectric, and those two conjugate expressions create this vortex geometry of magnetism and being this reciprocating precessional hyperboloid, and the dielectric force and motion, inertia and acceleration, magnetic permeability and dielectric permittivity. It's just a simplex expression of defining all fields. So you can't get away from that expression because it's witnessed upon every phenomena pertaining to gravity. And gravity is not a force; it's just incoherent dielectric acceleration, and it's the same thing as magnetic attraction. The only distinction is in the attribution. One is point source, and the other is non-point source. So there's only one conjugate geometry that makes up all field theory, respectively. That being the hyperboloid and the torus is one, and which is the negative image of each other, and that being the magnetic field, and the inverse of magnetism being the dielectric field. And it's just that simple, man. There's two masses accelerating towards one another, towards that null point within counter spaces where you get gravity.
Nice to hear you spitting some knowledge on these fools, Dicelo.
Hey, who are you calling fools?
Pity the fool.
Well, yeah, I mean, they're using assumed centripetal and centrifugal forces of a rotating globe Earth to claim that that's the cause of the weight change with latitude. But that is an entire assumption based upon begging the question of this rotating sphere that they're asserting, whereas in reality we have magnetic fields that are measurable and are inherent in everything, and those fields have centrifugal and centripetal forces and would be connected to what people call gravity as well. So that's something that is actually concrete rather than their explanation of the centripetal and centrifugal being connected to the Earth rotating and the gravity vector.
But even in that context, I would say it's still begging the question. I mean, to me, the dielectric, like the incoherent dielectric.
I would say the only difference between gravity and magnetic attraction is that in the case of magnets, they're multiplicative point source objects accelerating. So the intensity is many magnitudes greater than that of common objects accelerating towards the null point in counter space. So mere masses of the conventional kind are point non-specific or incoherent objects, and gravity doesn't exist. It's not a force at all. It's no different than electrostatic cling or magnetic attraction, which isn't actually magnetism at all. But and that's why you guys are so perplexed when it comes to fields, because you guys just don't understand them. And gravity is literally the gravity field that you guys is literally an anti-field. That being an attribute of a divergent magnetic field.
Hey, Coach, are you there? I'll check back in later.
How's everybody's 2023? Y'all doing all right?
Not a lot of difference. Same old, same old. How about you? Any good news?
Yeah, it's just a new year. New hopes. New dreams, maybe.
Seems like normally I'd hear people kind of discussing it more, but honestly, at work, on Discord, whatever, right? Just out and about, like, I'm not hearing the lines that I would normally hear, like, oh man, I can't believe it's 2022 or like, there's just certain like lines that I've heard my entire life. And I don't know, it just doesn't feel like anyone's really discussing it like they normally would.
They're sick of it. Things are changing, and that's part of the change. It's still new. It's I mean, it's new in a different way, I guess.
I don't see anything new about 2023 from 2022.
Did you ever see anything new in the past New Year's? I mean, it's
kind of
subjective,
felt like it. But yeah, you're right.
Yeah.
Feelings. You got any New Year's resolutions, Egypt? Gonna be a better person this year?
Never did. Never will, but
yeah, I never really did that sort of ritual either.
Yeah, I'm not like playing down. I'm not saying it's wrong to have resolutions, New Year's resolutions. Yeah, that's fine.
Not that you should save any sort of like self-bettering like attempts for one particular like starting point in the year. I mean, if you want to be a better person, you don't need to wait, right?
Well, yeah, I mean, theoretically speaking, but knowing how the human psyche works, I mean, this is literally what we would look for these new beginnings to actually give these resolutions, and it plays a part in our psyche. Like, that's how we work. That's why we need these kind of like New Year's kind of and season changes. Like, if you go down to the biological sense, if you know what I mean.
Sure.
Like,
yeah.
I would say it is part of human existence to aspire and have these changes. That's how you
feel you.
Yeah.
Yeah, I totally feel you there, especially in relation to like the seasons and the psyche and natural cycles and stuff like that, and how it kind of has an impact on us. But let me ask you, man, regardless of New Year's, would you want to share? I'd be interested in hearing if about any aspirations you have. You got any goals that you've decided, like I'm going after it. Like you got anything that you just like decided to really put some effort into going after, whether it be thought of after New Year's or before, but something you're kind of working on, like a project or something?
Well, this could get too personal, but in
Well, you don't.
essence,
That's your
yeah,
choice.
yeah. I mean, in essence, it is the cliche, right? It's the aspiration of just becoming a better person, providing better for your family, and so on and so forth. Like, I can't give you any new insights if that's what you're asking for, but
Like anything specific though, like you're after a raise at work, or you're after like, oh, there's this painting I've always wanted to make, and like it's been on my mind a lot lately that I'm gonna fucking finish that bitch, or I'm gonna make a YouTube video on a certain topic, or I'm gonna, maybe renovate a room in my house. Any sort of big plans you got?
well, not really. But yeah, I mean,
Maybe you should
I've
come up
been
with one
kind
then.
of yeah. I'm at that point in my life where yeah. I mean, I've been on and off work. Like I've had a previous career for 12 years of my life, and then I unplugged from it, and then for the past 2 years, I'm trying to find myself again. Like if that's how I
Yeah,
would phrase it, but yeah, I mean,
trying to find the invisible man.
exactly. And yeah, I
Yeah.
mean, just finding my purpose, finding where I'm supposed to be. That's what I'm trying to like aspire to, I guess.
I told someone before. They're like, "Oh, I haven't talked to you since way back in the day. How you been doing?" I told them that I found myself, and they said, "Holy shit! Any advice on that? I wish I could do that."
Yeah, of that. I don't believe you. Actually, did you?
You don't believe me?
No, I'm being jealous here. Because yeah,
I mean, what does that really mean? Because as far as I view it, like I've done it. Like at one
well,
time, I was lost, and then I found myself.
I guess yeah. I
Thanks,
mean,
Paul, on
that
that.
would be yeah. That would be the difference between you and me, right? I thought I had myself for most of my life, and now I'm lost. Like I'm 36 years old, and now I'm being lost. Where I thought I was like I had a how you like I like you
Foundation.
said, yeah, a foundation to fall back to. But now I'm out there. I'm completely lost.
You're
Trying to
questioning
find
the
myself.
foundation. Well, I'll tell you what, man. Ether will always be here for you. All right.
Yeah.
Whenever you're willing to come on over.
Oh, yeah. Well, I'm always willing. I'm open to everything. You know me, but yeah, like I need something rock solid for me to have a foundation.
You ever read the Kabbalion?
Nope.
Hey man, read the Kabbalion. You get an audiobook on YouTube easily. It's not very long, honestly. Like maybe like an hour long audiobook, maybe 2 hours, something pretty short. Or read it yourself, even better. Free PDFs at the ready. Like it's not hard to get your hands on a copy of it. And if I would say that there's one book that with a little bit of a choice of words that I disagree with, but honestly, really just choices of words that I disagree with. But as far as the content in it, for almost entirely the most part, I'd say I've never come across a book that I agree with more.
Yeah. I had someone in the text chat tag me and say almost exactly, feeling lost, come to Jesus, bro. He loves you. I appreciate that. I'm not lost religiously. Like, I'm trying to express. I mean,
The
it
Kabbalion
is
isn't a religious text,
no,
the
no,
way I
no,
view it,
no.
anyways.
I'm just yeah. I'm just addressing that that exact comment. Um, and I'm trying to be more specific where I'm lost. I'm lost when it comes to my profession, where I'm gonna make money. Basically, that's where I'm lost. I'm not lost anywhere like other aspects of my life. It's just the profession part.
So
I've been doing on and
let me
off
ask you.
jobs for the past 2 years. Different fucking shit. I've done so many different shit. It's weird as fuck. Like, compared to my, like, I did the same job, like I said, for 12
Yeah.
years, or basically the same career, right?
Let me ask you a question about that.
Yeah, go ahead.
So I'm gonna like put words in your mouth or speak for you. You just tell me if I'm wrong. You have options available to you, so accessibility isn't the issue, right? Like, you have options.
Yes, exactly. I mean, that person also said get a degree. I mean, the reason I had my fucking career is my degree. I did corporate banking for 12 years. I'm trying to find something outside of that.
All right. So next question. You have options available, but if I know you like I think I do, it isn't a lostness in the sense that you just can't make up your mind on which one to choose, right? That's also not the issue. It's like, oh, I have options, but I don't know which one to choose. That's also not the problem, is it?
Yeah, exactly. Yeah. I think
Are you
understand.
looking for an option? Are you looking for an option out there that you wouldn't necessarily know what it looks like if it even is out there?
Exactly.
But all you know is that it's outside of the options that you are aware of, because you've analyzed
which
each
is
one of
fucked
those
up.
and
Like, it'll
recognized
get
that
you.
none. You say none of these are it. None of these options I'm aware of are the thing that I want, even though they are accessible. So if you could say three things relating to a career, that just three qualities, not to say you can sum it all up in just three, but three that are like necessary qualities in the career you think you would want. What do you say, just off the top of your head?
Something that I'm passionate about and keeps me on my toes and makes me want to do more, basically.
What do you mean by wanting to do more?
Like, just being as passionate, like having this constant passion about it that I'm not going to get bored of, or just like do for the money. Like, I need to be constantly have this drive for it. It's something that is within me that just keeps me
That says to me
going.
though? Says to me though, and I'm with you, but because I feel the same way. But what that says to me is that you're not looking for one career to satisfy that desire, but you're looking for a path that involves a career that then leads into a different career. Because I don't think you would be satisfied being confined into the limitations that any way of making money would allow. And you're looking for something that then leads into a transformation into like something else, but not necessarily just a climbing the ladder, but like and this isn't it, but like, say, a high school yearbook photographer that then will then eventually start his business doing wedding photography, and then go into, and then make his money there, but then, transfer into some like even like commercial photography or something, even though that is kind of linear. I think you just
No,
want
I
on
get
evolving
what
and
you're
growing.
saying, and yeah,
Yeah.
that's pretty interesting the way. Like I never looked at it that way, but that's what I've actually been doing for the past 2.5 years. Is getting into just different shit, but not really. Like I wouldn't stay too long in that path. I'm still looking for. I don't know what the real end goal is, but I'm just like I said in the most broadest term, which I was relating to when you brought it up earlier, is finding myself. Right. Well, what does that mean? Like, just trying to find my place in the professional world where I can make money. I'm satisfied psychologically, spiritually, and monetarily, right?
Mm-hmm.
Yeah, and I haven't found that yet. That's hence the
I think
term I'm lost.
I think you'd be pretty happy as like an entrepreneur who starts a business, brings it to success, and then sells it off and takes the money that you gain from selling off a business you started, took it to a certain height, sells it off to someone else, right? Takes that money and then follows a different passion after that. Like that's to me what sounds like would satisfy you. Bringing something all the way to fruition, selling it off, and then going on to a even like a different dream, but funded and launched off of that first endeavor. You know what I mean? Sort of like Elon Musk, if he were to like say have made SpaceX, sold it off, and then started the Boring Company, and then brought that to fruition, and then sold that off to someone, and then bought Twitter, and then made Twitter great, and then sold that off to someone, and then moved on to something else. To me, that it sounds like you want to be like that sort of entrepreneur.
Well, so sounds about right. I mean, as an aspiration.
So I mean, have you ever thought about starting a business of any sort, or have you done that before?
Oh yeah, kinda, but didn't have any success so far. But
Well, don't
yeah,
let
I
that
mean,
stop you from trying again.
exactly, and that's the path I'm kind of following, and yeah, I don't want to
You ever
hog
thought
the
about
mic too
you ever thought about
much.
relocating?
Yes, actually, and
Well,
I'm working
why?
on that.
What are your thoughts on that? What's the draw towards relocating? Is there like a clear
Well,
goal that it's in like
kinda,
relation to?
yeah. I mean, I live in a third world country. Just the economy's going to shit.
Is Egypt a
Opportunities are.
third world country?
Yep. Oh
Oh, I didn't know
yes.
that.
I mean, if there were a fourth world country classification, that's
Oh,
where it would be.
jeez.
Yeah, I mean, economy right now is just fucked up. But anyway, yeah, I mean, the opportunity, because my grandmother was British. I'm filing for the British passport. Filing this lawsuit. There's this
Oh,
literally
holy cow!
legal loophole that I fall into, and in like 6 months, 9 months max,
Let me
I
ask you a
would
question.
be a UK citizen.
Yeah, that's cool, and I hope that works out. But let me ask you a question. If you're one man, and one man can only do so much in a day, and we all like to think that holds us back. Like, oh, it's just little old me, and there's only so many hours I'm awake, and some of that's I'm having bowel movements. Some of that I need to eat 3 meals. Oh, and I also don't want to like all work and no play. It makes Egypt a dull boy, so I need some time to relax and just like have some shut off my brain. Oh my god, I'll be right back. Mic check. Coming through?
Yep.
Oh, shit. No, it isn't working for me.
Oh man, that was funny.
All work and no play makes Fundy a dull boy.
Okay, so I got a phone call, and that always messes up my Discord settings. But I'll continue. Sorry about that. Anyways, if I were to say to you, well, guess what? Some legal and acceptable way, I give you 10 very skilled slaves. And I know that's like a fucked up sort of like thing to talk about or whatever, like slavery. However, let's just say you had 10 rich friends. They'll never give you their money to help you out, but they will be free like 12 hours a day, and they will follow any orders you give them. Because let's just say I'm one of those people, right? I have shit to do. I have a job or whatever. But let's just say, hey, Egypt, I want to help you fulfill your dreams. And I have a cloning machine, and I got free time, and the clones I'll make, they have free time. We are at your service. What if I said you have 1 week, and me and my 10 clones, very skilled individuals, we are at your disposal? What would you do with a team of 10 people to obey your commands?
Well, that's a tough question, but I'll tell you what. Like one of the things I've been passionate about, and I've been trying to launch, like my business through the industry. That'll be food.
Like a food truck or something, a restaurant?
Yeah, exactly.
Cool.
Delivery.
Cool.
Cloud kitchens. Kind of a business of that sort, just in the food industry. Because
so what would you order your 10 slaves to do to help you on that endeavor?
Well, just complete the team. I mean, that's what I need. I need a team to cover all aspects, right, of a business. And,
okay, what's one role?
Well, there are so many roles, but one role would be, let's say, the financial aspect.
You got 10 people.
Yeah, the financial aspects, marketing, operations, and so on and so forth. But yeah, like as a start, I would be willing to fucking go all the way. Like I get my hands dirty and do everything, and that's the kind of person I am. You know, I'm trying to do everything. But yeah, like you put it, I mean, having a team, that's how a business actually establishes itself, and that's how you become, rather than self-employed, become a business owner. If you create a right team to run your business where you're not needed there, that would be my end goal.
Okay, so that's like that's in-person slaves, and I guess what I was really trying to ask is, like, sort of just over the internet. Like, if I volunteered, say, hey, I'm free for the next week with nothing else to do. I can't come to Egypt, unfortunately, stuck here in America. But is there anything I could do for you over the next week, just through an online connection? We can face chat, voice chat. You can give me a task. I can't come there and like lift boxes or do anything for you, or give you money, but I am at your like online disposal.
Yeah, information.
At your
I mean,
service.
information is key. I mean, yeah.
What would you tell me to do? What would be like the first thing you would ask an assistant to do for you to follow that dream? Like,
well,
figure
it
out some like
depends.
laws, like figure out where and how to like register for licenses and permits and stuff.
Well, exactly. Things like that you would never be able, like for someone who's not in Egypt and has no connection with Egypt, for example.
An American can't figure out laws in Egypt.
No, because there are no fucking laws. It's the laws of the fucking jungle. It's insane.
Oh, that does suck, honestly.
Yeah, there's no way for you to get information about it, and that's not how it works. And
For
the
real?
way
I
it
can't even
actually.
use
Yeah.
like a VPN to, I don't know, change my
No.
online location or something.
I mean, the locals themselves. I mean, it's all corrupt. It's all bureaucratic bullshit. Like for you
Damn.
to get permits and licenses, you need to pay fucking bribes. You need, like, there's no real strict rule. There's nothing on paper. Like, there's no real way. I mean, there is on paper, but in actuality, that's not how it works. So,
Oh, okay. Well, you can't be
in that
involved in
sense,
that sort of environment. You got to get the fuck out of there.
good advice, I guess. But
Yeah, I mean, honestly, the way it sounds, if that's the situation and circumstance you're in, like, yeah, first thing would be get the fuck out of Egypt, I guess. You can't work within an illogical system to that degree. You need something to use as a standard. Yeah, it can't be all wishy-washy, unfortunately.
And at the
Or else it's
same
just
rate, at the same rate, you don't want it so overly complex to where it's like hard to even start
like
a business
overly
yourself,
bureaucratic.
without having legal counsel to perceive everything on top of all other requirements to have a successful business. Like now you're finding yourself, like I'm just thinking in terms of like the cannabis industry, for example. It's navigating that whole industry, certain types of legal counsel, not even just your everyday average legal counsel. Like,
yeah, it's hard
just
alone on itself as an industry, let alone if you have the other obstacles like I
exactly.
mentioned. Yeah. No, I completely get it. Yeah. Just laying it out as it is. And I have the same opinion as you guys. Yeah. Definitely.
Yeah, it's just two different polar opposites, I guess, of perceiving. Like here on one hand, you got this like things done off a handshake and corruption, and the other is just like over complexity of a legal system in order to support the business model. Like you have to navigate all this red tape in order to legally conduct business here.
Yeah, but at least there's law. There's a route, a clear cutout route for you to take. It might be hard for you to
I wouldn't say it's
follow
clear.
that.
It's fairly gray, and it's all depending on who you have writing up contracts and how they're able to navigate that and perceive it and use it to their advantage within that setting. Like dude, it's so complicated, bro.
Yeah, no, I agree with you. I mean, it is in a sense subjective, but what I would say, like comparing, let's say, Egypt to the U.S., I would say the path is much clearer in the U.S. If anything, like in the most basic sense.
It's predictable to a larger degree. I'd say that.
Exactly.
Right. Now, which one's more practical? Like, as far as even getting the business off the ground, I would say, you probably would have an easier time establishing something there in that setting. Not that it would ever thrive. Establishing it, probably better chance.
Well, I mean, I would have agreed with you a few years back, but the way things are changing here exponentially with regarding to laws and the economy, it's just things are going in so many different ways really quick. It's just it's confusion. It's like I don't know if you know much about what's going on with the economy here, but yeah.
No.
Anywho.
Telling you, bro, get that crypto.
Get that crypto. Get that fucking crypto.
Yeah.
I could go to jail getting that crypto.
Sir, what is
Yeah.
your favorite cryptocurrency?
Well, I think they even got brokers now, Egypt, that you might even be able to reach out to some sort of a third party that could facilitate within acquiring that and even probably hold it for you. Not that you would ever want that, but I'm just saying there's just possibilities of things.
And which cryptocurrency do you own, sir?
Me particularly, I'm pretty diversified as far as what I'm holding. And then I got my favorites from there. But yeah,
Do you hold
things
any
with utility.
Chainlink? Do you know about
Do I hold
Chainlink?
what?
Chainlink?
Chin link? Oh, chain link.
Chainlink, yeah.
Yeah, I got some chain link. Yeah, I bought into that years ago.
Yeah, I think it's gonna do really well next cycle.
Yeah, I mean that's got practical application, so it's not like just some bogus crypto like 90% of what's out there. So I think that's definitely one of the good ones. And they've always been fairly perceived to be that. So um yeah, things like IOTA, just Stellar, XRP.
Okay, IOTA, Stellar, XRP, those are kind of shit coins.
I mean, it's in terms of like how they're doing based on price alone, like the price charts, like maybe, but I think as far as like what they've set out to do and could possibly achieve, I think has practical essence, and those are the things that I think are gonna last through the crypto apocalypse to come. You know about that, right?
The bear market?
No, not the market. I'm just talking about the regulatory clarity that's encroaching upon the market.
Well, sir, you cannot regulate math.
Oh, okay, you're one of those. You think it's all just digital pixie dust?
No, I'm saying you can pass a regulation, but the fact is we're still going to be able to do it because cryptocurrency is just math.
Yeah, well, I'm not talking about what you can and can't do. I'm talking about what's going to be legally perceivable for institutions to navigate themselves on.
Wait, I
Well,
want to ask a question, the truth seeker. Is that different from regular currency, like the dollar? Is dollar more than just math?
well, the dollar is just numbers on a computer. The dollar has no math. It's not a consensus. The dollar is owned by the Federal Reserve. Cryptocurrency is decentralized. Cryptocurrency uses math because it uses cryptography.
So, like, are you rooting for the survival of crypto, or are you against crypto? I don't get it.
I'm rooting for the survival.
Do you think crypto is gonna overtake the traditional currencies over time?
Maybe one day, I mean. I definitely think they're just going to keep printing traditional currencies. That's why it's going to get worse and worse. I mean, in 2020, they printed like 40% of the circulating supply of US dollars, so that's quite a lot. So it's not sustainable.
But that's been going on for hundreds and hundreds of years. And
Well, actually, it hasn't been going on for that long.
no?
We only abandoned the gold standard in 1971. Before that, we weren't printing money like crazy. So that's only been 50 years, but we've been in this paradigm.
Yeah, I got to do something fast. Pretty.
Right now, Chainlink is working with SWIFT, the international money
Yeah.
settlement.
Transfer. Yep.
Yeah, they're gonna have cross-chain interoperability.
I think they already do, man. I mean, maybe in a local sense in some places, but on the international, like Swift kind of thing, maybe it's not been implemented. But yeah, blockchain technology has definitely made its way to banks, at least in the local sense. Maybe in some international circles, but definitely in a local sense, it's already been applied. Not just the banking, but yeah, with regards to banking, it's already been, like, from my experience, I've seen it locally been implemented. Blockchain, that is.
Oh wow. What did they implement? Chainlink or XRP?
Actually, neither in my situation and my knowledge. Locally in Egypt, it's this I forgot the name. Fuck. It's neither Chainlink or XRP or any of these, but it's this it's an independent network that uses blockchain, and transfers now locally are fucking instant. Like, when I say instant, I mean instant. Like, you transfer from one bank to another locally through this network, and it's literally instant, which didn't exist a couple of years ago. Now it's there, and it's blockchain. I forget the name of the network, but yeah, it's already in like applied across things in other industries, logistics and things. But yeah. I'm just speaking from the banking perspective because, yeah, I had a career in banking, and the only really instant transfer was that done internally within the same bank. Never was there an instant transfer from one bank to another, locally or internationally. That never existed.
That will exist very soon, sir.
Yes, like I said, it already does, from my experience locally, but I'm pretty sure it's already been at least implemented in some international networks.
If it's a transfer between the same bank, like, the money probably didn't switch accounts. It probably just, the same bank owns it, so they probably didn't transfer money. They probably just subtracted it from your account and added it to the other person's.
Well, it's still a transfer, though, in a accounting sense. But
yeah,
no, I know what you mean.
Pretty soon, international transfers will be instant.
Yes. And like I said, if not really already implemented through certain networks and with certain banks who've like established this kind of network, which I'm pretty sure it already exists. But nothing on the international standard like the SWIFT, like you mentioned earlier. The SWIFT system is what banks use internationally. Like two banks who have no relations can use the SWIFT system to make these transfers and are in no way instant. It depends on like the nostro and vostro of these banks, and yeah, it gets too complicated. But yeah, in the most basic sense, I would say that like yeah, the technology has not made its way to the regular just bank-to-bank transfer on the international standard where you can do it instantly. That does not exist in that sense. But money's just paper, bruh. Or numbers on a screen.
Money is power. Money is
Power.
power.
Yes. In today's capitalistic
I always thought
world.
knowledge was power, and money was just the amount of work that goes in to determine value.
Medium of exchange.
Yeah, like gold, for example, requires a certain amount of energy and work applied, because it's not just readily available. You have to actually do something to extract it. And that formula dictates and determines the value of the item. You like quantity and demand.
Yeah,
money is definitely symbolic, right?
No, in the traditional sense, like Dyslo said, mining gold would fit that standard. But today, with today's technology, it holds more true for the idea of knowledge being power, right? We're in the knowledge age, where information is value, and things like crypto, like mining for crypto. Ironically, it's still mining, but yeah, holding to the same standard. So traditionally versus
There's a calculable amount of energy input to get the output of the value based on the work and energy required to achieve that algorithm that equates to one token. And then there's a lot more obviously that goes into determining a value of something, but
it's like how finite that thing is, for example, is another aspect. How much of it is readily available, right?
Mm-hmm. Yeah. And then the demand of that item versus the quantity of it and versus the energy required over time to extract it. Yep. But not anymore.
Exactly, not anymore. Now you get AI algorithms, you get shit to calculate that shit for you and predict. And yeah, just see market trends and so on and so forth.
I think
Behavior.
even that still follows the principle, but what I was referring to is more the sense that they pulled us off the gold standard, and now there's really nothing to support the value of the dollar, and that's kind of why it's been falling over a course of the last 100+ years. It's just on a downward trend.
I would say the difference is one was a material value versus a perceived value, but it's still value in essence. But yeah, I agree with you. like what gives the dollar its value today is its perceived value, how the U.S. economy is doing and so forth. It's perceived value rather than material value, like a gold standard.
But yeah, I got high hopes for crypto, dude. At least I'm getting rich off it.
I got high hopes.
Kids love that song.
Do you have any NFT?
Nah, I don't really feel the necessity so much for the thing. I think it's like with the metaverse, and I think that's like further out than people think as far as becoming a possibility at having anything fruitful from it. So no. Long story short, no.
I have one.
Why?
You say why? Well,
Yeah, why do you have an NFT?
because I think it's kind of cool and I like it.
Yeah, just like for emotional comfort. Then you don't think it's gonna like
I think it's
do anything
more of
for
an
you?
art thing. It's
Yeah,
like a non-fungible
well,
token
Hey,
within
I'm not poo
like an
pooing on
art.
anything. Yeah, don't get me wrong. But like like in a general sense, why would one purchase an NFT? Like there's like
well,
a future plan, right? Where like, oh, I'm gonna sell this off for more than I bought it for someday or something like that, right?
yeah, well, I do think that will happen eventually, but I made it my profile picture on Twitter, and now a lot of people are following me.
Some NFTs also
Okay.
make passive income. They have like residual income linked to them. There's a lot of different uses.
Yeah, but yeah,
That's wild. I
I would
never knew that.
classify.
They even
I
have
would classify it under art.
there's
Definitely.
like this one called Step App where you actually buy these shoes. You buy the special shoes, these tennis shoes, and the tennis shoes have an NFT linked to them. And then as you walk or run in the shoes, you get paid in crypto. So that's an NFT an NFT system that pays you for walking.
Yeah, it's part of the influencer kind of market and things like that. It's
Yeah, but where do they get the crypto to pay you, right? They have to be just like increasing the supply of one crypto, right?
Well, it all depends on the crypto. I mean, yeah, generally a crypto that regulates its own circulation supply willy-nilly is not the kind of thing you want to invest in. Those are like one of the telltale signs of something being potentially corrupt
Ponzi
or
scheme.
just a Ponzi scheme or yeah.
Well, I think with the Step App one, I think you get paid in their token, but I think they also have like a whole store as well that you can buy like they have like a marketplace. And so I think they have other ways that you can make money. They have games and stuff you can play. And I think there's other there's competitions that you have to like pay to be involved in. So I think they have other ways of making money. Cause yeah, you would think like, how are they paying people out if you just run around on their shoes and make money? But yeah, I think there is some kind of other ways that they link it in with their whole kind of ecosystem.
Again, perceived. I mean, it is a pyramid. Like what you're explaining is exactly. I mean, these scams have gone on since the internet has started. These marketing schemes, pyramid schemes, where like oh, there is a real product, right? We're selling, but what they're selling these product at overpriced fucking, it's still a pyramid scheme. Like you tell a friend, you get a commission and so on. It's all a fucking scam. There's no real value to this shit.
I guess my mind is still thinking about the whole big conversation we had earlier. I was going to ask Dyslow, like, and we can stay on the other topics as well. I stepped away for a bit, so I'm not sure if you guys were on some other topics, but so we don't have to totally go back to this. But I was going to ask, like, Dyslow, what do you think is the causing the weight change at latitude? If you had to speculate, or what do you think that is connected to that?
I would say it would be the magnetic field connected to that. That would be my speculation.
Yeah,
we would have to go into defining what weight is, and I think within the definement of weight, we would see the correlation.
Yeah, and then it's connected to like a gradient from, let's say, from the North Pole to the equator, and then from the equator outwards, that there's a gradient within that field that has those variations within it.
Sorry, dude, I was dealing with kids. What'd you say?
I was just saying, in that perspective, that there would be like the idea, like there would be like a gradient from the North Pole to the equator, and then from the equator outwards, but that there would be a gradient that would then be the reason why it's different at the different latitudes.
Yeah, I mean, has anybody measured that difference all the way across those lines?
You mean like testing every one, like a full test through all of them?
Right, like all the way down that equatorial pathway or whatever it may be.
Hello? Mic check?
Yeah,
you're good.
Yeah, I was wondering about that topic earlier because, I mean, what do you guys think about that an object varies its exhibited weight when its temperature varies also? Wouldn't that be the case?
Well, I think we really need to dive into all the potential variables associated with weight and actually what weight is.
Right. Couldn't you rebut the latitude change in weight being a sole cause of what they were saying, centrifugal force? Isn't it possible that a change in a gravitational force would give you the same exact principle?
No, because invoking gravity is invoking their model of it, which would
No.
not
I'm not
agree with
saying
my.
necessarily their model of it, but
Well, I mean, you said gravity, so.
well, gravitational force, like the universal law of gravitation, in my opinion, is in no way dictated specifically by some sort of specific shape of an object, right?
Well, gravity is inherently spherical because it's omnidirectional.
Can you explain how gravity is has been proven to be omnidirectional?
Of course not.
It
Gravity
works in all
doesn't exist.
directions, sir.
What do you mean it works in all directions? Can you give me some sort of example of this?
Well, I mean, U-orbit.
presupposing a globe. Yeah, with
Well, have you seen
exactly.
the ISS orbiting?
Well, the
ISS orbit.
idea of the ISS, where it's at and what it's doing, is certainly not necessarily confirmed. Let's say that's a point of contention, right? So, without presupposing or presuming a globe and a sphere, can you give me an example of gravity being omnidirectional?
I mean, it's kind of hard if you take away all those possibilities. Like,
I don't know. I think it's a malformed question. I mean,
yeah.
How does gravity not exist without the sphere, and vice versa? Like, I was more interested in Isaac's and comment there. What did you mean by temperature? And like, if you can tell us more about that.
I'm just saying that maybe the temperature influences the object you are weighing. You know, because for example, if I just put enough heat into my block of ice, I wouldn't be able to weigh it anymore. It would just go into the air.
Oh, and you're saying that there would be different temperatures at different latitudes?
Yeah, sure.
Yeah. It's also a different distance from the sun, different
Right.
radiation from the sun. That's interesting. Yeah. Well, technically that could be temperature controlled, but there also may be other environmental factors like connected to that distance from the sun as well, like barometer and other changes connected to that distance. Because we all know how different it is. Like if you're in northern Canada versus, the Caribbean or something. I mean, it's just a dramatic difference in a lot of factors of the environment, more than just heat.
Yeah, but actually, I would say temperature. Like, I would say I would guess. I'm not saying this for a fact, but I would guess temperature with, let's say, state changes. Like, if you have a certain amount of gas being turned into liquid, I'm pretty sure we've already established the same quantity weighs the same when it makes a state change. I mean, that would be a given, but that's just me guessing. But yeah,
I would agree that would be one of the variables. That would fall into phase, and as being one of the variables.
Yeah, I feel like there's a ton of variables that would need to be tested. Did Bob actually do this experiment? I asked him to DM me his results, like his data, but he never did. Has he shown that he's actually done this himself?
I wouldn't take anything Bob has to say with seriousness.
Well, he said that he had. I just was curious if anybody knows whether he has or has not, or if he was just claiming, kind of like the proverbial we, right? Like we went to the moon kind of thing. I'm not sure what he was claiming there.
It looks like he posted his video earlier, and I'm skimming through it, and I do see him sitting here with weights on a scale, and it looks like he's got a little map showing that he did it in Panama City and then up in Detroit, Michigan.
So same scale, same weight?
different weight, I guess that's what he's saying.
What kind of scale is it? Is it a digital, mechanic?
Yeah, I think all those might
digital.
Did he in his video? Did he state that he zeroed it at one specific latitude and then never zeroed it again? Or is the claim that you zero out the scale at every specific latitude and then weigh an object?
I don't think you would want to use a digital scale because of too many variables with that, such as tearing it as being one of them.
Does anybody remember the name of, there was a company that makes scales, these highly sensitive sensors that can sense weight, and they did this test with like a little, I want to say it was a gnome, like a little concrete gnome that they sent all over various random places throughout the world and like weighed this gnome all over the world, and it certainly didn't give consistent weights as far as latitude was concerned. Can't remember the name of the scale company that did that. Has anybody heard of that?
No, actually not.
I'll have to look it up when I have a second.
So it just came into my mind because I was reading before about like the pendulum evidence, which has been brought up throughout the years, and I read in all German literature about it, where the author emphasized the aspect of that the pendulum, when the temperature increases, would expand from its material and so cause a deviation, which is interpreted exclusively as rotational evidence. But if the material of the, for example, I don't know, metal parts of the pendulum would expand in different conditions of temperature, then you won't get a consistent reading as well. And since the
Yes.
pendulum is well connected to the laws of free fall and all this stuff, I thought about the weight change on latitude as well.
Yeah, I mean, in that context, now it makes sense to me. Yeah, yeah. That would be a valid point and interesting, definitely.
Yeah, I wonder what the difference was in weight on Bob's thing. And that is a good point. I mean, I notice in the wintertime or when it's extremely cold, like everything tends to be dry. The air is really dry. So you have this lack of humidity. I wonder if that has an effect on the weight, right? Just the moisture level of the object itself can probably fluctuate slightly as well. I mean, in order to really, yeah, I feel like there's a lot of variables that you would have to control for. I feel like you would have to measure at the various latitudes with the same kind of conditions as well, even taking into account, barometric pressure, humidity, temperature, things like that could possibly affect it if you want it to be accurate.
Yeah, it's just ironic that all of their methods, like the pendulum, this weight change thing, it's like these very minimal, minute changes. This globe Earth is supposed to be moving in all these directions at a total of 2.2 million miles per hour in multiple different vectors. But somehow they always just do these just very light little drift, very light, very minuscule little results of these phenomena, like the pendulum or the weight change difference. It's like such a tiny little amount to supposedly try to be picking up the rotation of this massive globe Earth going in all these different vectors.
Yeah, and you would think that, like, how minute it is, they could at least see it plausible that the surface could be stationary and that some sort of background medium could have a movement across it, giving the same effects that they're measuring.
Well, you got to remember their philosophy of science. In their minds, science doesn't, like, they made it very clear it does not prove things, and they're not claiming they've proven anything with any of their so-called quote unquote experiments, right? And that's their way out of the argument. See, they can claim shit with no credence. I mean, it's not proof of anything. It's just in line with what we believe, right? But in their minds, it's not a belief. It's more. It's concrete. But that concretedness is not. There's no credence lent to it. I mean, in essence, they're contradicting like themselves. They're saying there's no proof, but it's right.
There's no proof.
And
Science doesn't prove anything, but here's our scientific proof.
exactly. And,
Don't question it.
Yeah,
So I had to leave earlier to eat dinner, and Bob and Larry were kind of going back and forth about the rotation of the Earth. Did Bob ever actually say that there was an experiment that led towards evidence for the rotation of the Earth at all?
First of all, I don't know, but just to say that repeatedly, it will be down to the usual reference frame sophistry. So in common and ordinary sense, you can just use the Earth as completely stationary and this inertial frame of reference. But in order to prove why it's rotating, then we can assume that it's not inertial and use this non-exclusive minute effects to explain this rotation. But then why we not experience it, it's considered stationary, right? So alone this fact makes this whole topic about rotational experience and experiments so convoluted that that this kind of arguments, I think, are even pretty stronger than in flat Earth argument.
Yeah, I mean these are the kind of arguments that they have no relevance in their narrative. I've said it 100 times, throughout today, and I made it clear. It's their philosophy of the narrative is what establishes what is true or not, and it's not proof according to them. But what is it? We can't really get a clear answer. I mean, at best, Ruif would say it's a logical fallacy, but yeah.
I mean, the word proof is defined as evidence sufficient to establish something is true. So they're saying that science doesn't give out evidence sufficient to establish something is true?
No, only to establish things that are false.
Right. So they can use pseudoscience to assert things that aren't actually true. Yeah, it's such a wiggle, using that wiggle room. Well, Napalm, that was his experiment. That if he said you have to take the Earth is a given. It's a given that it's a globe and that it's spinning, and then because this globe is spinning, it has the centrifugal forces. So the weight change at latitude. That was Bob's experiment the whole time. That was it.
Yeah, because we know how centrifugal and centripetal forces work, and our little so-called experiment coincides with. Therefore, it's true.
Yeah, but
actually, not true. But I don't know what the word is. But yeah, it just coincides with it. So it works. It works. Oh, the term is it works. Sorry. Yeah, it works.
If you try to establish the cause only from the observational effect, and then you prove the cause by the observed effect, doesn't really work, man.
Yeah, I agree with you. That's what we pointed out. But yeah. No, you're right. At least I agree with you.
Yeah, it's like an ultimate begging the question. Because, I mean, that's what Napalm was saying as well. You could make any assertion. You could say, there's invisible unicorns, leprechauns, whatever mythical creature, but let's use leprechauns. So there's galloping leprechauns at the different latitude lines. And these leprechauns have different weights. Some of them are fatter, some of them are skinnier, near the equator or further from the equator. And they're jumping around on things. And so when you weigh things on a scale, the leprechauns are going to jump on your weights and either make it more or less. And because the leprechauns have different weights, and if you just take that as a given, like Bob said, it's a given. So you take that as a given. You could build a whole model around that and then measure the weight change and say therefore it's leprechauns. So it's just a correlation on a phenomenon based upon an original assumption.
And then you build
how you
build a device to detect leprechauns through a means of quantifying. So this device will spit out a value, and that value tells you how many leprechauns were there or unicorns, and now they have verified it.
Yeah, as a flat earther, I would call them unicorns because you know how flat earthers like unicorns.
0.000
No offense, Gio.
0.00666 pounds per latitude degree, and that equals 1 unicorn of force. Could we use that?
Yeah, throw a 666 in there. Might as well.
Yeah, 0.00666 of a pound of change per latitude, and 0.00666 equals 1 unicorn. So therefore, if we measure this, unicorns.
Depends. Could be a leprechaun. I don't know.
A leprechaun.
Oh, but it doesn't prove it though, because science doesn't prove things. So we're just saying that it's leprechauns, but we're still not proving it apparently.
Right. To be honest with you, I don't know if I've ever seen compelling enough evidence that there is this weight change in the exact kind of manner that they're claiming actually taking place from, equator upwards and equator or equator northwards and equator southward. I don't know if I've been shown enough convincing evidence that this is even taking place to begin with to make it be a claim.
No, you're right. I mean, at best, they can pick and choose from several quote unquote experiments to kind of fit that narrative, but there's no single experiment that establishes it.
Because, like I said, the thing about the gnome that was sent around all over the place, like it was anomalous. It was anomalous data at best, right? So it's what is the claim there? If it doesn't match the predicted model, then there's some sort of like geodesic gravitational indifference, however they want to spin it.
No, they don't. That's the whole point. In their narrative, they don't have to spin anything. If it doesn't conform, it just doesn't conform, right? But if it does, you got something on your hands.
The thing about temperature being plausible, I think, is a good idea, right? That it's plausible that temperature could have an effect on weight when we're talking about latitude. What about the idea of, I don't know, is the magnetic pull towards the North Pole, right? Or that magnetic attraction, whether it's technically a South Pole that's in the north, or however you want to look at that, does that increase the closer you get to the pole? And could that be something that could skew your weight as you go north? I don't know.
Right. Yeah.
Yeah. My criticism. Yeah, my criticism would be, regardless of what the cause is, if I have a different reading that doesn't conform with their theory, is that a disqualification of their theory? I mean, they say science disproves things, doesn't prove them. So, I mean, there are many so-called pendulum experiments that have been conducted that don't conform with the globe theory. Are these just what do they say about those? Are is that just an error?
Yeah, unperceivable variable.
I was just now thinking about this, right? So the claim of taking clock up with increasing elevation, the atomic clocks seem to have some sort of difference in how they read the oscillation rate of a cesium atom. So therefore, they claim that this is proof of time dilating. Well, yeah, and
gravitational time dilation. Yeah.
So time is actually speeding up or slowing down depending on your elevation. So if that can be the claim, right, that time is dilating due to this type of force, couldn't there be something similar, right, when we're talking about weight and latitude?
No, actually, at its most basic thing of time, it
Weight is
does not.
dilating.
Time is a concept. Like time cannot be dilating or bending or anything because it's simply a concept. Time. What is time? I mean, it's not physical. It's not. It's just a concept.
It's the expression of magnitudes.
Yeah, we don't agree with
concept.
their idea of time having some sort of physical property that can be manipulated, but they seem to think it can happen that way.
Neither is space. I mean, space is just the same of a construct and a concept as time.
Correct. Ooh, so when you change latitude, you actually, it's the bending and warping of pound unicorns. So pound unicorn bends as you increase or decrease your latitude.
All right. It's a concept of a concept.
Yeah,
Of
pound
the birthing of
unicorn
a concept.
dilation. Yeah. Or maybe we could say unicorn shadows because a unicorn may actually be something that could exist. So we'll say unicorn shadows or pound shadows.
Yeah, it's pretty weird.
Unicorns do exist. We just call them rhinos.
Yeah. I've heard the argument that I've heard a lot of atheists. For some reason, atheists seem to have only a few things that they know from the Bible because they probably haven't read it. But one of them is something to do with unicorns, and that could easily be a one-horned rhinoceros.
Yeah. I mean, in my language, Arabic, the rhinoceros translates to unicorn. Wahid al-Qarn, i.e., one horn.
Are you serious or
Unicorn.
just horsing around?
No, really. In
Oh, really?
Arabic,
So that's a direct
Wahid
translation.
al-Qarn. Yeah, rhino is Wahid al-Qarn.
Yeah, but I don't think a
one
rhino has
horned.
one horn.
No, they have two, but in the Arabic language, that's what they're called. I'm just saying, it's just. I'm not saying it's
your
only
language is
evidence
flawed,
of
dude.
it might be, but
Well, maybe it's
Yeah,
an easier way to differentiate. Maybe it's the easier way to differentiate the animals that do have two horns, which are typically, kind of on the sides of their heads, as opposed to the rhinoceros that has the one huge horn kind of on its snout region, and then a smaller horn, maybe. Because if you called it a two horn, you'd be like, well, we have deer, we have elk, we have rams, we have sheep, all that kind of stuff that has two horns.
yeah, I don't want to get too deep in that because I can get into, but I was just making a point.
Plus, real unicorns make rainbow-colored turkeys. So I don't know, man. I'll tell you, Egypt.
I'm gonna
We had a
cook some oxtail tomorrow.
Nice.
I don't know if I should make some like a stew or a soup. I'm undecided.
What's the difference again?
A stew versus a soup. Like a stew is like a more of a sauce, a thicker sauce. A soup is like, you drink the soup with the oxtail.
Gotcha.
Yeah. A stew involves more spices, vegetables, and so on.
Condensed
A
version
soup,
of a soup.
yeah.
Somebody can correct me if I'm wrong on this, but I want to say, like, especially in the United States, to me, a stew is where you would basically cook your meat within your sauce, right? So it becomes this whole, the juices
Exactly.
from the
Yeah.
meat work into it. Whereas a soup doesn't necessarily. You can make a soup where you haven't cooked your meat or rendered your meat down over time in the sauce.
Well, they only, like you said, soup versus sauce. Like a sauce, you would put over some, let's say, rice, some mash, whatever. A soup is drunk as a soup. Like you drink it, like it's a broth, more of a. It's in the way you consume it, basically. A stew is more, like you said, a sauce.
I think
add that
I think
over.
of a soup as like all liquidy, whereas a stew has like maybe chunks of vegetables or potatoes or something in it.
I like a little soup
Yeah.
in my sauce.
Anyhow, yeah, I'm having oxtail tomorrow. I'm looking forward to that.
Nice. Well, hopefully it's melts in your mouth and it comes out wonderful.
Yeah. Just need to cook it down. Need at least a couple
We had
or 3 hours of.
We had a Muslim guy in here. Muslim guy in here a couple days ago, and he was a Glober, and he was saying how the Quran is doesn't
Is
say
a
anything
proof
about.
of, it's proof of a globe. These fucking idiots. I mean, just like any fucking idiot of any faith. I mean, 99% of the people on Earth believe in a globe. So,
Right.
yeah, 99% of Muslims believe in a
Some of the
globe.
scriptures you talk about were it being stretched out like a sheet.
Yeah, I mean,
And
it's black and white, man. Our scripture actually is, I would argue, the most descriptive of the Earth of all other historical and scriptural religious texts that describe the Earth. The Quran describes it as flat, motionless in all terms and aspects. But yeah, in today's world, you know how people can twist shit, and yeah, it's
crazy, isn't it?
it's very plausible. Yeah, like I understand why. Like I know 99% of Muslims believe it's a globe, but they don't read the scripture as it is.
Right. Yeah.
And the same for Christians, Buddhists,
Right.
whatever.
Right.
Yeah.
Yep. Yeah, it's a problem, dude. And then you ask them, do you believe verbatim and shit? And they're like, yeah, I mean, follow the scripture. And then you turn to the scripture and it's like they're just trying to twist it into what they want or not listen to what they don't find relevant. And it's crazy. Double standards.
Yeah, it's metaphorical when they want it.
Right.
Yeah. There's no consistent way of them reading their scripture.
Right. But to them, they're firm in their faith and whatnot.
You know why?
That's crazy.
You know why? Because science is the one world religion. The so-called science. Yeah.
Right.
That's what it is.
Right. And all science is at this point is consensus.
Exactly.
Like, literally.
Yeah.
It's like rule by consensus.
Yeah, and that's the point of contention of our modern world. Atheists their fallback is science. Like science proves there's no God, right? Like there's no evidence of God scientifically. Therefore, there is no God. And in the same sense, like a Christian, a Muslim, or a Buddhist, science agrees with our scripture and their narrative. So, yeah. Cheers to all the truthers there.
You want a screenshot of my dinner plate?
Yeah. I'm feeling hungry.
What happened?
Dice gonna show us something. His dinner plate. I guess.
Nothing major, just a simple little.
Where is it, Dice
Live stream text 1.
I don't know what that like. Where is that? Live stream? General? You mean? It's not in general.
Live stream 1 text. Just says that's what it says.
Maybe you're in the wrong server. Yeah, it's just above the voice channel.
Yeah, posted in general. General in the same live chat we're having. The text chat is called general in live stream.
You don't see it? It just says live stream 1 text chat.
Uh-oh. Rolls. You've got some roll or something. Or else you're in a different server. Like
No,
Jimmy said earlier.
He posted it in there. This is the longest we've ever gone through just for navigation to the chat.
What, in general?
No, dude, it's just right above the voice channel. Live stream 1 text.
Oh, I don't see it. Guess that's the problem.
Maybe expand the category. I don't know if you're on a PC, but sometimes it gets hidden if you minimize the whole category.
Wait. No. Live stream. Nope. I only see general in the live stream. Oh, wait. Shit. I'm the one on a different server. My fault. Yum. Are these mushrooms?
Yeah, mushrooms, some pasta there, garlic bread.
Yeah. 4 goes on the left plate. Just FYI.
Hey, what's up, fellas?
Hey,
Hey,
Good
what's
White. Is that Good White?
up?
Hey, what
That
up,
is,
bro?
dude.
He's
Hey,
now
not
Harry
much, man. How
Johnson.
you doing?
He's been very inventive with his new name.
Probably in the next 5 minutes, so I might as well make it quick, right? You guys don't need to know how I'm doing, right, with my life or anything. So it'd probably just be best that I just cut to the chase, right?
Yeah, he sent me a DM, said flat Earth is over, we're all done. Let's hear it.
Jeremy comes in swinging hard, bro. Yeah.
Bro, you
So
sent
should
me
I
a
just?
DM, said I'm
Should I?
done, it's all over, or something.
All right. Yeah. So here's what I got. Right. You guys may have watched this video, but I'm gonna go ahead and share it with you guys in the chat.
Yeah, no offense,
Oh yeah,
Good
I don't
White,
have
but
I
that's your
don't have
problem.
privileges to share.
Yeah, your problem is that your stance can change overnight. My
No,
stance hasn't changed since I became a flat earther. I've marked it down on my calendar. It's October 21st, 2016. And never have I changed my stance.
then
You have changed it at
but
least.
then the
Wait, let me finish. According to my experience, at least 6 times. At least. Go ahead.
No, I think that's being more open to the truth, because if you're just here defending one side, that means you're being biased, and that means that you're not actually out looking for the truth. It's
No, I
more
agree
like
with
you
you.
think you already
Can you
found the truth.
unsee?
No,
Can you
hold on.
unsee truth?
Let me finish.
Oh,
No, let me finish.
here's what the DM said. It said, "Get ready to be a glober. The flat Earth is toast." Verbatim, Good White
That's
Light.
it. That's all I said. Yeah.
Yeah. So
So what I did
let's hear
was I shared the video in the chat, and I'm not gonna really talk about it. I'm just gonna say that I watched that video, and from that video, that's why I believe the Earth is a globe now. It's that simple.
Okay, it's a Sly Sparkane video from 5 years ago. About the equinox.
about it.
It's just an Eratosthenes experiment, dude. Have you seen the video?
Yeah, I'm familiar with it. This is an old one.
So,
Well, Good White, if you can enlighten us, can you walk us through it? In a sense, I mean, not everybody has the luxury of just going through a video and you say,
it's a 9-minute
therefore,
video, bro.
That's fine. I mean,
Like,
but can you summarize it at least? Like just
well, nobody really did that for me, right? Like, I seen the video and I said, "Oh wow, this is demonstrable proof that the Earth is a globe." Now, before that, I never had any dimensions of the flat Earth. I didn't have any dimensions of the ice wall. Just all these ideas that were once thought of like in the early 2015s, 2016s. That was your model, the AE map, and then now you won't see flat earthers uh claiming those aspects of the flat earth anymore. They're just more like, well, we don't know what it is.
All right.
So
Right. Gio, are you familiar with this video, and is it demonstrable?
why are we asking Gio? I mean,
He
we
said he
got
was
good
familiar
white.
with the video. The first question was rhetorical.
I mean, good white himself can't even represent his video. He's like, watch it.
I don't need to, bro. Like, if you don't want to watch it, don't watch it, dude. But if I watched it and I find that it's sufficient proof to prove a globe, you're not forced to watch it. You don't have to watch it.
Of course, I'm not forced. I'm
What was
just
the
asking
demonstrable
you.
part?
Yeah, I'm just
But
was the
asking
I'm
you
sure you're
demonstrable
not
part?
gonna
what
watch
made
it.
it for you
I'm
when
sure
you
you won't
watched
watch
it.
it because then it's gonna question your belief system. And you don't want to question your belief system. You're nice and comfortable where you are. So you don't want anything to change your mind. You're not looking for the truth, dude.
Oh
You're
my
here
God.
to
Is
defend your
that
Gio,
position.
why?
are you
Wait,
there?
hold on, Jeremy. Is that why I changed my mind from Glober to flat earther, but you changed your mind from Glober to flat earther and back and forth and back and forth and back and forth, like at least, like I said, at least 6 times, if not
6 times.
exponentially
It hasn't
more.
been 6 times. I
Oh, it
think it's been
has.
twice.
No, twice. Twice would be from Glober to Flat Earther to Glober. Is that what you did?
That's 3 times. So first I was a Glober, right? Then I
From
went to Flat
Glober to
Earther
Flat Earther,
once.
Oh my God.
change is
Gio, are
twice.
you there?
Like I need to explain that to you.
Yeah,
3
I'm here.
times, dude.
Are
There's
you
nothing
No,
familiar
wrong
you
with
with
this
that.
changed
video he
Oh,
posted, and
twice.
is it demonstrable?
we'll get to the evidence. Yeah.
Yeah. You said it's demonstrable.
Yeah, because they actually demonstrate how it can't be on a flat Earth and how it can be on a globe, how it can only be on a globe Earth. Doing the Eratosthenes experiment. Why is there only crickets? Like,
This is
and
just
just
No,
Eratosthenes. I
it's
couldn't
not
get to my mute
crickets.
button fast enough. This is just Eratosthenes video then? An Eratosthenes thing?
so just like, why do you downplay it? Like, you even know what Eratosthenes did or who he
Do
is?
you? Do
Of
you?
course I know what
Good white.
Eratosthenes did.
Okay, what is
Is that all
Eratosthenes? You
this
said,
is?
oh, it's just Eratosthenes.
Is that all this is
Like,
an
you already proved
Eratosthenes thing?
Eratosthenes wrong? No, that's not all it is, dude.
All right. Well, we'll have to let someone speak on it who's familiar with it.
Okay, I'm
Yeah.
very familiar, but we're not the ones making the claim. It's Good White. So Good White, when you say it refers to an Eratosthenes experiment. Can you explain that?
Why do
How
I need
so?
to explain it? You
You're the
don't
one
know
presenting your evidence. Explain it.
what does it matter? What if I told you I don't know, but what does it matter?
How many
Does that
observers were in
invalidate?
this?
No, that's
No,
good enough for me.
hold
You
on.
don't know?
No, let me go, dude. Let me go. Why would it matter if I do or don't know about the Eratosthenes experiment? It would have no bearing on what I presented. The video stands alone. It does not have any bearing on if I know how to explain it or not.
So are you saying you don't know?
Now, you know what?
Are you
Okay,
saying
I'll explain it. I'll explain it though. What they did was they took 9 different points, not 2 like Syene and Alexandria, but they did 9 points, both south and north of the equator. And what they did was on the equinox, they took when the sun was at the solar noon, at the same time, everybody took a stick angle or just like a measuring stick and measured that angle that the sun was casting a shadow. So they took the height and then they took the length of that shadow, and that's how you get your elevation angle. And then so once you have your elevation angle, you plot that onto the globe, or even onto the globe. You plot that onto just a flat plane, and then from there, that shows like if you do 9 different points and you plot that on a sphere, it'll show that it can only happen on a sphere. All these different points.
yeah? Does anyone want to take this, or should I go?
I mean, be my guest. Let's hear it. I hope you do better than you did with Fight the Flat Earth the other night.
Whatever. So why do we need 9? How does 9 points prove? Like, you didn't explain how it doesn't work.
If you take on you take 9 observations and you get nine angles, if you lay that out on a okay, all right, go ahead.
Okay, so the favorite amongst the flat earthers is the AE map, right? And that's the one with the ice wall on it. If you project all these points on a flat earth map, they all won't point at the sun and point to their angles at the same time.
Nobody claims the AE map. Nobody claims the AE map is the map, though. You know that, right?
Yeah, you do. Don't lie.
I do, and I'm lying. What are you talking about, brother?
When you first
When
watch
have I
flat
claimed
Earth
that?
videos, then why would you claim anything else?
Is there anyone here that claims the AE map is the map of Earth?
Yes, you guys have claimed the
We're
ice
asking
wall.
right now. We're asking right now if anyone's here
when you guys argue against the
what do you mean, you guys? You realize we're not just one perfectly agreeable 100%. We all have the exact same outlook on everything. We're various individuals. You know that, right?
The 16 emergency landings. They plot the
right, but
map and they said,
here's the thing, but you're talking to us right now, so you're roboting.
We can fix this. Is there anyone here that thinks that?
When you convert it to flat Earth,
do you hear us? You're roboting, and do you hear anybody else talking?
We can fix this right now. Is there anyone here that thinks that? Is there anyone here that thinks the AE map is the map of Earth?
No, there is nobody. But
there's no one here.
We don't want to get into that. I mean, so
do you even have a map, dude?
Well, the thing is, wait, this is important.
I want to hear what Skylane has to say. Go ahead.
It doesn't matter which map you use. The thing is, if you lay the 9 observations out on a flat surface, each angle points at a different place in the sky. You have to map it on a spherical surface to get them all to point in the same direction.
Well, that's
a product of perspective. That's a very simple explanation. It's a product of perspective. We have what's called a celestial dome that's used in celestial navigation. The celestial dome is a dome of perspective over a flat surface.
Citation, please. Can you show us evidence of this little personal dome you have? I'll wait.
A good white. Nobody said personal dome, and you're cutting still. So maybe pop out and come back in. That'll fix it.
Yeah, I mean, it's using an assumption of the distance of the sun, and it's using an assumption of how those people, how those different locations of people taking those angles, how those are placed on the surface. It's just making two assumptions. It's like a double assumption setup.
Yeah, and the whole thing, it can't work on a flat Earth, is just it's clutching at straws at that point. I mean,
Well, you kind of have to bring into account that is the sun actually in 9 different places for 9 different people? You know, that would be an assumption. But
yeah, it's
I've heard
perceived.
it. You know, yeah.
Yeah, perceived as such from like there are factors that come into play that from the glober perspective you don't even account for and ignore. And for you to say, are you saying the sun is always where it is? Because you in your own like model, if there is such a thing, but in your thinking, you say there is refraction, for example, like a sunset can appear to be higher or lower than it actually is, according to the environment you're in. So why is that thrown out the window when you're making this certain argument? Like,
well, they generally do this at high noon, and when you've got an observation perpendicular to the gradient, refraction is minimal or negligible in that observation.
So if you have these positions around the Earth, how is he placing them on a flat surface to know that that's the correct flat surface of Earth? That's the thing.
Yes, that's a good question. Yeah,
right. That's where there's an assumption baked in. He might just be placing them on a random AE map, which is what he does. But that's also assuming that that's correct. So yeah, like it's the distance between them and their actual position to each other that he's assuming. And that's already, like, I've always said this. I mean, if you say, you know, Chicago to Dubai or something like that, that is a particular distance, but that's given on a globe model. Like somebody sitting at home in front of their computer is not actually out in the world measuring the soil between those two areas. So he's kind of using like a globe coordinates and then ad hocing them onto like a fabricated flat model that's a straw man, and then claiming that the lines don't line up. Well, of course they don't line up. The original sources of positions that he's using are given on a globe map, a globe projection.
And in all honesty, the assumptions like on a globe versus on a flat Earth are different. Like the position of the sun, like on a globe Earth, yes, like you said, the angles will be negligible from these positions, but on a flat Earth, they wouldn't be. They're not. So you're kind of conflating both models to just like you're using the standard of the globe to dictate what we should see on a flat Earth. It's just weird.
What are you even trying to say, dude? What did
Also,
you mean by that?
Are you talking about QNFE's channel where he uses the Gleason's map and shows you star angles, azimuths, and your altitude angles?
No, Data, you've probably seen this video. This is from years ago. This is Sly Sparkane at the equinox. He had a bunch of his friends take angles at high noon, a solar noon of the sun, and then put them on a kind of like a fabricated flat surface, and was showing the lines not all centering on one point, you know, the sun.
No, I never watched any of Sly's videos because I asked him a question and he lied to me within the first minute of me asking the question. He mocked perspective, which means he knows exactly what perspective does, the apparent convergence. He mocked.
Well, I'm not
perspective.
suggesting that you watch his channel, but this is a video that people have showed for years. I thought maybe you'd seen it flashed around somewhere.
Well, QNF, I don't know if you know what I'm talking about. QFNN or QFEs, whatever, QFNEs. You know his channel I'm talking about. I know I'm not fucking name right, but he's been doing it for years. Anyway, it's not new, but same position. He takes the Gleason maps and then throws a protractor on it. Then he uses a nautical almanac to look at the altitude angles and azimuths of stars and so forth, and then shows, hey, look, you got somebody in Africa, somebody in Brazil, and look, the guy over in Brazil is looking way off into the east, and then Africa, it's 90 degrees. You know what I mean? To a zenith. So there's all kinds of that going on with that particular map. Is taking observations from reality and applying it to the Gleason's map. It doesn't work.
Well, I'm not going to I don't I don't think it's worth like getting down to these nitty gritties, but you have to consider all we got to do is put those angles on a spherical surface and it works. We don't have to do all this other perspective and all these other
That's not true.
Yeah,
That's not true. Left lane. No,
well,
it's
it
not.
absolutely
Left lane.
is true.
No, it's not. So go to QNFE's account too. He'll give you. I don't know what video, but over the years, he's not the only one to show it. But there are angles. If you use the nautical almanac and use the sphere model, and you try to triangulate or try to find parallel positions that match, parallel lines of light that matches the positions equally to two people on a sphere, being that the stars are infinitely distant, so therefore the lines of light would be parallel.
Well,
you don't get the same parallel angles.
Data. You're missing
Nope.
my point, Data.
The globe.
You're
It
missing
doesn't
my
work on the
point.
globe as well.
You can attack what I say and say no, it's not. That's not true. But
yeah, but I can give you an example.
You know that
where
my
you're
argument.
wrong. I can give you.
that my argument. Fucking
I can
hell.
give you examples.
You're gonna have to let me
wrong.
talk, Data. You're gonna have to let me talk, Data.
But I can back it up.
My point is that all we have to do is map them on a spherical surface, and we say that our model works, and that's all we have to say about it. We don't have to go into perspective and refraction, and
it doesn't.
We don't have to do all that.
It's just approximation, dude.
You'll have to demonstrate that. You'll have to
it's a what if.
demonstrate
So
that.
there already is a guy who already does. He shows you both models. He shows you using a nautical almanac. He shows you that the angles to stars and positions using a protractor on a globe surface and a flat surface. There's discrepancy. You don't the same observer seeing the same position to the same angles, so it fails on a globe model as well as it does on a flat map. If they fail on the maps, put it that way.
You've never watched the vid. You're not gonna watch the video. These guys
I watched
just
the video.
took a stick angle, and at solar noon, all they did was take that angle, and from that angle, they plotted it onto a sphere. That's
It doesn't seem in the video like they all took it at noon, because shadows were being cast on their apparatuses, and some of them were like a 1 foot object casting a 2 foot shadow. I think almost half of the people were taking it either sunset or sunrise, honestly.
No, it doesn't work if you do that. It has to be a solar noon to get your angle.
The reason why they're different elevation angles is because the sun is casting a different angle. It's a different length because they're a different latitude.
First off, it'd be best if all of them were at the same latitude, but they're not. They need to be at different longitudes, but for the test to be as well performed as possible, they'd all be at the same latitude at least. And when someone said, "Oh, it's noon, so there's no refraction," well, unless you're at the equator on the equinox, then yeah, there's gonna be a refraction because you're looking at an angle.
Oh my god! You know that refraction only works when you look at the horizon, right?
Excuse me?
You want me to repeat myself? Refraction only works when you look at the horizon.
Excuse you, then.
Okay, so prove to me a citation that refraction happens when you look at solar noon.
Can I be at the North? Can I be at the North Pole?
What's the refractive index?
Can it be noon at the North Pole? You think there's no refraction going on there?
No, because you have these measurements.
Maybe
right?
if you're at the equator. If you're at the equator and it's solar noon, sure. Anywhere else is going to be refraction involved.
Okay, well, let's see your citations then.
Yeah, I don't even think this is worth my time. You can call
Because
that
you don't
backing
have
out or whatever.
any evidence to back up your claim, right? You made a claim that there's
Whatever
refraction.
you, whatever you say, man. You got
Yeah,
this.
'cause you can't
Yeah,
prove it.
whatever
Gotcha,
you say,
brother.
man.
Another gotcha.
Okay, you got me. Okay.
I
Honestly,
got you,
this is a pretty piss poor attempt.
What, that this experiment proves a globe?
It says some things, but it doesn't say ultimately what you think it's saying.
Yeah, because all right.
Just give it a month. You're gonna get some other presentation that's gonna sway you back and forth like you always do, man.
Oh, do you really think that a man can measure the entire circumference of the Earth with sticks and shadows? Do you really think that that's possible? I'm not asking you, Left Lane. I'm asking the other guy.
Why wouldn't it be? Why wouldn't it be
The
possible?
whole entire circumference, you would have to have some presuppositions, wouldn't you? You'd have to first of all think that it would be a sphere to claim that you would have evidence to deduce a sphere, right?
No, because there's no other way it could work. It can't be a cube. Can't be
So-
flat. We already proved that it can't be flat.
So just
it's
so you
not
know, the
flat.
ancients,
So
yeah.
then-
So the
then
ancients,
all the
so the ancients,
all the latitudes point to a sphere. Every single latitude that they measured lines up to a sphere. How can that work?
So just so you know, even in their mathematical equations, because the Earth is considered 2D in Riemannian geometry, that it's two-dimensional in 3D coordinate space. So when you say that, they're saying that the surface is two-dimensional because you can have a 2D surface on a sphere, right? Well, all the ancients knew this in mathematics. Well, the ones that were particularly trying to figure out the globe. The point of the matter is that they suggested that the effect would be both the same on a planar surface as it would be a sphere, because the sphere is a 2D surface. In other words, what I'm going to say to you is you can take Euclidean pieces and put it on a really, really, really large sphere, but you can't take spherical pieces and put it on a flat surface. So what you have to realize is the angle measurement that you're getting is coming from a planar surface. Just as long as you understand that.
I could screen share and like draw a picture to help demonstrate. But I mean, are you open to that?
Just watch the video, dude. Why
Oh, I
can't
watched.
you guys just watch
I watched the video. I watched the whole video, man.
Sly Sparkane's a liar, dude. I've caught him lying, so I don't really watch any of his stuff, man. So if you're going to be convinced by Sly Sparkane, I would be very, very careful there, guy, because this guy's not. I don't think he's really forthcoming.
So how did they falsify it then? You're telling me that they're lying. Where are they lying?
So it's not that they're lying. You have to realize is that there's a presupposition involved, and the mathematics is going to be the presupposition of a sphere, right? So if you can get an angle, let's say, for instance, you measure an angle and you get an apparent altitude to something. If you move a certain distance along a pathway, and you measure another angle, and you have a 1 degree change over a certain distance, you'd have to realize that you would first of all deduce a circle, right? To get a radius, you need a circle. Do you agree?
You're not understanding what they're doing. They're simply taking.
I understand very well the Aristophanes. I understand the Aristophanes, and I'm trying to tell you what the ancients said about this. Not the fact that you can get an angle from a shadow, but the fact that it doesn't matter if it's on a sphere or a planar surface, the results will be the same. Why would the results be the same? Is because you're measuring it on a planar surface. You're not measuring the angle on a curved surface. In other words, between the distance of 500 miles and the angle that's being produced, there's no curve. You understand? Because on a large body sphere, you have to have Euclidean surfaces. Do you understand?
No.
So all they admit in the mathematics themselves is that they're having to put 2D systems inside a 3D Cartesian coordinate system, or a 3D Cartesian system. Sorry, 3D Euclidean space. My apologies. So Bernard Riemann worked a mathematical equation, a two-dimensional mathematical equation to fit inside of 3D Euclidean space. And like I said, I'm going to repeat it again. You can put large pieces of Euclidean sections on a massive sphere, but you cannot take curved pieces and put them on you can't put curved pieces and put them on a planar surface. So all the measurements you're getting are from a planar surface. So you're getting all the angles on a flat surface.
You see those lines that they put on the sphere? It works on the sphere. It really does.
Do you want me to screen share and draw you some pictures, man? Because I'm willing to just pull out the old pen and paper and draw some pictures for you if you want.
It's just a more of a basic concept. Does someone understand that the same observation can work on both explanations? That's as simple as that.
They showed why it can't. Why it can't work on the flat Earth.
So Eratosthenes' experiment doesn't have any other angles than the one that he's got two positions in his calculation. Okay, all you have now.
More.
9, bro.
Eratosthenes has 2 in his presupposition. Okay, I understand. I understand. You're talking about going.
Dude.
You're talking about Sly-Sparkane. We're talking about Eratosthenes right now and how he made his measurement. He made two observations. Sorry, not even a measurement. Now, question for you.
And
when I go look at
9
the
lined up on a sphere, not on
sure. When I go
Earth.
look at the math between the 2 points, do you know the distance between the 2 points Eratosthenes apparently made his measurement?
I don't care about Eratosthenes. If it was 563, that's irrelevant. Sly-Sparkane
563. Why would that be irrelevant? If you wanted to reduplicate Eratosthenes' example, wouldn't you be trying to do the same?
563?
So you're not going to let me talk, right? So if you wanted to do the Eratosthenes experiment, why hasn't nobody that I've seen do it reduplicated? It's always been, like, for instance, I think there was a guy in Canada here that rode bike. He got front pages in the news too, but he only rode a certain amount of distance. He didn't do 500 miles. No way. I don't even think he did 50 miles, for Pete's sakes. Or maybe he did 50 miles. I don't know. But he did a very small section, and he claimed to prove the Earth's a sphere. Do you really think that's logical and reasonable to start at 2 points, travel 50 miles, and claim to prove a sphere? Do you really think that's logical?
Yeah, but hold on. Okay, you're kind of not addressing the fact that he's saying that Sly has more than 2, and he's not.
Yeah, I understand. The more than 2 is a red herring away from the point. Is the observation that Eratosthenes. Yeah, Eratosthenes only made.
He's not recognizing that it doesn't matter that Sly has more. The same observation can be had, and and a different explanation for different models can work based on the same observation. That's the point.
No, it
doesn't matter. It doesn't prove one thing.
I'm going to do this guy a favor. So listen, you want to know whether or not Earth's a ball or flat, right? That's the idea. You went from globe to flat back to globe, correct? Which is fine. I don't give a fuck.
This is why.
Yeah, no, I don't care. I don't give a fuck what you believe. I really don't. At the end of the day, I really don't care. But I'm going to suggest that you go do this, just to may help you understand what's going on. There's a PDF. It's called In the Search. It's in the Search of the Edge. It's with Andrea Barnes. They literally give you all of the best flat Earth arguments, okay? And then they rebuke all the arguments as well. That may help you understand. One of the first arguments they bring up is the Eratosthenes example. Now, the reason why I wanted you to read that is because I want you to understand that the arguments in these debates are not new. None of them are new. Not one of them. Okay, we're going through the regurgitation process.
Well, so in Sly-Sparkane, what map did he use for the flat map?
He used the A map
Okay, cool.
And now you guys
And
think
because
that
he
was
didn't,
never your map.
right? So he used the AE map,
You guys don't even have
and he
images
had
of your
about what
flat Earth. So how
9
can
to
you
10
claim
people.
that it's even flat?
Okay.
Or you guys claim that you don't even have an ice wall. You guys
So
have nothing.
hold on.
Dude.
Can you answer just one? Stop, please. I'm trying to ask.
You got nothing.
Hold on, please.
Come on,
Well, the Earth
bro.
is
Hold on, guys, hold on.
demonstrably horizontal, bro. Everywhere you go, at every point you have ever been in your life will all be
Mic check.
horizontal planes of
Hello?
reference.
Come on, guys.
Is
Come
this
on, guys.
working?
Y'all really
Mic
need
check.
a bit.
Anybody?
Fuck, all you have to
I
do is
had
hop on
it
a
up
plane,
here.
bro, and you'll realize the Earth is parallel everywhere you go, horizontal, parallel to the plane everywhere you go.
So is this mic check? Is this working? Can anyone hear me?
Yeah,
Yes,
go
I
ahead.
hear you.
Go ahead, Fuzzy. This
Okay.
good
This
white
is
guy.
like crazy. Why
Robot.
is it all of a sudden chaos? I was asking a very simple question. Okay, the map that Sly was using was the AE map, and you said that he had multiple people, and because of the multiple people, based on that map, it didn't quite work out. Therefore, it's got to be a globe. Have you ever considered that the AE map is not quite exactly correct, but it's the best thing we have so far per se?
You're
Is he breaking up for anybody else or just me?
Yeah, he's roboting.
For the record, the AE map is just a clock, a sun clock. That's it.
Yeah, no, I know. That's what I'm saying. Like, so if anyone is going to use the AE map to then say that this is the definitive map of the world, and if nothing lines up on it, therefore it's a globe, well, you got to take into consideration the fact that the map itself might be off.
It's just to tell the time where the sun is at, man.
So it'd be like the same as saying like the globe in the classroom, as even though, I mean, there is no official globe that's accurate, but you could like get a good idea about it, is the idea of the AE map. But that's not a definitive thing. That's not what he's not addressing that.
It's not just not definitive,
Your
it's horrible.
5,000 kilometer sun distance is based off of the AE map and the 45-degree angle that you get from the sun's shadow. This is where you guys get that number from. And
You're cutting out, buddy.
It's inaccurate because just watch the video and become a just try and entertain it a little bit. Just try. I know it's hard for you guys, but I believe you guys
Sly Sparkane is a liar, dude. There's no point in me watching his stuff.
Did you hear the roboting guy? Did you hear anything I just said about the map that he used in the video? How do you how do we know that that map is correct? Exactly. Could it be off
What's
by?
flat Earth? Which one, dude? Which one? Which
The
one shows
the one that Sly
dimensions of flat
Sparkane
Earth,
claimed to be the real flat Earth. He claimed that the AE map is the real flat Earth.
So which one should we use then?
Well, I don't know, but I'm just saying, if you're going to all of a sudden discount the entire concept, and you're not even going to entertain the idea that the map is not quite accurate.
Do you also do you also understand that you have no accurate globe map either?
What do you mean?
Do you think you have an entire section of the Earth in a globe format that has all the right sizes and positions?
Like Google Earth?
Your maps that you
Google Earth.
use, even Google Earth, if you do the measurements circumference-wise or do it from to equator, they're still off. They don't measure exactly the same.
No. Everything I've traveled using Google works to the T.
Yeah, sure. The whole maps that you have as one piece, like the Gleason's map, are all those sizes correct? Because it's a globe projection, right? The Gleason's map. Those sizes aren't correct. That's why you have distortions and so forth on them. Greenland is not as big as it is and so forth, right? So if you're looking at a map that has irregular land sizes, even in the Mercator, then what are you comparing to visually? What do you have to compare to visually? An incorrect map to begin with.
Oh, can you substantiate the claim that Google Earth is off? How much off we're talking about?
Probably at least 5%.
Like 5% of what?
I don't know. Well, first of all, if you think that Google Earth is total and collective all of the world's data, then you have way more confidence in man than I do.
I didn't say that. I'm asking for you to substantiate the claim that it's a map that is off.
So there are videos online. If you want to just go on YouTube and Google errors or whatever.
Hey,
Sure,
yeah.
there's a. This is years
Alright,
ago.
so
of
you
course.
don't have nothing.
You'll have to find me a 100-mile stretch of road
Yeah,
that,
so
that's
years
only
ago,
95
it's
miles
not.
or
It's
something.
not
Yeah,
new, right?
Hey,
It's
Data,
not new, boys.
if you don't let
Your
people
models
finish,
aren't
I'm going to mute your
100%.
ass.
Yeah, your
I'm going to
models aren't
mute you if
100%.
you don't let people finish.
So I was talking, right? You interrupted me.
No, I was talking. You cut the end of my sentence off.
Dude, I was talking. You just cut right in.
Yeah,
You're always
everybody knows.
talking.
All right, let's just reset. Try to, but yeah, I mean, even if you don't like what someone's saying, it's fair to just let them finish because that's often what happens. Someone disagrees and then they just interrupt right in the middle just because they disagree. Just let the person finish and then respond. And then we can hear what both people are saying.
Easy enough.
So there's many videos online. It's common knowledge that the maps are incorrect. Just go type in correct
I'm talking about
incorrect
Google
maps.
Earth. I'm talking about
Google
Google
Earth
Earth.
as well. Okay, so I just asked you, is Google Earth 100%? You said, I'm not saying that. So in the same breath, you just asked me about evidence of Google Earth. I just told you what to do. Take your little walking fingers and go see if the maps are correct, even with Google Earth. They'll tell you openly. It's common knowledge. It's not 100%.
Right, so you're not going to substantiate your claim. Fair enough.
Yeah, I substantiate it by telling you what to do. Whether you do it or not, to fact check me is up to you. I'm not going to spoon feed you. You've been around this
So
arena
you don't
long
have the
enough.
facts to provide.
So I'm going to ask you to clarify. I'm going to clarify. In my statement, what I stated as that the maps that they have, even of the globe, are not 100% correct. Would you agree with my statement?
Yeah, nothing is
Thank you.
100% correct.
There you go. Awesome. So you just validated what I was saying. Where can you find the information of them not being 100%? Did I tell you to go to YouTube and type it in? Yeah, I did. Yeah. So go ahead and type it in YouTube. You'll find that the globe map itself is incorrect. There's errors all over the place. They do not hide this information. So at any point,
Yeah,
you're going to talk about using a map that has a whole bunch of errors. First of
God
all,
dang
let's
this.
address the fact. First of all, let's
Yeah,
address the fact that
it's
the
his
maps are
style.
incorrect.
Right. Well,
So
and
You
I
didn't.
asked
You don't
you.
even listen. You interrupt. You cut me off, and you don't like what I'm saying, so you cut me
I
off. and
waited
then
so you
No,
finished.
dude.
Now I'm
Dude,
trying
you
to
were-
answer you.
Dude, you had like little hiccups in there trying to jump
Okay,
in, right?
more 5 minutes. Go ahead.
So you just
I'll wait.
confirmed that the maps are incorrect, even Google Earth. Thanks for playing.
Yeah, I agree that they're not 100% correct. Like no measurement is 100%
Awesome,
correct.
buddy.
And
Thank you.
you're
Thanks for
cutting me.
proving my point.
You can't wait like for 5 seconds before doing the very thing you're accusing me to do. So you said it was off. I asked, what do you mean? How much is off? You said at least 5%. Can you substantiate that? Because if I'm just agreeing that it's not 100%, doesn't mean I'm agreeing with your 5%. 5% is a hell of a margin of error.
Here's
To be fair,
two
hold on, before you
spots.
guys
Here's
go
two
down-
spots. Here's two spots you can go look right now
Why are
using
you
Google Earth. Go to
entertaining
the
the
North Pole
5%?
and go to the South Pole and tell me if any of those are real images. Thank you kindly.
Okay, real quick. Why are you talking about 5?
hell?
You agree that the maps are not 100%. Why then would you not agree that the AE map is not 100% and could be off by a little bit?
That's the logic of these people.
A map is off by a lot more than a little bit.
How do you know?
Just compare
Not for telling the time.
Just compare the map of my state, the paper map of my state, to the shape of my state in the A map. It's like vastly different. It's almost twice as large east to west on the A map. Because I'm in Southern Hemisphere, where this map is the worst. That's not just a little bit. It's like twice the size of my state.
So, all right, what about the Mercator map that we have in our classrooms? Is that the actual size of Greenland?
Obviously not.
Okay,
How's that relevant to the conversation?
Well, but I'm
How's it
saying,
relevant to the conversation?
Depending on, so if I were to take that map, which is supposed to be a globe map, right, and I try to measure out Greenland, I'm going to be vastly off. So therefore, there's not a globe, right?
No.
If I'm using that map,
that map wasn't meant to be a correct representation of the Earth. It meant to be a projection of the Earth.
Okay,
And that
so
was
why-
not. That's not. The, one second, Fuzzy. Fuzzy, let me finish. Let me finish my response to you. Let me finish. That wasn't what I was responding to. I wasn't responding to if there's any globe map that is accurate. He said there's no model of the Earth, even in a globe shape, that is accurate. And I asked by how much. He said at least 5% off. So we're not talking about whether flat maps can be.
I know that's how we
Obviously,
got-
flat maps. Obviously, flat maps are not going to be accurate. Are not going to have accurate distances and shapes.
But I know, but this is like we were talking to someone else who started roboting, so I guess it's not why he's not here anymore. But he was discarding the idea that the whole concept is null and void because the AE map is not 100% accurate. But what if it was never meant to be 100% accurate? Just like your Mercator map is not meant to be 100% accurate. It's meant to serve a different purpose.
Well, if the Earth is flat, you could have a flat representation of it. That is very. That would be very good. But the A map is not just not 100% correct. It sucks. It's horrible.
The Mercator map sucks, right? That's not the real
Sure.
size of Greenland. Right?
Sure. Of course. If Earth was a sphere, any flat map of it would suck.
My point is, man probably cannot map the whole entire Earth, period, plain and simple. So that's why you have all of these you have all of these consistent inconsistencies with map making. In fact, I believe a guy just won an award 2 years ago for releasing the newest modern map, which looks nothing like a globe, nothing like a Mercator, and nothing like the Gleasons. So again, you have all of these interpretations of coordinates, you have this interpretation of the land masses based on a coordinate system. How they fit it on the coordinate system is with the equation. Anyway, it's just equation based off of like a grid system. So if you're going to try to make things conform to a grid system, like a perfect circle, you're going to have distortions and issues.
Did Slice Barcane use another map other than the E map? Like, or did he try? He just tried the one and then said we figured it out. If I did the same by that same logic, if I tried to do anything using the Mercator map and I got wrong answers, I could then therefore throw out the entire globe because of one map.
Well, technically,
Well,
you
the
could.
thing is,
Mercator map is a globe projection, and if it's incorrect as a globe projection, therefore the globe is not correct.
Well, no, I know.
So it's
that's
not
why I was
incorrect as a
saying
globe projection.
yeah, it
The
doesn't
Gleason's
matter
map's
which.
apparently a globe projection, right? So if the
It
Gleason map
doesn't
is
matter.
incorrect with angles
Doesn't
and all
matter
that stuff,
which
then
map you.
Advancing
It doesn't matter which
computer-
flat map you use. It doesn't work on a flat surface.
what doesn't work on a flat surface? There's many things
The
that don't work on a globe.
The Eratosthenes observation.
And I can give you an observation. I can give you a test to do with your sphere to show you that you cannot have time zones on one longitude line on a sphere. I can give you an example that shows you you'll have a discrepancy along one longitude line. So if you have time zones from one city to another city, and along that longitude you'd have discrepancy for time, it would show up, but it doesn't show up on your globe model, does it? So that's why you can also falsify the sphere with time zones with two nomens between the North Pole and the 45 degree. If you set out to do the time, there's only two times that will match, which is 6 a.m. and 12 noon. Around 10:45 a.m. is when you get the discrepancies in angles. In other words, shadow angles. So if we had two sundials and they were pointed between the two spots, they would tell two different times along one longitude line. I can give you a demonstration to show how that doesn't work on how a sphere produces that result. Therefore, you can't have one longitude line with the equal time zones. Proving.
Yeah, I don't even know what all that fucking means, Data. I don't have any idea what all that
Okay,
means
so you have
compared to
a
the
Mercator.
Eratosthenes. We're talking about the Eratosthenes experiment.
Because I can debunk it with this one. You're claiming that the Eratosthenes ones only works on a sphere, right? And because if you add whatever, you add a third pole in, I can give you an example to show you, because on your sphere model, you have a terminator line, okay? That terminator line moves, from longitude to longitude, right? As it gets to nighttime or dark.
No, not the terminator line, but can we respond?
The terminator line moves along the longitudes. Doesn't matter. I'm giving you I'm just saying, as it goes to night, you have a terminator. That terminator line means that you have a longitude line that would have to have the same time between the 2 points. Yeah, that's the whole point.
No,
and they don't. I can give you
actually.
Yes, it is, because Eratosthenes is the same thing. It's between 2 points. It's an angle being produced at 500 miles of 7.2 degrees. Okay.
We were able to respond, or
Well, that's the same thing. So if you don't understand that I'm offering you this same
I understand what you're
demonstration.
offering, and I'm trying to respond to you.
No, you're not. You're not even letting me finish. You bet you don't even know how to do the
But
demonstration.
you never finish.
Yeah, you don't finish,
Data,
dude.
you've said a lot of points, so just give someone 20 seconds to respond. Because if you keep coming with new points, it almost becomes a tactic where you're like overloading them with information. So just let someone respond.
The terminator line is not what you should be looking for. Maybe on the equinox, but let's just use any given day. That's not true. But if you want to map the longitude, you just can use noon. So noon will be consistent for all the places on the same meridian. But that's not to say the terminator line, which is going to express the night and day, and morning and night, sunrise and sunset. It's obviously going to be different the further north and south you are. So it's just the noon that you're worried about being consistent.
No, it's not noon about being consistent. Again, you didn't hear. So in the Eratosthenes experiment, you have two sticks in the ground, if you will, two 90-degree verticals between 2 points, right? But in your model, it has to be tilted 7.2 degrees to produce the shadow at the distance of 500 miles. It's 1/50th of 150. I can't remember the math now. Anyway, the point is that the angles produced at 7.2 degrees because the Earth is curved at that point, 530 miles away, or whatever the math, whatever they like to say, 500 miles, 530 miles, 560 miles, whatever they use in the storytelling. So in the same example, like I'm using the terminal line as an example of a meridian line, if you will. And as the sun moves, that meridian line changes from meridian line to meridian line. That's why you have time zones along one longitude. So if that's the case, if I have a vertical at the North Pole and a vertical pole at the 45 degree, then only at 6 a.m. and 12, they'll tell accurate times between the 2 points along that one line. But around 11:45 or 10:45, 11:45, between that hour time frame, it falls to be about a half an hour out of time, meaning the shadow is different. So if it's along one meridian line, how do you get two different shadows? You can't.
It's already been responded to.
No, it's not. It's never been responded to.
You're strawmanning an argument that I just told you wasn't the case.
Again, you're not even on my point. No, steal my point. I bet you still don't know. I'll have to say it again to you.
Your point is that the terminator line is going to be consistent.
No, has nothing to do with terminator line.
Hold on.
Nope, has nothing to do with terminator line. Has to do with casting shadows. Let me finish. You got it wrong. No, you hold on. You got it wrong.
Still man your position.
No, you got it wrong. It has nothing to do with terminator line. I just said the terminator line to give you an example of the meridian line, a shadow line. It goes down one. Let me finish. It has nothing to do. It has nothing to do with the terminator line. Hear me?
Okay.
Nothing to do with it. What it has to do with. Is one longitude line, that meridian between 2 points, just like in Eratosthenes' example. It's not along a longitude line, it's not along a meridian, but it's between 2 points. My example is explicitly demonstrating that between these 2 points, at a certain time, the shadows. Let me finish. I'm almost done, dude. The shadows will not match at a certain point along one longitude line. That means you put 2 gnomons along one longitude line, one at the North Pole, one at the 45 degree.
Christ.
You will see.
You said that several times, and then you asked me to steal.
Well, there you go. It has nothing to do. It has nothing to do with the term. It has nothing to do with the terminator line. Now, does it? So now again, you know my position. What is it?
All the measurements are taken at solar noon, dude.
Yeah.
So 15 minutes, 30 minutes, 45 minutes before it, that's irrelevant.
Exactly.
All these measurements are taken at one point in time.
Yeah, all the measurements are taken at the local solar noon. So no other time is important anywhere except for local solar noon.
So you don't get the point.
Hold on, David. I'm not going to take 2 minutes to say this. Not at sunrise, not at sunset, not at any terminator lines. The only time that's consistent for the meridian is the local solar noon.
So, Coach, how did they get the distances between these individuals, and whether those are spherical or coplanar? How did he get those points?
Talking about Eratosthenes specifically?
No. Well, are you still talking about the slice of arcane thing?
No. Well, when I did it, I did the same thing Sly did basically, but I did each observer and I used their coordinates to calculate the distance from them to the equator. So each person's position, I just calculated their distance to the equator.
Their latitude.
You don't have to do the equator, dude. You can actually do all the stick angles. All point to the radius of the Earth.
Yeah, no, but
equidistantly.
we did it on the equinox, so the sun was going over the equator that day, so this way.
Right, but how are you plotting
That's
those?
what they did too. They did their experiment on the what is it?
I think they did
equinox
the
as well.
solstice.
Yeah, you're using the given
No,
distances
they
of
didn't
the
do
globe.
it on the solstice, dude. They did it September 21st or whatever.
That's the day I did mine. Maybe they did it on the equinox, but I think they did it on the solstice. But regardless, no, I just used the latitude, geo, and the distance between each latitude is 60 nautical miles. So any latitude to the equator is just going to be your latitude times 60 nautical miles.
And by the way, if you're measuring the angle to the sun at solar noon during the equinox, that also tells your latitude. You don't have to know your latitude. That will tell you.
Wow, that's amazing. What did you say, Kosho, again about the 69 miles?
Oh, just the distance between any two latitudes is going to be 69 nautical miles north to south. So when I made the predictions for everybody that I was using, I just simply gathered their latitudes and then calculated the distance to the equator by multiplying their latitude by 60 nautical miles.
Wow.
You get a linear distance, don't you?
That's amazing. Wow. And that gives you the exact.
You're cutting out. Hey, I got to change the subject. Kosho, are you using that Chat GPT to write your script now for apps? Apparently, it's getting better and better. You can get it to write your code for you. A guy just built a phone recording app with Chat GPT.
Yeah, it's been they've been able they've had that for a while, so I've been using it for like since last year.
You've been using Chat GPT for a year already?
Well, no, OpenAI has
yeah, OpenAI, yeah.
They have a thing called Codex. That's what Chat GPT is using. That's been available for about a year.
So what are you trying to what are you going to do for because right now I'm looking at getting into it to ask about some flat earth shit.
Well, we made flat earth bots.
What's that?
We made flat earth bots with it. We had a Glober bot that they were arguing with, and it was actually acting like a Glober.
That's fucking funny.
That's hilarious.
Well, it's pretty easy to do because I mean, it's no offense, but everything you guys get is pretty much just off the internet.
No, it was funny how it contradicted
off
itself.
Google.
Code pasting.
Off of Google, yeah. I mean, it's because so you just mix it up.
Convenient while you're on the internet.
I was arguing with it though, and he got it to basically contradict itself, and then it wouldn't say that it was wrong. That was pretty funny.
Oh yeah, when you brought it in here.
Yeah.
What do you think? What do you think the most malicious thing they can use it for now?
Malicious, I don't know, but
sandworms.
Yeah,
I was thinking about creating a going in there and creating a so everybody has a unique way of writing, right? The way they spell, the way they punctuate. In fact, it's almost like a heartbeat, apparently. And there are already some programs. There's already some programs already right now that can do it. But I was thinking about making something like that so that you can get some interesting results.
By doing what? Say again, what you were trying to do?
Well, Web 3.0 is like putting your fingerprint, right? Like Web 3.0 is the same thing. You'll have your node, and that node will have a fingerprint every place it goes, right? Just sort of like the internet has now. You have a fingerprint everywhere you go. You get an IP address and so forth, right? MAC address and all that shit.
So you're gonna build on the Web 3.0, or you're gonna?
Well, it's in the idea of the Web 3.0, right? It's just to collect information regarding fingerprints.
Yeah, but what about pickles?
What did you say, Damon?
See, I stumped you there. I said, what about pickles? You don't know anything about that.
Pickles?
Do you know what's funny? I was going to ask GPT to write me about pickles, actually. Write me like the reason why I should make a recipe book out of pickles.
It'll help you make the recipe book. I've had made
I
these
know.
songs.
Well,
I've
this
had
is
I
good
wrote,
because the thing is that you can use the pickles because pickles last a long time. They're somewhat flavorful, but they give you a great salt content. So they're long storage of salt, of tasty salt, right? And also like some liquid your body can use.
Well, when you said pickles, it made me
Pickles are
think
just
of Glat Flow the other day. He said like a flat earther going back to the globe would be like a pickle going back to a cucumber.
Yeah. Well,
Oh, that's Shunji.
if you mean
Sometimes when I listen to Eric Dubay, I want to go
I
back.
think he
to
was
the
kind of
globe.
saying as likely as a pickle going back to a cucumber, that kind of thing.
Oh, I see. Yeah. That's good. That's good. I like that.
Can
That
I
works.
change the subject just a little bit?
Yeah, but I think Data was about to say something too, though.
It's all good.
Eric Dubay.
I was trying to.
Oh, I just say sometimes sometimes when I listen to Eric Dubay, it makes me want to go back to the globe.
Yeah, I can see that.
Yeah, Coach, you know the 4 points Jeremy was asking for.
I would say like Anthony Riley does the same thing.
He's worse.
Yeah.
Yeah, but I mean, if you're into like a certain music group and somebody else that you have some aversion to also likes that group, does that mean you're gonna just not like that music anymore?
I don't know. I guess.
Are you that fickle?
Depends who's in the band.
Do you build your identity on being that fickle on to comparing oneself to others?
Well, I know it's very common. I know it's very common for an individual to value himself based on his friends. So it would only conclude that online kind of adhere to the same who you have as a subscribers. You know, don't you want
really.
Good subscribers?
There's only like a couple of decent flat earthers I can think of. Everybody else is kind of an asshole.
I'm really not an asshole. I just play one.
Oh, I didn't say you. I just meant like I'm thinking of like all the flat earthers I know, and I'm like running down the list, and I'm like, wow, that guy's kind of an asshole too. Anyway.
Crack me up is a flat Earth millionaire. That guy fucking. I was talking to that guy, and he goes, "Yeah, we're gonna be able to go to Mars soon." I was like, "You're a flat earther, right?" He's like, "Yeah, don't worry, man." And then he sent me a picture of the new egg Earth. It's almost like a little bit of Witsit, little brain, double brain thing in there.
Mm-hmm.
They're gonna fuck shit up.
I will tell you though, Damon, you probably never have. Have you ever been to like a meetup, like a flat earth type meetup where there's a lot of people there that are aware of this?
I mean, even if I went, I'd instantly be like shunned and kicked out.
No,
I went and hung out with flat Earth.
When I've gone to meetups when there's globe earthers there's no problems. Usually globe earthers they're just really interested. You know the way it is. You guys are super into flat earth. You want to talk to them and all that stuff. So that's how it is at the meetups.
Yeah, no, I know what you were saying. I think you misunderstood what I was saying. It wouldn't be the flat earthers that were the problem. It would be me. I'm an asshole.
Nah, you'd probably be fine. What I was just gonna say.
So is he a glober? This guy's a glober. He believes the Earth's a sphere.
Yeah, yeah. I like reality. I mean, I stick with that. Thank you.
So reality is that you have to ignore reality.
Yeah, that's exactly what I said. Yep. Mm-hmm.
Well, the reason why I'd imply that is because I'm in the same reality as you, as I hope. We're in the same space, just between us.
No, definitely not.
So I don't feel it moving, spinning, rotating, nothing. And then what I observe is I observe the heavenly bodies rotating. So for me to think for that to happen, I have to think that the Earth is spinning.
That's fine.
Right? But you see, I have to go outside of my sense. I have to go outside of my senses for that, right? So I have no way to validate that. Zero. Or do I have a way to validate that?
You know, where in reality can we see this?
I mean, it just all depends on whether you think that you can build knowledge on things that you know what I mean, on top of each other. If you think that there's no truth but the original direct observation of something, then you're kind of like in a 51st date situation where every day you have to wake up and learn everything once again. So like,
Well,
if you say that the only thing that's true is the direct observation of that thing, then yeah, like you're stuck because you're unable to continue to learn anything more than the original observation.
no, it would be more stated as this: is that once you come to determine that you're stuck, you have to build a new set of a new way to understand things, which means you need a new coordinate system, you need new mathematics, and you need, more importantly, a new presupposition. Hold on,
I mean more
this is what
basic
you.
than that.
No, this is what you need. So I can show you, like in scripture, in written text regarding people who created these coordinate systems, whether it's Descartes or Riemann or Ptolemy. They admit clearly, with just like you stated, without moving forward, we'd be stuck. So why would we be stuck? You think because we would be stuck because we're using the first primitives or the first ontologicals, which is looking at everything for what it is and taking it for face value, what it is. Like, I'll give you a reference.
Yeah, that's true.
So Ronald Reagan said in a thing, one of his doodads, he said you might end up thinking the Earth is flat if you obeyed your senses. That's just what he said, right?
Yeah.
So the sense is that that's really the argument. It's just the base ground zero.
You just argued against yourself, right?
No, I'm saying what he said to emphasize my point, which is the senses, which is your argument saying that we're stuck at our senses. This is really what you're implying by saying that we're stuck.
No. You misunderstood.
Okay, all right.
I'm saying from what you were saying, or at least what I perceived you of saying, which I could be wrong, that there's no way to build knowledge because the only thing that matters, right, is you individually, your observation. So you can know that observation, and you can think whatever you think of it. You can call it true or whatever, and then make conclusions from that observation. But if you were to be in the reality that I exist in, right, then there isn't just the original observation. It would be whoever made that observation then can give us that observation in detail, and then the other person can sort of like make that same observation, or they could build on top of that and say, okay, if I assume that the information they're giving me is correct, then I should be able to do this or build on top of this. And so what you know what I mean, and like you can continue on with that, and like then you build a knowledge base, meaning the things that work that we consider to be most likely true, and then we go with that and like build on top of it over the years.
Sure. So we do have a limitation, right, to our abilities as man and our tools, right?
Sure.
And if we are always striving to get to the next level, we must have a reason, or we're observing something that's a phenomenon. We want to figure it out. We're trying to figure out why the Earth is appearing to be stationary, but we see this body above rotating. We must say that it's not rotating. We must say that it's the Earth that's rotating, and that body that's infinitely distant away is the one that is stationary, and the Earth is spinning. So now I have to prove that because I have a presupposition. I have a hunch. That's really what these.
So that would be a hypothesis for.
Yeah, exactly. So
observation.
So I'm just trying to dumb it down because this is what they concluded in the earlier days, which is without me having a presupposition, in this case a hypothesis, I can't proceed forward with any other kind of determination of how to figure out my hypothesis, right?
Yeah,
so
I mean,
what I have is what's called a presupposition. I think the Earth's a sphere, therefore, if I see this, therefore sphere. So, for instance, the sun and moon are spherical, therefore the Earth is spherical, right?
No,
basis
I
in a
would just say you're
hold on.
building a hypothesis.
That's yeah, hold on, but that's one of the
The
first
presupposition is right out. Just
yeah,
get rid
so
of
that's
that
one of
word.
the that's one of the first reifications, right? And the presupposition the Earth is rotating.
No,
You have
that's
to.
not a presupposition.
Well, you're assuming that what's causing the rotation of the bodies is the Earth
So
spinning.
that's a
right?
hypothesis to an observation. Like
It's
if I say,
presupposition, very
I
similar to
believe that
hypothesis
the
in
Earth
this
is.
regard.
I believe that I see objects moving in the sky. I believe that there's two ways that this could happen: that the objects are moving, or that I am
Sure.
moving under the objects, right? And so you can make a hypothesis that if that I am moving, meaning basically the ground below me is moving and I'm moving with it, that I should see this, and then I would make under that hypothesis I would make a prediction or like a test. A test to see if this is true, right? Then this would be my experiment, and then you know what I mean. Like you don't just presuppose it to be true.
So
You
if I
just say,
run-
look, if I'm going to figure this out, I have to sort of start somewhere, and so I'm going to say that if this would be true, if it would be true, that I should be able to figure it out this way, and then
Right.
do that, and then if it works, then you could say, well, I'm more sure that this hypothesis is true and that this other hypothesis is less true, and then you
So-
keep building on
right.
top of it. That's what I'm saying. Is just like my original observation of things moving. If I just stop there and not go anywhere with it, then I'm just stuck basically saying, well, I believe that the sky is the thing that's moving, and that's true.
Would
But like you
agree-
don't have anything to
would you
base
agree
that on, right?
that's-
You just
The idea is that
you'd have
the
to
idea
leave
would be that that's exactly what they had to do to proceed forward, right? And bear with me, I'm trying to actually find Ptolemy's work here because he even admits that without a presupposition, they really can't go anywhere forward in their calculations and reasoning for their observations, right? So they have to make assumptions of what's happening based on the Earth data that they're getting, right?
An assumption, which would be a hypothesis, not a presupposition.
In this case, they even admit that the Earth, because here's the issue. The Babylonians and the Chinese did all these star measurements on a planar Earth. They believed the Earth was flat, right? And then the Greeks came along and we're like, okay, well, no, the Earth isn't flat. We're going to use this sphericity of
Might have been the
'cause-
Vikings.
No, Pythagoras thought the Earth was, the spherical things were perfect, right? It was a very deep philosophical held belief that things spherical were perfect in nature. The Earth must be spherical. Anyway, according to history, the evolution of the spherical mind came when the Greek mind came and invented this spherical world, if you will, through a form of Neoplatonism and so forth. But
I'm
what's that?
agreeing with you. I'm just saying that there's other things that were happening at the same time. So it wasn't just.
Yeah. So let me just continue on. So what I'm saying about Ptolemy admits that the surface of the body of the Earth, his observation is a private perspective as they described it. More importantly, they had a presupposition which was a tangent to the plane. Can you tell me why the presupposition was a tangent to the plane?
I don't believe there was a presupposition.
I'm not asking you whether you believe it or not. I'm actually telling you, historical fact, that their presupposition was a tangent to the plane. Now, okay, but I'm stating that for a reason, right? Because you have to say that the apparent junction of the sky and ground is an optical illusion. But if we presuppose that's a sphere, then we can do different calculations. Would you agree?
No, I disagree.
Oh, okay. So the apparent junction of the sky and ground is not an optical illusion. It's actually due to spherical of the Earth or sphericity of the Earth.
I would think that there's only two ways that you could have. Well, basically, what you're saying is a horizon, and that would be that if there's something.
No, sir.
Way,
I told you. I said what the presupposition was. The presupposition was a tangent to the plane. You asked me for a citation. I'll give you a book. I'll give you the material. You can go download it.
In relation to what? I'm sorry. It seems
our conversation
awry here.
No, it's regarding Ptolemy, the tangent to the plane, the presupposition of what the tangent to the plane means, which you're saying that the Earth's a sphere. That's therefore tangent to the plane.
And we were talking about stuff moving in the sky, and now we're talking about tangent to it.
We were. Can I ask you a quick question? Right. So
we're talking about presuppositions here, right? We're talking about assuming what
you're
the
talking
phenomenon.
about presuppositions. I'm talking about hypothesis on
Yeah,
the
same thing.
movement of objects in the sky.
Right. The
Yeah, sure.
presupposition. Yeah, you have to. So you said you'd have to be able to test that, right? The things about moving in the sky with your
Well, I
arm.
mean, if you want to get
right?
to the bottom
So,
of things,
right,
right, you
I
have
know.
to
So
just
would you
not
agree
be like,
that a
I believe it
test?
to be this, right?
Right, I know. So if we're moving, if we're standing on the ground and it's spinning, and that's what's causing the sky to move, if we left the ground, would we expect the sky to still be moving, or would it stop?
That would be one hypothesis.
Well, what would we expect? We should expect that it would stop, right?
I think if you had no knowledge or understanding of the basics of what is around you, then you could have several hypotheses, some of which might meet certain criteria, and the others that would be wrong, and others that would meet it exactly.
Well, okay, that's my
So
point. So,
I mean, you'd have to
so
test for those things.
yeah, we'd have to test one. So if we still see the sky moving, even though we are not stepping on the ground anymore, that tells us that there's a pretty strong evidence for the fact that the ground itself is not moving and that the sky is moving.
Or that
Once we leave it.
if we were moving with the ground and then we came off of it, we could still be moving with the ground.
Not if you're up there for long enough and you've gone the opposite direction to negate any
Well,
kind of
that would be a
movement. If you're
hypothesis,
assuming,
and
but
then you
also-
would test for that and prove
You're also
that. Right?
presuming. You're also presuming that you're moving in the first
Nope,
place.
that's not a presumption. That's
It
just a
is. You
hypothesis.
said we could be moving.
I said we could be, meaning that's a hypothesis.
Yeah, so how would you ever test that, then?
hypothesize that I am moving with the Earth. The Earth is moving. If I were to leap off of the Earth, I would still be moving with the Earth because I was moving with the Earth before
For
I
a
leapt
half
off
hour?
of it.
So if a drone is up in the air, no longer moving,
Yeah, I
it's
mean,
flying in the opposite
what
direction of
I
the
mean,
movement.
like I said, that would be a hypothesis. You would also have to have the hypothesis of if I was moving with the Earth and I leaped off and then I stopped moving, I would have to have a hypothesis of why I stopped moving. So I could say, well, there's air resistance or something like that. I could think of something, right? Another hypothesis to explain the reason why I would have stopped moving with the Earth.
Okay, so could I come up with a hypothesis that says, so my hypothesis is that the Earth is not moving and that the sky is moving, and in order to test this, I'll put a drone up in there, and I still see that the sky moves, even though I'm not connected to it. Based on that hypothesis and that observation and that explanation, I'm correct, right?
I'm not sure your test is rigorous enough, but
How
you may
would
be
I
able
put
to
a
draw some
rigorous enough
certain
test? Because
conclusions of it.
you just said that we could be
Sticks and shadows rigorous.
based in an entirely different assumption. If I entirely opposite claim of if this, instead of assuming my hypothesis at the beginning is that the Earth is stationary, I'm going to assume that it's moving, and that while I go off of it, that I'm still moving with it, and I see the observation. Therefore, how is that a rigorous enough test? That's not rigorous either.
I didn't say it was.
Well, I know, but I'm saying
I didn't suggest
you
it.
have no
That was
rigorous
a
test at this point.
hypothesis, not the test.
You
That
have
was me saying, I think this to be true. Let's test for it.
You can't test for it. So I would love
Why
to see
can't
the
I?
test of Earth movement.
Well, you would have to have something that were related to the Earth and not the sky in some way. So, whatever your test would be if I'm still in the hypothesis that the sky could be moving or the Earth could be moving, and then you also added the extra detail that if you came off of the Earth, then you could still be moving with the Earth, or you could stop. You should, if the Earth was moving, you should stop, right? And the Earth should move under you. That's also then another hypothesis. These are all tests that you would have to make. And so now you're becoming more and more complicated when you haven't even done the first test on whether the sky is moving or the Earth is moving.
Right. So what I'm asking for is that your rigorous test that claimed that you're basing your entire belief structure on.
To be honest, I had too much wine. I can't think of something rigorous at the moment. I know there's tests that have been done, and
you don't know what it is.
You should probably use one of those.
We've been looking for years about what the rigorous test is that proves. So there's no rigorous test in your entire mind that proves the Earth is moving.
Like right offhand, right now, dude. No, I don't have something that I can whip together.
That's crazy. So I just wanted to ask you: do you believe that the mind does put pieces together? Like, for instance, if you heard an incident happened, a scenario, wouldn't your mind kind of play out the situation of the scenario to fit the pieces together to tell a cohesive story? Do you think perhaps that's what your mind is doing? To the fact
that's
that
what your mind does all the time. I think
exactly.
I think
So,
that that even
hold on.
like take just our vision for instance. Take just our vision for instance. It's very spotty. We have terrible eyes. Really, I mean, it
No,
gives
we
us
don't.
very little information. And
No.
our
Our eyes are
brain
awesome,
pieces
dude.
together. Our brain pieces together many bits of it.
Our eyes are awesome, dude. They're a
Well,
marvel.
look,
Our
there's
eyeballs are
a
a
certain
marvel,
section of our eyes that's okay. It's decent.
It's a marvel. It's
It
amazing.
has a blank spot in the middle, and our peripheral vision is terrible. But
Sure.
you know, we can focus on things pretty well, and we can tell a certain amount of colors. So I mean,
Yeah, I want
compared
pigeon
to
eyesight.
compared to an eagle, our eyes are terrible for distance. Compared to an octopus or something like that, it's terrible or like a bee, say for instance, is terrible
Colors.
for color. I mean, it depends on what you're comparing it to.
Yeah,
You can say our eyes are great,
comparing
but
it to the
compared to
idea
what?
that you would complete a story in your mind that it's a proof for the rotation of the Earth, but you have no idea what that proof is. That's crazy that you hold that belief. There's a famous quote that says,
I didn't say that I couldn't do it. I said right now I'm not going to do it
There's a
because
famous
I'm
quote.
drunk and
There's a
I'm
famous
tired.
quote.
I'm going
If
to
you're
bed.
not willing to falsify your beliefs, you stand for nothing.
I always falsify my beliefs. Didn't
How do
say
you
that I
falsify
couldn't
the
do
Earth
it.
is rotating? How do you falsify the Earth is a sphere with a
I
radius
said-
of 3959?
Well, I could think of a few different ways, but at the moment I wouldn't be able to put
Fire
them
in the
together
hole, just
rigorously
one.
enough.
Just one. Give us an example, bud. Come on.
Well, I mean,
have fun. You're drinking.
If you're talking about moving, if you had multiple observations around the Earth, you should be able to figure out if the Earth is moving or if the sky is moving. Just by simple geometry, really. And then, as far as like the Earth being round or not, I mean that's easy. Like why? Like just tell me why there's a horizon. Like you could say there's a hypothesis that the horizon is caused by
I'll tell you
something
why.
being in the way.
Do you know how many? Even if we took the circumference, even if we took the circumference size of the Earth,
I mean, why? Are you
and we
making me
compared
do
it,
this? You
and,
do
and
it.
we compared it, and we
You're
compared
the
it
one
to the
that believes
ratio.
hokey shit. You do it.
And we compared it to the
David,
ratio of.
All right, go for it, Data. But let me just say super briefly. Data's might go on a longer thing. I would, over a planar Earth, what I would expect to see and what would occur is that there would be an optical extinction point as far as you're able to see in those conditions between the ground and the sky, which would make up a horizon.
I agree with you, but the horizon should never be sharp, right? Like it should always be at least somewhat fuzzy. It should never be a really sharp line.
Oh, it depends. It could be very sharp in certain conditions.
Well, maybe in certain conditions, but for the most part, like say I'm looking over the ocean, which is supposed to be level and flat, right? If I were to look off and there's nothing in the way and I see a sharp line, why would there be a fucking sharp line? It should just fade out as our eyes are unable to discern in the distance what the fuck is going on. It should never.
So
be a sharp line.
everything converges, right? Do you know what the convergence
Yeah,
is?
converge in a fucking fuzzy mess because I can't see that far.
So listen, bro.
I mean, I see what
the
you're
vanishing
saying.
point. The vanishing point converges into that
The vanishing
unresolvable
point is not a sharp line.
Hold on.
It's a fuzzy
Hold
mess
on.
all the time.
Yeah. So what happens is
Except for a
diffraction creates
drawing.
refraction creates a banding and blurring. Diffraction creates a blending and blurring. A discoloration and a banding effect. First of all, so if you have a convergence of that plus a diffraction effect into the eye, into the pupil, and then it's foreshortened due to refraction of the light into the neutral point of the eye, right? Because that's how we see.
No.
And the surface, let me finish. And the surface is horizontal, then you would totally get that effect because it's like, I'll give you an example how you can see it for yourself. You can giggle. I'll give you an example. Take a piece of tape on the ground and make sure it's like really bright red tape, and then stretch it out, and take your camera to the floor, and then bring it close down. You'll see this foreshortening effect with this red line. If you could imagine it, because it's just material, it's just a tape, but this red line will actually converge into a line as you reduce your angle to the floor.
It's not actually reducing in size; it's only foreshortening due to the angle of it. But you'll actually get this effect.
I
So
mean,
if you
that's
have
nothing
buildings,
like the
if you
horizon
have
we see.
buildings, if you have buildings and topography along your z-axis moving out, and it converges into a point, this is what you would expect with optical angular limits on a planar surface. That's what you would expect. Exactly what you see.
Kind of
what you're
off into the
saying
weeds
is
here.
that
Hold on.
you're done with the hypothesis that you
Guys.
have done all the experiments and that you have convinced yourself that
Nope.
the Earth is
I've
flat
falsified.
because
I falsified
because the
I falsified the
horizon
math.
is
I falsified the.
sometimes you've come up with some idea of
No.
why the
You're
horizon
letting
might be
him-
sharp
you're
in
letting him
certain
get away with
occasions.
You're letting
So
him go down
you're
this
fucking
rabbit
crazy.
hole of nonsense when
Yeah,
he
no.
clearly said he was asking about the sky, the Earth moving, and he
Yeah,
said that you
exactly.
could do it simply enough by getting multiple
Because
locations on Earth, making an observation, and basic geometry could tell us that we're spinning. I'd like verification of that, please. That's what you
no.
just mentioned, and then moved on to something else.
No,
Yeah, because
I'm
it was
just
it was
dude.
it
I'm
was
just
horse.
some
When I
dude on the
listened to it, it was
internet.
horse shit. I just listened to it.
I'm
It was horse
just
shit.
some dude on the
instead of
internet.
keeping him there,
Do it
you moved on
yourself.
to this other thing.
It was just horseshit though when he said it. It's up to him what he
I
says.
know,
I
but
really don't care.
allow him
I
to
mean, dude,
understand
I'm
that
just
that was
some dude
horseshit.
on the internet. Do it yourself.
That
You're
was
definitely a
fucking-
dude on the
I'm
internet.
a fucking.
Don't you don't realize that what you said?
I work
Like,
in the air compressor
have no
industry.
discernible way
I know air
to dis-
compressors. You want to
you
know
have
about
no
air
discernible
compressors?
way.
I can tell you all the
They
fucking
don't have a
things,
discernible
theories,
way,
and fucking
even
everything
in
about air compressors.
All right,
go to
well, hold on.
Einstein. There you go. Right?
The combo doesn't have to go south. Let me say this, because you were bringing up that point about the horizon. I do hear what you're saying, that your thought is that it should be more dissipated. But what I would say is that over a planar surface, like let's say you're standing like 6 feet off the water, 10 feet, 20 feet, anything like that. When you're looking out, obviously the ground is much closer to you than the sky. The sky is, much further.
The sky is on top of you, just like the Earth is on your feet.
Right. Exactly. So since it's on your feet, the Earth, it's almost like if you were to look down a hallway and put your head right next to one of the walls or even right down to the ground, almost kind of like Data was saying, because if you put your head right to it, then that is going to change the whole setup. Whereas you're going to see much closer on the wall and much further, the wall being the Earth or the in the sky.
Parallel lines meet.
So I'm just saying in general, if you're standing, let's say 10 feet above the ground looking out, that water level is the closest physical material reality to you. That's why that can appear sharp, because you're only seeing that limit. The rest of it is all sky, which almost could be considered not really infinite, but you know what I mean? Just whatever, an expanse. But that's why it can look sharp, because it's the difference.
That's a
between-
hypothesis, or it could be that there's some sort of shape that is either curved or it's shaped in a way that is brought forth where it's down and away from us. So as we look
And you know
down
what? I
onto
would
the
be cool with
horizon, it basically makes an obstruction so that
So
we
with the
see a
globe
sharp line.
explanation, like let's just consider for a minute the Earth could be a globe. I would say yes, that sounds good. There should be a physical edge. There should be a leading edge of the sphere. And then if I were to take that and say, okay, let's go test that and go out in the world, if that was consistently there and it was obscuring things in the distance at a consistent material physical way, then that would give that would be what would be needed. At least one thing that would be needed for the Earth to be a sphere. But the problem is that cutoff point is not consistent whatsoever at all. It changes.
Right. If we
dramatically.
saw it and it's not consistent, could we not then have another hypothesis saying, okay, our hypothesis might not be correct. However, what if there's some other effect that we haven't thought of? Is there a hypothesis we could come up with to say that to account for the variation in this horizon that we see? But you guys don't do that, right? Like you just stop and say the Earth is flat because the horizon isn't regular.
I don't know what you guys did, but what I was talking about originally is simply that on a sphere, if that was the leading edge of the sphere, it should behave like that. So
right, but I'm saying could there be another effect that you're not taking into account that would change
right, so let me lead
what
on
we see
to
as the horizon?
Correct. So let me go from there. So the horizon doesn't function like a globe would, But some people might say it doesn't function like a flat Earth because it changes. There is cutoff, there is obscuration. So since it doesn't fit a globe, and then some might say it doesn't fit a flat Earth type thing, both would have to then have a further explanation. So what then ends up happening is on the globe side, they say that there's this form of refraction, meaning that it's not really a geometric horizon, it's a refracted horizon. It changes, it moves, and sometimes we're able to see around the bend, basically, the light's bending. They get into that whole thing. And they'll even say like, oh yeah, well, sometimes the Earth looks flat because of the refraction.
I mean, that's a
And
bit
on,
of a
on
straw
a
man,
flat
but I
Earth,
agree
it
with
does
you.
need to be explained as well as to why things can be obscured visually.
Yeah, like I said, I agree with you. However, what you said was a bit of a straw man as far as what you would call Globers think. We believe that the only reason why you would see a horizon at all is because of geometry. Now we think that, or we say, an apparent horizon because there's other things affecting it other than the geometry. So we see it because there's the geometry of the Earth, like it's a sphere. So we have a horizon. We account for the irregularity in the distance or the effect of the horizon that we see because of other effects, such as refraction.
Yeah, so that's a presupposition, right? Based on your optics, you're presuming
it's
that
not
it's
a
a sphere without.
presupposition.
Yes, it is. I'll tell you why. You're saying
It's
that
a
I see this with my
proven
eye.
hypothesis.
No, I'll tell you why, buddy. You're talking even in your own globe maths. The Earth is 7 million times bigger than your Earth. The Earth is 7 million times bigger than you are, right? The Earth is 7 million times bigger than you are, apparently, based on your own geometry. And you're claiming that you can see the curve of it at a distance of, for a 6-foot observer. Do you know how far away is claimed evidence of a curvature?
Between 3 and 4 miles, probably.
Okay, so they're claiming that at 16,000, 17,000 feet from the observer's line of sight, you're having
10, 15. Yeah, that's about 3 miles.
Yeah,
3 to
so
4 miles.
it's I can run that distance in 15 minutes. You're claiming that the size of the Earth is measurable at a 15-minute run.
In 15 minutes?
20 minutes, maybe. 20 minutes, maybe exaggerated a little bit. Anyway, the 20-minute run to run the distance of 16,000 feet, it's not a very long distance to apparently see or get to a Mercator point. Let me finish. To get to a Mercator point, which you call physical Earth curve. It's outlined by a horizon that you're presuming that it's a sphere by negating optics. Correct?
Negating optics.
Correct.
What's
You're claiming that the features attributed to your eyesight is due to physical Earth curve, as opposing to just being the fact that you have optics, convergence of light. In other words, I'll give you an example. A simple understanding is the apparent.
How does optics make a thing curved that you're standing?
Okay, so it's a lens, and you have a circle aperture. What it does is it converges light. And I'll give you an example. So two parallel lines, like a railroad track, will converge, right? It's not really happening. So this apparent position that you see,
where's this optic?
Let me finish.
That's happening?
Let me finish.
What is that?
Let me finish. The apparent position that you call a horizon isn't actually touching. Nothing's converging. It remains in its state as it is, but optically.
That's a straw man.
Let me finish. No, it's not. It doesn't.
Sure
it's not. It's not. Your eyeball is receiving the information and interpreting the distance. It's not interpreting a sphere. It's interpreting the distance to your eye, the light from the horizon to your eye.
I'm not sure what you mean by that. Like, what's the point of what you just said?
So the convergence that you see is not really happening. So, for instance, if we were to lay a whole bunch of
really.
Yeah, it's an
the
optical
thing I see
illusion.
Isn't actually happening. It's an optical
right.
illusion.
So it's not a sphere
oh
now,
God.
is it? So it's
You've
not a
totally
sphere now,
warped
is it?
my world, dude.
Yeah. So it's not a sphere, is it? Right? Because a sphere is not an optical illusion, isn't it?
It's
not an optical illusion. A sphere doesn't have convergence, does it?
Blown my mind.
Optics does. For instance, the apparent rising of the ground. The ground isn't really rising now, is it? In your Earth curvature calculators, you have an arc.
No, you're looking through a part of the Earth that's in the way, right? So, like, as you look down, more of
the ground isn't really rising, brother. You understand that, right?
No, it drops away, yeah.
So, but it appears to rise to the neutral. If you stare straight out, you're looking at it at 90.
Jackass, it doesn't.
Okay, so your voice just changed. So there's a trigger for you. So again, buddy,
Yeah, you got real excited there for a second. So
Did I?
again, the ground doesn't rise,
Oh my
does
God.
it?
Data, you
Hold
are
on,
a character, dude.
Damon, for
I'm
real.
I'm
Let- let-
LOLing, even though I would never usually say LOLing, but I'm actually laughing out loud, so that's funny.
It is pretty funny, but Damon,
This guy is excited.
Well, Damon, really, listen real quick. You said, the railroad tracks, you agree that they don't curve left to right to actually meet each other in the center, right?
No, they never actually meet. Parallel lines don't
I-
meet.
I get-
That's
yep,
that's
yep,
just
yep,
the
yep,
nature of
yep.
geometry.
I
I mean,
understand.
if parallel lines met,
For a
you don't
yes or
have
no
parallel
question.
lines.
Yes or no? Yes or no?
It's the very definition of parallel
You
lines.
agree. You agree that left or right, the railroad tracks don't curve or move to actually meet, but it appears as though that they are meeting in the middle, left or right. Now, if I'm looking at clouds off in the distance that are right next to the edge of the horizon, are they actually close to the ground, or are they up in the sky? And it, like, instead of it being left and right converging to a point, it's up and down converging to a point. You understand that?
No, actually, I'm sorry, my brain totally shut off with that. I'm not understanding. I'm not following it.
So imagine instead of the railroad tracks are instead of left and right to you, they're up and down to you, like streetlights
Okay,
going
so
off.
parallel lines in a vertical position rather than horizontal.
Exactly, like a cloud. So when I see a cloud in the distance, right on the horizon, is that cloud actually touching the ground, or is that up in the sky, but it looks like it's touching the ground because there's a convergence?
Like a very differing situation. So hold on, let me think about it a second. I mean, a cloud's just floating in the air. It could be various distances from you. As it goes away in distance, its size shrinks. Yeah, I guess it would appear to come closer to the ground in the
Right, and
distance.
the
Yeah,
ground
yeah,
itself appears to come up to meet it up. The ground isn't actually up as far as I'm looking at it. It's just at the ground, but it looks like it's converging with the sky up and down, they'll say, same way that the railroad tracks looks like they're converging left to right.
I mean,
that's how optics work.
Yeah, I mean,
And
a,
at that
a
point-
cloud
at
off
that
into the
point-
distance, I've never
Right.
actually seen hit the ground, like touch the horizon, except for in certain cases, like such as mountains and stuff like that.
You've never seen a picture of like
He has to go do some more observation.
Yeah, I guess. But so therefore, I guess the point is,
Yeah, I've spent my whole life outdoors. Yep. Uh-huh.
You've
Yeah, so
never
I need more
seen a
observation.
beautiful horizon with the clouds and ground coming together?
Yeah, I mean, I've never seen them actually touching the horizon.
No, they
There's-
don't
there's always
touch,
been a-
buddy. They appear
there's
to
always
touch, but they're
been-
not touching.
There's always been a bit of a fuzziness where I'm not able to really see if they're actually touching the horizon or not.
So
I
next
mean, I
time
guess-
you're going to notice, you're going to see them appear to touch.
I mean, I
They're
guess,
gonna-
it's,
they're-
I guess
they're
in the ocean you do see that once in a while. Yes, that's true. Now I think about it.
not really happening.
What, the clouds actually not touching the ground?
So the convergence that you
Oh my
see
God,
is
dude, you
purely
blow my mind. Oh my God.
wonderful.
Therefore,
I'm gonna cream myself.
You didn't know the sun doesn't fall into the ocean?
I did not know that.
When it sets, it's actually going underwater.
when you see that convergence,
Nuh-uh.
you no longer can optically resolve things. What you're
Sorry.
calling that is the edge
I'll
of
stop
the
now.
leading edge of the sphere. Right?
I've had a bit too much wine.
Yeah, like
No,
it's
I
definitely
mean,
not
you
the
go.
leading edge of a sphere.
He's coming in his pants. He's had so much wine.
That's the thing. I mean, that horizon line does not function as the edge of a sphere. That is the problem. It can be ad hoc explained with cherry-picked observations of visual obscuration to be described as the curve of a proposed sphere, but it actually doesn't function like the actual geometry of the edge of a sphere.
Like you
All right.
like Geo, like honestly, I'm gonna tell you something like 100% from the bottom of my heart, truthful. Like I hear your sincerity in your voice, and I believe that you believe what you're saying, and like I actually understand that how it makes sense. I really do. But it's just not true, dude. It's very simply explained by geometry, and
Cloud-
any variations is simply explained by refraction. I mean, these are known things. We can do experiments with them all day long. You can yourself if you actually want to do it. I mean, Now you can say I'm just being contrarian, or
your
I'm
Earth
just not
size.
seeing the truth or whatever. That's
No,
fine.
it's not
I
that.
agree.
It's not about
But,
seeing the truth. No.
Well, it requires a pseudo-physical explanation of refraction. So it requires fabricating a form of refraction that can't actually be validated to basically account for a curve that isn't there.
What? No, I'm not accounting for a curve that isn't there. There is a curve. That's why we see our horizon.
Do you know what the dimensions of your radius ball Earth apparently are? And there's an observation you could do.
4K or something like that.
So there's an observation you can do. Sure. So they say that there's a drop feature to that, the arc, if you will. So if you look at a curve calculator, you're going to see the drop of an object past the horizon.
Don't need it.
Point,
I can
right?
imagine it in my head.
Yeah, I understand. So your curvature calculator says at 3 miles, which is 15,800 feet, 16,000 feet,
Fine.
that you're going to be able to measure anything past this point due to Earth curve, due to the drop, right? Your Earth is 7 million times bigger than the size that you are, and you are saying to yourself that you can see the horizon and you're seeing the curve of the Earth, but then you don't want to acknowledge the fact the apparent junction, which is called the horizon, a little definition is called the apparent junction of the sky and ground, which means it's not going to be an actual physical location.
Oh no, it is.
Do you understand do you understand that you're saying that you can see, you're really a big human being on a massive Earth by being able to measure curvature of 15,000, 16,000 feet, right? This is what I'm not trying to get you to be the truth. I'm trying to get you to look at the fact that you're really tiny, bro.
Geometry would create a horizon. Whether
you're really tiny,
right or not, that doesn't matter. Like,
it's not about being right. I'm trying to appeal to your.
I'm trying to appeal horizon because of the curvature.
I'm trying.
Answer the
no,
question.
you would have a. Well, what would happen is that in this regard, if the dimensions of the Earth were as such, I would be living on a cylinder, because at 15, 16. I'd be living on a cylinder because at 15, 16,000 feet, somebody of a 6 foot height could disappear.
The cylinder would work also as well if you're just talking about a single direction. However, on a sphere, you could look at any direction and the same effect would happen. Correct?
Well, that can't happen if you have more than one observer.
If you have more than one observer, they could look anywhere and the horizon would still exist.
If you were always trying to represent your ball with only one observer, if you are always trying to represent your Earth ball with one observer, well, you should think about adding in a second observer.
The point is that dissonance is strong with you, son.
Sure, ad hom. Anyway, the 16,000 feet that you claim
that
you
wasn't
can measure,
an ad hom. It wasn't an argument.
Sure. The 16,000 feet that you claim
it's used in response to what he's saying, though.
No, it wasn't.
It
was an insult, not an ad hom.
Yeah, well, it's the same thing to me.
I didn't use it to refute your whatever you were saying, your argument. I didn't do it to prove one of my arguments.
It's just attacking. So at the end of the day, it's just
not a fallacy.
Yeah,
it's not a fallacy. It's an insult.
You're a small little guy. You're a small little guy.
You have insult.
You're a small little guy on this Earth. You have a presupposition called tangent to the plane, is what you have, which is you're conflating the idea
There's no such thing as tangents.
So in geometry, a tangent to the plane would be the way that they would presuppose the Earth is a sphere using a right angle triangle.
I don't think a tangent to a plane quite works. You mean an intersection?
It's called tangent to the plane. That's what I understand it as. If I'm not saying it correctly, then
that must be some sort of math word that I don't know about. Sorry.
So that's what they do to presuppose what the horizon is. The point is that you're really tiny. Even though the size that you mentioned, 20 miles. Let me finish, brother.
Let's be real. Come on.
Let me finish. Hey, shut up. Shut up. Anyway, so if you're 7 million times smaller than the size of the Earth, you're trying to measure what percentage of the Earth do you think you're actually measuring? If it's at 16,000 feet, you're measuring a drop of 6 feet.
No fucking clue.
Yeah.
Let's talk real though.
Yeah, total real.
No, seriously, like human to human. Let's talk.
Yeah, total real.
All right. Well,
Like
then
we
let me
were
ask you. Let me ask
actually
you
having
that.
coffee together.
Yeah. So this guy
Well,
here
let me ask you this, David,
wants to conflate the horizon Earth curve, which is fine, but he does, and it's not about being truthful. It's about getting you to acknowledge the fact that the horizon is an extremely short distance for a tiny person to conflate it as Earth curve, and not hijacking per se, but misinterpreting optics and having a presupposition that the horizon is due to an Earth curve when you're just a tiny little person, bro.
If you started right on the Earth, right, like if you could basically put your eyes on the same exact level as the dirt, right, or the water, your horizon would be very short, right? Correct. And then if you were say, a giant that was fucking 40 feet tall, right, the horizon would be further out than that. Correct. So the taller you are, the further
It's what
out
you
the
would
horizon
expect. That's what you would expect on a planar Earth with optics. That the more angle, that's correct.
Yeah, because
That's exactly what we'd expect on a planar surface, because the higher we go, the larger the angle goes, the farther out we can see.
Gio, can we like seriously? Can we like just talk as like human beings here, guys?
Yeah, I'm down. I'm down with that.
Like,
Well,
let's not be adversaries here.
Yeah, the guy that's being insulting, huh? You playing victim now? You Marxist or weirdo?
I mean, I'll take it back and say that I was being very childish and it was very dumb of me, and I shouldn't have done it. And it didn't lead any
You're
good
one of those
way
guys
to the conversation. Like
You're
it
one of those
didn't
guys.
add anything to the conversation. It detracted from the conversation, and it was a dumb thing. I'm a human being. I've had a little alcohol. I'm being a little testy.
You're coming in your pants earlier.
Data's thinking that
This
you
is
are,
like a bipolar situation.
Hold on, you guys are interrupting a lot.
Insulting.
I think Data's taking it
Coming
as
in
if
his
it's like a
pants.
full blown debate, and it sounds like you're just wanting to chill, and I'm kind of more in chill mode too. So I'm cool just to chill.
I just like talking about the horizon. The horizon is kind of like my thing. I love the horizon. It's kind of like
let's go with what you're saying. Let's say you're in the ocean.
Put a
it's
postcard
dead
in the
calm
mail.
Flat. Let's say
Tell
you're in
him
the
you love
ocean
the horizon.
and it's dead calm flat.
Yeah.
Okay, so you're in the ocean, you're swimming, and you put your eyes right above the water level. You know, like you peek your head out, and you're looking just like a centimeter above the water. And just imagine it's perfectly flat water. Yeah, your horizon would be pretty close to you, considering. And then, like you're right, as you would go higher, it would extend out, but it would then reach like an extension point where it wouldn't really go further. So what I would say is happening there is that you have like your eye works, your whole field of vision works as a adjustable radial system. Like there's a radius within the hemisphere of vision. I would say sphere, but you can't see under the ground. So let's just say like a hemispherical field of vision, that there's a radius to that. Now, if you're inside of your house, that radius might only be like 20 feet. You can't even see outside. So you're just seeing in your region, but we all know our eyes can see further than 20 feet. But that would be your only field of view if you were, inside of a house. Once you go outside, now you have the extent of how the atmosphere and how far it lets you see, and the capacity of your eye and how far it can see. And then now you have a radius as well within that whole system. And there's a limit to that, which I would call like I was saying before, the optical extinction point. So if you're right at the water level, that would be closer. But as you go up in distance, you're raising the angle and you're able to see more. That radius grows.
Sure. Can I get a clarification on what you mean by optical extinction point? Is that just sort of where, like,
vanishing point, bro?
Generally speaking, like at a 30-mile distance, anything smaller than a house is pretty much indistinguishable by your eyes because we just can't. Yeah, our eyes are incapable physically to determine that sort of thing.
Yeah. Well, I would say with optical extinction and the definition, the way I was using it, or just in the phraseology that I was using it, I would say there's two different optical extinction points. One of them is when the atmosphere comes in the way, so it's extinct there. And then another one is yeah, exactly. And then the other one is the actual extent of your eye.
Gotcha. Yeah, I would agree with that 100%. Just thank you for the clarification. And the end of your question there was, I'm sorry.
I don't know. I was more just responding.
Well, you were just more kind of talking about what Clint, I guess, was talking about with the horizon. But yeah, like I said, I'm being 100% honest when I understand what you're saying. Like I really do. I just
Weirdo, come on,
I'm just
man.
wondering.
You don't need
I'm
to
just
confess so much, man.
have you? I mean, have you even given what? I mean, what us Clovers are even saying? Like, have you even attempted to sort of like entertain it for any reason?
Has it ever
or
dawned on you
purpose?
that most people here, or at least I can't speak for everybody, do you realize that I thought the Earth was a ball? And actually, now I don't
Yeah.
even know.
Yeah, you've been convinced otherwise.
No, here's the two things. It's either much bigger than they say it is for a sphere. Number one, that's just because of the other details, or the idea. The idea is that it's a realm, which in a realm you can have any model. Because it's a realm, so you can have a flat Earth model, you can have a globe model. Because the idea behind a creator, which I was thinking about, is to have unlimited ideas of creation, imagination. It's like an amazing thing,
Look,
right?
dude,
So
I'll be perfectly honest with you that if you want to include some sort of supernatural being, that I am unable to falsify
it's just
that,
we're not even talking about
argue
the
with
fact
you.
that
It's possible that
the idea of
this
storytelling,
is
even
some
if you were
sort
to
of
tell
like
a story.
supernaturally involved
Nah, man, if you just tell
situation.
a story. What's a better story? That it exploded from nothing. It's a sphere, gravity coalesced everything to the center of mass, and then everything expanded outward and contracted at the same time, and you have all these explosive bodies going on that are attracting each other. Like, that's really the story. It's the idea of these gases and black holes and stars and planets creating. Where the other one is that a being created, a being lives above. He's in a throne above us, and then he created a realm for us. The realm is the idea is that number one is hold on. Number one is to actually play. It's an area where you can play with all kinds of philosophy,
Well, I
with
mean,
all kinds of religion. The idea behind it is you have to find that Christ, if
I'm
you
not
will,
going
or
to
that
rule.
God, or that whatever, right? Whatever that is
Look,
for
I'm a
you.
philosophical junkie, so I'm not going to rule out your supernatural causes, right? Like I'm never going to rule them out.
It's not about that. It's not about
possible.
that.
It's possible that
It's
there
the
was
story.
a creator, either a deist god or like some other fucking god or whatever, Christian god. It doesn't matter, right? Like it could be some sort of supernatural entity, or it could be something like a supernatural entity, like a relative, like what
What's
Feynman
a better
talked about,
story,
or other
dude? All these
people talk about,
gases. What's a
aliens
better
that are
story?
sufficiently technologically advanced to make them seem like gods. I mean, all that stuff, right? Can
Okay, so
exist.
there's a story. That's a better
I'm
story
a
than
much
that's
simpler
better.
man, right?
That's
I'm
well,
a
that's a
simpler
better
man.
story. The aliens, at least being intelligent and putting stuff on Earth, that's a better story than just a singular explosion creating this expansion of
I mean,
galaxies
that's
and
just a matter
universe
of opinion, right? I
and
mean,
well, I sure it's fantastical, but really the story is just about these planets and black holes and the mathematics behind they're
I
phenomena,
feel like
right?
you're getting off into the weeds here with this.
No, we're just asking you what the better story is. So you said depending on the man. You're a
I mean,
simple
the
man,
better
you
story
said.
would be
The better story wouldn't be that it's a realm
to
and that
have
you
very few presuppositions and to take observation. You know what I mean? Take what we see in reality as it is. I mean, to add entities is
well, you don't
against
do that.
Occam's razor.
You don't do that. You think that the Earth is rotating for the star bodies to appear to rotate, where
Well, right,
we
but
look at.
that's you're taking that information in a bit of vacuum, right? Like
No,
this is what I was
that's what
saying
you
before,
believe.
that
You ignore
this is
reality.
what I
You
was saying
ignore your
before, that
senses.
you're basically erasing all of history and saying that it doesn't exist, and the
No,
only thing that
nobody's
matters
erasing
is your
history at
current
all.
observation and the
You can
moment.
still have that history within the realm. The realm doesn't. The
No.
realm doesn't care about what
Okay, well,
history
that's a
man
weird, nebulous
creates.
thing to say, right? I don't know what to
Why?
do with it.
Well, Damon,
Why?
like
If you
before, like have we considered the Earth being a globe? And I would say for myself, absolutely, thoroughly have considered the globe Earth on multiple levels.
Yeah, but you don't believe that it's a globe anymore.
Absolutely correct. Yes.
Right. So
But
something convinced you of that, and I'm
no,
lacking
there was nothing
that
that
knowledge
I
of
would
that.
say that might be a projection because you might be thinking that something has to convince you of what the Earth is if that's your default. There was nothing outside of myself that convinced me of what the Earth actually is. It was my
Okay,
own
well, something's
understanding.
convinced you that it's not a globe, right?
No, nothing convinced me. I came to the truth of it.
Okay, you're convinced now that
No,
it's a globe.
I wouldn't define it as convinced.
It's not a globe.
I mean, maybe the word awareness, understanding, conscious.
Well, I mean, I'm not trying to trick you with words here. I mean, convince is a pretty colloquial word here. I mean, I'm just saying, like, you believe it now, right? You think that it's true.
I know that it's true, that the Earth is
Okay.
planar.
I get that you're confident in this belief, and so that you call that knowledge. I understand. Now,
Do you fly much at all?
what was it that made you convinced? What was it that said that you now have knowledge? What is the knowledge?
Many, many things in many categories.
Right, many things. And if I told you that the reason why I'm convinced that the Earth is a globe is for many, many things, not just one thing, many, many, many things.
Definitely. I understand the way that they sell it and propagandize it. And I mean, I see it as
Right, I get that you believe that it's been propagandized, but you see how that's condescending.
No, it's not. That's just I'm not saying you are believing propaganda per se.
Okay.
I'm saying that it is, in my viewpoints, a propagandized cosmological media psyop.
Could it be true and propagandized?
Well, it's not usually the definition of propaganda, but I guess
Right.
technically it
So
could.
that's why I had the offense that I was feeling when you said that.
What I was going to ask you originally as well, though, have you ever thought, because you asked me if I consider the globe, my main thing was to say yes, and I could go more on that, but actually I was just going to say yes, and then I was going to throw it back your way and say, have you considered that the Earth could be a realm, stationary planar Earth, meaning that like we're in a realm, some kind of an environment, and as a human, you know, et cetera, and that there's a geometry to the environment, up is up, down is down, east, west, north, south, like the XYZ axis. So water is level, you know, the land comes up out of the water. Have you considered that that's what you could be living in? However, it can be looked at as a globe Earth. Like it can be viewed as that. It can
I mean,
theorized as
absolutely.
Even some of the observations
Sorry.
overlay a bit.
Yeah. I mean, absolutely. Like, there are certain parts of the flat Earth hypothesis that fits the globe hypothesis. There are certain parts that meet together. They're not in contradiction. And so if I were to stop at those particular observations, then I wouldn't know which is true, right? Like I could say I'm agnostic on whether the Earth is a globe or flat. There are contradictory sort of things that would happen, especially like simply geometric. Like the reason why the horizon is such my favorite is because in geometry, right, there's only one way that you could have a horizon as a human on the Earth, and that would be if a geometric shape would be something like a sphere. It could be dodecahedron. It could be anything that's like a sphere with multiple sides, or there may be a few other shapes that I'm not thinking of at the time.
Can I give you? He's not. Can I suggest something
Sorry.
again? Your optics of your eyeballs have a spatial relationship.
No, that's just not true.
Yes, please just stop.
Your eyes
Let me
see
finish.
the light that comes in.
Let me finish. Let me finish.
If it wasn't there, it wouldn't be there. And any other theory is just fucking stupid.
Yeah, so you have spatial relationship with objects. In other words, you have an angular relationship to them. Okay.
I don't even know what that means.
And you have an angular relationship to them. In other words, the distance.
You might start fighting again.
I mean, I have an angular relationship with my penis right now, but like, what's your point?
So, well, you come in your penis talk, dude. You're definitely drinking the wine, right?
Sorry.
Maybe you don't understand this. So
I like
this relationship. There you go. This relationship that you have with objects is in
like
Euclidean 3D space, right? The thing is, with optics,
non-Euclidean.
It's not. Then then when you introduce optics, it becomes non-Euclidean. So this is what I'm trying to say. Well, that's what the optics dictate.
David,
do you understand how?
This is just a side thing, but what do you think about using this guy Euclid? Like, you're into that? Like, just the whole thing. I know it represents certain geometrical principles. Those could be discussed. I'm saying calling it Euclid. You know what I mean? I'm not really a fan of it personally. Like just
Euclid's
Euclidean,
you mean?
Names and it's like worshiping
non-Euclid.
Well, the point is that in geometry, though, that it's specified as non-Euclidean or Euclidean. So until you come up with another terminology just to show the difference between, parallel line converging at 290s, then you got to come up with a phraseology. Other than that, in the geometry described, you have to describe it as either non-Euclidean or Euclidean.
Perpendicular.
I know, but it's just a way that they control consciousness with using their names and their figures. But what I was going to say, Damon, the thing is, the definition of the word the definition of the word horizon is a plane parallel. A plane parallel to the horizon.
Simple.
No. What I meant to say is that
like I said, let's talk human to human here. It's just
one thing I'm saying.
Meets the ground. That's all.
All right. What I was going to say is the word horizontal is a plane parallel to the horizon. So it's actually, that's what a horizon is. It's not the leading edge of a sphere. It's a horizontal is a plane parallel to the horizon. So the horizon is parallel to horizontal.
If you look in the dictionary, there's several definitions to the term. However, I agree with you.
Yeah, so you would have a horizon on a planar surface.
No.
And it would extend, it would either be further or closer to you in the visibility.
What would be making the horizon? Would it be caused by the geometry, or would it be caused by the effects of your
light
vision?
To your eye?
It's both. It's ultimately both.
Well, really, the surface of the Earth. If you're looking at the surface of the Earth, it could either recede away. As it recedes away from you, the surface of the Earth could either drop down. For instance, if you make an observation over land, and that body of land is you're looking in the ocean, but you're standing on the land, more than likely that land will be sloping down towards the body of water. So depending on where you're looking over at land, you can have this rising of land and dropping away of land when you do any kind of linear measurements along the z-axis. So when you're looking at these images, you have to be careful what the land does as well. But primarily, there's this apparent effect where things rise to the neutral point. Do you disagree with that?
I'm sorry, I'm making a diagram. Can you give me 1 second?
Yeah, there you go.
I'm done. Let me clip this real quick. Damn it, I always want to put my freaking snipping tool on the toolbar so I don't have to freaking type it every time. Can I use the live stream chat?
I don't know. You have to ask Geo, but don't do anything with comment or dicks, dude.
No, simple line drawing. Yeah, see, so on a flat Earth, right, if I looked parallel to the ground, which is what the little guy is standing on there, at the bottom line, and then his eyeballs are at the top line there, you see have it no horizon right there. Yeah, I just keep looking out, right? And there's no horizon ever that I should see if I look parallel to the ground.
So in the model of the globe, what causes the convergence? Is it physical
that's
Earth
easy.
curve or
Hold
is
on a second.
optics?
Yeah, it's because when we look to the horizon, yeah, that it's since the Earth is a sphere, the Earth gets
Presupposing
in our way.
you're presupposing the sphere. You're negating optics.
Okay, fine. It's presupposing the sphere.
Yeah,
Whatever makes you feel
you're negating the fact that the ground isn't actually rising to the eye level. Optical illusion. Again, you keep forgetting that.
What do you mean? That's
doesn't
not true.
matter
You know
if
that's not
it
true.
doesn't. So 100%. If you and I
300,000 different experiments showing that the horizon doesn't
So-
rise to eye level. I mean, for
Yeah.
fuck's sake, how do you know what eye level is anyway? I mean, our eyes look in all different directions.
Stop being disingenuous. If we forced
I'm not.
perspective, if we had forced perspective and we made a long enough hallway, you would see that convergence. point, it would rise to
No,
the neutral
definitely
point.
wouldn't.
Stop. You
But
can force perspective to high.
Parallel lines don't cross.
Yeah, it's an optical illusion. Thank you for again stating my point. And
Parallel
always the
lines
position.
do not cross.
Wonderful. This is exactly the interpretation.
And now we
the
live
horizon,
in the land of optical illusions, where optical illusions decide reality.
Pythagoreans took Euclidean 3D space, and used optics because the apparent convergence, the railroad tracks combining and creating a spherical nature, claiming a presupposition which was a tangent to the plane, which was basically
was that
claiming.
gobbledygook you just spouted?
Yeah, well, maybe you should just go back and listen.
Okay, it is a live stream, I suppose. Didn't seem to make any damn sense to me. Do I really gotta go hear it again?
The convergence never ever happens. The ground never ever rises. Clouds never together. Okay, it's an angular relationship to light and. And we almost done. It's an angular relationship to light and the human eye. Obviously, the topography of the land has something to do with it, whether the land slopes down or slopes up. The point is that it's not actually happening. If you're looking over the surface, the ground isn't rising. Just like in a hallway, the hallway will rise to the apparent neutral point of the eyeball. If you didn't know it, maybe you should look at.
That's silly.
Okay.
That you're basically saying that the floor physically comes up to your eyeballs, which it never does.
So
it's parallel to your
exactly.
eyeballs.
There you go, bud. So that's the horizon for you. So if you want to have a presupposition and say that that optical illusion is actually a physical effect due to sphericity, you can say that, but you're presupposing that effect. How do I know that I can falsify that as a presupposition?
Only the sharp line.
How can I falsify that? Is because I look at the math. And I don't know if you've ever flown aircraft or if you've ever done anything with the math and observations. The math, even at a short distance of 3 miles, 4 miles,
flight simulator count?
Sure, it's used in class. It's used in if you're getting your private pilot license. They use it to help you train. Why not? If you got the actual gear, if you got the gear and everything set up, the actual pedals and headset, and you're actually using the codes, and you got all if you got all that stuff when you're training to become a pilot, because that's usually what pilots do. They actually have the equipment at home too to keep up with their skills. So believe it or not, these simulators are very useful in the no kidding, right? And the funny thing is that actually you don't adjust for rotation or curvature at all at flying, right? So if you're going to claim that the horizon,
thank you for a second. I mean, I learned something today.
Your voice changed again, dude. Right on. Good one.
Oh, I'm not allowed to have a dynamic voice.
It's just you get real.
I'm a singer too. Like I take vocal lessons and stuff. So like,
right on, Batman.
When I have dynamics to my voice, it doesn't really necessarily mean anything other than I don't like to drone on in the same tone all day long, talking to somebody in the same monotone voice with no inflection.
Well, being a robot wouldn't be fun, would it?
Well, that's what I'm saying.
Anyway, the Earth has to be much bigger. They conflated the idea that the horizon is due to the physical Earth curve because it can be falsified as not Earth curve. In other words, the math can be falsified, the dimensions. In other words, if you had a set of boundaries and parameters and you use technology to say, well, wait a second, I can do this to this, and there's no horizon, no sphere matching these dimensions, then I falsified the math. So if you're not willing to go try that out to see if you can test that, you said it earlier. You said it earlier. We see too far, right? Well, if you made that statement, the only reason why you should make that statement is we see too far is because there is a limited boundary based on the math. And if you're saying that
statement though, can you guys like tighten that up a little bit? Like, I know what you're saying when you say it, but like when you say see too far, like,
you said it, not
to
me.
a glober, right? Like we say,
but you must know what that means.
There's geometric horizon, right, that we see all the time, and it varies in its sort of like.
So you see the geometric horizon all the time? Is that correct?
Yes, because it varies, but it varies in its position due to like sort of atmosphere.
What about all the globers that disagree with
like
you?
When you say
that you don't actually see the geometric.
what you would
What
have
about the
to
globers that disagree
hold
with
on,
you?
I'm almost done. One
What
second,
What do you
second.
think about
So-
the globers that disagree with you that say that you never see the geometric horizon? That's why you
Well,
always
I
see the
mean,
apparent horizon.
I understand why they're saying that
So
too.
now
I
let's
mean,
just go back about 20
this
minutes
could
ago.
be-
You just
Oh my fucking
did the
God.
reverse of what you said, dude. You're going back. Now you're doing a 180. Now
Hard
you're
to
saying
have a
you see the
conversation with you.
you said you see the geometric horizon when about 20 minutes ago you said you didn't see the
You're-
geometric horizon.
you're
So
kinda
listen,
mean.
is that the law of non-contradiction, or is that cognitive dissonance? What is it when you're holding two beliefs? But this guy must know he's holding the two beliefs, but comes here. And
Man,
why
you
does he
got-
come here? So I'm going to
You
ask
got
you a quick
2
question.
points there, dude.
Yeah.
You
What is
scored.
it? Right on. What is attractive about flat Earth to you? I'm just going to ask you a couple of questions. Is that
Struck
okay?
a blow.
Yeah, yeah. Well, I'm
Wow,
just going to ask
you
you a couple
really-
questions. What's
really put
attractive?
me in my place, didn't you?
All right, yeah, Data, I'm gonna mute you for a second, dude. Go ahead, Damon. Dude, you're out of control. Out of control, Data.
Yeah, no, I'll look, man. Originally, all I was trying to say is that if we could talk like humans about the horizon, we could say that there's this geometric horizon due to its sphericity, right? I mean, any fool would that knows about any kind of geometry would know that if we actually did live on a sphere, that there would be horizon at a particular point. And when I said that the apparent horizon is a chosen words that we use because it's there's things in the way like the atmosphere and shit. So we're not necessarily seeing you know the world in a very cut and dry geometric way. Like there's other factors that we have to take into account to sort of you know explain what we're seeing. That's all. I mean, nothing complicated, nothing hokey, nothing weird, nothing sort of conspiratorial. None of that shit going on. Okay, I'm done.
16,000 feet, brother. Let's say 25-minute run. You're claiming that a person is going to disappear due to Earth curvature and not to an angular relationship to the optics of a person it moves away from. I can show you clearly in angular resolution calculations that indeed a person at that height would disappear at 3 miles. What is the coincidence that even just an angular relationship for a 6-foot person would disappear at 3 miles, and your globe math seeing that a 6-foot person would disappear at 3 miles? What is the relationship there? If one's based on angular relationship, based on light, and the other one's based on a sphere, why are they different?
I mean,
why do they dictate the same answer, but they're different?
in my reality, both things could be true. However, if we took an object such as like a large boat that's several football fields long, or a couple of football fields long, right? That would be different than a human, right? Like we could see that for a much longer distance.
You would have to use an optics from a camera. You're talking about another element. See, now you've jumped into a conversation. Well, you're not talking about when you're talking about visualizing a boat. Are you still using the human?
What do you think a lens does? I mean, I wear glasses. Do you think it warps my reality in such a way that I can't fucking discern it anymore? I mean, what a ridiculous thing to say.
So even if you're 6 feet standing on the shore and you're talking about a boat of this size, to see any kind of this detail that you're talking about, you're going to have quite a bit of distance away. You're going to have to use optics to see this.
Yeah, I might have to
right?
zoom
Like
in
of
a
a
little
camera
bit to sort of see detail, if that's what you mean.
Well, that's the whole point. So again, there's a limitation to eyesight for the human, and that convergence that happens.
Always have. I've actually the one that brought it up.
The convergence is an optical illusion. So what I'm saying, just so you know, I'm not saying that the Earth is flat or a sphere. I'm just being truthful about what the observation dictates. This observation, from what I see from the math, is a purely optical illusion. Does it mean that the Earth is not a sphere or flat? No, it just means that it has to be either a bigger ball with a bigger radius.
Convergence is an optical illusion. Can you go back to that?
Of course.
What do you mean by that?
Okay, so I'll give you an example. So if you had somebody stand in front of you and hold 2 cell phones, and they moved away from you, eventually those 2 cell phones would appear to come together, but they're not coming together. There's a convergence there, right?
No, wow. That made things much more confusing. I have no idea what you're fucking talking about.
You're standing face to face to somebody, and they're holding 2 cell phones in front of you, right in front of your face. The two cell phones are 6 inches apart. Okay.
Okay.
And the person starts to walk away from you. There's two things that are going to happen. The phones will reduce in size, but eventually they'll appear like they're coming together. But they're actually not coming together. It's purely an optical illusion.
You talking about perspective? I don't like. Yeah, duh.
Yes, it's an optical illusion.
Kind of a duh
Perspective.
statement, I guess. I was kind of blown away by that. Sorry.
Well, you asked what convergence was. I gave you a simple visual for it.
Oh, God. I'm sorry. Wow.
Are you done there? Did you put the jelly away? I don't know, dude. You're having
I
a
had
good
no
time
idea
over
what
there.
you were talking about at first, but I pretty much got it now. I get what you mean by convergence. I just didn't put two and two together for what you were talking about, like, within the context of what you were talking
when
about.
parallel lines appear to converge, but they're not converging, it would be an
because they're
optical
parallel lines.
effect. So if you have a 3D Euclidean
It'd
space,
be because your eyesight is not able to discern that at that distance.
if you have 3D Euclidean space and you throw a circular aperture in there, which would converge light into a point, then you're going to have you're going to have subtended angles of light.
Back up. I don't think you even know what you just said.
I'm talking about light to the human eye. Are you familiar with light to the human eye? How you have these subtended angles of light, there can be calculated. You have one arc minute. You have a 1 arc minute or a 0.16 degree angular resolution. Sometimes they put 0.02 degrees. The point is that you have a visual. You have visual acuity. It's discernible. In this case, we can use Rayleigh criterion to discern. Let's say we're looking at an eye chart.
Criterion.
Yeah, we
Wow.
want to look at an eye chart. You want to see
now.
just optics, bro. We're talking about light, subtended angles of light. Diffraction point is
fancy. Not everybody knows that.
Anyway, dude.
Come on, I'm giving you props.
He doesn't know. Yeah, it doesn't matter. Do you know? Look, dude, I've been around the arena for a long time. If I told you my name, I'd be on him the front.
Oh well, I mean, I've been in the institution of flat Earth for at least a decade. So I mean, I'm right there with you, buddy.
You've been in it for 10 years. You're longer than I.
Well, I mean, let's see. I was in a community on a what the fuck do you call it? Like what is Discord? What do you call this? It's Discord is a place where you meet, right? Online.
Social media.
Yeah, like something like that, right? It used to be called Blab. Like I started like SE community back then, and we talked when that was still around, and that was probably about 10 years ago. So that's when I first started getting into this.
Did you say SE?
I've been a part of the skeptical community. I've had subscriptions to magazines for at least 25 years. So yeah, I mean, I've been in this kind of stuff for a long time. Yeah.
But the globe still makes sense to enough for you to believe?
No, I mean, it doesn't make sense, right? Like it's.
I would agree. It doesn't.
It's a thing that actually is. So like it's not about making sense. It's that it's like you would say it's knowledge. I mean, there's no doubt. Like it's as close as I can get as a skeptic to saying that something is 100% true. Like I know it as well as I know it of what my name is. I'm sorry, did I kill the conversation? Okay.
I mean, I think the globe has enough. There are explanations, and there's pictures, and the government, and there seems to be like a mainstream kind of model built around it, of course. But there's really no actual practical evidence for it.
Well, I mean, except for the thousands and thousands of pictures. Yeah.
I wouldn't really describe that as necessarily practical evidence, like especially when they're from government-based organizations. I mean, that's just sketchy to begin with. I mean,
Well, and now you have like private companies that have those sort of images too. Like, I mean, SpaceX has a bunch of them now.
So you think the Elon car above Earth is a real picture?
Yeah, I think he's dumb enough to do something stupid like that. Waste one of his cars.
Can you tell me how high the Tesla car was above Earth when that shot was taken?
Oh, I have no fucking clue, man. You have to look it up.
Well, I think it was only 100 miles. Does that
Okay.
mean that you're going to see Earth in that sphericity only 100 miles from the surface?
Yeah, I think you can. If you have a very good wide vision, right? Like if you can use all of your eyesight, you have pretty decent peripheral vision as well. I think that even from a plane, like traveling at about 40,000 feet, you should at least be able to begin to make it out in a vague way. Like, not, I don't mean like, oh yeah, that's definitely a curve. I mean like, no, it seems like it's curving, kind of. If I really like squint and look at it, it looks curved. But I mean, like at 100 miles, I mean, yeah, you should definitely be able to see that the Earth is curved, a globe.
So the ISS goes, what, 250 miles, right?
On average, yeah.
Do you know how much the ISS claims to see at 250 miles, like the
I don't know. It's some
surface area?
generally
I
small
know that.
percentage, like maybe like 30%, maybe. I'm guessing.
Yeah, so it's 3%. Do you know what 3%
Okay,
of a do you know what 3% of a 1,000 diameter visual length? Do you know how much you see?
I mean, I could do the math, but not off the top of my head at the moment. A little drunk for that.
3% of 25,000 miles circumference. And you're saying that of that 3% you can see physically.
Yeah, I mean, yeah, that seems right.
Okay, then you should do some math.
Okay. Thanks for your advice.
Because all you see is maybe what, 1,000 miles, maybe 1,400 miles. I have to.
I think 3% is a little small. Maybe of the
That's what.
surface area, 3% of the surface area of the Earth, maybe.
Yeah. So if you go look at Vsauce, he has a video on YouTube. He talks about going to visit the ISS. Vsauce, yeah. He has a video on YouTube, and he talks about the ISS being able to see only 3% of the Earth. Shows you a little video. So if you're claiming that at 100 miles I can see the whole encompassing Earth from the Elon video, and Vsauce contradicts that by showing his demonstration of what they actually see from the ISS, you might have a problem there, guys. Anybody got a joke? I'm looking for a new joke.
I don't know. Maybe the Lorentz transformation?
just going through some stuff, and look what I found. This is bound to trigger a couple of people. Sorry.
What did you find there, Odysee?
Go to Livestream text 1.
Yeah, I think Polaris has been seen like 13 degrees south.
That's a problem for your sphere, right?
I don't see, and I don't possess any sphere, so, but I know.
Yeah, I'm saying in general, that's a problem for the sphere. It's funny how this thing just came up. I was just scrolling through some stuff, and wham. A direct contradiction. Who's right?
No, it says you can see it just south of the equator. How far south of the equator?
I don't know. Apparently, we're not supposed to see it just south of the equator.
Yeah, I would say that you could, because it's not exactly on the celestial pole. It's a little bit off. And then also, if you're at an elevation, above sea level, I would think you would be able to see it at some distance south of the equator, but not very far.
So funny how we have baller propaganda, WS. Whenever you see that, it's, you know who that is, right? And then we have an official explanation. From astronomy.com, no less. So would you say left lane if that's true? That would be like a aha moment for your model?
No, like I said, I would expect to see it, depending on your elevation and, you're talking about a mile past the equator or how far past the equator. I would think you could see it a little bit past it.
Can I just interrupt you 1 second just to say goodnight? I appreciate the conversation. So, yeah, sorry I had to leave, take the dogs out. And I got to go to bed. Thanks, Clint and Gio.
Later, dude.
See you.
Don't ignore your senses.
So, Clint, you think celestial navigation proves a flat Earth?
Do I believe it proves a flat Earth? I haven't done enough direct observations myself, and I don't have a working map to conclude the terrain in its totality. But you need right-angled triangles eyes all over, and you need a horizontal plane to devise that information. So your senses would be using Euclidean. I haven't done that all over, so I can't conclude. I do know that it's a realm that working presuppositions on both models seem to be apparent in whatever translation you decide to make.
Oh, but you seem to have been pretty sure yourself the other day when you came into Nathan's. Yes, you can do with an angle, you can do something, and you can celestial navigate. And yeah, I told you. You seem pretty sure.
So Yeah, so if you have an angle,
You talking
to
about the
some,
one with Bev and all, that one?
Yeah,
Oh,
yeah,
yeah.
he came in
So
white knighting for Nathan.
Yeah.
That I did. Yeah, that was pretty
yeah, so
pitiful, bro. That was pretty pitiful. I just gotta say that. But go on.
again, you can get an angle by using a right angle triangle. Imply the word angle means you a 90 degree, right? So to get an angle, you need a ratio of some sort or some sort of base point. So when you say the word angle, what did you just get it from, and how did you get it? Well, if you're going to get an angle, it's going to be coming from a ratio. That was the whole point. So when they say that you can do fuck all with an angle, that's bullshit. As long
Yeah,
as you're
definitely.
using an angle, you have a ratio to work with. And if you have a ratio to work with and a couple of known variables, you can do a lot with an.
Yeah, but you don't understand the statement. Why you don't understand the statement is because I
I do
tried to.
understand. I do understand, dude. Don't say I don't, because Bev,
No,
Bev,
you don't
Bev,
because
Bev, Bev stated it, and he implicitly stated it. It was just about getting the conversation going about angle. That was basically at the end of that whole thing. I would put his tail between his legs, kind of thing. He just said, "Well, I hope you guys get it. You guys are talking about angles now. I mean, that's the whole point. Let's talk about angles."
Who put his tail between his legs?
Well, if you go listen to the audio of it, I'm sure you can tell you that he became meek near the end.
Who became meek?
Bev. I don't know if meek's the right description. A little bit more like kind of gave up, right? And in a sense that when he was giving up, he's like,
No,
"Yep,
wrong. Wrong.
I was right. It was all about angles. You guys are
No,
talking about
wrong.
angles now. I mean,
Wrong.
now you get
Wrong.
the point, right?" But he didn't have
Wrong
that
on all counts.
meter.
Wrong on all counts. First of all, the clown called Nathan muted me, Bev, and Emma at every turn. We didn't get a chance to speak. So you going there and white knighting for Nathan, that's the most pitiful thing I've ever heard you seen you do, bro. Like seriously, that
Yeah, but Bev has been a
was
douche to me,
really
dude.
low of you.
Bev is the douche. I showed you can get an angle at his show, and he's trying to make fun of me. I brought in an observation signs to his show, and he held the same position back then. It's just an angle, right? I say bullshit. This is what you can do with an angle, and by the way, it's a right angle triangle. I did the whole geometry on his show, and he treated me like dirt, dude. So
Right, so you took the
if you can
opportunity.
have the ratios work,
Nice. That's what I thought. Yeah.
No, I know that Bev and Data have tension because I remember back in the early days when you would go over to his server, and I think for a minute there you guys almost got along at the beginning, and then wow, there's been some happenings between you guys.
Yeah.
he just was always
just-
very rude to me, dude. So yes, you can get a lot with an angle. Like I said, using the word angle is derived ratio. If we live in a Neoplatonic system, and it's the Greek mind that we're trying to dissolve here to get to a new reality, sure. But at the end of the day, when you mention the fucking word angle, you have a 90 degree or
Listen, dude, that statement was made for Ruhiv. Had people been allowed to speak, it would have been explained to them that statement was made for Ruhiv, not for the FED crowd, and they got all defensive about it. It had nothing to do with them. It was made for Ruhiv, that you can do fuck all with an angle, with a single angle. That's what that means.
Oh,
In other words, to use
Ruhiv loves his angles. He shoots.
yeah.
He shoots his auto level to the moon.
Yeah, bro. That's what it was done for Ruhiv, to make fun of Ruhiv. That's what that's all about, Data. So now you know.
Sorry, so the clip where Bev said you can do fuck all with an angle would be from a conversation he actually had with Ruhiv, and answered to Ruhiv that he can fuck all with an angle, with the FED guys taking that out of context.
Yeah, I think a year or two, maybe 2 years ago, this happened. Yeah.
Okay, crazy, because I was already aware of Bev's criticism of the modus tollens, which I think the FED guys also recognized in a way, that Bev criticized that. Maybe they won't admit it, but I'm sure that this slipped through to them, right? So in a way, this might be just this intoxicated ferment on which the conversation has been introduced, right?
Yeah, well, people feelings get hurt, and people don't like their theories being questioned, and that's understandable. But you know, if you have something, you should be able to discuss it and don't freak out about it.
See, I remember in the earlier days when Nathan used to, in a way, almost kind of promote Bev. Like they did a couple of little streams together, and even just fairly recently. Remember when, yeah, he was like helping with that was a little while ago with a GoFundMe thing. Yeah,
right.
Yeah, absolutely. Yeah. Mm-hmm.
Yeah,
I got a
also
beef. I don't know what
I
it is.
remember when QE used to like jump on Bev, and Nathan used to almost like kind of not let QE go off on him. So he used to kind of, he was like actually standing up for Bev and not letting it go into a dumpster fire. But then now I guess Nathan's just went full dumpster fire on Bev.
Yeah, they flipped out. Like, I've been on the show a couple of times, and I'm not gonna say I wasn't respected. I was. I'm not gonna. I've been a few times on the show. I was respected at all times. But that last time, I don't know what happened. They're very sensitive with the angle, and and the sextant proves flat Earth. They don't want to discuss. Like they don't want to hear nothing.
I don't know if did you hear me when I confronted 10th Man about getting the declination angle from the sun, and that you need a circumference size to do that from? Do you guys remember what I called him out for that?
No, I never heard anybody call 10th Man out.
Yep. I went on Nathan Oakley's show and had it out with 10 because they're not being honest about celestial navigation. I'll tell you that.
Well, now you're changing your tune. How come you weren't saying that when you were on the show?
They're not. Look, they've not, because Bev is not honest either. Both of them have been fucking around with some bullshit, and yeah, that's what I've documented, dude. I don't know what to tell you.
I mean,
yeah, well, that was a sneaky thing. Anyways, well, it is what it is.
Yeah, I mean, I think that in a way the polarity in the content and the arguments back and forth in the flat Earth community also kind of maybe make content which Nathan wants. So I also think it's healthy to like differentiate between the show and the insights being displayed there, as it's for the show, right? It's always a benefit, I think, on Nathan's part for the audience if he can make an entertaining show, and if there's somebody to smash, it will be an entertaining show,
Yeah, well, if you want to make your bones, as they say, on insulting people and muting people, I mean, you can do that. See how far you can go with that.
Yeah, I think they have just a very rigid protocol, and this leads to the problems, as they are not able to step away from the rigid protocol,
Me, I've always supported most of their arguments. The gas pressure thing, the
I do.
Coriolis,
I find them
the Black
brilliant.
Swan.
Yes.
Yeah.
The arguments, in my perspective, are usable, or at least worth a thought, right? So when I came across their content, I was positively impressed, but this impression got relativized pretty quick. But I'm still listening to the show once in a while.
Well, I don't know. I don't know what to say. It's weird,
Yeah, I like in the days where I didn't read that much and rather watched videos. I came across a video from Marty Leeds. Have you heard about this dude?
I think so. Yeah.
Yeah, I mean he does some crazy stuff. He does this occult gematria stuff and this number letter systems and crazy esoteric stuff I don't know about. But one phrase of him really I remember this phrase he said almost daily, and he said that you have to be careful in your like learning and knowledge process. It's a jungle out there. And I really feel like that at the moment. I really feel like in the jungle of different camps and people trying to ideologize opinion, and this is what always have what I always like made me suspicious about groups, topics, and stuff in the world. You know?
Yeah, see, the only beef I have with anybody, not just Nathan, right? You have a show, right? A guest comes on. Now, do you call muting and insulting a way to treat a guest?
That's why I don't watch his show. I haven't been part of their show or listened to their show in months, dude. Like, I don't know how many months and months.
Yeah, but
I can't
that's
stand
what
that
I'm.
shit.
That's what I tried to hint before, SE, that they have a rigid protocol, and as soon the guest steps away or, like in a way, violates their protocol, they already know what to do. And since the guest violated their rigid protocol, it's then demonstrated that the guest is in a way stupid and can be insulted. You know the mechanism I'm trying to explain?
Oh yeah, too well.
Yeah, yeah. I think I watched a special edition of yours recently.
It's a version of subjugation.
Yep, well said. Subjugation. There's a few rules, a few ideas, and everybody's got to follow in line. That's it. Can't veer off. Can't question anything. It's too bad because there's a couple of smart people that I actually like
Yeah,
on the
but
show.
I mean,
Yeah.
we don't have to be dependent in our knowledge process from different people. I try to be only dependent on myself, right? In this way, like no gray areas in the learning process, only direct experience. I don't need anyone who like formulates any arguments for me or not. I mean, I'm interested in every good argument and interested in every thought process, but I don't need those to come to my conclusions. I'm not dependent on those.
Right, but certain content creators want people to be dependent on either their ideas or their arguments or different components like that.
And I really can't stand flat earthers also, which like come across their research from 5D RTRH videos, man. It's both sided.
Yeah, well, it certainly was not an open dialogue, that's for sure.
No.
Well, I was surprised that I really was surprised.
Yeah, I was too. I mean, I don't listen to their show, but that one, I just saw it pop up, on my list, and I saw he was going after Bev, and I was like, oh, what is this about? So I listened to it. So I did hear that whole.
Yeah, he had a video with SE also, I think.
I watched a couple short clips, and then there was like a 2-hour one, which I think was the main cut with Bev. That
Yeah.
one.
So how do you know it was me, SC, that called? Because I didn't call under data. Then
You're kidding me, right?
so how
I
did
don't
you know me? Like,
recognize your name.
did Nathan?
Well,
I never had a
recognize
name
you.
on his show.
I mean, I do think you can do a lot with an angle. So that discussion was, I mean, I don't know. I mean, does Bev really think you can't do anything with an angle, or was that just more the Ruhif thing, and it had to do with the way Ruhif was using an angle? Because those guys took it as like practically, like, you know, as Bev was saying. I mean, is that really Bev's position? You can't do anything with an angle, or was he just repeating that phrase because it had to do something with Ruhif, and it was like a little bit of a different context?
Well, that phrase started with Ruhif, but he claims, and I don't want to speak for him, that just with a single angle, you can't do fuck all with it. It's just an angle. In other words, you need, for celestial navigation, you also need a clock. You also need the book, right? The nautical almanac.
No, you don't need those. You don't need those.
I just realized. No, I just
you know
what I just found out, SE?
Hold on, let me just.
What I just found out.
You can take angles to stars, travel to their GPs all day, just with an angle. And you don't even.
Yeah,
need
and not only that, and what I also finding out where the declination of the sun is. If you take the basic circle Euclidean 360 divided by 360 days, 365 days with a cosine of the angle, and then you'll get the apparent you can get the apparent position of the sun along its position in the tropics, right between Capricorn and so you don't need an almanac for that. Because I was looking into this, I'm like, why do you need an almanac to find? You can find your latitude with Polaris and so forth, but to find your position with the sun, your latitude with the sun was quite a bit more challenging, right? So apparently, with this quick calculation, you can you don't need necessarily the almanac entirely, but they do have it because all the corrections are there. Which obviously, when you do navigate, you're anywhere from a mile to 20 miles off your location, right? So anyway, I'm just saying I found out that you can use shorthand geometry calculations to find the declination of the sun without an almanac.
What is an angle with no numbers?
You have to have some more information, but at the end of the day, when you get that angle, you're taking it.
So what is an angle with no numbers?
A ratio.
A ratio, a portion of a circle.
Lines meeting in the vertex?
It's much like a point until you define it. It's just an angle. Just like a point's a point until you define it.
Yeah, I mean, an angle makes up 3 coplanar points.
3? Yeah, right, 3.
And 3 points make a plane.
So you're saying, Gio, that just with an angle, you're saying that you can navigate? How did you say that before? Just without using a clock or nautical almanac, you're saying that you found a way that you can navigate with that?
Yeah, you can navigate just with an angle. Yep.
How can you do that?
Well, if you
let's say you're in Los Angeles and you want to go to Hawaii, right? And you're on your boat and you take an angle, just an angle. How would you navigate?
Well, what I was referring to is like if you take a freeze frame of the sky, let's say at 2 a.m. Now, if you're saying you don't have like a physical watch or a clock, then yeah, you would have to be able to keep track of the sun. You'd have to either be in the rhythm of it, or there's other ways to, sundials. There's a lot of different ways to track the sun and moon, just so you know your general time. If you know the cycles of sun and moon. So let's say you take a freeze frame at like 2 a.m. one night, and you don't even need a clock. You could use sundials and moon dials. So let's say at 2 a.m. you take a freeze frame of the sky. Now, in order to get the same positions of those stars every night, all you would need to do is adjust your 2 a.m. time by 4 minutes to account for the sidereal rotation, the 23 hours and 56 minutes. So if you offset it by 4 minutes every night, you'll get the same positions of the stars. So once you have that, now you have a grid system above the Earth, and every angle you take to a star is part of a circle of equal altitude and is a radius to a GP. So at that point, you can use an angle if you wanted to, just to go to like the GP of one star. you could use that angle to calculate where you are in the circle of equal altitude, and then continue traveling in the direction of that star until you're at the GP.
Yeah, but you just added a whole bunch of stuff there, right? So maybe so. I'm not saying no, but you mentioned almanacs, you mentioned a whole bunch of stuff.
No, I never mentioned an almanac.
Didn't you mention an almanac?
No.
Oh,
I
my
just
bad,
said
man.
you freeze frame the stars at 2 a.m. every night. Now you have a grid system. And if you take one, I mean, I'm not saying this is the way to navigate. You were asking, could you do it with one angle? And I'm just saying, yes, you could take that one angle and calculate where you are in the circle of equal altitude from it, and then travel in the direction of that star and get to the GP. And of course, you could take many other angles and get you could get your position on the circles of equal altitude of any star that you take an angle to. So, I mean, the angle alone gives you that position. And then you do need to either calculate or measure the distance.
Okay. How would you get the GP though?
Well, you're not being given the GP. You're calculating. Well, you're just using the angle because you have your horizontal baseline, your angle to that star. The GP is directly under the Earth at that position. So your angle to it places you on the circle of equal altitude and gives you a radius to the GP. And then you can just travel to the GP. Now, if you've done a lot of this in an area, you would make a map and you'd have your map. And at that point, you would say, okay, like let's just say in theory, if you started just on an island in the middle of nowhere, let's say way in the South Pacific, and you wanted to get to Hawaii or whatever it may be, really far, and like you were saying, get to Hawaii, you could start with just one angle to a star and start your traveling. And once you start hitting the GPs of the stars as you travel and you're taking all of the angles to them, you end up essentially making a map and mapping out the whole grid system. So if you already have done the map and you've already been to Hawaii, well, now you know exactly, it's your own almanac, basically. You're building it out of the angles. So then at that point, once you have a map of it, you would then be able to even have more information. If you want to travel to Hawaii, you'd be able to use the angle of the star to your position to hone in on it as you're traveling night after night.
I don't think it's that simple, bro, to get the GP. I'm pretty sure there's no way you're going to get the GP the way you're saying.
Well, you can even do it in the simplest way in the world, which is just to travel in the direction of a star until you're under it. Literally, which is absurdly simple. Like if you just picked you use the North Star, for example, you just follow the North Star, you'll be at the North Pole. But even if you use another star, you literally can just point the nose of your boat at that star every night. And once you get to the GP of it, you're at the GP. Now, I'm not saying that's like the most accurate way to do it, because obviously once you get pretty close to it, it's going to take some more subtlety to get to the actual bottom of it, in your local area. But you could technically do it that way.
I never heard of that before, so I'm not going to say yes or no either way. But to me, I think the GP, there's more to it than just an angle. There's way more to it than that.
Well, it's just the position under the star. If you are directly under the star, you can build a little device just out of anything really, like a little shell of something, but you can build where you can put it on the ground and then the starlight will shine directly through it if it's at the GP. And if it's not, it won't actually shine through. So you can build a little GP device and then you can actually be at the GP. But I mean, any angle you are to it is going to bring you to it.
Geo's GP device. It sounds like a marketing thing.
We've talked about making ones that you could mail to people, like in a little cardboard, and you kind of, they could paste it together and get the GPs. Sorry, someone else.
Essie, it doesn't bother you at all, or your conflict within you that when they mention angle, the whole devised system of angle, the number that you get, the ratio you get, comes from a 90-degree, without that presupposition, I guess, of a right angle triangle, that you can't get an angle to begin with. And so, for instance, if I measure an angle to Polaris and I take 90 degree and I subtract that angle that I measured, that I got from Polaris, and then I multiply it by 60
60?
because I will get a linear distance, right? Now, where did I get that
Based
60
on what?
from?
Based on what?
Well, this
Based
is
on
another
what?
example. Well, this is another example.
What's
So
the 60 based on? Data?
a circle,
Of what?
25,000 mile circumference circle.
A globe cut in half, correct?
Well, it's technically just a circle. It's just
Technically a
derived from a
globe
circle.
cut in half, correct? The
It's a circle.
circumference of a globe, right?
No, it's a circle. It's not a
Yeah.
circumference of a globe. It's a circle, dude.
Yeah, okay,
It's
dude.
all circles. That's why it works wonderfully
You
on a
know very
sphere.
well that celestial navigation uses a globe and uses the center of the globe, and the nautical miles are based on a globe cut in half at the equator, 360 degrees. Each degree is 1 nautical mile. Surely you know that with your intellect and your research and your book writing.
Yes.
Yes. Uh-huh.
But
not
he's just
an
saying
equal-
it's based on a circle, though. Instead of like you're saying the equator, he's just using essentially the circle of the equator
I understand that.
as a
I just
circle.
want-
That's it. It's just circle. That's why you can get away with it, whether it's sphere or flat, because it's based off that circle.
Yeah,
so
yeah,
even
but
though,
I just
for
want
instance,
to
hold
be
on.
clear.
So can I?
Yeah, go on, Data. I know you're going to go on anyway.
Well, if you wanted to find the circumference of a circle, or if you wanted to find, let's say, for instance, you had an object in the sky, and it would move in relation to how far you moved away from it, and you could get two angles in a known distance between it. You could multiply the 360-degree circle to find out how big the radius is and how big the circumference is. You understand that, right? So what I'm saying is if I make an angle to Polaris and I move 70 miles and it changes 1 degree, which there's videos online, guys taking and doing a marking on the vehicle, and then driving 70 kilometers and doing a second marking and doing a measurement showing there's a degree change. Well, if that was the case, you would be able to take basic Euclidean and derive the radius and a circle from that, right? You agree to that, correct?
Speaking just geometry, yeah, but that's not, I mean, you can do that, but are you sure that you measured the whole thing that you're on? Have you done it, first of all? Have you went all around and done that?
Again, that's
These
just
are
a
just
presupposition. Hold on, this is a presupposition. So there's,
hold on, bro. Hold on. Every time I go to talk, you always interrupt, right? Now, what I was going to say before was the nautical mile, right, is based, whether you like it or not, I don't care. It's based on a sphere. I want the people to hear this that are listening. It's based on a sphere cut at the equator in half, and the two halves, you use either one. You make 360 degree, and each degree is assigned 60 nautical miles. Now, there's nothing you can say or do that can change that. I just want to make that clear.
Yeah,
now, go
yes,
on,
I
say
can.
whatever you want.
I can change that because they say that it's nautical miles is a hypothetical. See, here's the thing: is if you look at the origin of how a mile was made, which is 1,000 paces with a man of a foot span of 5.28 feet, a nautical mile is 6,064 feet, where a standard statute mile is 5,280 feet. But here's the thing: I thought the distances between the 2 points. Hold on here. Sorry, I'm having to do something. My apologies. Sorry. One sec, I'll be back.
It's not a problem. I'm not saying that I believe them. I'm not saying, I don't believe there's a globe, right? I'm just, that my argument was with the FED boys was this. Wasn't the angle. It was that they use a nautical almanac for the GP. And that's based on a sphere cut in half at the equator and given each degree is given 60 nautical miles. I mean, that's what it is, man.
So hold on, just to correct you. So all observations, even Ptolemy's observations, were made with the presupposition that the only way to get those measurements was to put yourself at the center of a presupposed sphere. Yes.
There you go.
They even
There
say
you
that.
go.
Yes. Yeah.
So thank you for being honest, Data.
But it's not. Yeah, I understand that, but it's a presupposition. See, the thing is that all taken planar surface, right? And they're having all those objects presuppose them. You have to be at the center to get those ratios. right? The problem is that they're not at the center, and those are not the ratios. So, for instance, you claim that 1 arc minute is part of the equator. 1 nautical mile is 1 arc minute, which they also say it isn't true. Isn't true. Different latitudes. In other words, the linear relationship and the angular relationship are the same, right? So if you have that context change all where you go. Hold on, man. Oh, sorry.
You know, if we're gonna say stuff, if we're gonna get somewhere, we have to say what is, no matter, you know, whoever likes it or not. Too bad, you know. And there's no question the nautical almanac uses nautical miles, and nautical miles are a globe-based model. I
Does
mean,
it?
it's, you can't argue that.
Oh,
Hit us with it, Bacon.
where do you find nautical almanac? Sorry, where do you find nautical miles on the almanac?
No,
I
that
didn't
is
see any nautical miles.
the GP. We're not taught. When I say the nautical almanac, the main thing for that is getting the GP and all
Well,
the
how is
corrections.
that? How is that related to nautical miles?
How do you navigate?
It's a long
It's
process.
it's just a unit of measurement. Statute miles.
Are you talking about?
Hold on. If I wanted to find out how many
I want to
degrees
ask
the Earth,
Essie a question.
if I wanted to find, I know. If I wanted to find out how many kilometers I'd have to travel for the degree to change, it would be 111 kilometers, as the same as 69.1969 miles versus 60 nautical miles. They don't mean anything, dude. It's just based on the unit of measurement and the circle that it's derived from.
Hey, Essie, when you talk about GP, are you talking about the GP of the celestial body or your GP?
Of the celestial body, of course.
Yeah, that doesn't make any reference to nautical miles. It's just a coordinate.
I didn't say it. May I you want me to say it again? The nautical almanac is used for the GP and corrections, a lot of corrections.
Right.
Now, the nautical mile is used for navigation, for celestial navigation. Those are two things. The nautical almanac and the nautical mile. Those are two different things that I talk about.
Yeah, I'm just trying to understand. So you're not saying that.
Ask me whatever you want.
Okay, so you weren't saying then that the almanac gives you the 60 nautical miles per degree. You're not saying that, right?
No.
All right, that's what I thought you said. Sorry then.
Oh, no problem. What I'm saying is where the nautical mile was derived from, and if I made an error, anybody feel free to correct me.
It's just the hypothetical ball, dude. That's all. So it's just another measurement.
Yeah, right? It is, but it's based on that, isn't it?
But you can look, dude. You can take a size of a circumference of in kilometers. 11
yes, I understand.
kilometers.
You can draw a circle on a plane. I get what you're saying. I'm not arguing that, bro. Not arguing that.
So it's irrelevant whether you claim that it's a sphere. The point is,
it is relevant when you use celestial navigation as proof for a flat Earth. That is a problem for you. Yes, because celestial navigation uses a nautical almanac, and it also uses nautical miles to navigate. There's no way around that.
But you can convert the nautical miles at any point. I can get a measurement.
You can play bingo on top of your mast if you want. It doesn't matter. You won't change that fact. You can tell me anything else you want after that. How it's done, who did it, how it's done. We can talk about corrections, about mirrors, whatever you want, angles, anything you want, bro. You can't change the fact of what I told you.
Well, it's a nautical almanac, right? And nautical miles are associated with nautical almanac. So I guess you can infer that they all go together for a sphere.
Well, yeah, I mean,
the word nautical.
1 nautical mile is correlated with 1 minute of latitude. So for each minute of latitude is 1 nautical mile. So it's really just derived from a circle.
It's an arc minute.
1 arc
Yeah,
minute.
based on a sphere.
They also say 1 degree too in aviation, which means every 60 nautical miles the plane drifts 1 degree, which means it'll be 1 mile off course as well. So there's an interesting thing to be said about that.
I mean, they explain it as an equator on a sphere, but if you were to met like an AE map with an equator or a sphere with an equator, it's 1 minute of latitude. So whether you call it an AE map with an equator and it's a circle, or whether you call it a sphere and you make the circle the equator of a sphere, I think it still is just rooted in the circle ultimately. It's just a degree of a circle. It's a minute of the entire 360-degree latitudinal system.
Well, but the longitudes shrink in the southern hemisphere. How
Take
that,
out
how
your
does that make sense?
calculator. Take out your calculator and times 69 by 360. See what you get.
You know how they're doing that?
What's that?
24/9.
Wow.
I just posted in the chat there. That's how they're doing that. They're just calculating the latitudes as pinpointing to 4 quadrants on a planar surface.
Who's doing that?
Well, I'm not saying this is the map or anything, but the continents I definitely do think come out the way like this, in 4 cardinal directions. And I'm just saying,
You're saying on a horizontal plane? Is that what you're saying?
Yeah, and just see how
Okay.
see how those longitude lines, like if you go to South America in the lower left there, see how they look like they're all converging? That can still happen over a planar surface. Doesn't have to be a sphere for that.
Yeah, it can happen.
To calculate it that way. But then you have the southern oceans, which is where the real key would be to deciphering that.
Yeah, it can happen on a flat Earth as long as you can teleport, right? Because that's what that map implies.
No, I'm not referring to any teleportation. No.
Right. So you're also not referring to that map. Like you can't throw a map.
No, hold on. I simply posted that to respond to one thing, which is you said, how can longitude lines converge in the south? I simply posted it to just show one layout that shows a planar surface and still those longitude lines centering in 4 quadrants like that, to where they can converge in the south like that, if you want to interpret it that way. So I do think they're doing something like that, because you're right. They do claim that longitude lines converge in the south, but it's not because they're all converging to the bottom of a sphere. It's just that they're just creating that geometry within a northern southern region, just like in a similar way that map shows.
Yeah, but I mean that map would require you to teleport, so it doesn't help.
Why are you going to teleportation when I'm talking about the geometry of longitude lines?
Yeah, because those lines, like if you get the next line past the equator, that line below Africa is the same as that line below South America, right after the equator. So if you follow that line from South America, you end up in the line of Africa. So if you, in that map, you teleport from one side to the other. And also, in that line, the equator is a square. So, I mean, it doesn't help.
I didn't post this map to say that this is the map of the Earth.
I know, I'm trying to respond to that.
And there's no teleportation. I simply posted it to show how converging and diverging latitude lines in northern, what one might think is a globe, like the southern region, can be laid out over a planar surface.
Yeah, I don't think it's a valid response to bring a map that brings more problems that it solves. Like, okay, it solves this problem.
You're using red herrings to run off about this map. I didn't post it post to talk about the map. I posted it to respond to one simple thing you said, which is longitude lines converging in the south. That's the only thing. You're red herring going all into non sequiturs about other things about this map. That's not even what I was referring to. If you want to talk about this one, we could, but it seems like you're avoiding the fact. Okay, could you just agree with me? Yes, I see what you mean. Longitude lines could converge in the south on a planar surface.
Yeah, as long as you can teleport.
You can't bring up something that even you say is objectively wrong to try to dispute his.
I did
his
not
one
say anything was
aspect
right or
of-
wrong. I never said that. Now you're making up
You
things I never
can't
said.
use it to try to dispute this one aspect
I
of
can
his
use
argument.
anything I want to do anything. Bacon simply
That's
said
not
the
how
word,
logic
how
works.
could longitude lines converge in the south? I posted a map layout that shows longitude lines converging in the south. That was the only thing I posted that for.
Yeah, but you will agree that that map layout is objectively incorrect. Yet
No.
you're using it to dispute
No.
an
That's
aspect
I
of
never
his
said it's
argument.
incorrect. No.
So you think that's the layout of the Earth?
I never said that either.
So you don't think it is, then? You don't have confidence in that.
This whole simple point could it, like if Bacon just said, "Oh yeah, I see what you mean. Yeah, I see how okay, longitude lines could converge in 4 southern quadrants like this instead of at the bottom of the sphere." I see what you mean. So if our governments and our different people are calculating the longitude lines over the areas of land in this way, that yeah, it could be that. That's all he would have had.
Okay.
Yeah, but
Latitudes of
I'm
lines,
not.
sorry, latitudes of lines cannot converge and also represent the Earth as we know it to exist. I don't know if I said that right, but whatever. Y'all get my point.
I didn't. Okay, so
And Dave, just because celestial navigation works doesn't mean that I think that the Earth is a sphere, because there's many civilizations that have used the stars for navigation for millennia. So it doesn't mean anything one way or the other, for the sphere or for the flat Earth.
well, it does. What kind of method you're talking about that was used for millennia?
I didn't say math. I never mentioned math. I
That's a
said
method.
people use the stars. Listen to what I said. People
You-
use the stars to
you misheard me.
navigate for millennia.
Yeah, and I asked you what method they used. No, what method?
I'm not an expert. I know the
Right.
Chinese navigated. I know the Arabs navigated. I know the
how?
Polynesians. I can tell you a bit of how the Polynesians did it because I
Yeah,
looked
how?
into it recently.
How?
How? They apparently they used the coconut.
Mhm.
Okay. They also used the wind, the
How did
sun.
they use the coconut?
They used the coconut for to get an angle, I think, to look at the sun.
I
Now, I don't
looked
know
at-
exactly. I don't know exactly how they did that.
You can use it as a sextant. Yeah.
Yeah.
You
Yeah,
drill
they
little holes in
didn't-
it. Yeah, you drill little holes in it. You can look at the stars through the holes and the angles. You get the angle from it.
Yeah, but they didn't get angle measurements of stars using that.
Yeah,
They were only.
That's what they say. Now it's hard to know
One
because they
second.
didn't have any
Can I-
written records. But yeah, that's they
Yeah.
actually say they use the coconut.
Yeah, I agree that they used the coconut, but I also looked into how they think they use the coconut. Like, what's the possible way they could be using the coconut to navigate? And the way
if
they,
I would guess, they would use like
experts already
sun
guessed.
or the moon. What?
Yeah, experts on the subject already guessed how they used it. I
Yeah,
read
yeah.
into it too. Yeah,
Okay,
I read
go for
it.
This is a very crude drawing right here, or this one's obviously not very highly detailed, although it does show when you have multiple lines, you basically have, there's different ways to do it, but you don't get as much accuracy because you're not getting every single degree, but these different lines will align with different degrees, and then you can get the angles through it. The different
Okay.
holes align to create different sights through the little coconut itself, and then when you can sight a star through it, then you verify that angle.
So you think the Polynesians thought it was a globe too, Bacon? I mean, the
Not
coconut is a globe.
necessarily.
Looks
No,
like
not
a ball, the
necessarily.
coconut.
Not necessarily.
Yeah.
So that's why I'm asking how they're using. Because if they're using in a way that is agnostic on the shape of the Earth, which means that nothing that they're doing requires any understanding on the shape of the Earth, then their method is irrelevant to the conversation on the shape of the Earth. If what they're doing does require some understanding on the shape of the Earth, if it's based on Earth being like this or like that, then it is valid. That's why I'm asking how they used. So I looked into how they used, or how the experts that study the subject think that how they used. And they have specific angles for specific stars. And they would only They have to wait until the star reaches its high noon. So they wait until the star is in its highest peak, and that is related to latitude. And that doesn't require any shape of the Earth. That would that work on both flat or spherical. That doesn't matter if a star is at a certain angle to you when it's at its high noon. If you're in the same latitude, it would always get to that same angle. So they would use that coconut sextant just to keep sure the star is reaching that same angle when it's high noon. If it's too high, they have to go away from the latitude. If it's too low, they have to go towards that star, and that's how they would keep themselves in the same latitude all the time. So they weren't getting a straight line to where their destination was. It wouldn't tell them where they were. It would only tell them if they're in the same latitude as they were before.
Did they navigate using that system?
Obviously, I already just explained how. Are you going to ignore everything I said?
So, no, I'm not going to ignore anything. So you're saying that your system, the one you have now, is guaranteed to prove globe. That's what you're saying, right?
That's what you must
be saying. So you're saying that
the method we use definitely treats the Earth as a specific shape in order to work. If you change that
argument. That's my argument.
No,
so I don't know why you're arguing with me. Yeah.
I'm arguing when you said that other civilizations are doing celestial navigation for millennia. Yeah, but
that's
in the conversation about the shape of the Earth, it matters what the method that they're using, what kind of information that method uses, what kind of information that method can provide them, and whether or not it depends on the shape of the Earth. This one
it only matters to you and your brain because you think that the method that you use can only work on a globe, right? Now, the FED boys say the same method can only work on a flat Earth.
They don't know how to do it. Right? That's why they think it. They have no clue how to do it.
They use. That's what you don't get.
But that's not symmetrical.
Boys, and I laugh at you guys because I say you can't prove fuck all with lights in the sky.
There's a key difference between we and the FED guys.
That's what they say too, bro. Yeah.
Yeah, but we have demonstrated it. They didn't.
Of course, they have demonstrated it too.
No,
bro.
they didn't.
Yes, they did.
No, there's no video of them doing celestial navigation. What you're talking about?
Is there any video of you doing it?
I can do it right now. I've done it in this server, so it's recorded here.
Okay, I want to see you on a boat. I don't want to see you playing games on your computer.
I'm not talking about playing games.
I want to see you on a boat, my friend, with a sextant, a chronographer, and I want to see a nautical almanac, and I want to see you go from point A to point B. I'll bet money you will get lost at sea. Take my bet.
If you're paying to put me in that situation, I'll take the bet.
I'm not going to pay for it. Why should I pay for it?
Oh, why should I pay for it?
Exactly. So you're just going to come and talk with your fancy little computer models.
No, I've done this shit in real life.
Well, Bacon, the thing that would put it to rest, because you can actually do it. Like, here's what I'll say. I definitely, the Earth is as planar in its geometry in my viewpoint. However, you can still navigate on the planar Earth with a globe celestial assumption, because it's not going to be as accurate, but you can still do it within a margin of error. So that's where the problem is. So to really put this to rest, it's not about assuming it's a globe and going out there and getting from one point to another. You can definitely do that. There's many. That's why Kool-Aid comes in and says he's done it. That absolutely can be done. It's not going to be as accurate, however. And the people that are doing it are not building entire circles of equal altitudes and so on. They're usually just using the almanac, using a lot of the corrections and the general directional headings to then get to where they're getting. And they don't get nearly as accurate as they would be if they were using the correct geometry.
I don't know that.
Because that's the history of how they've transferred over celestial navigation with the globe model and have ad hoc'd it into the world, and then have also very swiftly suppressed it in various ways, in terms of GPS and trying to replace it. And at this point, it's kind of not something that's taught and studied, because what you would have to do to delineate the difference is to go out, start taking tons. I've said this many times, take a lot of angles and actually build an actual map yourself a grid of the actual angles that you're getting and build real GP points, not from any almanac or anything like that, just your own GP points with circles of equal altitude, and connect all of those GPs and the circles of equal altitude. And so by doing that's a lot of work to do. Like, you're not just going out and trying to navigate from one city to another, or from one and get generally close. What I'm talking about is actually building the entire grid system with all of those angles and actually building the GPs and circles of equal altitude and the land at which those line up with, the soil, the actual dirt and rocks. Now, to do that would mean it would be a pretty large project to do, and to do enough area to where you could actually get the answer as to the GPs and the circles of equal altitude, whether they're all coplanar or whether they're curving on a curved surface. But with the 8 inches per mile squared, it's obviously not a massive amount of curve. So you'd have to do enough of it to actually get that difference. That is the only thing that would actually settle the shape of the Earth with celestial navigation. Otherwise, both sides are going to claim it can be done with their model, and both sides will be able to do it with their model.
Okay, let's rewind a little bit. You said it's not as accurate as if we were doing it right. Do you have any example of any comparison between doing it right and the way we do it? Or are you just guessing that?
I'm not guessing that. I know that it is not accurate to, like, if you wanted to get into, like, let's say you were going to, trying to think like the coast of somewhere, like wherever you want, just a coast. I'm just trying to think of a coast that doesn't have a lot of landmarks, where it's just a lot of, yeah. But anyways, if you're trying to get like to a port, like into like a dock, like in a specific area, the globe celestial navigation will not get you that accurate. It'll get you within a range, and then you're going to have to use other techniques to actually get into the port. So it's not accurate to a location like that. Or if you want to get to like one island, like a particular island, it's not accurate enough to get you to that island. It's accurate enough to get you within a range, but not to the actual island. So the 8 inches per mile squared changes it, but not enough to make it undoable, but not so much that people can't still use it in these globe boat races, and that, like, that Drink a Kool-Aid uses it and stuff like that.
Well, what is the way to do it that is more accurate than the way we do it? And how do you know it's more accurate?
You have to use the correct geometry, and you have to have an accurate, ideally, if you really want to be super accurate, you have to have the GPs.
Just more accurate.
The GPs, it's three components. If you just are born on an island in the middle of nowhere, and you have a sextant for some reason, and you make a little boat out of wood, and you get in your boat and you start going. You don't need any almanac. You don't literally need anything. A moon dial and a sundial obviously is helpful to know the time, but you can make those with a stick in the ground. So you can begin. Now, if you don't know anything yet, yeah, of course you're not going to be very accurate, because these are places you've never even been before. So you can't just go find a little rock somewhere in the middle of nowhere if you haven't even been there yet. So, however, you can, let's just say in theory, you begin navigating and you begin doing what I'm saying, GP, circles of equal altitude, etc., and you're actually mapping it to the soil, and you're drawing a very, like a 2-scale map, of course, on a flat surface. You're drawing your map of your coordinates to that. Now, once you've done that in a big enough area, you now have the correct map. At that point, now if you want to get somewhere very accurate, now you can get to precision, because you have all your angles, all your circles of equal altitude. Wherever you are at any time, you can take angles to a couple stars. You can plot yourself on that map and be like, oh yeah, here I am, all these circles of equal altitude. And then where do I want to get? Oh yeah, I see my, the area I want to get to is over here. And now it's all you have to do is navigate upon that path and check it every night against the stars and continue on that track, and you can get pinpoint where you want to go.
Well, you're not describing any method. You're saying how you would come up with one. But you seem to already know that there's some method that is better or more accurate than the one we use. And
I'm claiming that using the correct geometry of the Earth, the way I just laid out, the coplanar points on a flat table or something that you're mapping it on, Of course, that won't even work if it's a sphere. You won't be able to fit it on a table. But maps have been flat since the beginning of time. That's why I've told you, if the Earth was a globe, map makers from literally day one when they started doing it, they would have been like, oh my God, this isn't even fitting on a flat surface here, guys. We got to get some kind of curved surface. Let's get some paper mache or let's try to make a sphere. That's what they would have had to do. But that's not what they've ever done, other than in this modern day where they print out these globe things.
That's another topic. I'm still waiting for what's the method that is more accurate, and how do you know it's more accurate?
The only way to do that is to do what I just said.
Okay, so there is not that method yet, because no one had done that, right?
I think in our modern times, it doesn't appear so that I'm aware of. No, it seems like even like in the military, they do the simplistic form because it's all been replaced with GPS. So even like experts in the field, they know how to do it as far as the globe model goes. But what I just said, like an accurate, all the angles, the GP, circles of equal altitude, as far as I'm aware, in our modern day, I've never seen it done and documented in a large enough area to decipher the shape of the Earth. So this is something that in our modern day has not yet been done.
Okay, so you are guessing.
It's not guessing though, because the thing is that the globe ad hoc version of it, of course, my viewpoint is ad hoc, is not accurate. So that's already the case. It's only accurate within a range. And that's why
Okay,
you guys have to do all the corrections because of that problem. The Haversine, there's all these corrections you have to do to deal with the geometry not being accurate.
That's not even a correction. But okay, so if I get what you're saying,
it's used in the correction.
You think this method would be better because you don't think Earth is a globe, not because you have evidence for that.
No, you're convinced the Earth is a globe because of celestial navigation. Absolutely ridiculous.
That's cool.
Everybody knows the Earth is not a globe.
What I'm asking from Gio. I'm asking something for Gio because Gio said there's some better method. I was trying to get to the better method, and he described how he would get to the better method. And he also said that there's no one that did that in modern time have that better method. So I'm asking if he's done guessing that this better method actually is better. He's saying no because Earth isn't a globe. That's what I understood from his answer.
That's not what I said. That's another topic. Like how I know that. Is that what you're now asking?
Yeah, how you know it's more accurate. Because you're saying there's a more accurate method. I'm trying to get to how you know that.
Okay, so you're asking if I'm saying that using planar geometry, using the circles equal altitude, GPs, etc., if that's more accurate than using a globe. But if it hasn't been done sufficiently with evidence in our modern time, how do I know that to be the case? Is that your question?
I think so.
Well, right, because I'm not claiming that I have evidence for it. I'm claiming it's the truth. And I know that because of the geometry, for many other reasons, like the geometry of what the Earth is, many other components of my understanding. And the fact that using the globe one is not accurate doesn't make sense because the stars are a grid system with precision accuracy to the Earth. So to have using celestial navigation that isn't pinpoint accurate means you're obviously not using the correct geometry.
Well, but like our measurements have a margin of error, like margin of error of a
it's 8 inches per mile squared.
No, the angle.
That's the precise amount of margin of error.
The angle, the precision of a sextant, the angle reading is 0.1 arc minute, and that you have index error, you have refraction to correct for, and you have the dip correction to correct for. If you're using, for example, theodolite, you don't have to worry about dip correction, for example. And the precision is much closer to, like it's down to a tenth of an arc second or just 1 arc second. That's much better than a sextant. If you use a theodolite, you get a much better position. So it has nothing to do with Earth not being a sphere. It has to do with the limitation of a sextant. A sextant isn't that precise enough. The precision you get to your coordinates is similar to the precision of the instrument itself. So that's not any evidence that the geometry is flawed. It's just evidence that the sextant has a margin of error, which it does.
Yeah, so you're just throwing in a margin of error within the ad hoc use on a globe model. That kind of illustrates my whole point. That shouldn't have to be done.
No.
Because in reality, the angles do have, I mean, they're obviously, the angles themselves have some limitation of accuracy. However, that's the whole thing about the circles of equal altitude and GPs, because those are all a grid system. And the coplanar nature of that grid system means that it's like gridlocked on a plane. You know, they all have to be on a plane. So when you start building those GPs and circles of equal altitude, the little bit of margin of error that could be off from either your coconut sextant or your sextant, whatever you may be using, becomes less and less because you're comparing it to all of the other grids on the system. You're comparing it to all of those consistently. So it actually minimizes the margin of error. If you only have like 3 points, yeah, that's going to be a bit of a bigger margin of error. But if you have hundreds of them or thousands, it becomes extremely minuscule. And that's why it can be so accurate.
Not really. You're adding up a lot of error, even though you have a lot of measurements. They don't all cancel each other out. That depends on the source of your measurement. So for example, if it's an index error, then you need the azimuth that you're reading to be evenly distributed. Otherwise, you're going to get worse instead of getting better. So, I mean, that's not how errors work. And again, sextant do have a margin of error that's not something globe-based. That's just how the instrument works. It only measures up to arc minutes and has a smaller ruler for the tenths of arc minutes. So that's as good as you can get. Can't get better than that. That's the physical limitation of the tool. It has nothing to do with Earth being a globe. And that also follows the kind of precision you get for your position. So your position, the accuracy of your position is very close to the accuracy of your instrument. So that's not evidence for the geometry being wrong. Because when we get better precision, like using a theodolite, we also get a better position. So I'd say it's probably because we get the right geometry. And I mean, just compare any flat version of a sphere, you don't get like a tenth of an arc minute difference. So there are some positions in which distances get like 3 times, 4 times as big. There's nowhere near the kind of precision you get. Oh, look what Jess is doing. Can you please?
Yeah, I mean, we'll get it done, dude, in this lifetime for sure. So just, hang tight. We'll get it all taken care of in terms of mapping it all out. And it's not that difficult to do what I've explained there. It would definitely take a team, a group. You'd have to have the equipment, the time, resources, etc. But it's really it does depend on a couple factors, but in terms of the size of area that is needed, but it can definitely be done. It's not beyond the scope of what we can do. So we'll get it done, dude. We'll show it's all coplanar, and that'll be one of the many things that validate the falseness of the globe Earth.
Right.
Look, he's putting things on a ball. He's making triangles. All I do is take a pitcher of water and just pour it. This kills all your fantasy, man. Just one pitcher of water. That's it. Bam! Reality. Come to simplicity, man. First principles. Forget the stars. Forget making little plastic little toys and playing with your computers. Go out into the real world.
Can you guys see Jesse? Jesse's camera.
Yeah, he's playing with his little games. Yeah, we see him.
It's not a little game. That's what happens if you turn angles into distances. They don't.
My God, man. Is that what you think the Earth does? You can press on it and it goes down and humps and curves and what is this, man? Are you guys serious?
Well, that's what I'm saying. Map makers would have had to have globes from the beginning.
Of course.
Yeah.
Maps wouldn't have ever even been on flat tables. Like, you know what a map is? It's a thing you roll out on a table. You know, they roll them up, you know, in the pirate ship, and they store them all in a wooden, you know, trunk.
Yeah, not a globe to be seen in sight.
It's in a trunk. You pull it out, you roll it out on the table, and they go, we got to go here, Captain. That's what maps are. That if the Earth was a globe, they would have never been able to have a map like that. They would have had to pull out balls, and they would have had to paste things to a ball.
Why?
I'm laughing because I know that's not like some like
Why?
argument in a sense, but it also kind of is because it's true.
Okay, so either it is or it isn't. Like,
well, it's like this little thing Jesse
I think,
made. Like, you think for eons of time, humans have just been like question marks and then making little things like Jesse just did and being like, what's going on here?
Look, Captain. We live on the ball. Captain, look.
Captain, it's not fitting.
well, if you look to old maps, like the shape of the continents and borders were much less precise than they are today. Like they would vary by a lot more than they vary today. So of course, if they are wrong about the geometry at that scale, given how poorly precision those maps had, that like why would that be an issue? Why would that prevent those maps from being drawn? Because they're clearly not how the continents are. Like their shapes are very different. Not just compared to ours, compared to other maps from like that same time. You get different maps, they're very different from each other. So there wasn't very high precision on that.
Well, I'm not claiming any one particular map. I'm just talking about since the dawn of time,
sure,
humans make maps. I'm not even counting like what you can find on Google today as what you think is a map from some time. I'm just talking about map making in general, that it couldn't be done making a map on a flat surface.
Well,
there would be inconsistencies, especially with the GPs and circles of equal altitude. I mean, the way I'm describing that is like, the way I'm describing the GPs and circles of equal altitude is like the quintessential way to make a map.
Maps don't have circles of equal altitude.
That's precisely what they are. Because as you're navigating, angles, circles of equal altitude, and GPs, those are all matching up to the ground. And you're able to put like a little flag in the soil and say, all right, this is this one, this is that one. And as you do that, you're making the map from that directly.
Who's doing that?
You draw a little circle, whatever it may be, and you actually, the distances between the GPs and the circles of equal altitude and the angles to your stars all match up to the soil, which gives you your map.
No one was creating maps using circles of equal altitude. Where are you getting this from?
That's the foundational way maps have been made. If you're using the stars, there's other ways to make maps without the stars. But if you're using the stars to make a map, that's precisely how it's done.
Do you have any example of that?
Wait, I'm sorry, but stereographic projection was one of the first thing presupposed spherical celestial sphere on a flat.
Hey Jesse, watch out with your face.
You were cutting out a little. Data.
Well, stereographic projection came with a presupposition, right? The celestial sphere, they projected that on a 2D plane surface, right? That's what stereographic projection came from in the 1300s.
Hey, what continents did this triangle or this square go to, Bacon?
All right, let me pull up the data here.
I haven't glued it yet. I've just got it. Just the little tack pins in it.
Right. Yeah, the base of that. I don't remember which one is which. Let me send you like it connects North America, South America, Africa, and Europe. And that the base of that triangle, like the midpoint of the base of the triangle, is the one that is on Africa.
You know, we do Bacon. We get a group of globe Earth enthusiasts and a group of stationary planar Earth enthusiasts, and you get 2 teams on 2 boats. It's an all-out quest, and then compare all of their data.
I like that, stationary planar Earth instead of flat earther.
Yeah, I dropped the points on the Livestream 1 text.
Hey, do you have a little Apollo rocket somewhere in your room there? Little capsule of the LM or something? You must have, no?
Hey, we got Perthet here. Hey, what's up? Or maybe he can't. VC.
Bacon wants to interview Protothad.
Well, he was saying he's lurking, but he wasn't going to speak. But maybe if he's spoken to.
Sorry.
Well, get your team together, Bacon.
Are we going to do fantasy? We're going to do fantasy leagues? We're going to do a fantasy draft?
Yeah. We're going to live stream it all, record it all. It's all going to be vetted, audited. And
be warned, Bacon. Protothad is a little green around the gills.
From what?
What? I don't know what the expression means.
That means he's a little bit new to the game.
Well, I took that as to mean he was seasick, but whatever.
I don't think so.
Hey, SC, did you ever see Protothad go up against QE or 10th Man or any of those guys?
I seen his presentation. He makes good videos. I'll give him that.
I mean, he's been when you say he's new, he's been I don't know if you'd say engaging 10th Man and that bunch for years at this point.
Well, maybe he's not that new. Well, I'm basing it on the conversation I had with him yesterday about water. I wasn't too impressed, I'll tell you that. He was making like 2017 arguments.
So Bacon, if you had a team together and you did this and it comes out, you get the planar coordinates, would you want to are you going to be in the mainstream eye and are you going to tell the world?
Sure.
The question is, if it doesn't, then what? I mean, if he turns the globe, then what?
Yeah.
If I figure out,
then we tell everyone.
If I figure out mainstream science is wrong about the shape of the Earth, I'll bring that to everywhere I go. I'll bring my best argument, best evidence, and
Bacon. They tell you in the earlier works that they presuppose the horizon to be a tangent to the plane. So
I didn't hear that from anyone.
Well, that's what Ptolemy said, and the point is all the observations come from that presupposition, right? The geometry of the horizon, whether it's Alberuni or whatever star angle, you're presupposing that it's the edge of that sphere Earth, right? And the idea behind these measurements is that even philosophically, they place you at the center of a sphere. Ptolemy and all these other people who did these measurements, they were never at the center of a sphere, were they? But they had to presuppose they were to have everything move about them in a circular path from that center. That's how they devised the system, right? But you have to understand the contention between being able to see farther than the geometry states or the radius states. Like you must see the contention in that manner. Do you not?
I don't get it. I don't get your point.
Okay, so if you're going to make all your measurements and you're going to presuppose the spherical nature of the Earth, and then you're going to put yourself at the center of it, and then everything moves around you from that center point, and that's where you're deducing all your angles and measurements from. You're begging the question. You're making the model. You're putting yourself in the center of that model, and then deducing calculations from it. The contention is that those measurements were deduced from a radius. right?
What
Which
do
is
you
at
mean?
3.
I'm putting myself in the center. What do you mean by that?
So even in the nautical almanac, they place you at the center of the sphere when you're making these measurements, right? But more importantly, even Ptolemy states when he was making the measurements of the globe, like trying to find proof of the sphericity, they have a pre. Listen, dude. Listen. If you're gonna say it doesn't, I'm telling you right now, it's in a book. I'll give you the name of the book. You can go
Can I
download it for
answer?
free.
I say
Hold on.
why?
I'll tell you that
Can I say
before you.
why?
You just said no. Listen, they put themselves at the center. Okay, here the book.
No, the Earth is in the center.
This guy steals
book?
City. This guy steals City. When people are like giving him way too much information at once, he always says a little phrase. He says, "It's like trying to take a drink from a fire hose."
Who says that?
Steel City, that guy. It is kind of like that, Data. You throw, it's like just trying to take a little sip from a fire hose. Like you're blasting so much information, and the minute someone responds, you come with like 10 more points. It does make it pretty hard to respond.
I don't know that I'm making like 10 points.
It would be more potent if you said your point and then boom, pass the mic, and then let them say whatever they say, and then if you're right, just come back and just kill it like every time, because when you do, like when you keep going like that, and it's like it's almost like you're just saying your thing and then they're not even responding, and then you're just kind of getting like a false sense of overcoming whatever they're saying without actually, you know what I mean? So
I think it's a case of substituting them.
That was my long way of saying just let them respond.
I think it's a way of substituting quality with quantity.
No, Data has good points, but it's like if he links, it's like the Zanuck effect. Like he links 8 points together, and it's just, everyone's just like, "Oh my god!" Like 8 people wanted to respond to 8 things he said 8 times before, and then it's just mayhem.
Okay, so what's centered is the Earth. The Earth is in the center. The center of the Earth is in the center of the celestial sphere that you get in the almanac, not you. That's why you have to do things like a parallax correction when you're sighting the moon, because when you get the GP, you get it towards the Earth, not towards yourself, and there's a difference. There's a discrepancy there, because Earth is close enough that you have parallax. If you could argue that the stars could be centered at you, because it doesn't make any difference if you centered them at you or at the center of the Earth, because that difference doesn't give you any parallax to the stars, but it does give you to the moon.
Ptolemy was making the measurements, placed himself at the center, right? So
I don't know what you're talking. What measurement you're referring to?
Just the way they built the sphere, where they assumed they were at the center of everything. And to corroborate that is even in the celestial almanac, you are placed at the center when you're doing these observations, right? It's just what they so it's just what they state. I'm just trying to find you a passage here. Okay, so just give me a second. I mean, if you want to talk about something else till I find it.
If you go to Stellarium, you'll be on the center. Stellarium does put the coordinate of the star centered at the observer, but the almanac doesn't do that. The almanac does that to the center of the Earth.
So it's always going to be at the center, whether it's you, the observer, or the observation. It's always have that presupposition of the center of the sphere,
which they have no idea where it is.
Well, we do have an idea. What do you mean we don't have an idea?
Not even the slightest.
I mean, you can argue it's wrong, but we do have an idea.
What's the idea?
Well, take your ECEF coordinate system that take the square root of take the square of each one of those coordinates, add them up, and take the square root. That's how far the center of the Earth is downward.
What?
Yeah,
And
your
they know this
ECEF
for
coordinate
sure 'cause
system.
they dug 8 miles, so they know this certainly.
That's not how they do it. That's not how they know it.
I know that's not how they know.
So this is what it says here. It says now with this done, it should next take up the question of the Earth's position. The observed appearances with respect to it could only be understood if we put it in the middle of the heavens as the center of the sphere. If this were not so, then the Earth would either have to be off the axis, but equidistant from the poles, or on the axis, but farther advanced towards one of the poles, or neither on the axis nor equidistant from the poles. So
Can
they
you
have to make.
reading from?
So I'm reading from the Alchemist. This is Ptolemy's work. I always want to say Ptolemy, but
Is
it's
it
Ptolemy.
online?
Yeah, so it's great. Britannia, great books. It's
Can you link it?
books. It's a physical book I have in my hand. I don't like. I like actually grabbing physical books from the library, so or wherever I get them
Can
in
you
secondhand stores.
send a picture of the paragraph read in the live stream on text, please?
So go search it. Go online. It's free PDF. I highly recommend you read it. There's an argument as well that Ptolemy has. It says the Earth does not in any way move locally. Would you like me to read his claims on why it's ridiculous that the Earth spins?
I would like to read. I can't follow you reading.
Well, then you want to download the book. It's Britannica Great Books.
Can you just send a picture of the paragraph you're reading?
Volume 16. You have fingers, right? You can go into Google and type in what I'm telling you, and you can actually get the PDF for yourself.
All right, what's the name of it?
Britannica. Great Books. Yeah, Britannica Great Books. Volume 16. Ptolemy, Copernicus, and Kepler.
How do you spell Ptolemy?
P-T. O-L-E.
You can go faster.
M-Y.
All right. Ptolemy and what?
It just Copernicus and Kepler. You want me to spell Copernicus for you?
Nope.
Kepler.
Also no.
I keep saying Ptolemy. It's Ptolemy. The P is silent.
You said there's free download of it?
That's what she said.
Yeah, well, I don't know. That's what I've been told. I mean, I have the book here. I'm not going to.
Not funny to download it.
I don't know what to tell you.
You can
it's
take
definitely definitely worth the buy for sure. You know.
Yeah, I heard that from many people. But yeah, so what is exactly your contention?
My statement earlier was you must understand the argument of the radius and how it has certain boundaries, and you must be here because there's obviously one of two things. You understand that there must be a misconception to what the horizon is and the measurement to it. In other words, as Ptolemy suggested, the presupposition is a tangent to the plane. In other words, when we're viewing the horizon, we're going to assume that it's due to the sphericity of the Earth. That's why we're using the geometry in this manner, right? That's why we're calling it a tangent to the plane, because the definition is for a sphere, essentially. And the way, in context, mathematically, the way they're using it. So the contention would be is that is based on physical boundaries on a radius size of the Earth. If that has been falsified in the sense that that radius appears to change, in other words, that particular Mercator point, the horizon, is sometimes closer, sometimes farther. The point is the geometry is inconsistent to the actual geometry of the ball Earth unless you apply a whole bunch of other interesting anomalies on top of it. The point of me just clarifying here is that my contention is that you must understand the flat earther's position that we see too far. You must understand there's a paradox there between what you claim the sphere is and how far we can see, mathematically anyway.
I understand that's a completely different subject than navigation, which was what I thought you were talking about.
No, essentially, but while you're here, though, in navigation, it's still going to be from a planar surface. All the angles that we need are going to be from a right angle triangle, and from all the circles are all equal points of equal altitude, right? All the circles are. So you have these radiuses, circles, and all these 90 degree right angle triangles to get approximations for linear distances too. On top of that, I mean, these are the basic
right angle triangles. What right angle triangles are we talking about?
Okay, so I'll give you a basic thing, and you can check the geometry right now. So if you knew the distance where you were at your latitude to a North Pole, and you were to actually get a map, just a Mercator map, and map up that distance, and you were to go to the sun calc or whatever the you can use stellarium too,
Orchid
and just
doesn't
get
have
it. You can go to like you can type online what's the from your latitude, how far is it from the North Pole from where I'm at, and then you can go to an angle measurement program, which is stellarium is one of them, and go to your place where you're at and get the angle to the star to Polaris. Take a 90-degree, subtract that angle that you get, multiply it by kilometers, multiply it by miles, multiply it by nautical miles. You'll get a linear distance to the approximation of the North Pole. Now, ironically, when you do this, it could be off about 200 miles, but it's a pretty good approximation when you're talking, 4,000 mile distance, right? Or sometimes 5,000 kilometers, right? 6,000, well, depending where you are, but no farther than that. Just
where's the right angle triangle?
So this is the what is an angle? Can you describe what an angle is?
I don't remember the definition. I think it's like the separation between two lines or race.
Sure.
Something like that.
Sure. But when you have an angle, you're implying that it has some information, right? Because if you're going to get an angle, you're getting an angle to gather information. So you have a device that you're using. That device has a system. So are we just gathering an angle and going, we don't have a system? Or are we grabbing an angle because we have a system to use that angle in? Obviously, we have a system. We're using that angle to use with the system. That system suggests that if I have an angle to something and I subtract the 90 from it, multiply it by the circumference of the circle around it, I'll get a linear distance to that point. Well,
so now you're getting a data. You need a system in order for the angle to mean something.
Okay, so again, I
done.
Where is the right angle triangle?
No, listen, I already stated earlier to Bev, or I said what Bev said was at the end of it, I stated what he said. He was in his position. He stated at the end of the debate that it was really just about talking about understanding you need a system to do something with the angle, which is obviously Bev's point. We all know that, but the fact that to even have a conversation that you can't do anything with an angle is just ridiculous. It's a waste of time.
Bacon?
Now,
what?
Did you see? I taped it up on the globe.
Oh, nice. You put in
Hey!
Well, that's pretty.
You gotta show that. You gotta show this to Jeremy.
Looks like a mask.
What the hell is that, bro? Come on.
I honestly think the Earth is small. Like when they displayed the globe, it's small, man. It has to be much bigger, man. If it's a sphere, it has to be way bigger.
Yeah.
What kind of weed do they have where you're at?
Yeah, like
bro?
7/6. 7/6 are bigger.
That makes it flat, man. Didn't you realize that?
Hey,
That
Brazil
makes it
got some good
7/6.
weed, huh? Yeah.
I've never been to Brazil. Don't smoke much weed. I'm just joking about
I haven't tried.
The weed. The weed is really good in Brazil.
Well, for him to be doing this, I mean, yeah, it's.
I'm not doing that. Jess is doing that.
Oh, that's Jesse. Oh, sorry, I thought it was you, bro. My bad.
I don't think that's an activity of someone who's very high.
Are you sure, bro?
I don't know. I mean, maybe high on.
What am I missing here?
Maybe sniffing glue.
Oh God, are you kidding?
Maybe high on.
What is he doing?
Glue sniffing, maybe.
Go on his camera. Go on his thing.
All right, that's not an insult. It's just funny to think that it's he's high on. Glue.
Yeah, well, when I was a kid, the glue sniffing was a big thing. You used to walk in lanes and used to see bags with Lepage's glue. I remember it was a sad sight, a very sad sight.
Sniffing gas. It wasn't gasoline, but it was acetone or something.
Glue, actual glue. In a tube, model glue in a tube.
Oh yeah.
Hey Jesse.
Yeah.
You think if you remove the tacks, is that how you call it?
Yeah, like thumbtacks, but like bulletin board tacks. They're like little nails with really broad heads and short spikes on them. They're for pinning paper to the wall.
Right.
Does your globe have insurance?
I got the tax aiming out. Don't worry.
If you glue them,
sorry, bro, but it's funny.
Better on that globe.
What's that?
If you glue them and then remove the text, would it make it fit better in the globe?
Yes, because the tacks are kind of see, the tack doesn't let the ends sit flat. See how it's sticking up? That's because the tack won't let it. The tack won't let it touch the globe at the ends because the tacks are thick. They're kind of domed.
Yeah, but the one written left is seems to be bigger than the circumference, right? Are you saying something?
Oh, that one there?
Yes.
Yeah, that one's. I'm not sure. I'll get a better idea. I might not have it taped on straight either, but I'll get a better idea once I glue it, and the tacks aren't jacking it up.
You know what you made there? Here, I'm going to post it in the chat. So this is a pattern geometrically, like what you put on your globe there. In astrology, it's a circle, and you have all of the angles, the positions of the celestial bodies in a circle. And this is called a kite pattern because it looks like a kite. And there's actually a bunch of different geometric patterns. They're all essentially sacred geometrical structures based upon a relationship of angles. So in this case, in the one I just posted there, see how the lines on the, like let's say on the bottom of the kite, like those two lines, see how there's a little triangle at the midway point? That's denoting that it's a trine. Trine is a 120-degree angle. So those are trines. There's three trines, 120, 120, 120. That makes up the main triangle. And then the middle line there is an opposition, 180 degrees. You see the little infinity sign so they're using that for opposition. And then the two ones, the top parts of the kite are called sextiles. Sex, because breaking this, SEX, breaking the circle into six. So you have the sextile, and those are 60-degree. So 60, 60, 120, 120, and the 120 opposition gives that pattern. That's basically what you made there that you're putting on the globe.
You know what cracks me up is in the mathematics for Bernard Riemann for his manifold calculations. The Earth is two-dimensional, like 2D, right? Like you would have distance and elevation information. It's too funny, man. That all the calculations break down to 2D inside of 3D Cartesian.
Okay, why is your writing a triangle FED?
Once you get an angle, you have to realize that angle was devised from a ratio, and you're getting an angle by using a system that was already devised. So even to have a thought what an angle is, you must be already introduced to a system that angles have been used to calculate information from, right? So when you're saying an angle, you mean you're getting it from a 90-degree ratio to complete a triangle.
Not a ratio.
They're all ratios, buddy. If I had a 3, 4, 5, I could tell you the angles of each of those corners. You give me any ratio of any 3 points of a triangle, I'll tell you the degrees of them.
Yeah, if I give you a triangle, you can get the angles. Doesn't mean angles are ratios.
They're all ratios, bro. Okay? It comes down just to ratios. If you don't believe me, that's what the 3, 4, 5 rule is. It's a ratio rule, right? So the point is whether the ratios or degrees, to have them congruent, they're from a system. So as soon as you invoke the word angle, you're invoking a system that was devised using a 90-degree or 360-degree, some system.
Yeah, it's all 360, dividing the circle by a particular ratio number.
If you're using degrees, yes, but you could be using radians, for example.
They're all ratios, buddy. Degrees, radians, they're all ratios.
Triangle. Where's the triangle? Because you said for using writing a triangle. Where is the writing?
So soon as you have an angle to something, your system would dictate that to get that angle would come from a 90-degree.
Why?
Because that's how the system was created.
No,
that's how you came up with the word angle.
No, that has nothing to do with 90 degrees.
In this particular case,
and even if it did, 90 degree doesn't imply a triangle. 90 degrees.
Let me rephrase that. You get a system that you're using.
Right. Go on.
You have a system that you're using.
Certainly.
That system has a ratio or degrees, whatever. We use angles, and when we use angles in reality, there has to be a system that angle comes from. It gives it a value. That value is a ratio. That ratio is based on the observation. My ratio, what I see to the object, is a ratio. How many feet, how many height, right? So I have a system that I'm using.
You're not answering my question.
Whether it's rise over run and I use a small angle approximation, or I have a 90-degree system that I get an angle from, like the inclinometer, you need a system created to get the ratio. You can't walk in. You can't walk in and measure something without a system. So you invoke the word angle. So if I'm going to get a degree from that angle, I need a system to use. So you're saying that I have two angles that I created. Well, to get that ratio, to make it a system where that one ratio that you got comes from, you need to complete the system. In this case, that's a right angle triangle.
Now, if I give you two lines that intersect and ask you the angle between them, you don't need any right angle triangle. What are you talking about?
So what you need to have, if you have two angles to something, what you're going to have is a known distance between those 2 points and those two angles. And then what ends up happening is to get that information, use the law of sines, you complete a right angle triangle.
You can create a right angle triangle out of it. That doesn't tell you anything about
it's all derived from that system. It's all derived from that system, my friend.
Or don't. Okay, two lines, angle between. No right angle triangle. It's just an angle between two lines.
If you are observing something, and we're using a practical example, if I'm looking at my lampshade or my ceiling light, and I'm looking up at it, I know below that point, because I'm looking at it, I can visually see, I know that there's a GP there of that lamp. Well, I know visually if I want to complete the design, I can create a right angle triangle of that. Sorry, if I wanted to create a visual of that observation, I could create a right angle triangle to describe it, correct?
You can.
Thank you.
I'm not asking if you can, I'm asking if it's required, which is what you claimed before.
So I'll give you another demonstration that you can apply this to maps. Go to any celestial information where your latitude is and measure your angle to Polaris. Take a 90-degree number and subtract it by the angle that you measured and multiply it by 111 kilometers, 69 miles, 60 nautical miles. You'll get a linear distance to the GP, the apparent
Where's
GP.
the triangle there?
That's an application of the arc length formula, and I just posted an image in the chat that shows you exactly what that means.
So it's a linear distance.
You're not using a right triangle in that.
It's a right triangle because it gives me the calculation to the GP position of the star approximately. Okay, we know that
you'd have to use, if you were using a right triangle, you'd be using something like, tangent, cosine. You'd be using a trig function. You're only multiplying. That means you're using the arc length formula.
So again, you can use a right angle triangle to deduce this information very easily.
Nope, you can't.
Yes.
That's not how it works. That's not how right triangles work.
So I just gave you a demonstration. I just told you how to do it. You measure a angle to a star. You subtract it. You take 90 degrees, you subtract that angle. Okay, that 90 degree automatically comes from a right angle triangle. I don't know if you know that. I just said that.
No, it doesn't. You're splitting the right angle into the altitude and co-altitude
I'm taking
angle.
Listen, bud. I'm getting the co-altitude angle by taking the 90 degrees, subtracting the angle, multiplying by 60. That is a basic linear distance navigation calculation. I didn't make the rules. I didn't make it up. I'm just repeating the math and the instruction. Whether you like that or not, I don't care. The fact is, you taking a 90, you're minusing your angle that you witnessed to Polaris, and you're multiplying it by 60 to get a linear distance to the GP. That is the functionality.
You're explaining that to someone who's been doing it for 35 years.
Don't care. Bring it up with the navigators online, bro, because that's where I learned it from.
I am a navigator who's been doing it for 35 years.
Don't care. Bring it up with the instructors on. Giggle, 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 giggle. Bring it up with the instructions. I urge you to make a correction video right now. It's so urgent. You must do it. Go on YouTube, go to all these navigator videos, collect them, and you know what? Make a video right now. Yep, make that video right now. Post it in the chat and say all those other navigators are wrong, okay?
All those navigators agree with me, and I'll post the video right now.
Yeah, so again, I learned this from the navigators, bud. It's to get a linear distance to the GP.
Navigators
So
disagree with you. It's not a
I
triangle.
get it from the navigators. Again, taking a 90 degree, minusing your angle to Polaris, multiplying by 60, you'll get the GP to Polaris. That is the basic calculation.
And that's not a triangle. That's not a right triangle.
I used a 90 degree. Where do I get that from?
You're splitting the 90-degree angle into two angles. You're not making a right triangle.
I'm taking a 90 degree. Where did I get it from?
Can I answer that? It's because you have a vertical and a horizontal, and the angle between those two is 90 degrees. Not because you have a triangle, but because you have two perpendicular lines.
What has a triangle? Does a triangle have a 90 degree? Yeah, that's right. So if
a right angle triangle does.
There you go, right angle triangle. Yeah, right angle triangles are 90 degree. In this case, I can complete a right angle triangle. In other words, if I visually draw it out, I have my altitude angle to a star, and I want to get a linear distance to the GP. I also draw a straight line, and then I have a right angle triangle that completes out of that. I can take that right angle triangle.
That's not what you're doing. You're getting an arc length. You're getting an arc length. You're absolutely getting an arc length.
So I'm using basic trigonometry.
That's not trigonometry. Where's the sine? Where's the cosine? Where's the tangent?
Sorry, I'm not using trigonometry. I'm just using basic degrees, angle measurement here to get it to get the linear distance. So, well, we could do rise over run if I assume the apparent height of the star and then get a small angle approximation. I do different math, right? We can do it that way. The point is that you can get a linear distance with the method I showed you or told you because that's what they taught me.
I want to see you do it that way.
So here, I'll give you an example. Go online, find a distance between your latitude and North Pole, take the angle where you're at, and take a 90 degree minus that, multiply it by 60, you'll get the linear distance to the distance that the map will show. It'll be off maybe by, depending on the distance, it might be up to 200 miles off. But at the end of the day, for a simple calculation on a linear distance between 2 points, I'm sure if you had some other calculations, you get a little more accurate. But
you won't be 200 miles off. No way.
For a basic paper drawing mathematical equation to give you a linear distance to the GP, that's what they show you.
If you look at the picture I just posted, you will see that linear distance is a curving arc length. That's what you get when you multiply a distance by an angle.
There's no curving lines on a planar surface, and there's no straight lines.
Exactly.
And there's no straight lines on a sphere. Right? So there's no straight lines on a sphere. So if you're showing me geometry that has straight lines on your sphere, why are you using Euclidean 3 space on your sphere if it's supposed to be spherical?
I'm using the arc length formula because we're on a curving surface.
Okay, so your arc length formula has a 90 degree right angle triangle in it?
No.
Okay, so I'm using a 90 degree right angle triangle. Yes. You may or not. I am.
You are taking the 90 degree. That 90 degrees is simply
where does it come from?
Horizontal and vertical. Horizontal and vertical is your 90 degrees. Your sight line to the star splits that in half into two angles: your altitude angle and your co-altitude angle. There's no triangle there. There's a right angle that's split into two smaller angles. That one from
you've seen the images, right? Line. You literally can create a right angle triangle from it. Now, if you're going to have you can say no all you want. You literally can show all the images, whether it's co-altitude angle, whether it's co-altitude angle, whatever your measurement you're doing between the point of the GP and the observer, you can create a right angle triangle from it.
Now, GP if you're on your sight line. The GP is not on your horizon sightline.
It's
That is
all good,
only
dude.
getting you the horizontal to get the zenith.
It's all good. There's a GP of every star. Every star has a zenith position on the surface of the Earth. You can calculate the GP position of that star with a shorthand calculation I just gave you is what they instruct. It's not 100% accurate, obviously. It's not 100% accurate, obviously. It's just that's what they have for the basic tools of getting a linear distance between 2 points. That's it.
What you're using is not a right triangle calculation. You would use a trig function for that. You're using the arc length formula. And I've proven this in the video I posted because the circles of equal altitude only intersect on the globe.
All
They
I'm
don't
doing
intersect
is taking an angle measurement from a right angle triangle. That's all I'm doing, and I'm left with another degree, which I can do into radians or I can do into ratios to get a linear distance, right? It's just taking one hypotenuse, that angle to the observer to get the linear distance. So if you can't do that with just basic geometry, I don't understand your guys' problem here. Like, I mean, it's just pretty straightforward. And if you could verify that, now it's not going to be 100% on. Same with any formula that you use, whether it's the Haver sign or whatever you say. They're not 100% accurate.
Yeah, when you have two sides, they are rays. They're not line segments. You don't get a triangle out of two rays because they're only two directions. They don't have any length.
Well, you can
again. You still have ratios. You're using a system that was devised. You're using a circular system, and then using a 90 degree to that circular system. The point is to get your angle. You get a number. You have to devise it from that right angle triangle or that 90 degree, whatever you want to claim.
Yeah, Bacon. The third line is just the connecting point between the star and the ground, which is the GP.
Yeah, but we don't have those distances.
But you can go to the Earth at that section, and like you could have a friend at the GP, and he's pointing at the star. You could be somewhere. You could be far away, taking angles to it, and you have an angle on the ground between you and him. You have the angle, your elevation angle up to the object, and then the third line is the GP line from the star to where he's at.
Yeah, but I don't know any of those distances. I don't know my distance to the star I'm seeing. I don't know my distance to the horizon I'm seeing.
The distance is not relevant. Not to the star, not the distance.
If you wanna build a triangle, it is. If you only have those two lines as directions, then you can't get a triangle out of that.
Well,
it doesn't give you a triangle.
Makes a triangle. It's just the
It
star
will always make a triangle, bro.
Anything physical for it to work.
I just posted an image that shows you what the actual geometry is. There is no triangle in that. The cartoonish triangles you see are people who are not showing you the actual geometry of it. It's simplified things just to get a concept across. There is no triangle.
Yeah. Okay. So again, that's full of shit. I can give you another formula right now with the calculate a linear distance. I'll give it to you right now. You take the size of the object, multiply it by a refraction number 0.56, and let's say we did an angle measurement, the apparent angular size of an object, and it was let's say 2 point something degrees. I could turn that into arc minutes. So take the height of an object, multiply it by the refraction of 0.56, divide it by, let's say, 151 arc minutes. I'll get the linear distance to an object. These are what they teach you. You guys are full of shit. That's also another observation they teach you in class. It creates a right angle triangle. And I just gave you another formula that you can do yourself. It doesn't matter nautical miles, arc minutes, whatever. The point is that it adds in refraction, and then it adds in the degree angular size change, which is, by the way, a vertical height and distance calculation. No curve.
Yeah. I'm sorry, dude. Constant. If you take a constant distance and you multiply an angle, it's an arc length. That's basic geometry. That's what you're getting
Again,
when you do 60 nautical miles times.
You get it on a
the
circle.
co-altitude.
You can get do the same with a circle. I can get the radius and a circle. If I have an object, let's say I have because ideally the way that we have the apparent position, the apparent position of the stars don't change in angular size. So they're wherever you measure them, they appear to be the same distance away. Well, this is what the agents say. Not all stars, but relatively, it's pretty much infinitely distant because that doesn't change any size. There's no angular size change anything. So you get around this 4,000 mile thing everywhere you go, right? That's the idea. So they can't be that, right? It can't be 4,000 miles everywhere you go. Rough. I'm just saying approximation. It has to be something greater than that. Anyway, I'm losing my point here. When they're teaching you this in class, Yeah, because I'm distracted, dude. I got lots going on. The vertical and the vertical and the horizontal distance is that calculation I gave you, which is the height of the object. It's a vertical height. Okay, so in other words, if you're measuring something the distance that's 2 degrees and it's vertical from you, you're getting a linear distance based on that degree change and the vertical height. There's no diverging vertical from the observer's point of view or the vertical change. It's a complete Euclidean right angle triangle it makes between the observer and the height of the object. So these are the calculations they teach you. They all derive from a right angle triangle, or they all can fit in a right angle triangle.
Can you point to any celestial navigation text, any documents that actually say it uses a right triangle to get the distance to GP?
So I'll give you a calculation. I just told you this is a
you gave me a calculation that you got wrong, that you misinterpreted.
No,
you said it was for a right
misinterpret
triangle, but it was for an arc length. So
again, no, it's not for an arc length. It's using a 90-degree right angle triangle. Listen, you can draw it out. You can't be look, dude. It just can't be that daft. The shit works on a flat circle just as much as it works on a sphere. If it's a circle based, you're still going to end up with this arc shit that you talk about. The point is you can get the calculations on with a circle. Okay.
These guys get their measurements from the ball dimensions. So these differences in degrees, they don't do it the way that you think they do it. They take it from the degrees of separation used in the center of the Earth, and then such and such. They don't do it on land, as you think. Come on, like all you guys, when you respond to me, the ballers, you'll give me the same answer. You use the dimensions of the Earth as your degrees of difference. You don't use these angles and stuff like that.
The co-altitude angle sweeps out an arc length along the surface of the Earth. So the surface of the Earth.
Oh, yeah, but it's an arc angle using the Earth as reference frame. You're not eliminating the Earth and saying, right, well, how can we do this without assuming the shape? You assume the shape, you've got your dimensions, and then all you've worked out is an inversion tactic where you take Euclidean geometry and you apply it to your ball. You set the amount of kilometers per degree. Bob's your uncle. You do that on all the lands, great. But when you try to fit it into and then you make a reference frame from that, easy.
The spherical shape comes from the fact that the motions of the GPs over the surface don't work on any other shape. The longitude.
So that's not true. There's not true.
The longitude lines
that's not
get closer
true
together as you go south.
Yeah,
the speed at which the GPs move over the surface are slower as you get south of the equator. That only works
star
on a sphere.
observations in totality do not match up on a sphere. You'll have different discrepancies.
That's absolutely not true. You can go through the nautical almanac and prove it yourself. You can observe them yourself in the sky.
So listen, I'll just tell you right now. There's a guy already on. This is old shit anyway. They don't work on a flat Earth. They don't work on a globe Earth. Both observations. So for as an example, we have two observers at two different locations on either map, globe or Gleason. They make observations. The guy's obviously using the globe projection, the Gleasons, so it's not technically a flat Earth map. It's just a globe projection, and he's showing you that observers at these on a globe and on a Gleason's map that they don't always line up. In other words, somebody would be looking in a totally different. I shouldn't say totally different direction, but a few degrees off. And for the globe factor, of course, as it grows infinitely distant, the angle grows larger the farther the star is out. So the angle's even more off, right? So the idea that you have errors in both models. And if you don't believe me, I can give you an example to try.
I think my audio actually dropped out there for a bit, so I probably missed a bunch of what you're speaking. But you hear me at all?
I have an example to show you that that's not true. If you think that all the angles match sphere Earth as well, using the almanac, then you're wrong. I can give you a channel. You can go find resource as far as, the guy's a little bit different flavor, but he'll give you some examples.
Sure, by all means.
It's been known for a while. QFNE. So type in.
That guy.
Yeah. So he showed me, and I went and fact checked some things. I've had a couple of my examples that I can give you if you want. Go to December 21st in Perth, Australia, and show me how you can get a southeast sunrise at 120 degrees.
Okay,
If you can show me that, if you can show me that.
Yeah, if you've got some links you want to drop to videos or something, that'd be cool. I'll look
Well,
at them a little later.
I'll do it right now. I'll do it right now.
Yeah, it's
I'll
all
pick up
good. You can
Blender
do that. You could also do show me where you get like on the globe Earth, you have a Mercator or you have a terminator line. Let's say that would move along each meridian as the sun moved, and day and night would change. Each longitude line would have that terminator line on it. So in other words, it would be along one longitude line on a sphere Earth, you would have the time be consistent along one longitude line. Well, I can give you an example that shows you that doesn't work on a sphere in reality. In other words, the time that it would be at one location and the time would be at another location along one longitude line would be off on your sphere Earth, and it doesn't match reality.
Can we verify the first example about the sunrise?
December 21st. It
Mhm.
is the first day of summer in Antarctica. It is the first day of summer in the south.
Do you have a timestamp?
December 21st
Okay.
is the
What's the
first day
location?
of summer.
What's the
Go
location
to
there?
Perth, Australia.
Right. Just give me a second.
It has
Opening
zero
time.
it has 0 degrees magnetic declination. So you don't have to worry about any magnetic declination. And if the sun is supposed to be along the Tropic of Capricorn, that means you would be looking 90 degrees east, maybe a little bit west, but you're not going to be looking at 120 degrees west, southwest. Sorry,
December
southeast,
21st?
pardon me, southeast, sorry. So yeah, if you look at it, just go
Which year?
demonstrate it, it's fine.
Which year?
Just go demonstrate, go put a video up, and show me, because at the end of the day, I have a video up that's already done.
I'm doing it right now.
Yeah, you'll never get it. So if you put a gnomon at Perth, like just a stick in the ground, just to see where the sunrise would come in at 120 degrees, you can't duplicate that in Blender, and you can't duplicate that with a toy model.
That's what I'm doing right now.
Yeah, I understand. Look, dude, it's all good, dude. Look, dude, I know how to do Blender. I know how to do all that shit. It's again, at the end of the day, I have a toy model that would operate the same way as Blender. In other words, with the local sun, because you can't have a big giant sun in Blender, you're going to have it along the 90 degree or the equatorial plane of the program, and then you have the tilt. Then you have the tilt of the Earth's equatorial.
Can you pause for a second? Are you referring to the sunset or the sunrise?
So it'll be sunrise, Perth, 120 degrees southeast, 119 degrees southeast, sunrise. Doesn't work on the toy model. So your little toy model, your little globe, you don't get that. The Earth would have to be tilted around 30 degrees.
Let's see if that's the case.
Keep in mind too, right? All you do is take a protractor, because you're in Perth. You just go along that one meridian. At one meridian is north, and east is 90, right? West is 270. And when you come down and look at the gnomon where it's at, and that the sun where it's coming up at 120, doesn't work. You'd have to tilt the ball Earth up. I've done it in Blender, and I've also done it in a toy model, dude.
All right. Do you want December 21st for Pearl or for UTC?
So it's December 21st. It's going to be the first day of summer. The sunrise, whether it's UTC, it doesn't matter. It's sunrise in Perth.
Right, but
it doesn't matter what time. It has nothing. It's sunrise period in Perth. What time structure you have? No, you don't. It doesn't.
December.
Because if you go to SunCal,
Shut up for a second. I'm trying to answer.
If you go to, it doesn't matter.
Okay. 21st, December 21st for Perth and for UTC are not the same day. Like the sunset of one is not the same day as the sunset of the other one. It does matter.
It doesn't matter. It's the sunrise. You got that?
Sunrise, December 21st in Perth. That's it. That's all you need to worry about. Now produce a 120 degree angle. Produce a 120 degree angle during a sunrise in Perth. That's it. On your toy model. Go ahead.
That is not. I don't think that's December 21st for UTC when it's rising on Perth. So
do you realize that not actually December 21st, it's only going to be 120 degrees? Just it's an arbitrary day within that time frame. Go the 29th.
If you don't want to give an answer,
dude, you're red herring the conversation. It's the sunrise in Perth. It don't matter the time structure. Okay, it's just sunrise on December 21st.
It's 24 hours apart. All right, but it doesn't make a lot of difference. So I'll just ignore what you're saying.
It doesn't matter the time. If you want to go talk about the time UTC, whatever time would you say? Like, why would you even mention that? It has no effect on the result. Zero. And then I have another example, which I'm sure you've tried to do, but I don't know if you've the gnomons at the north. Anyway, the sphere doesn't work, dude. The Earth is a sphere, and it's got different contours to it. The star charts show that the Earth is not shaped like a sphere, like they put in a toy classroom.
Okay, I've got something for you to try. Go to your nautical almanac and pick a star like Cos Australis that has a declination of about a negative 34 degrees, which would put it passing right over Perth and Sydney. Find out what times it'll be overhead each of those cities.
Did you try my example?
Which example were you talking about? The one that Bacon was just going through?
Yeah, did you try it before? See, here's the thing.
Hold on, man. Let him finish. You didn't even let him finish.
I was going to say, like, find out the distance between Sydney and Perth, and the amount of time it takes for Cos Australis to be directly overhead at Sydney, directly overhead Perth. And so how fast it's moving between those two, and then how much distance it would have to cover at that speed to be going all the way around that latitude. It's following that latitude the whole time. Negative 34 degrees, 22.4 arc seconds.
Do you know the ancients? Do you know the ancients wrote about how the stars would appear for some observers and not appear locations for others?
You can observe.
So hold on. Hold on. Just it's okay. So when you make these observations, there's anomalies that they still write about to this day, to where the apparent positions of these are. That's why you have all these errors and corrections, not only with the instruments, but also giggle. Okay, so there's no errors.
There is. We can get the ground positions of these things down to arc seconds, predicting it years in advance. That's why the nautical almanac used to navigate.
And they're off
if that wasn't the case.
And they're off when they make their predictions. They're never accurate. They're either a day earlier, a day behind, or they're never exactly on. Bullshit again. They're not exactly on, dude. They're not. Giggle. I hear you, but they're not actually 100% now, are they?
They're incredibly accurate. The source of error you get in nautical navigation.
What can you prove today? What can you prove today, right now? Proving the heavenly bodies to make the surface of the Earth a sphere is not going to be proof. What are you going to do for proof right now?
The ground positions of these things that you can verify just by looking up and seeing when they're directly overhead, where they track over time, only works on a globe. Distances that they travel do not work flat. Geometrically, they do not work. That is why the latitude-longitude system is arranged the way it is. That's why it's a globe. That's why circles of equal altitude only intersect on a globe and cannot be made to intersect flat. Here's
the conundrum. When you fly an aircraft, right? You're flying in your mind. You have to say that eventually I'm going to be slowly flying upside down to be on a sphere, correct?
And I've detected that with gyroscopes, yes.
Yeah, wonderful. So you have to forgo your senses and believe that you're slowly at some point 700 miles away from your destination. You're quite a bit, you're at a pretty good angle at this point.
Which is exactly what gyroscopes in airplanes detect, yes.
Yeah, sure. So they don't detect this 1 degree 60 mile of drop or dip, is what you're saying they do?
They do detect that change, yes.
They do to detect that change. How do they detect that change? What instrument do they have to test for that?
Gyroscopes.
Because
Gyroscopes detect a change in orientation.
yeah, pitch,
It tells you that the
velocity
Earth is
changes,
curved.
and so forth, right? Pitch and velocity changes. So
No.
if you're
That's pitch,
if you're
roll,
playing
and yaw. Pitch, raw,
yeah,
and yaw.
sure. So if your plane is maintaining all of those functions, it has a rigid space, a rigid point in 3D space for it to be able to measure these pitch and changes, right? So if it's focused on pitch changes, like you said, yaw and so forth, at what point is it fixated on the 1 degree change?
Inertia. Inertia
So
will want to
inertia now.
keep it keeping the same orientation all the time. As the plane
So-
changes, the change of the gyroscope relative to the plane itself shows that orientation change. If you have a 3-axis optical gyroscope, it detects the rotation of the Earth. It detects the change of the orientation of the plane as it moves over the curvature of the Earth. I work for
so
aerospace
I
and the
fly
defense
planes.
industry. I work with
I
this
fly
stuff.
planes. I fly planes, not professionally, not commercially. I fly them locally, 2,500 feet, a couple hundred miles. I don't adjust for any spin, any rotation, any
Because the
curvature.
equipment I build
Hold
for
on.
you adjusts for you.
Oh, okay. So the gyro adjusts for me. So I never
Yes.
learned it in class. The instructor never talks about a spinning globe Earth. When I use the simulating program, it matches my observed reality, which everything is stationary. So am I just going to ignore the present reality that everything's flat and stationary, and that none of the instruments I operate adjust for a curvature, spinning Earth, no ball, nothing?
They do adjust for it, but they do it for you, so you don't have to worry about it.
So my gyroscope, let's say I was in 1935 and I was flying one of the old school planes. I had an air-driven gyroscope, vacuum-driven
Hey, hold on.
gyroscope.
What equipment is adjusting for him the curve of the Earth?
Exactly.
If you have a modern plane with an optical gyroscope, it does not have the sort of air-based stabilization that the 1935 plane would have. It has to subtract it out with software because it is so sensitive. It detects that change in orientation, both from the rotation of the Earth and from flying over its curvature.
Yeah, so it doesn't.
Software that does that.
Yeah, so it doesn't, because I've tried to capture this information. In other words, I tried to measure it myself to say that if I was to measure, let me finish, if I was to measure this curvature to correct for it. So what could I use to measure this arc? Do you think? You claim a gyro, right? Well, a gyro would work the same as anything else that would have a center of mass and then a deviation from one point to another. So in other words, if I had a measured point at one position, and I transverse along that other position, like I was to move up a hill or go over something physical, that the device I would have would measure these pitch changes, right? So I thought that if I have a device to measure pitch change, that I would be able to find this curvature. Now, is a gyroscope the only thing that I could use to show this pitch change? In other words, if I left point A to point B, if I made a measurement at point A and transverse to point B, I should be able to detect this arc, right?
With a gyroscope, you will. Yes, go on. What are you saying?
Okay, so just with a gyroscope, that's it. There's no other instrument that
if you think there's another instrument,
I'm asking you. You just seem to think a gyroscope is the only one.
I didn't say it was the only one. I mean, there's probably visual things you might be able to do in the right circumstances.
Visual
I'm talking
things
about
I might be able to do.
with a gyroscope, you definitely can.
Okay, so with a gyroscope only. Okay.
You're putting words in my mouth. I didn't say a gyroscope is the only thing I said, but I said a gyroscope definitely will detect it.
So awesome. So a gyroscope, if I was to record a gyroscope with a camera and I was to fly my plane 700 miles, the gyroscope would automatically, according to you, be correcting for a dip and drop. Okay, so whatever velocity I was traveling at or whatever speed, the gyroscope would be correcting for the curve of the Earth, right? That's what you suggest, correct?
If it's an sensitive optical gyroscope, yes, it will be.
Oh, so it's just an optical gyroscope, so it works off of light?
Some of the
it's using the Sagnac effect?
will do the same thing. Yeah, the ones with the Sagnac effect. There are mechanical ones that are sensitive enough to do it as well. But your older ones generally won't, because they're going to be using, gravity or air dams to restabilize them.
Right.
But you can have ones that are not stabilized that way that will also detect the rotation.
Okay, so not gyroscopes. It's just the optical Sagnac effect that can only detect or only correct for Earth curvature.
was gonna say
That's it.
Mechanical ones will do it too.
Mechanical ones will do it. How does mechanical ones do it then?
They're using inertia. There has to be a three-axis gyro.
So they're using resistance to acceleration. They're using resistance to acceleration to correct for Earth curvature.
Resistance to the change
That's
in orientation.
inertia.
Inertia, yeah.
Okay, so the resistance to change in orientation. So what is causing the change in orientation?
The change in orientation of the airplane or whatever the housing of the gyroscope is connected to.
So I'm sorry, whatever the gyroscope's connected to.
The internal mechanism will maintain its inertia. The outer housing and the vehicle that it's attached to could be changing its orientation, and then that's how you detect the change in orientation of the vehicle.
So gyroscopes are meant for rigidity in space, right? This is the inertia that you're talking about, the resistance to acceleration. That's why you can pick up the pitched yaw and so forth, right? Okay, so it's not correcting for curvature because it's not a new one. It corrects for curvature. The old ones correct for curvature. How again? Via inertia.
The old ones are. Sorry, go ahead.
Well, you're just saying that the gyroscopes, the old ones, correct for curvature due to inertia. So in your program writing, you say that you write for the Earth being a curve, right? But when I fly my plane at 2,500 feet, 500 miles, I don't adjust for any curve or any spin.
Sure, because you're telling me. Corrected that.
Hold on. Yeah, you're telling me that my Cessna plane, my little Cessna plane that has a mechanical gyro in it, is correcting for Earth curve, but they've never taught me that.
Your mechanical gyro is going to have a mechanism that reorients it by gravity. That is
by
how
gravity, right? By gravity. Okay. So all of these are begging the questions. It's gravity, it's inertia, and it only can be the Sagnac effect that actually corrects for this 1 degree change.
A mechanical one will do it as well, as long as it is a 3-axis gyro that is not being restabilized by gravity, and those do exist, and I've actually seen one of those that also detects the rotation.
So when I fly my Cessna, your software that you create automatically corrects from the software flying over the sphere. That's what you're saying.
Your Cessna has an optical gyroscope in it, yes, but
it doesn't.
So
I haven't seen your plane.
It doesn't. It doesn't. But the point is that I don't have to adjust for any curvature. So I'm flying a distance of 500 miles between 3 points. Let's say 300 miles between 3 points.
Has yours got pendulous vanes, Dana?
Yeah, so those ones I'm familiar with, because at the end of the day, that's to help correct for velocity change, pitch, and so forth, right? To help you level out, because you also have this thing due to the natural mechanical precession as well that you also need to help correct for when you fly, which has nothing to do with the rotation of the Earth. It's just the mechanical feature of the precession. The mechanism itself has an error in it, right? So you have to correct for it. And plus, when you, for instance, if I was to bank left for like 5 minutes, apparently, this particular pendulous vanes might correct that or might leave me at that position for a little bit, and as I level up, a second or two to come back, right? So it's just interesting how it's meant to utilize your horizontal position so that you can have correct pitch and yaw and those readings, right? So which indicates a rigidity in 3D space, which means it doesn't give two shits about the shape of the Earth. It cares about its position and its orientation in 3D space, which has nothing to do with the sphere of Earth.
Yeah, but if you have a mechanical gyro that does not have pendulous vanes, it will detect the rotation of the Earth.
So they don't because the Earth doesn't rotate it at 15 degrees, right? This is a quantification of 15 degrees of. And you were the one who brought up. I shouldn't say it's false. It's a constant. It's a constant derived because you don't have consistent motion, so you have to create consistent motion. So to invoke this 15 degree as a precise change, that's false as well. Sometimes there's nowhere near 15 degree change, and most of the time it's mechanical error due to velocity changes or pitch changes or whatever.
So you believe that optical gyroscopes are detecting something other than.
So optical gyros, the Sagnac effect, which is in the machines, they've got they've got usually three mechanisms in them for dead reckoning. So a lot of these, I'm having a blank right now what these systems are devised, but there is the gyro in it for emergency backups. If all the power goes down, and so forth. You have a mechanical gyro, of course, but these what are they called? The INFs or. It's basically a coordinate system, that is designed for dead reckoning, which is the straight line between 2 points. And if we are going to create software, you're telling me that I can't create an object that travels in a straight path and then create a product that helps an object fly in a curved path and then differentiate between the two of them in Euclidean space. Of course I can do that.
If you want to have something that does dead reckoning over extremely long distances, it has to take the curvature of the Earth into effect.
It doesn't, because it's a straight line in 3D space. It doesn't give a fuck about the shape of the Earth, bro.
Yeah, I've worked on these navigation systems. I'm sorry, you're just absolutely wrong about that. I just posted.
It doesn't matter whether you worked on them or not. Whether you say it, I'm just telling you, dead reckoning is a straight line between 2 points, and to get the best accurate fuel. Like, for instance, if I was in the, if I had to go to my neighbor's house and my neighbor's house was at the end of the block and I could travel in a straight line in 3D space, I can do that, correct? Mm-hmm. So if I can do that, I can dead reckon to my neighbor's house in a straight path. Now, you're going to tell me that that's a curved path due to geodesics and light? Well, that's another philosophy, dude.
Over short distances, the curvature is going to be so small that, yeah, you're not going to worry about that.
But hold on,
you have to use something like the Haversine formula to get your fuel calculations correct. I know for a fact that you use the curvature calculations.
So again, Haversine is just another hypotenuse calculation. It's a straight line between 2 points.
You're
it's a straight.
Wrong on that.
You can claim it's curved. You can claim it's curved. You can claim it's straight. Doesn't matter. The point is that it fails at longer distances as well. It's not a perfect formula. Don't get too excited. I work with the Haversine formula, dude. It can have errors in it, buddy. You think all these formulas are 100% right? You're wrong, dude. They're not 100%.
Over long distances, though, it's the curvature, the difference between what you would get with a straight line distance and that curved distance with a Haversine. It's the Haversine is giving you the accurate result compared to if you were trying to do it as a linear
and
distance.
You can do a Haversine. You can do a Haversine on a flat map with a curved line, right, bud?
You're speaking nonsense now. The Haversine is giving you...
Dude, you can have a grid system laid with longitude and latitude. You could still calculate your Haversine with a flat map with longitude and latitude. You just draw a curved line over it, right? Do you understand that?
But then it wouldn't be the shortest distance on that flat surface. You're looking for the
Again, did you hear what I said? You could have a flat map with the longitude latitude lines and have a Haversine calculate the distance between the two of them, and all you just do is curve the line. But yet the map is flat with the same coordinate systems put over it with the same lands in the same areas as the globe.
Do you even listen? Are you even listening to what you're saying? So you're saying that
you have a flat map using a flat map, and then using a Haversine with the flat map and drawing a curved line over it between using a flat map. Like, you listen to yourself. You're saying the Haversine is only spherical. But yeah, you're using a fucking flat map with a Haversine formula and then drawing a curved line over it. That's what I'm saying.
Okay, so why would you be using a curved line for the shortest distance?
Why would you represent the Earth as a flat planar surface and then draw a curved line over top of it?
Can I step in real quick?
Sure, go ahead, Bacon.
Yeah, I went to Blender and I put all the data I think that is necessary for the thing you claim wasn't possible on a globe. So I got the azimuth of the sunset in Perth, in Australia. I got the position on the sun, and I put a very big arrow pointing where the sun is. And it all lined up perfectly. If you go to my live stream, you'll be able to see
I have a video already online. I demonstrate clearly let's say, for instance, the GP position of the sun. When you're making your sphere, Bacon, can you show me the specular highlight of where the sun is positioned? Because I show you the specular highlight, where the GP of the sun is, and I show you the transition between Tropic of Capricorn and the Tropic of Cancer. And then I show you how the shadow is changed between where the GP of the sun is. Now, if the GP of the sun is at 23.5 degrees, then you cannot get the angle, buddy. So please show me the specular highlight of the sun. And better yet, I have an email. It's flatearth@yahoo.com, flatearthdata@yahoo.com. Send me your Blender file. That would be wonderful.
I'm showing you right now. Can you spell where the problem is?
Send me the Blender file. Because listen, Bacon, I don't trust a single person in this debate. I've been asked for this for years. I have Cinema 4D. I have Blender. Send me your Blender file, bro. Stingray didn't want to do it because he said it was too big of a file. maybe you can just do the basics, which is a sphere, a map, a sun,
Yeah.
a gnomon, real basic stuff, like about 10 steps, maybe 15 in total. You can have a representation of what I stated, but more importantly, you can just take a toy model and do the same very thing and end up with the same result that I've already documented on my channel. So this is why I ask you, just send me the Blender file, flatearth.yahoo, and I'll take a look.
I dropped in the text chat.
Hey, Baking, can you describe to me what you're showing and what his error is in logic? Because he doesn't want to hear it. I do, actually.
Well, he was saying that the azimuth of the sunrise of this in December 21st in Perth doesn't match the globe. So I went to time and date, got the GP of the sun at that time. Also got the same coordinates from Stellarium. I went to Stellarium to just check if the sun is actually at zenith at that location, and you can check that it is. And then I also got what's the azimuth that Stellarium gives me for the sun at that time. And I replicated all that on Blender. And both the azimuth points to the same direction as the GP of the sun. So it's
so
exactly
you have a indication that shows that the gnomon is on the meridian line where it's you can clearly see north, east, south, and west, and you have it mapped out with numbers to show you the angle. Like in a video that I've done, I've put a protractor along the meridian line. In other words, Perth is 0 degrees magnetic declination, which means I can just lay a protractor right on that meridian line. In other words, north is at 0. In this case, my protractor...
Magnetic declination?
There's no magnetic declination at
You
Perth.
said
It's
magnetic
0.
declination.
There is no magnetic declination at Perth. It's 0. In other words, I'm just using the true north. There's no reason to calculate any. So the geographical north I'm using.
Okay,
I'm putting the protractor right along the
Why did
meridian.
you say magnetic? I'm just curious why you said that. Was it a misspeak or? Were you
Just so you, when you go looking at something, you'd be like, oh, it's maybe the magnetic.
Hey, Data.
I also find that really interesting too. It's 0 magnetic north.
Hey, Data. Take a look at the last two screenshots.
0 magnetic declination. Pardon me.
Take a look at the two last screenshots I sent.
So I'm just going to send you my video because I've already done it, dude. I've already done the demonstration. So whatever you're going to show me, I know that's full of shit because I have the same result. I'm not doing anything disingenuous. I have the model out there. I have the fucking flashlight along the horizontal equatorial plane of it. You have the tilt there, the poles there. You see the transition between Capricorn and Cancer, where the GP of the sun would be as producing, sunrise. The result is there. So I'm just going to send the video, dude.
Okay, so you're not going to address what I did there.
So again, it's a very simple demonstration. If you're not coming up with the same results as me, it means you're doing something else. That's it. Because I'm not doing anything. Listen, dude, I'm not doing anything. Sphere, putting a protractor on it along the meridian so that it's 0 degrees. And so that and then putting a pole there at gnomon or the Perth to produce the shadow, you can clearly see you can't get that angle that's described. And it's that simple. As long as you keep it really simple, sphere, gnomon at Perth, a way to measure the angle coming in, the sun, specular highlight or GP position between the two tropics to show the deviation of the shadow. If you don't come up with the same result as me, that means you're doing something else than I'm doing.
Okay, look at my last picture.
So can you describe what you're doing in Blender, and I'll tell you if that's... Go ahead, just describe.
Can you take a look at the last picture? It will help me explain
because, dude, just describe what you're doing, because I'll tell you if you're doing more steps than me. Would you like me to describe my Blender thing first, and then you can tell me if you're doing more than me? Mine's real simple.
I have a hard time following you. Let me try to explain what I did. What
do you mean?
So I got what's the azimuth of the sun when setting from Stellarium. That's the one you're trusting, right? The azimuth of the sun setting.
I use SunCalc, and all it was with SunCalc is if you go December 21st, you can see that the SunCalc will have so the azimuth is 119, probably 119 degrees to be more accurate on December 21st. And
116.
It's 119 at SunCalc, bro. I just did a video, dude. I just posted this, man. And the thing is in Blender,
maybe it's a different point of Perth. I don't know.
It's a sphere. It's just Perth, dude. It's not going to matter. It's Perth at 120 degrees. It's a sphere map over top. Gnomon at Perth. Sun along the equatorial plane. The Earth is tilted 23.5 degrees because it is December 21st. So it will be first day of summer, which means the GP of the sun will be Tropic of Capricorn. That's as simple as the drawing. That's as simple as it is. Basic. And the shadow angle does not come in.
Yeah, that's correct. All of what you're saying is on my blend.
Yeah.
What I did on blend.
Again, so I just so again, I'm going to post a video then because that's exactly what I did in real life with a 20. And you show me because I have the protractor there. You can see the angles. Not the angles nowhere near 100 degrees, bro. It's most likely even 90 to 100 degrees at the sunrise for December 21st on the toy model.
I want to say you did it wrong because when I did here, it matched it. One sec. It matched it perfectly. So maybe I did it wrong, and it happened to match it perfectly by accident, or you did it wrong, and because it didn't match, you think there's a problem with the globe.
So I didn't do anything wrong. It's very simple, bro. You have a protractor along the meridian to give you degree witness where the shadow angles coming in. I don't have my video up. I took it down. Doesn't matter. This is old shit anyway, dude. I just don't care. The point is that I know that you guys.
You can see
I'm looking for it.
That.
I'm looking for it right now. So I'll just take a look at your Blender file because I don't even need Zanuck would. Kosho wouldn't send me anything. You're the only person in what fucking 5-6 years that will send me something. So well, I think maybe Stingray sent me something once before, but it wasn't. It was a different thing. So.
Yeah, I think if the azimuths did not match a globe, you wouldn't be able to get your position from azimuths, and you actually can. Just like you can use elevation angles to find your position, you can also use azimuths. It's a different method.
Yeah, because in azimuth, it's the XYZ. Yeah, it's the XYZ geometry of reality. Because the azimuth has to do with the circle, a horizontal circle around you. Then the elevation angle is the actual, it's just the XYZ matrix.
Yeah, but they don't point to where the ground position is on flat Earth.
Yeah, so I'm looking at your specular highlight. You have a specular highlight on the left side of Perth. Like, dude, come on, man. You can do better than that. Like, where's your sun at? Where's your GP of the 20th? Show me the sun angle at the GP of 23.5. Show me that the Tropic of Capricorn, the GP of the sun, and then rotate the sun. Yeah,
the coordinates. It's on the live stream.
So the sun has a subsolar point, right? We call it a hot spot, if you will. That's how you know how it goes along the Tropic of Capricorn, and it's got all that. It's got all that dark. It's got all that wonderful sand, right? Anyway, the sun obviously has a path that it travels, and we're just going to call it a GP position or a subpolar point, if you will.
Ecliptic.
That there on a sphere, especially a toy model, if I shine a light on it, if I have a direct center of path to the Earth and I want to have that GP of the sun or the specular highlight or the solar point of the sun, I have to point it at that Tropic of Capricorn to have it follow that path. And when doing so, it shows me the specular highlight of its location. Thereby indicating as I move the sphere into the sunrise at Perth, the shadow comes at around 100 degrees and not at 120. I don't see your Blender file. Did you? I just see images. Oh, is that your Blender file? Okay.
I sent it before. I tagged you. I'll send it again.
So how about you do this? How about if you go on Blender live, I'll tell you exactly what to do. It's
That's what I'm doing. It's live.
It's within 15 steps. So create your sphere, put a map on it, which you've done there. You've got that map, but do you have do you have another? Oh, you basically okay, that map.
Yep.
All right. So why don't you go to a position where you pull out and you can see the location of the spotlight of the sun, where you're using the sun, so you can create a specular highlight. So what you want to do is put the sun at a 90 degree, because when you have the Blender programs, they're usually sorry, let me rephrase that. The Blender program, when you open a default, the sun is usually directly above the center position of the map that you get in your coordinate system. So take that and change it to 90 degree, and therefore it will go along the equatorial plane or the plane of the program. And that way it will hit the center part of the globe that you have. And then take the globe and then tilt it to 23.5 degrees. And when you do that, you should see, like, I don't know if you're getting specular highlight here, maybe bring the light a little closer, I don't know. But you're not really producing any shadows here in this drawing or this program that you have. In other words,
Yeah.
you don't really have a strong light interacting with that gnomon pole.
Change the
Now, did you pull the same stunt that you tried last time by making the gnomon pole parallel to Polaris or to the axis of the Earth?
Slow down a little bit.
Did you just try pulling that again? Like we're trying to put the stick in the ground to match the axis of the Earth when that's not reality on a curved surface?
I don't know what you're talking about.
Okay, it was as long as you're not trying to take the gnomon and make it parallel to the axis, which that wouldn't happen if you were just throwing a stick in the ground.
Are you watching the live stream? No, right?
No, I wasn't watching no live stream. No, we'll know.
Yeah, so far I have the sunlight is not that sharp. I'll get a different texture for the Earth that has the tropics. Just give me a sec.
Yeah, so why don't you go to where Australia is on the right-hand side of the sphere, and it's tilted up towards the sun, because that would be December 23rd. Sorry, December 21st.
You want me to
summertime?
You want me to tilt the Earth 22 degrees, right?
23.5 degrees. Yeah. Anyway, just don't go there. I'll tell you where to position yourself. So see that little specular highlight you got there, right? That's where the sun is off to 90.
Right there.
Yeah. You see the specular highlight you got, right?
Yeah.
Now, if you tilt the Earth.
Oh, sorry, I wasn't rotating.
No, that's about right. You have it about right. That's matching what the toy is. So go back to where you just had it, dude. Don't fuck around. I'm just gonna stop watching you start fucking around, dude. Because I'm telling you, man, I already done this.
Shut up for a second. I forgot to do one thing.
No, there's nothing. You just had it.
Dude.
All you had to do is rotate the fucking Earth, and then you would have seen the shadow, dude.
No, I wasn't rotating the mark of birth with the Earth. So when I rotated the Earth, the mark stayed where it was. So it screwed up the location of the observation. That's why I'm going back, so I can do the thing with the mark of birth. So we know where birth is after I'm done rotating it. So I do it again, same exact thing.
Yeah.
Birth, mark of the sun, and this is the mark of birth with the azimuth.
Yeah. So again, you're fucking around, buddy. Go back to where you were. I'm not going to do that shit. No. Go back. You're fucking around. No, you're not, dude. Don't even fuck with me, dude. I'm telling.
What am I doing differently?
Look at your little smiling fucking lips there, dude. I can hear you smiling, buddy.
What the hell are you talking about?
Yeah.
I did
Go back.
I did the same thing. The only difference
stop
is
right
now
there. Stop right there. Yeah.
Okay.
Stop there. Pull back where the sun is. Let's see where you have your sun positioned, because you can't have the sun too far. No, where's the sun at?
In that direction.
Show me where the sun is, dude. Don't fuck around. It's beyond the 90.
This is the sun. This line here represents the sun. What are you talking about? If you want me
So the sun is the other way, right? On the left-hand side, the sun is coming in the left-hand side.
That was just a direction. That wasn't where it was. Because if you create a sunlight in Blender, it doesn't have a position. It only has a direction.
Yeah, so when you first have a default, dude, it just comes above. You just have to hit 90, and then you can increase the light if you want. The point is when you tilt the Earth, like you have no lines here to show. You should have the grid system so you can see it better. Yeah, perfect. Yeah, that's good. 90 degree, right? 90 degree to that. And then when you tilt it, you're going to notice, go back the other side. We never have to see that side, dude. Just go to the other fucking side right there.
What side?
Yeah, right there, dude. Now zoom in, dude. Yeah. Now, why do you have a flat disk and not a gnomon yet?
That's
Just put a fucking
100
little pole, dude. Just put a little pole. Like, what the fuck is that shit?
That's the azimuth. That's so I can have the azimuth. I can make that very small, so it becomes a point.
Now, you just want to pull a gnomon to cast a shadow, all right? Yeah, there you go. Not 120 degrees now, is it? Not going to cast 120 fucking degrees right there, buddy. You're just showing me right now. You're not going to...
north.
That's not 120, dude. No.
It is to north. Yes, north is here, right?
That's right. It's not 120 degrees, dude.
It is if you get the angle to this angle.
No, it's not. It's not 120 degrees, dude. Look where the sun's coming in at. The sun's going to come in at.
I created that arrow here.
Go back. Yeah.
Shut up for 1 second. Let me speak for 1 second. This arrow here that you're seeing there, I created the arrow to be exactly 116 degrees.
No, it's not 116. Again, fuck on your dude. You're fucking around. It's 119, 120 degrees, buddy. You don't get 120 degrees sunrise on. I can demonstrate this.
I used 116 because that's what I got from Stellarium. You didn't tell me to use 119. I don't know where you get the 119, but Stellarium gave me 116. But it's just 30 degrees of difference. It's not going to be insignificant on Blender. And that's why I'm using it. I'm not fucking around. That's how I got that arrow. I can do it again if you want to.
You have meridian lines on there. You will see that if you point that wheel that you have with the directional and you point it totally 190 degrees, so you can get your position between north, east, south, and west.
I'll put meridian lines, but you gotta give me a second because I don't have any map.
It's all good, dude. I've already done it before anyway. I've done this with the toy model that matches Blender. So I'm not doing anything different than you're doing. If you don't come up with the same fucking shit, then you're doing some finagling, buddy, because it's just cut and dry. I'm not doing anything except for putting the GP of the sun, the Tropic Capricorn, which is the specular highlight that you have there. I have the Earth. The Earth is at a tilt at 23.5 degrees. I fucking literally glued a little screw or a little fucking thing on the toy model at a Perth and put a protractor along that meridian, dude. Just like you're doing with your little wheel. Doesn't come in the bottom. It doesn't come in the bottom like that. You'd have to have it come in. You'd have to tilt the Earth up to 30 degrees to have it come in the bottom like that.
I'll align north again. And then I'll delete that.
Just go get a meridian system, buddy. Get a meridian system, because once you have the meridian system, you'd have north and east right away to determine. And you'll notice that the sun will come in closer to 100 degrees east rather than 120 degrees southeast. I mean, it's still 100 degrees southeast, but it's not as, it's 120 degrees southeast is quite a bit different because the Earth would have to be tilted more. Anyway, Bacon, I appreciate your candor and ability to do this on the fly with at least some determination to be honest, which I appreciate. The other guys that I've dealt with didn't want to do this at all, even if I presented a video or a Blender before. It's not that hard, dude. You're doing more time. You just need to...
Here you have the meridian. Can you see it? Can you see the meridians there?
I can see them.
Okay. So what I'm going to do right now is I'm going to create the 116 degrees. And I'm going to place that on Perth. So I'm going to come here, create a cylinder, and go to this direction. Delete the old one. I'll do it from scratch.
Just put a gnome in there. It's all good, yeah.
Well, it's a little different than you do, but he's probably better at it than you are.
No, I stopped doing the Blender skills last year. I'm a little rusty.
Yeah, I'll create an arrow that points north. So I'll create another cylinder. Let me delete this. I don't need this.
So you see how you have your cylinder placed along the meridian there? That's exactly how the protractor is placed. The same thing, except for it's at Perth. So it still points north. It still highlights 90 and still highlights 270. So there's nothing different that I'm doing at this point than you're doing. And I still have that shadow angle come in at greater than, it doesn't work on your ball. Your ball comes in around 100 degrees, maybe. Yeah, just put 100 degrees. Let me rephrase that, the toy model. Again, I'm not surprised you guys think your toy model is correct when it's considered and told not to be used for scientific purposes. That's what I also find entertaining as well, is the fact that you defend your toy model that actually says it's not meant to be used for scientific purposes.
Be serious.
Okay, that's an arrow. It's an arrow pointing north, right?
Yep, that's an arrow pointing north.
Okay, and now I'm going to duplicate this arrow and rotate it by 116 degrees. This arrow here is pointing to 116 degrees azimuth. That's the azimuth of this arrow.
Yeah, go down to Perth and do the same thing there.
So I'm going to move to the latitude of Perth.
Yeah, you see how that's angling down, beyond, like underneath the Tropic of Capricorn.
Because it's at 0, it's not
right. But here's the problem with that: the sun is at the Tropic of Capricorn during the sunrise.
Exactly.
Yeah.
Yeah, but that's.
But see how you have it angling down? It's not actually looking at it on a globe. Right.
It's not in the right position yet. This azimuth here isn't coming from this location. Of course, it's not going to match. Sun is in that direction.
Well, if you went and put it over on Australia, like he said, it would show it even more so.
Just give me a second.
Right,
Just
but
get the coordinates.
it's pointing
It's not
southeast
what
of the
I'm saying.
Tropic of Capricorn. That's the whole point. But the sun is on the Tropic of Capricorn.
I'll put it in the latitude first.
So that's what I mean. They're all full of fuckeries, man. Bacon, don't fuck around, buddy. I'm telling you.
In the latitude of Perth. Now I'm going to rotate it to the longitude of Perth.
Why are you at Perth already? Why didn't you just create it all at Perth at the position there?
Because it's tilted. How I'm going to create a tilted? I mean, it's easier to start at 0 and then move it to Perth because I can have a perfect reference to north.
So you still haven't put a gnomon on Perth yet, right?
No, it's on the latitude.
So you still haven't put a gnomon at Perth. So listen, what you're doing is you're going out of your way. You still haven't done the basics yet. You're going out of where you're doing some fuckery again. Just create a gnomon at Perth. Show me the shadow angle that gnomon creates. Just do that first, all right? Then you can take your fucking north, and then you can look at where that shadow angle is coming down at Perth with that gnomon and show me the 120 degrees.
Okay, now it is 100. This is north. This points north. North is there, right?
There you go. Now guess what? Are you going to get a shadow angle? You're not going to get a shadow angle, dude. Matches
That's where
that.
the sun is.
Again, that's not where the sun is. The sun is at the Tropic of Capricorn.
That's the Tropic of Capricorn.
Yeah. And then do the sunrise. So rotate around and do the sunrise. Rotate around and do the sunrise. You shut the fuck.
Can you see the dotted line, the dotted red line, right where my arrow is pointing? That's the Tropic of Capricorn. So what the fuck are you talking about when you're saying it's not a Tropic of Capricorn? It's exactly there.
Show me the specular highlight over the Tropic of Capricorn as if the GP of the sun is moving towards Perth for sunrise. You have it opposite right now.
What?
Holy fuck, buddy. Go to make a sunrise in Perth, please. Have the GP of the sun over the Tropic of Capricorn. Show me the specular highlight of the sun moving along the Tropic of Capricorn to sunrise for Australia.
Oh, just give me a second. I'm getting the.
See, that's what I mean. You don't have to go through all this bullshittery, dude.
I need the angles so I can do what you're asking for.
No, you don't. All you need to do is put a fucking gnomon pole at Perth, and you will
Yeah, I
see
need
the
the
shadow
angle
angle.
dead.
You
Stop.
see the shadow angle on the toy model.
Stop speaking louder every time you're interrupting me.
Anyway, dude, you're spending way too much fuckery for a fucking simple example anybody can do in their room with a toy model, for fuck's sake.
Did you guys get the globe to work?
It's the toy model that doesn't work, man. It's just a I don't know. It's just a fucking mind tool.
The toy model doesn't work, but the real one works.
It's in shambles, Godric. Fractured all over the place.
I'll rotate 23.4 degrees. So now the tropical Capricorn is right where the sunlight gets, and I'll put a source of light. So you stop complaining about it.
So now you're going to put another source of light, dude. It's only one sun you need.
There's
You only
no
need one source of light.
There's no source
Again,
of light right now. Now there's zero sources of light.
You're doing some fuckery, dude. So again, with the default, I told you. Listen, buddy, default blender starts with a sun right over. Dude, suck a dick. The globe Earth or the globe sphere.
There is no source of light right now. I didn't put any. I'm not putting two. I didn't put any yet. So stop complaining before I even do the very thing you're asking for. Jesus.
You just had the sun up there. Why you changing?
There wasn't the sun. Blender was not in render preview. It was in texture preview. So it creates an artificial light. That's not the light that I put it there. It's the light of Blender itself. It moves around the camera. It's not a source of light. There was no source of light.
That's what I kind of thought from the very beginning of this. I think Dirt Data is really confused about Blender.
Yeah.
No,
again, any light in Blender will show the same in a rendered model if it's a line, direct line.
Shit. Why are you such a little cocksucker? Stop it. Just let me talk. So what happens is any of these type of programs have this artificial light. That's not where the sun is. That's just the illumination of this object in this stage. It doesn't relate to what you're actually doing. And that's why you got all screwed up. This little light that you thought is the sun has really screwed up your understanding of what you're seeing.
No, buddy. It's all good. It's all good. It's
the
there for you.
truth.
It's there for you. You can go demonstrate it yourself. It's
that
not
light
crazy.
Is not the sun. Why do you think that
crazy.
it is?
There's no. There you go. There's no southeast sunrise.
Why
it's 100 degrees, like I stated. He's just showing you.
It's shining on the edge of the.
He's showing you right now.
You see the eclipse, the
you're
shadow.
Are you
the shadow wouldn't be. The shadow wouldn't be there.
Don't tilt the global view, dude. Don't tilt the global view. Don't fuck around.
That sunspot.
Having to tilt the Earth more than.
It was something that is the sun. It's not.
Okay. It's right there. The very thing you said wasn't possible if I did on Blender. I did on Blender. The arrow pointing up is obviously pointing north because now you have the lines of the meridians, and you have the whole grid there. You also have the line of Tropic of Capricorn. You also have the GP of the sun, and you have Perth, and you also have the 116 degrees from north, which is the azimuth of the sun at the location. So everything that you said that should be there is there. So what's the problem there?
So again, you're fucking around again by lowering the view to get the specular highlight of the observer. So see, if the Earth is centered in frame and you have just the tilt function going on, you're not doing this global search button by going around the object. It's just at its straight on reference frame. As the sun sees away, you're not changing the specular highlight position by the observers. All you're wanting is to see the observation of the tilted Earth and the.
Now he feels really stupid, Blender.
You're getting the tilt of the Earth and the shadow angle it produces. You're not trying to change the observer's position. You're not trying to change the observer's position in Blender to change the shadow angle. You want to produce the shadow angle. I still waiting for the shadow angle to be produced. He hasn't produced a shadow angle. What he's doing is he's lowering the. No, he does not have a shadow angle. It's not produced.
Looking at it.
He has an arrow direction. He's not producing
That's
a shadow.
Parallel to the direction of the sun.
Okay. So again, if you actually have a physical.
Really, are you scrambling just because you feel so stupid? Really?
No, I have a video of the same thing. I demonstrate. I demonstrate the same thing in the video. I have a video of this example.
You got to get a grip. I want to read your
book. Literally have a video of this example.
You mock people that know 10 to 100 times more than you do about almost everything you speak about. It's pretty uncanny.
I have a video already demonstrating the opposite of what he has here in practical, and I have a Blender video with the same thing, the same effect.
You're so smart, Data. You could have walked him through it step by step, and you could have proved.
So he doesn't have a gnomon there. He doesn't have a gnomon there. He has a gnomon there. So you can change that.
It makes total sense to me. I don't know why it's so hard for you to understand it.
Wait, so that
'Cause
arrow,
if-
hold on, Bacon, go zoom in again. That arrow, is that showing it rising south of east?
Which arrow?
That's your
This
arrow
one?
there?
Only
Yeah.
only if he lowers it. If
Yeah,
he lowers his view.
Yeah, see how that's, hold on, Data, chill for a second, bro. See how that line is pointing south of the Tropic of Capricorn?
Yes.
That's the whole point. But the sun is at the Tropic of Capricorn at that
Yeah,
moment. For a human on Earth.
Yeah, the ground position it is. But
See,
if
you got
look-
that's a perfect angle right there. Perfect angle, dude. Oh yeah, go back a little bit. Just there, yeah, like that. See how those are totally differing.
No, this
Well,
line here.
Those are parallel.
It's perspective. They're parallel. You're both going out in the same direction. Why is
One
this
sec,
so
one
hard to see? I don't get it.
They're not.
That's
the
not
tropic-
the direction. That's not where a human would be viewing it. A human would be viewing it on the Tropic of Capricorn.
Yeah, but well, no. That one
The
second.
ground position. That's not where the sun is.
Yeah, the ground position.
The
of
sun
here.
is at Tropic of Capricorn
Stop.
during December
Stop.
21st. It's at Tropic.
Bacon.
I
One
meant
is going
Capricorn.
to the.
Yeah, I might have
one
said
is
Cancer.
To the left.
Capricorn.
One's going to the left and one's going straight. They're not
I know
going
what
to
you meant,
straight.
Joe.
No, they are parallel. Those two lines are parallel.
It's in Blender.
This
You
line-
can see that they're parallel.
this
When
line
it shows head on, they're
parallel.
parallel.
Those two lines point to the sun.
So it seems to me the whole misunderstanding here is he thinks that you would be looking at the ground position of the sun rather than the actual direction of where the sun is when you're seeing it rise.
He thinks the specular highlight is
Yeah.
the sun.
Yeah.
The specular highlight is where they would indicate the sun's position over the Tropic
No,
of
it's
Capricorn.
not.
That would give it.
It's
That would
not.
give. That would give it its.
Light.
That would give it its. If I was to look straight up at the Tropic of Capricorn, I would directly see the sun above me. Right. That's the whole point of the tropics. Correct. Just like I was at Capricorn, I looked straight up. I'd be able to see the sun directly straight up, not just the equator, but between the two tropics too. Right. So if it's at that point, that GP point, that means the sun must follow that GP, that pathway, right?
Exactly.
But it
That's
is
exactly
not.
the section. Anytime you walk outside, if you can see that all three tropics and the equator, anytime you walk out, they're literally above you in your local sky. So if the sun is, that's why the sun changes position throughout the year, because it's changing between the tropics. So it absolutely is in that. Now you're going to be at a particular angle to it, depending on where you're at. But on this globe thing, if it was actually tracking at the Tropic of Capricorn, you would be looking, that line that you have on Australia that's like angling down and off to the right would actually be angling directly at the Tropic of Capricorn as to the position of where the sun actually is.
The Tropic
Because
of
the sun is
Capricorn.
not on the Tropic of Capricorn. It's just
Yeah.
the light
Yeah.
is hitting at that
It's
location, but
literally
hitting-
on the Tropic of Capricorn. That's the cycle. That is where the sun's GP.
Tropic
where
of
the
Capricorn.
GP is, not the sun.
Yeah, the Tropic of Capricorn is tilted. So if someone is not like directly below the sun, somewhere else on the Tropic of Capricorn, it's not gonna see the sun due east or the west just because it's at the Tropic of Capricorn.
So again, that's the position, the solar subpoint. It goes upon the Tropic of Capricorn. It means that trajectory of where it comes in follows a path. The way I indicate to acknowledge the sun's position is by making it follow that path, which means the only thing I do is I keep the sun stationary and I tilt the Earth 23.5 degrees. And when I do that, when I use a map that has a Tropic of Capricorn circle on it, I get a specular highlight at that point in position. And then I just add a gnomon to the Perth, and then I can see, well, knowing that it's along that meridian, which is north, and it's a zero magnetic declination, you can see the shadow angle is not coming in parallel to what he's showing here, in a sense, where he's got the other arrow headed out. In the model demonstration, it actually shows that you have to look, the Earth has to be tilted up for you to look at that southeast direction at 120 degrees. That's what the demonstration shows. So what you're doing there, you're changing the position of the specular highlight by changing your global position, right?
It was a very long sentence.
That was a book.
Yeah.
I gotta hand it to you, Data. You're like one guy that never gets sick of being wrong. It's uncanny.
I have a video of the same demonstration, bro, with a protractor on it that I show you. So it's not that I'm wrong. I have a demonstration that is
Dana-
exactly.
Sorry, I thought you were done. I was just gonna go ahead.
Anyway, it's a demonstration I have with a toy model. It just debunks the toy model. Get over it. Your toy model doesn't represent reality.
I'll be interested in seeing that, but I assume what that shows is that the angle to the GP location isn't what you expect it to be, and that's not what anyone should expect it to be, because the sun is actually not sitting on the GP. The sun is considerably far away from the GP, and you would be looking in the direction that the sun is, which is the same direction of that light traveling to the GP.
Right.
I mean,
it's above
Bacon
it.
is showing it right there. The direction he's showing is the same as the direction that the sunlight is coming from. Those lines are parallel, which is exactly what you would expect.
He has a little problem with things that are really big or really, really
if
far
we're
away.
on your globe Earth and the sun was December 21st, it would have to go along the Tropic of Capricorn, which means you would be looking east, maybe slightly southeast. In this case, you're looking 120 degrees southeast, right? You're showing me this arrow, but put a gnomon on Perth and not the arrow, and look where the shadow is produced. The shadow angle is going to be different than that arrow angle it should be. Because when you use this global position, you're going to change that specular highlight, and then you can line it up with that. So wait, you got that straight line there?
Yeah, they're head on. They're parallel. You just don't understand perspective, I guess. This is a common
No.
misconception.
So I have a toy model. I have a toy model that shows this, shows it different. I'm going to upload the video. I'll show it to you in the chat, or I'll put it in the chat. You guys can watch it. Again, it simply shows exactly what I'm demonstrating, which the sun comes in at 100 degrees. No, I demonstrated
The thing is, what they're doing here is they're making the sun a very, very far distance away. So it's just the Eratosthenes trick again.
No, that wouldn't matter. That doesn't
Because
matter.
it absolutely would. Because the sun traveling over the Tropic of Capricorn as a close and local sun will be a very different position than if it's infinitely far away, which is what they've done here.
Well, that's true. By the way, pardon me, because he does have the arrow extended out. When I was using the toy model, I have a close sun to it, so I don't have that extended sun. But I only did the
difference. That's the difference in these geometries.
I don't think so. It's arbitrary in this particular case because when I do in Blender, the way I've done it here, what he's done, I can get it to match in Blender. So, which means it doesn't matter how far away the sun is because you can change the brightness and the size. It's arbitrary.
Hey guys, I gotta head to bed, but I had a couple unrelated questions for Data. Would it be okay if I hijacked the conversation and then left?
Please.
So, Data, you got 3 gyroscope instruments in that airplane of yours, right?
Not a small aircraft, no.
Oh, really?
Oh, really? You don't have
like a light wing?
You don't have a. Okay, which 2 do you have?
Flying a 172 or a 152? What are you flying around in?
Oh, I can't remember. That's not even a 152. It's a light wing I was last in. It was a couple of years back, so I can't remember what it had.
Well, you had a turn rate indicator, right? A turn coordinator?
It's been a while, buddy.
Artificial Horizon. They ring a bell?
All I know
Artificial
is
Horizon?
Yeah,
Turn
all I know is
indicator,
I didn't have to adjust for any curvature or spin while I was training.
Of course you don't.
That's it.
We've already explained why you don't.
And which gyroscope unit do you think would have been the one that you would have had to worry about? The one that would not have automatically corrected for Earth curve and Earth rotation?
It doesn't automatically correct. It's bullshit.
That's what
Stop.
the pendulous veins are for. Yes, it does.
Pendulous veins are for velocity changes. Stop lying.
No, that's not true at all. Dude, I had a
100% true.
We disassembled a plane from
Hey, Zanuck?
every nut. And
Yeah,
no, that's not good for you.
I got to take off, and you can have them when I'm done.
Oh, you're priming them up. Okay, go ahead. Sorry, go ahead.
Yeah. Anyway, so the pendulous veins correct for any out of plumb state. It doesn't matter what causes it, they correct for it at a guaranteed minimum of 2.5 degrees a minute or something. So even if it doesn't matter if the if the Earth rotation or the plane going around the curve caused a slight out of level, the pendulous vanes would still correct it. So you can't use the ADI unit as your evidence that the Earth doesn't curve. So which other gyro do you expect would have had a trouble on a
So
curve?
I can use a small flight path between 3 points and not correct for any curvature
Can you
or
answer
spin,
his question?
and not even
Okay.
account for
Data.
any of it.
Data,
So
can you answer his
if you're
question?
telling me that a gyro automatically corrects for it, I'm going to call bullshit on it, because you would be instructed that you would have to correct for errors if the instrument was to fail. So there'd be a precautionary setup to correct for precession error in a gyroscope if it wasn't to function properly. That doesn't exist. There's nothing to compensate for the error at all. So it's
Yeah,
just
if you do a 2-minute turn and you do it for like 10 minutes, you will completely disorient your artificial horizon. It will be arrow.
and
You'll
then
go level. Hold on.
it'll
Can I finish?
eventually
Can I finish? Can I
recorrect.
finish? Can I
It'll
finish?
eventually
Can I finish?
recorrect.
Can I please finish? Can I please finish? No one can hear you when I say it. So yeah, when you make it, you Steve, get in the bank turn, 2-minute turn, and you keep it there for 10 minutes. When you level the wings off, the horoscope will be way off, and it'll take about
So
3 or
again,
4
it's
minutes.
you're full of
Can I
shit. I'll
Can
tell
I
you why
finish?
you're full of
Can I
shit.
finish?
I
Can I
can
finish,
maintain
please? Can I finish?
my
Can I finish? You
horizontal
can
with my
respond when I'm done.
wingtips to the
You can
plane.
respond when I'm done. You can respond when I finish the sentence, Data, please. So when you straighten the wings off, this gyroscope will be out. It will not show level. It will be completely cattywamped. But it will
I asked the
gently,
pilot.
and so, or
I'm
you
going to
can
ask you.
you can do two things. You can wait for it to readjust itself, which the pendulous phase will do, or you can cage it and orient it again for zero.
So you're full of shit, all full of shit. Can you fly the aircraft
I flew a little more
horizontal?
than you have, I
Can you
guarantee
fly?
it.
Can
You
you
were
fly
wrong.
the aircraft horizontal and level without a gyroscope?
What?
Can you fly an aircraft horizontal and level without a gyroscope?
Without a gyroscope, is that what you're saying?
Yep, without a gyroscope.
You're pretty close, but no, not you can't be guaranteed level.
So you're
No.
full of shit again. So again, full of shit.
How do you
Why you're
fly
full of
level?
shit? Why you're full of shit?
How do you fly level if you
can
don't have
watch
any
you
instruments? How
you
do you
can
fly perfectly
maintain
level?
once you
It's
get trimmed
impossible.
off. Once you maintain trim, you can actually get your 2 wingtips to match the horizontal plane. You can fly level, yeah, without a gyroscope. But I asked the pilot
Well,
how to
that's
do
true.
it.
That's true. Yeah, that's true.
The point is
I thought we were being
you're
absolute,
full
but
of
you can get
fucking
close to
shit. The
absolute.
gyroscope doesn't correct for fucking any dip, no shit, because I can fly the fucking airplane with no gyro and still fly horizontal and level. So fuck off with your storytelling.
No, it's not storytelling. You know, it's true.
Fuck off with your storytelling.
No, it's not storytelling.
I can fly the
Data.
plane
It's
without a
not
gyroscope by
storytelling.
matching my
You're
wingtips
never
to
going
the
to get it
horizon.
perfect. You're never going to get it perfect, but you get pretty close using your wings and the angle from the
Get
horizon. The
the
horizon will
fuck
always
out
be
of there.
below. The
One of
horizon
your
will
one
always
of
be
your main
below.
jobs
The
as being a
horizon will
pilot is to
always
learn
be
how to
below. If
fly
you use the
level and
horizon,
horizontal all being fucked.
Data, you will crash the plane. Okay. Period. End of story.
So again, I asked a professional pilot, can you fly a plane horizontal and level without a gyroscope? He said yes. So there's no fucking correction for
Well, yeah, you
dip,
can
drop,
keep
or
on correcting
curvature.
until you don't lose
Get
or
the
gain
fuck out of
altitude.
here with a gyroscope is
You can
needed
do
to
this
fly
by
horizontal and
Data.
level,
You are
and
the
then it
most
corrects for
obnoxious person
curve.
to talk to
It's
of all time.
full of shit.
World record for being obnoxious. You.
Have you talked to Zanuck?
You're obnoxious.
Have you talked to Zanuck?
You're obnoxious. I'm just trying to get a word in
Have you
edgewise. You
talked to
keep on talking.
Zanuck?
You're
Have you talked
obnoxious.
to
Listen to you
yourself?
right now. You're obnoxious.
Dude, you're trying to feed me some horse shit, some gyroscope
It's
corrects
not
for Earth
horseshit.
curve.
You can fly the
It's,
plane level by
dude,
looking at your
it's horse
altimeter and
shit.
making sure you're not getting. See, look what you're doing. You're obnoxious. You can't let people speak. You do it to everybody else, not just me. Everybody you talk to, especially when you get contradicted. So yeah, you can do a number of ways to get pretty close to level, but the pendulous vanes on the artificial horizon will eventually level out and give you a level orientation on the artificial horizon. If you go into a bank
How
for
can I
2 minute turn for
fly?
10 minutes, why do you feel compelled to talk over me? So if you do
Because you're
make a
just talking
2 minute turn
horse shit
and you
again.
keep it there for 10 minutes, it will get out of whack and you level the wings and the artificial horizon will be completely out of whack. You can do two
So
things.
when
You
you
can cage
fly,
it.
when you
You can
fly
do
a
a cage. You
plane,
can cage it. You can cage it, readjust it, or you can wait for it to readjust itself, which will take about 5 or 10 minutes, depending on how
so
far away.
fly a plane on a horizontal surface, it has to be horizontal. For you to fly level and without a gyroscope, you have to have a horizontal plane surface to do that, correct?
No.
No? Okay. So
No.
what would you how would you fly a plane horizontal with a gyroscope then on a curved surface? How does that work?
But I eyeball where the horizon is, knowing that it's a few degrees below eye level, and I would look at my altimeter, and as I fly, I'd see if
You
I'm
have no
gaining or losing
instruments. You have no instruments.
Oh, no instruments.
No instruments,
You
dude.
can
So how do you?
just you'd have to guesstimate your dashboard and the horizon.
The only way that you can fly with no instruments is on a horizontal plane surface is to match your wingtips to the horizon. And then I forget what he told me. And then I forget what he told me with the nose. You have a Mercator part with the nose because you don't want to decrease or increase in elevation. But I forget what the tip was with the nose. But you can fly. You can fly. You can fly horizontal and level.
If you're in a plane
fly
where it's
horizontal and level without a gyroscope.
What if it's a Cessna? You can't do it with a Cessna.
You can fly a plane.
Your wings are above your head, you knucklehead.
So now you're changing the plane for your argument. So the point is, I asked a professional pilot.
Even a
you
low
don't
wing,
need a gyroscope to fly a plane. Which means,
if you have a lot of dihedral, it's going to be point. Okay, I'm done.
Which means
you are an idiot.
When you fly the plane without no instruments and you can fly it horizontal and level, you do not have to think of a ball when you do it. Throw a gyroscope in there to help you with maybe some, pitch or yaw, whatever you want to talk about. Sure, but at the end of the day, it doesn't give a fuck about the shape of the Earth. Hence why you can fly the plane on a plane surface, and then a gyro is to help you figure out the orientation in 3D space. It doesn't give a fuck about the shape of the Earth.
I just posted a link to a vendor that puts out a 3D gyroscope that I've actually worked with, and I suggest you go look on the section in that page saying gyro compassing and see what it says.
Yeah, they talk about precession. They talk about correcting for precession, right? Mechanical precession. They talk about velocity changes for certain. But if you're going to hold true to the affirmation that it corrects for 15 degrees per hour, I would say you're lying, because there is no exact every 15 degrees per latitude. That's bullshit. It's horseshit.
You don't know what you're talking about.
You got it wrong again.
And actually, this particular one is not
going to be. It's horseshit, dude.
You're doing it to him too now, Data. Just shut up.
Your storytelling and your claimed affirmation, your storytelling, your claimed affirmations,
for curvature,
your stories and claimed affirmations are irrelevant to pragmatic practicality. In other words, if I fly a plane, I can fly it level and horizontal. Why is that? Because I'm flying over a horizontal plane. How do I know? It's because I have a technique that I developed to apply to a horizontal plane as I fly a plane.
Then why is the horizon below level?
Why do you think I asked him?
Why can't you
think
fly
I asked him?
to the horizon? Because you will lose altitude.
That's why
I asked the pilot. If you point to the horizon, you will lose altitude.
Why are you interrupting me?
You will not
what are you afraid of,
level.
buddy? What are you afraid of? So again, that's why I asked him, could you fly the plane horizontal level to instruments? And he said yes. And I said, how do you do it? He told me how. That has a hypothesis. The hypothesis is I think the Earth is flat. How do I prove the Earth is flat? Well, I'm going to take my wingtips and fly. I'm going to make my wingtips match horizon side to side. I'm going to do that. And if I do that, I can fly level. Boom! I fly level.
I see what you're saying.
Plane.
No, that's not what we're talking about. We're not talking about wings level, like you're not in a
Get
bank
the
or not.
fuck out of here, dude.
Flying. We're talking about going up. See how stupid you are. We're not talking about that.
You got no argument. Just insults.
I do have an argument.
Just moronic insults.
Gio, I need 30 seconds.
Just a moronic insult.
Otherwise, it'll be a shit show. Gio, can I have 30 seconds?
I asked the pilot, buddy.
Gio,
bring it up with the pilot.
Can I have a 30
Testing.
30 seconds, too funny. So again, Zanuck, just so you don't get confused, the pilot was asked.
I'll tell you why.
Don't interrupt, please. Don't interrupt, please. Don't get confused.
Wings level is different than gaining or losing altitude.
Get confused.
You hear me?
I asked him.
If you hear me,
repeat myself
wings
again.
level is different than gaining or losing altitude. Yeah, wings level is different than gaining. It's my turn. So wings level is different than gaining and losing altitude. Yes, level your wings. You compare to the horizons. Perfect. That has nothing to do with the shape of the Earth because we're talking about going over the curve, rising or falling with respect to the horizon. That only happens with you looking at the horizon and seeing the horizon below level. And
that's
then,
an assumption.
And then then when you are flying, if you gain or lose altitude, you'll know which way you're going and how to adjust for that to make it perfectly level without your artificial horizon. But what the pilot was talking about was your wings to the sides of you, so you're not in a bank, so you're not in a slip, so your wings are level with respect to the horizons. Even when you're wrong, you're even double wrong because you don't even know what we're talking about. Oh, and thank you for this.
So again, just so to reiterate, I'm just going to say this and I'm done. The pilot was asked, can you fly your plane horizontal and level with instruments? His response was, yes, unequivocally, yes. I asked him how so. He gave a few tips on what he does to fly his plane horizontal or can fly his plane horizontal if there's an emergency. And that was done by placing his wingtips from wingtip to wingtip, match the horizon. So when you go to trim off your plane to avoid banking, you keep looking at the horizon, both left and right wing, until they level out. We're not talking about descending or ascending at this point, but there's also another technique for
That's
that.
what level means. That's what we're talking.
So let me
That's
finish.
the context
Let me
of him
finish.
saying
Let me
level.
finish. Let me finish. I believe there's a point. There's a point with your tips of your wings that the way they sit next to the horizon. I can't remember exactly, but the way that they look next to the horizon, you can also get your angle of incidence, if you will, and that's where the angle of incidence to the horizon will tell you if you're ascending or descending.
No,
I
that's
can't
not
remember exactly. I
Not
can't
even
remember
a
exactly.
angle of incidence to
But
the
the point
horizon.
is,
You're
the
just saying what
point
you're
is,
talking about.
the point is,
You don't know what you're talking about. Some angle.
Point
some
is,
wings have a higher. Okay, my turn now.
Point
Let
is,
me finish.
point is, I'm not done. I'm going to finish this point and I'm done. The point is, he was asked, can you fly the plane level and horizontal without an instrument? Meaning, you don't have to think of a fucking ball. You don't have to adjust for drop or curvature. All he had to do was couple of simple procedures to fly horizontal and level. That's it.
Okay. So again, you reiterate what you said the first time. It took me a while to figure out what you were talking about. Now I get it. Yeah, if you want to fly the wings level, like not in a bank, then you would look at the horizons, both wings, and you could tell if you're level or not within
Do you listen, Zanuck?
a good
What was
error
the
margin.
pilot
Now,
asked? What was the pilot
Can I
asked,
finish?
Zanuck?
Can I finish? You said
No.
I could finish. I let you finish my turn. So we have the wings, and we can also, by the width of the wings, if you see them, you can, but depending on the angle of incidence to the actual fuselage, because they all have a little bit of an angle of incidence. They're not perfectly in line with the fuselage. So that doesn't always work either. You could be a degree off. You could be 2 degrees off in some airplanes. So you would look at the wings and say, okay, I see the top curve, which is a curve shape, a chord, is between the top of the ring and the bottom of the ring, which is flat. But you're going to try to guesstimate by the shape of the curve and knowing what that lift wing surface looks like, because you've seen it on the ground. You can kind of approximate what the wing would look like if it's going straight parallel with the horizon. That works as well. But because the horizon is below level, it's very hard to do this with the dashboard too, unless you know and look what to look for or have a level orientation. So you can do it and be close enough. The best way is to look at your alternative. Or if you don't have any instruments at all, that way he told you is correct. You can fly it reasonably flat and straight. And when you start getting closer to the ground, I've been losing altitude. If you get too high, well, and the plane performs incorrectly, then you're too high because you've been gaining altitude.
Zanuck, how is it possible that I can navigate over a surfaced body, negating the fact that I have no idea if it's curved or flat? But when I navigate over it, I have a process, a methodology that allows me to fly level and horizontal without any instruments.
Because you fly level. Level is just flying without gaining or losing altitude. It's flying through the curve.
I have
curving,
no instruments. I have no instruments.
I know
Listen, I have no
That's not what I'm talking about.
So
I'm saying
let me finish.
It means flying
I have
level,
no instruments.
meaning you don't
I have no
gain
instruments.
or lose. I didn't say you had fucking
dude. I have no instruments.
What the hell's wrong? Are
right?
you retarded? Were you
keep
dropped on your
interrupting
head or
me,
something?
dude. You
I'm
keep interrupting
talking.
me.
Shut
you
up.
keep
No, I was
interrupting me,
talking.
dude. No, I was talking. You interrupted
rolled
me.
over me. I was going
You
to tell
interrupted me, dude. Again, you
Go ahead.
interrupt. That's all
a
you do,
joker.
dude, is
You're a
interrupt.
joker.
Bottom line,
You're a
you
smoker.
always interrupt.
You're a midnight joker.
The point is, I can fly a plane without any instruments, and I can fly it
Yeah,
horizontal
we all can.
and
Anyone
level.
who gets
So
half of a brain can do it.
if I can do that, why am I not adjusting for dip or curvature as opposed
because you
to
fly in a curved atmosphere. That's what I was trying to tell you.
Oh, okay, right. So how do I
Yes,
know
right.
that?
Thank you.
How do I
Good.
know that? How do I know that?
You don't need to know that.
Oh, okay. Right on, buddy. Good talking to you.
right on.
I learned a lot. I learned a lot, Zanuck.
Don't forget rotation, by the way.
And rotation as well.
I'm not even talking about rotation
1.5
yet
miles per hour per
because
minute.
the 60 to 1 rule doesn't take account any for rotation, but yet I can correct my course change based on this rule of thumb, which is in practical use,
Yeah,
which
why do
means
you
I
think
don't
you're
account
off?
for rotation.
Why are you off? After 60 miles? Why do you think you're off 1 degree?
In class, they teach you due to wind drift.
What if it's going the other direction?
Giggle, 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 giggle.
Yeah, dude.
Good question. What if it does go the
you're just
other
a novice.
direction?
You're a rank amateur, dude, and you're trying to hang with the friggin' big boys, and it's just a joke.
You got no
You're a
argument,
joke.
buddy.
You're a
you
complete
got
joke.
no
That's just all I
argument.
gotta say to you.
No argument.
I'm done.
Zero at all.
Sorry, go ahead.
Can fly the plane horizontal and level, no instruments. I can use a 61 rule, which has nothing to do with rotation, but yet correct my course based on this methodology. Nothing equates to curvature or spin when I'm flying local distances. Right on, buddy.
So if Earth spin doesn't come into all, why does the vector nav say that that's what they use for detecting true north, that they detect the rotation of the Earth? Are they lying to us for some reason?
Yeah, if they're detecting the rotation of the Earth, then there'd be a really easy way to falsify that claim, meaning that if you left the surface of the Earth, that the objects would be moving towards you or away from you, and that's one. Number two, if you left the surface of the Earth and you were to film the heavenly bodies, what would be rotating, the Earth or the heavenly bodies?
You run that last one. If I leave the surface of the Earth and
If you leave the surface of the Earth, what will be rotating? The Earth's rotating, or the heavenly bodies rotating? If I leave the surface of the
if
Earth?
you're in a vehicle that's in motion, then you'd have to take the motion of the vehicle into account. So the answer would depend.
The answer would depend. Well, give me a try. Let's depend on an answer.
I mean, I'm not even sure I understand what you're trying to say with that. I mean,
if I leave a body that is rotating, and there is a apparent effect due to that rotating body, if I leave the surface of it, what's going to rotate? The body that I conflate as the apparent rotation, or the visual representation that I see rotating, or is it the body that I'm on rotating? What will I see when I leave the surface?
which thing are you looking at? You're looking at the Earth itself, or the
I can
heavenly
see
bodies?
both. I can see both at the same time. I've just left the surface of the Earth. I can see both the star rotations, and I can see both the surface of the Earth. Now that I left the body of the Earth, what is going to be rotating? The stars or the body of the Earth?
I mean, the Earth is rotating. You've preserved your inertia with that, so you're moving with the
No,
Earth.
I just know I left the surface of the Earth. I left the surface of the
You
Earth.
left
I'm
the
no
surface.
longer.
You don't
I'm
lose
no
your
longer.
inertia when you do that.
I'm no longer
One of these people
attached to
doesn't
this.
understand that.
I'm
Okay,
no
that's fine.
longer attached to the surface of the Earth. In other words, when I leave that body, that rotating body, I have two visuals here. I've got the celestial bodies rotating, and I have the Earth rotating. But when I leave the surface of the Earth, am I going to see both rotating? Which one will I see rotating?
What do you mean by C rotating? Okay, you leave the surface of the Earth. You're in some powered plane. It preserves the inertia that it had.
No,
but
we're
you're
not.
also
See, no,
correcting
dude, no,
yourself.
we're not talking about powered planes. I'm just talking about being off the body of the Earth that's rotating and spinning, because the claim is that we see the heavenly bodies rotate, right? That's in motion, which means the Earth is spinning. But if I leave the surface of the Earth, means no longer I'm spinning. Will I still see the star
Your
rotating, or
momentum is
will I
always
see?
conserved.
Will I still see? Will I see the stars
Your
rotating still,
momentum
or will
is
I see?
conserved, you knucklehead.
I'm not
You're
part of the
such a
Earth.
knucklehead.
Separated from the Earth. Listen carefully.
You can't
I
just
have-
separate without. You cannot
I can't.
destroy momentum, angular
Of course,
or.
I can separate. Of course, I can leave the Earth. I can
No,
travel
you
in a
can't.
plane. I can
Inertia
leave the
cannot be
surface.
destroyed or created. When you jump up in the air, you still have the angular momentum that you were given by the Earth when you're standing on it.
You're
You can't get
begging
rid
the
of it.
question. I have no.
I'm not
effect of this
begging the question.
I have no effect of this
Regardless
angular
if it is
momentum. There's
spinning
no
or
way.
not,
There's no
you
way to
would
measure
retain-
this. There's no way to
you-
measure
it
this
doesn't
angular
matter.
momentum.
You don't
No.
understand. You are a living, breathing.
Saying I don't
oxymoron.
understand. Saying that I don't understand is not an argument. So if I leave the surface
Yeah, but you
of
don't
the
because you're
Earth,
showing me
Danik,
you don't understand. You're
Yeah,
showing
so
me that
listen,
I
you're
can
getting
always
very
leave.
excited for being
I can
wrong.
Oh, I don't know why I
You're
came
very
back.
excited
You are
for being
such an
wrong, bro.
idiot. Dude, you're
being
such
you're
an idiot. Really, you don't even think. Like a 4-year-old can think better than you. And I'm telling you why a 4-year-old can think better than you.
Zanuck, you
You're not
are
thinking
a
because if you leave,
4-year-old.
oh, I wish I would have known
You
what to do.
are a 4-year-old, Zanuck. You're literally a 4-year-old in a man's body.
That's ridiculous. You guys are just tail spinning.
We need some moderation here.
Yeah, for real. Come on, Zanuck. Say an actual point. Or if someone else wants to get in, these guys are just going
Okay,
bananas.
I'll say an actual point. When you jump up in the air, you've conserved a momentum that was given to you by the surface before you jump. You can't destroy it. You can't do anything with it. It's given to you. It's you can't destroy it. In other words, I don't know why I have to use so many words to describe something so simple. So when you leave the ground, you still have the momentum. You start going south. That momentum that you were originally given is still going to be. You're still possessing it. It's not going anywhere. So you start going south. If you're going to an area on the Earth that has a higher tangential velocity, you would have to gain momentum to get there.
Yeah,
So
that's New Perspective's entire point, or part of it.
I know, but no, hold on. But
So
then
then if you gain it, how do you gain it?
Can I
How do you
finish?
gain it?
God, Gio, what the hell? This shit
Dude,
show.
you were pretty much done, man. I mean, you got to pass.
I wasn't done. You said that's what perspective was. I said no. Perspective didn't understand, or maybe he does now, that you have a powered engine that actually drives a propeller that imparts a negative
Right.
momentum into the air molecules, and that force allows you to gain momentum. No one ever said you can't gain or lose momentum. It said it can't be destroyed or created. There's a difference. Get it straight, guys. Come on.
You said it can't be
So
destroyed or
Zanuck,
created.
it's a
You
thought
add to it,
experiment.
You're creating it. If you're adding to it, you're creating it, right?
Talk over each other.
How are you adding it? If you're headed south and you need to gain momentum, how do you gain momentum?
You use a force. Forces, by definition, will allow you to change momentum. Any change
so you're
momentum
saying
is
you
a
would
force.
accelerate east.
Can you let
You would
me
accelerate
speak
east.
and finish a goddamn sentence? So
Zanuck, you need a
add
break, bro.
power. You add a force. You add a
You're maybe
force.
acting like a
That force,
5-year-old today.
by definition, is a change in momentum. So when you change that momentum, you need a force. As long as you have a force, you can change momentum. It's not created. It's added.
Explain what you do. Explain what you do.
You bank the plane to the direction of the tangential velocity that you want to achieve, and that will allow you to get a higher tangential velocity, i.e., give you more momentum from the inertial reference frame. It's
And
not that hard, guys.
Then if you bank the plane in the opposite direction, Zanuck, if you bank the plane in the opposite direction, you lose momentum, right?
You don't gain. You lose momentum. Correct with respect to the inertial frame.
So
right.
if
you
you're
can
trying
have
to gain
you can become
momentum,
inertial. You can have no momentum with respect to the inertial frame. All you have to do is go 1,000 miles an hour eastward, and you will have no momentum. Hold on.
Then all you have to do is
all you have to do is go 1,000 miles an hour,
then
1,000 miles an hour at
there
the
you go.
equator eastward, and you will have no momentum with respect to the inertial reference frame. So what?
Well, then if you go 1,000 miles per hour westward and stop on a dime and hover, you'd be able to actually stick a camera out the window and show the Earth spinning independently of the plane below you. There you go. You can prove your spin.
No, you just made a completely nonsensical statement. No, it's not.
Well,
how it
really,
works.
why?
Because you don't stop on a dime and see the Earth spin beneath you.
Well, what if you did? You would
Then
be
you
able
would.
to,
You'd
right?
be going 1,000 miles to the east then, with respect to the ground. But for the
no, but
inertial
you would
frame,
be
you'd be
able
inertial.
to-
You'd be inertial again. You'd be inertial again.
If
Are
you're-
you listening to me?
Zanuck,
Are you
listen
listening?
to me.
Are you? Do you have any
I'm
capacity
saying-
to listen?
listen to me.
Is
I'm
it
saying if
possible?
there's any-
Is it possible if you to listen at all?
Zanuck, I'm listening to everything you're saying. I'm repeating
You're
it
not
back to
listening
you.
because everything I say, you're counteracting.
You're not.
You got to
You're not
just.
helping.
You guys got to find a way to just say your point, Zanuck. Like you wanting to drill it in his mind and make him see it your way. That's not really like what the conversation is. Like say your point. You know what I mean, and then let him say his point, and then the points stand on their own. Like you screaming that he doesn't understand is not really what the topic.
No,
is.
I haven't been saying that all the time. Just when I say simple things and he starts talking over me. So I will do I'll do my best to not talk over him. If he gives me space to not talk over him, I will not talk over him as well.
Panicked.
God, I can't even talk. All I hear him is yapping in the background. George,
See?
he can't stop himself. Look at him. Even now, he's still lighting up. So I'll let you speak.
You said your piece, dude. I think you said your piece. I think you heard what
I'll
I
let
said.
you speak. Let me speak when it's my turn. Go ahead.
All right, here's my point, and you got to shut up, Zanuck. My point is this: you're talking about catching up to the Earth, right? Which you have to do if there was tangential velocities that were higher than where you started from with your conserved momentum not matching. We agree upon that, right? So if there's any point at which you're catching up, then there'd be a way to get out of sync with the Earth intentionally by not banking east or wherever you think that you need to go to get this momentum. And all you have to do is stick a camera out the window and show the Earth spinning 15 degrees consistently underneath you, independently of your plane's motion. Then you could prove the Earth
Yeah,
spins.
if you were to stop with respect to the inertial frame, you would be you would see the Earth spinning underneath you 1,000 miles an hour.
There you go.
With nothing. I told you what you'd have
Why
to do
doesn't
that.
somebody do that? Why doesn't somebody do that and prove the Earth spins?
All you gotta do is go 1,000 miles an hour to the east. You'll see it.
Well, with the F-35B, you could do that.
Well, there we go.
So why hasn't someone done that? Because last time I heard you talk to Whitson about this.
You're not seeing it from the inertial frame. You're seeing it from the plane or from the ground. Don't you get it?
This is totally.
It's all about reference.
Don't you get it, Zanuck? The last time I heard you talk about
I do get it. I get it perfectly well.
Let me say
I get it perfectly well. If you go
you
east,
don't, because you're contradicting yourself.
If you go east, so remember we promised we'd let each other speak. Just shut up for a second. If you go east 1,000 miles an hour, you will see the ground move past you at 1,000 miles an hour. If you go west at 1,000 miles an hour, you will see the ground go 1,000 miles an hour underneath you. But from the inertial frame, there's a difference because you already have a spin of 1,000-mile tangential velocity. So if you go westward, I totally misspoke before. If you go westward at 1,000 miles an hour, you will become inertial, roughly inertial, which means you will not be moving with respect to an inertial body. But from the ground of the Earth will be spinning underneath you 1,000 miles an hour. But with respect to the inertial frame, you will be motionless, relatively motionless.
Yeah, these are all things I know. These are all things that are obviously the case if we are actually spinning. But last time I heard you talk about this with Whitson, you repeatedly said that a pilot always treats the ground, and a plane always has the ground treated as stationary below it. It's only the plane's relative motion to a stationary Earth below it. That's why they film. That's why they use simulators that way. They're never trained to fly over a spinning ball because it's stationary.
Okay.
With
and
respect
I said,
to the plane.
Are you done?
Go ahead.
Okay. So no, they're trained to fly to a point, regardless of what happens at that point, regardless of whether they encounter a crosswind, which are no different than if the ground was moving, i.e., on an aircraft carrier. You said you'd stop talking. You promised me. Stop. So you only fly to a point. Whatever. No, stop it. Please just stop it, or I will disengage completely. So you are
disengage.
No, stop. Let him talk. Let him talk. He's already dug the hole.
So
Go ahead.
you can fly. You fly to a point. Whatever that point goes, if it's on an aircraft carrier or you're in a crosswind, you've seen commercial aircraft approach a runway with a 20 or 30 knot crosswind. Their maximum is probably 30 or 40 miles an hour before they can't do it. You'll see them crab or slip into the airport, and it is pretty nasty looking. It's like this almost looks like it's defying physics, but they're flying in this air mass and they're at a complete angle because they want to fly to a point. It's no different than if they had to correct for many orders of magnitude less effect is if they flew due to Coriolis, because it's only about 1.5 miles per hour per minute, even at 500 miles an hour, and much less if you're going slower. So there's nothing really to worry about. All we care about is going to a point, flying to a point, and using the control surfaces to bank the wing or twist the airplane with the rudder only to get it in the direction we want it to travel to land on wherever we want it to land.
Okay, are you done? Because now I have something to say. I'm gonna go. Okay, not gonna interrupt me. Okay, now I'm going. Okay, so you've talked about crosswinds. You've conflated crosswinds with Earth moving. It's not the same thing. You'd have 15 degrees, your 1,000 miles per hour consistent motion, just like we talked about. If you were to go to the equator and do some fancy things that got you out of sync with the Earth, you'd be able to see that 1,000 miles per hour, one consistent direction of the Earth moving below you in one direction eastward. That would be totally different than a crosswind that you'd be somehow confusing with that, because you would see the Earth moving 1,000 miles an hour below you eastward, which would totally not be the same as a westward wind moving you 1,000 miles per hour, because you'd be hovering over a stationary Earth. It would be not conflated with winds, and you guys always try to conflate with winds as if it'd be the same as the Earth moving, just because the Earth seems to be moving since your plane is moving side to side with winds that go in all directions, and it's not the same as one consistent ground movement. Stop conflating those two. They're not the same. It ruins your whole idea, because you have to say that, because you did say and have stated repeatedly that the pilot always treats the ground as stationary, just like the simulators teach him to treat the ground, right? So there's no conflation of the winds That's the only thing that can save you in your mind. I don't know if you actually believe that or if you're just saying that. And then and if, let's just say the scenario, if you did get into that 1,000 miles per hour of seeing the ground move, like we just talked about, would be possible, and you could be able to film it and show that Earth moves. How would you then go about correcting yourself to get back in line with this 1,000 miles per hour sideways speed? And then explain how you would slow down to land and then still be going sideways at that 1,000 miles per hour to make it seem as though the Earth is completely stationary, just as all simulators would indicate. Done.
Wow. Complete confusion of inertial versus non-inertial reference frames. A. B. All we care about, yes, is the target. We can adjust the plane of flight to it, whether the Earth moves or the wind moves or the air mass moves. Doesn't matter. I'm not conflating anything. All you have to do is control the plane. Now, when you fly south and you're going from a higher tangential velocity to a lower tangential velocity, you still started with a tangential velocity. The air mass has a tangential velocity. And I was actually defending your position to a certain extent because people said, oh, well, the wind will naturally correct it along the way because it is going also at the same tangential velocity as the ground, roughly. And I said, no, that's not true because you start out with a so much lower of a tangential velocity. The difference in the wind or the air mass velocity is not going to move it fast enough so that it'll always be lagging behind. It's like jumping in a river versus jumping out a window or of a moving
So
train.
Zanuck, if these airplanes are going under these
I don't
effects,
think I was quite done yet. Now he was giving me
if these airplanes are going the effects, the satellite goes under the
he
effects
gave
too,
me.
then, right?
Now we had agreement. Thank you, Perspective, for actually being a human. You know, Data can't do that.
Data,
So
don't
anyway,
jump in. He's dug himself. He's still conflating the winds with the ground
I'm not
movement, which he
conflating
said he's
anything.
not.
So
Yeah.
just like, and I'm actually defending your position I'm steel manning it for a second actually by saying that if you jumped into water, like 10-mile-an-hour water, I mentioned it to what's it yesterday or day before yesterday, you would jump in and with relatively quick amount of time be going the exact same velocity as the river. Because you're floating in the river and it's moving at 10 miles an hour. But you don't do it instantly. It takes maybe a second or so before you would actually spin up. But in the air, jumping out of a moving train, that doesn't happen, right? Because the air resistance, the drag on your body is a force, and that force isn't great enough to accelerate you to whatever the ground speed is or whatever the train speed was. It doesn't work that way. So that's kind of what happens with the airplane. That's why we have to bank to account for Coriolis going southward from like North America to the equator, because there is let's say it's called a 500 miles an hour difference of tangential velocity. And it's only accomplished by adding momentum with respect to the inertial frame to the east. And we do that by turning the airplane, whether we crab it or whether we bank the wings, whatever we got to do. All we have to do is by a small 1.5 miles per hour per minute deviation from a straight course south, we will accelerate over hours, many hours, to that 500 miles an hour. And that only takes, like I said, 1.5 miles per hour per minute.
All right, so let me talk now. So now you're saying that you would have to correct for these Coriolis changes, right? Because you would have to meet that 500 mile per hour difference in your tangential velocities, and somehow just by banking east is going to make you catch up, and all of a sudden now you're moving in perfect sync with the Earth in that one-to-one relationship that you would need when you land. Doesn't work that way, because if you bank west, then you're losing momentum. What if you have to spin around and go back and correct for it? And oh, you missed your runway. Now you have to go back west to catch up to it. Oh wait, no, it's moving east still. Hold on a second. What about this scenario, Zanuck? What if you're going south-southwest, right? Now you're not going east at all, but you still need a higher tangential velocity because you're going towards the equator. So you need to make up that 500 mile per hour eastward direction that the plane would be needing to go to be in sync, which is impossible anyway if you're out of sync at all at any point. But if you're going south-southwest, now you're not going east at all. How do you gain eastward momentum when you're flying south-southwest?
Why would you need to gain eastward momentum when you're flying south-southwest?
Because you're headed towards the equator, which is a higher tangential velocity than where you started from.
Now you're going to an area of lesser. You just have to basically lose.
No, you're going with more.
You're going south-southwest. South-southwest.
No, but you're not starting at the equator. You're starting above the equator and going towards the equator, south-southwest.
Right. So now you take less.
So you need a higher tangential velocity.
So depending on the distance between the longitude line, how much off that longitude line you are, that will tell you how much less of a leftward bank you need to make. Now, where would you? Here's a good question for you. There is a number that I'm looking
You didn't
for
answer my
from you.
question.
That where would you point the airplane if you're traveling from North America to the equator? Where would you point it initially if you wanted to bypass?
He just totally
all
deflected, dude, from your question.
Hold on. You want to
Yeah,
go
yeah, he
let's
has
just
to
wait.
because it
Where would
fucks
you
them all up.
point the airplane to go to that position? Where would you point it? That's the
I'm not answering any. I haven't even listened to your
doing it
question because
again.
you
I
totally
just
avoided
trying to
mine.
help you understand. You're not
No,
willing
you're not
to
trying to
learn
help me with
anything.
anything
You think
because
you
you're
understand
avoiding
something,
my
you just
question,
don't.
Danik.
Okay, so now we're
Danik,
talking over
answer
each other
my
again. This is
question
great. No one can hear
because
us.
you haven't
We're just
answered
talking
my
over each
question.
other. Fantastic. Go ahead.
See, he's trying to deflect. Answer my
I'm not
question. If
deflecting.
if the plane is going south-southwest but needs a higher eastward tangential velocity, it
Why would it need?
hasn't banked
Why would it need a higher tangential velocity?
because it's going to the higher tangential velocity of the equator.
But it's going via a long way, going a little bit west.
It's going south-southwest, like let's
So
say
now you're going to be going a
Chicago,
little west. So
LA.
you're going to lose. So you're going to lose some tangential velocity, be going west. And you have to gain it back by the time it might make a harder, more accelerated or different angle by the time you get there. And by the time you get close to there, latitudinally.
How is
By
that
the time you
possible?
get there,
We're west.
by the time you get near there latitudinally, you're going to be more off course, and it would take more of a left-hand turn to get there.
Well, yeah, but you've already gone west and you've lost all your momentum because of going east as
Not
momentum
all your
and going
momentum,
west.
whatever
makes you lose
momentum
it.
you,
Doesn't
whatever,
matter.
whatever,
It doesn't matter. You're
whatever
still
you.
not gonna, you're not
Oh
gonna
my
be
God,
gaining it.
dude, you are obnoxious.
You won't be gaining any. You still
both
need
are
to make up that
obnoxious.
500 miles per hour eastward velocity, right? You still need to have that extra 500 miles per hour eastward tangential velocity to meet the 1,000 miles at the equator. But you've been flying west the whole time. So how did you gain any eastward momentum?
You're flying to an area on the ground that has a higher tangential velocity due to the conservation. I see what you're saying totally. So listen very carefully. I know what you're saying. You're thinking that suddenly you still have a 500 mile an hour. No, you're flying. You have an angular momentum, and you have a tangential velocity. You're going from an area of a lower tangential velocity to higher tangential velocity. Even if you go to the west, as you said, you're going to an area of higher tangential velocity, but you retain momentum. So the position that this plane goes to with this 500 mile an hour tangential velocity will be chewed up by going west as you fly south, and then you will end up at some far even farther west than you intended to go. And that's how momentum is conserved. That's the answer to your question. You think, well, but how could you
So you're
land?
saying you would
Hold
not
on,
hit your mark?
let me
No,
finish.
still
Let
flying
me
towards
finish. I'll
your
tell you when I'm done.
destination.
I'll tell you when I'm done. I'll tell you when I'm done. when you get so the point at which you can have that tangential velocity and where you will end up, because you are still traveling. You're still traveling a direction. You are going a little bit west, and it's curving to the west with respect to the ground. You will land, even though you started with a tangential velocity of 500 miles an hour, you will land on an area that has a area of 1,000 miles an hour. You say, well, that doesn't make any sense. We're not going 1,000 miles an hour. And that's what the curved path allows you to do. You've maintained and preserved. I know it's mind-boggling for you.
You're kind of
monologuing,
Zanuck.
but it has to be. Okay,
No,
Elbow, we don't
it
need
doesn't
you
have
right now.
to calm
This is a
down.
little bit of a complex question,
If you don't,
and I
if you
wanted to be very clear.
guys,
I wanted to be very.
Let him do
Help,
it.
you're not
Let him
helping.
do it.
You're
I'd
not
like
helping.
to see him try to figure this out because there is no answer. But go ahead, try to
I'm
say
not
it.
trying to help. I'm trying to moderate, and you're taking
Yeah,
a little bit too long,
I was
dude.
monologuing. It's
yeah,
called
but because he doesn't have an answer, so just let him squirm. Let him squirm.
Thank you.
Please.
I'm not squirming. I'm not squirming at all. The whole
How did
idea
you
about the
gain
conservation
500
of
miles
linear,
per hour?
the whole idea
momentum?
about the conservation
And you
laws
only went
is
west.
that momentum is. Are you going to let me talk, or are you going to be as bad as everybody else?
This
It's
is
a simple
unbearable,
question.
Zanuck. I've only heard you talk.
Yeah, Zanuck, it's really just too much, dude.
He was asking me the questions, and I was responding. Go ahead, have at it. Go ahead. Stay in your level of ignorance. That's not good.
Zanuck,
I
you
have
have
an
an
answer.
answer for this.
I'm giving
Go
you an
ahead. What is it?
answer. Forget it. You're done.
All right, dude, just
No,
take a break.
see,
Take a break, Zanuck. Go ahead.
He got the out. He got the out because people. Please, Zanuck, please explain it. How you would gain eastward velocity, eastward momentum, if you're only headed west and you're going south. How would you gain it? How are you going to land on that 1,000 miles per hour equator with only 500 miles to conserve momentum? And you've lost some because you're going against the spin, right? You're going westward, which somehow makes you lose momentum because eastward somehow makes you gain momentum in that direction. So you have no answer because you can't
I do have an
gain
answer
when you're headed west.
I
How?
have an answer.
Go ahead. Say it
I
quickly,
told
though,
you.
please.
So by the direction that you will, with respect to the ground, that you have traveled eastward will be the gain in momentum to the surface. That is the gain in momentum. You start with a tangential velocity of 500. You are ending up at a spot on the Earth that has twice the tangential velocity. So if you headed south, you would miss it. And just because you miss it doesn't mean you now can't land and have a tangential velocity of 500 because it's tangential velocity. You've
But
gained
you
that
only went
tangential
west.
velocity. But hold on, you've gained that tangential velocity by making the curve to the east relative to the ground. I
No,
know
you
you
went
can't
west.
understand this.
You only went west.
Yes, west. Going west. Did I say east? West. Sorry. Going west.
Yeah,
You
you have to
still
go.
gain.
You have to
You
go only
gain
west.
by going west. By going west, you've increased the tangential velocity with respect to the ground, and that's why you're now at a position that is 500 miles an hour, 500 miles off course.
How have you
Let's
gained
say
it if you're only going west?
let's say it took an hour to get down there. I mean, let's throw some numbers out. I don't want to go through the calculations, but let's say it took you like, it'll take you 5 hours to get down there. You could be 5 hours off. So you might be, several thousand miles off because it probably took a couple,
But no,
2,
no,
3
no.
hours.
You're
Or
just
let's say
headed to
5
your
hours.
destination, but you're only going
by with respect to the ground, by going eastward, you've now gained the tangential
No,
velocity with
you're
respect to
going
the
westward.
ground. But
Stop
from
with
the
that
inertial,
eastward. You're not
from the
going
inertial
eastward. You're
reference
only going
frame,
west.
God damn it, perspective. Okay, you know what? Sorry, I'm trying to help you understand. I know why you don't get it. I'm smiling
you
because I
keep
understand
changing
your
it.
question. I
Yeah,
understand why you're
smiling because
confused.
you're stuck.
I understand why you. Okay,
You want to make it me be confused
you're giving
here
me a
when you
fucking
can't even
headache. You're
explain it?
giving me a headache. Sorry, and I'm losing my
Yeah,
voice yelling.
because you have
Yeah,
no point. Listen,
this is
Danny, you're going southwest, right? You're only going west, so you wouldn't gain eastward momentum. You keep saying you go east to get this extra 500, but if you're going southwest, you wouldn't be going east at all.
You guys want to fight me or something, man? Because yikes.
You have no answer. That's why this doesn't work, and we're not on a globe. Period.
Either that, or you're a fucking moron. That's the other
Oh
option.
yeah, that's your alternative. Just call me stupid and say I don't understand when you can't explain it. Neither of you. Your answer,
We've
Ruhif, was
explained
don't
it to
go
you
west. Don't go
literally
west.
for
That's what you said
days.
many times. Oh, just don't
No, I
go
said
west.
don't.
Like pilots are ever trained not to go west.
Don't lie. I didn't say don't go
That's what you
west. I
said.
said don't
You did say
accelerate
that many
west.
times.
Don't
Okay, what's the
accelerate
difference?
west.
Well, what's the difference?
Do I seriously have to explain the difference between velocity and
Yeah.
acceleration?
You tell me how going west
You're
and
telling me
accelerating
you
west are
don't
different.
know the difference between velocity and acceleration. Please say that.
It's not that. It's not that.
Okay. So then, what is the difference between going west and accelerating west?
Well, the pilots are never trained to not accelerate west
What's the
because they're going to
difference
have to
between
land on
going
the runway.
west and accelerating west?
Well, you tell me.
West
Do you
would be
not
a
know?
direction, and
Do you not
acceleration
know?
would be speeding up towards that direction.
That
Well,
data?
if you aim in that direction, wouldn't you be accelerating in that direction?
Hang on, is that data? That is data.
Yeah, you want it out, don't you? You want it out too, don't you, Ruth? You're looking for one.
I'm here. I'm here.
Yeah.
Do
So
you
if
know the
accelerate
difference
west,
between velocity and acceleration?
you accelerate west, you're fucked. Is that what you're saying?
No.
Pilots are trained to not accelerate west. Is that what you're saying?
Did we get the answer to the question, do you know the difference between traveling west and accelerating west? Do you know the difference?
It doesn't matter the difference, but
Yes,
you
it
want to tell me
does.
the difference.
I want
Go
you
ahead.
to tell me so
if
that I know that you understand.
If you aim west and you're headed that direction, are you not accelerating in that direction?
We're not accelerating west. We're moving west. We're not accelerating west. Do you know the
Okay.
difference?
Either way, the difference
Do
doesn't
you know the
matter.
difference?
Is the point. Yeah, I know the difference. So continue.
Okay.
Tell
What's
me
the
why
difference
it matters.
between accelerating west
Tell me
and
why.
going
Tell
west?
me why it matters. Well, if you're accelerating, then you're accelerating. Okay.
Right. What
Why
does
is
that
that
mean?
something that you're trying to make that point an obfuscation from the whole idea that
Not
pilots are never
obfuscation.
trained not to go west, accelerate west, move west, however you want to put it. If they're going west, they're not gaining the eastward momentum they would need. That's the point.
Please tell me the difference between moving west
See
and
how he has to resort to
accelerating
this?
west.
Making
Do you
it
know the
be like
difference?
some kind of test about my understanding
Yeah,
of something
because we've
rather than just
spent
explaining it?
days trying to explain this to you.
Okay, well then
Do
why
you
don't you
know
just
the
explain it to me?
difference?
Instead of quizzing me, Ruhif, just go ahead and explain the difference
Okay.
and why it
The
matters.
question is,
Go ahead.
do you know the difference? Right? Because if you don't, do you know the difference?
See? Explain it. Don't even
No,
quiz me anymore.
I
I'm not
want to hear
playing
it
your
from
game.
you. I
No,
want
no,
to
no.
hear you
No, you
say, I
explain
don't
why
know
it
the
matters,
difference.
Janet.
I want to hear
Ruda,
from
explain
you.
why
I
it matters.
don't know the
No, see,
difference
see, this
between
is
velocity and
obfuscation.
acceleration.
I do know the difference. Now continue and
Okay,
tell me why
please
it matters.
explain the
I'm not going to
difference
play your games
between.
anymore.
Please explain the difference between having a westward velocity and a westward acceleration.
A velocity would be your overall movement of the plane, regardless if you accelerate. Acceleration would be if you accelerate.
What does accelerate mean?
It means that you would be using force in that direction.
Which will change what?
Which will change your momentum as well as your direction.
And your velocity, right? Velocity.
Yeah.
Well done. Okay, so now you do
Great.
understand the difference
Now,
from moving west.
I've always understood the difference. That's not the point. How do you
It took
gain
a long time
acceleration
to
when you're
explain
eastward?
it.
How do you gain? You didn't explain it. You just kept quizzing me as if I didn't know, which I already did, and it's not the point. You make it seem like it's a quiz about my intelligence rather than something that you can't explain, which is the
It
truth.
is because we've spent days trying to explain it to you.
Well, I mean, you
Doesn't
need to
know.
gain.
You're
Yeah,
just
you need to.
obfuscation.
You need to gain momentum in the direction of where the Earth is
Yeah,
moving.
by doing what? By doing what?
Well, you guys have. It's like a Spider-Man atmosphere that's clung along with.
No, ignore the atmosphere. Ignore the atmosphere. Don't worry
Well,
about atmosphere.
that's
We're
the only
ignoring it.
explanation. Because, dude, if you have a tennis ball and a little tiny toy airplane or something, and you spin the tennis ball and then you start, like what Dave is saying is correct in certain ways in terms of the physics, if that was the case. So you guys need to make the entire spinning Earth its own reference frame, and then have the gravity and the atmosphere, the Spider-Man jello, whatever you want to call it, atmosphere that's like stuck to the globe. But then that brings in a whole set of other problems. So the way you're describing it, Ruhiv, is essentially if that was the case, you're talking about that sort of atmospheric thing that's surrounding the globe, essentially accounting for the differences in the velocity and the speed and the acceleration, the momentum that would be taking place as we normally would know it as physics with a ball and something that's detached from the ball.
Don't worry about the atmosphere. That confuses things.
Ruhiv, just explain how you would gain eastward momentum if you're only going west, south-southwest towards the equator, where you need to gain 500 miles per hour eastward momentum, but you've only gone west. So banking east doesn't solve your problem now. How do you solve that problem?
Yeah, it's okay. Yeah. All right. Sorry, I missed that bit. Sorry.
Santa couldn't do it. Can you do it?
What was
No.
it?
So if
Sorry,
you
what
need
was the
to
question?
gain 500 miles per hour of eastward, you have to gain 500 miles per hour of eastward momentum.
Yep.
But you're
Right.
only headed south-southwest. Right?
Right.
You haven't gone east at all. How do you gain 500 miles per hour eastward momentum if you've
If
only
I
gone
said
west?
to you,
Don't start quizzing
our velocity is west or southwest or whatever, right? And I can accelerate east. Do you understand what that means?
No, I'm not quizzing. Just explain it, Zanuck. How do you
I just
gain your
did.
500
Okay.
miles per hour difference?
Right. Our velocity is southwest, right? And then I accelerate towards the east. That's your answer.
Okay, so how do you accelerate when you're headed west?
Oh,
How do you
Jesus.
accelerate east?
Literally,
when
I
you're headed west?
literally asked you 2 minutes ago, do you know the difference between velocity and
Yeah,
acceleration?
see how
You
you're
said
trying
you
to
did.
do this? Okay, so no, I'm saying, how do you accelerate east when you're headed west? You explain
accelerate
it.
to
Don't
the
quiz me.
east. You bank
How do you
left.
accelerate to the east when you bank left, but you're
Or
headed
bank,
west?
whatever.
Banking left
Sorry,
would be
if we're going
headed
southwest. Sorry, if we're going southwest, you bank, left,
southwest.
whatever.
You can't bank both directions at the same time.
Oh,
exactly.
We're going southwest. We bank to the southeast or whatever.
You're aimed towards the west. Your whole plane is
Understood.
headed west.
Right.
So
Our
banking
velocity
to
is
the left is
southwest.
going to bank you towards the equator. It's not going to bank you east.
Yep.
If your plane is facing
Well,
west.
okay, then bank a little bit more to the east then.
How do you bank to the east when you're facing west?
No, we're facing southwest. Facing southwest, right? So if we bank to the left, right? Bank to the left, we're banking southeast.
No, but you've already lost a bunch of momentum going west. How are you going to make up for the extra momentum you've lost plus gain the 500?
I explained this to you in a PDF.
You didn't.
Right? We took. Yes,
Dude,
I did.
Your PDF is ridiculous.
I explained it to you that when you take off,
well, you
right?
can't
When you
explain it
take
now.
off, I'll read the PDF if you like. Would you like me to do that?
No. Why don't you just
No.
why don't you just correct your contradiction if you can, but you can't.
There's no contradiction with having a westward velocity and accelerating eastwards. Do you think that's a contradiction?
Yes.
Okay, you're a fucking moron.
And that's your result. Is just to say
Yes.
that if you're accelerating, if you're going west, and then
Yep.
you can still accelerate east.
Yes.
Right? So you're accelerating west, right? You're accelerating west.
Let's put it
Get
this
to your
way, right?
destination.
Let's put it this
You've
way.
already
If I
accelerated
jump,
west and lost a bunch of
right,
points.
I'm on the floor right now, right, and I jump up in the air, right. When I'm jumping upwards, which direction is my velocity when I'm jumping upwards?
You're just going to go through this actually that you're going downward, even if you're going upward.
No.
That whole mind
When
game is
I'm
not
jumping up, which direction is my velocity?
See, these games don't work with
Oh,
me.
it's a
dude.
simple
I've already
question,
heard it
dude.
from you.
Simple question.
Just
It's a simple question. Just answer the
because
question.
I know your answer, which is you're actually accelerating downward, even though you're going upward.
Correct. So if my velocity is westward, can I accelerate to the east?
Well, you explain how that works, and then explain why pilots are never trained to do that. But pilots are trained to bank left. Pilots are trained to fly over a stationary Earth, which Zanuck and you both have completely acknowledged. They only train over a stationary Earth. They treat the surface as completely stationary. They never have to bank.
I agree.
One way or the other. They don't.
Right.
Yeah,
So
you
that's
agree with that?
why the
Great.
only way to describe it is some kind of Spider-Man Jello attached atmosphere thing. Because
no, not
doesn't
the
actually
atmosphere.
have
We don't even need the atmosphere. We don't even need the
If
atmosphere.
they're moving, Zanuck, with your example
Do
of
it on the
moving
moon.
with it, as if the wind, as if the atmosphere acts like a current of the river, the way you described it. Well, if the plane was always pushed towards the east in that way, and it was supposed to be lining up, if it was clung like with the Jello scenario that Gio brings up, if it was always in that same reference frame, then it would never be able to fly anywhere, right? Because it would always be stuck in that one-to-one relationship with the stationary Earth.
Just with the jumping up and down, do you accept or reject that when you jump up in the air, your velocity is up and your acceleration is down? Do you accept that or reject it?
Real fast, bro. Did you just say that pilots are trained to bank to the left?
Pilots are trained to keep to a ground track.
This is their go-to.
That involves
You
banking
just said
left, and
pilots
that's
are
what they
trained to
will do.
bank to the left. That's what you said.
Yes, pilots can bank left. They
So
are trained to
I could
maneuver
ask
the
about
aircraft.
30 right now, and they would
Say again?
never say that they've been trained to bank to the left consistently because of Earth spin.
No, I didn't
Never,
say that,
ever,
Whitsett.
ever.
I didn't say that. I said pilots are trained to bank left. You deny that pilots are trained to bank left.
Why are
I
they
didn't
trained
say
to bank
Coriolis.
left? Why
To
is
maneuver the
left
fucking airplane,
correct
Whitsett.
Coriolis.
To maneuver the fucking airplane.
Well, why is left
They're trained to maneuver the airplane.
He's not saying it's left or right. He's saying in this case they can bank left. They're trained to bank the airplane to control the airplane and make it go a certain direction.
So they're trained to not bank left. Then
No, they're trained to bank left. They're trained to bank right. They're trained to land, and they're trained to take off. All of those things pilots are trained to do.
Tell me if
Do you
I
agree?
talk to a pilot who's going to bank in one direction the whole
I
flight.
didn't say one direction. Pilots are trained to bank left. Pilots are trained to bank right. Pilots are trained to slow down.
Oh my
Pilots
God,
are trained to
you're basically
speed
saying
up.
nothing at this point.
Pilots are trained to, in emergency procedures, what to do. Pilots trained to land the plane. Pilots trained to take off the plane. Do you
You're not
deny any of
banking
that?
the
So you're
direction
making a
relative to
point that
motion
doesn't
of
really
Earth.
make a point, right? Really?
Correct.
Yeah.
Correct. Thank you, Albo.
This is where the intellectual integrity comes in. They know that the Earth is not moving because they know that pilots wouldn't be trained to fly over a stationary Earth unless it was stationary. They're just here to defend the ridiculous idea that it actually is, and that it would be the same as flying over a stationary Earth, even though they're talking about banking as a way of correcting for this spinning of the Earth, even though the pilots are never trained to do that. So that it's over right there.
Pilots are trained to bank left.
Wait,
Pilots
Ruben,
are trained to bank left. Pilots are trained to bank right.
All right, Ruben.
saying that.
We know
Ruben,
pilots
I think I
bank
know
the
what.
airplane. The
Sorry,
question
Joe.
is, were you trying to use it in a way that it's accounting for the spin of the Earth?
No, not at all.
Yeah, you were.
Not at all.
No, he
I
wasn't.
wasn't.
Why would they be trained to
Can I have a private, like not private, but just kind of a
No, Zanuck,
one-on-one
you've been
with
talking
Ruben for a
nonstop
second?
for
I know, but I have
dude.
one point to make.
No, you
one
don't.
might
You
clear
never
up
have one
everything. Really,
point. You never
it
even
might.
make coherent
Gio, will
points.
you please indulge me for one point that might help everybody understand something? Ruben, I think he's talking about if you're on the edge of a merry-go-round and you have the higher tangential velocity outside the merry-go-round, like on the edge, and you roll a ball to the center. When it hits the center, how does it lose the tangential velocity? And that's again, or going from the lower tangential out to the edge. How does it increase tangential velocity?
You didn't help
That's
anyone
probably the
out at
question
all,
you're
man.
asking.
Can you?
Yeah. No, the question I
That's
really
what
want
you're
to
asking.
ask.
If I have a map,
No, I'm asking why he said in the
roll the
middle
ball.
of an exchange about the plane, accounting for spin, he ends up saying, and I quote, "Pilots are trained to bank to the left."
Yes,
In the
and pilots
context
are
of the
trained to
conversation, it was presented as if a rebuttal that Coriolis or the spin of the Earth is not accounted for.
Incorrect.
as
It
if
was
to
in
say it
response to
is
New
because
Perspective
pilots
saying
bank
pilots are not trained to bank left, and I said yes,
Nope, I
pilots are
never
trained to
said
bank
that.
left. Yes,
No,
you did.
now
That's
you're
exactly
now
what I
you're
was responding
conflating it.
to.
I didn't say pilots weren't trained to bank left. I said pilots aren't trained to correct for the spin of the Earth. If you're
You
headed
did not say that.
south-southwest,
You said bank
of
left.
course I
Anyway,
did.
I
This is
just
my
want
whole
to I just
point.
want to
You
get
act like
this
see how you're trying
single.
to run away now. You're trying to run away
It
because
doesn't
you've been
matter.
caught. You've been
Short
caught.
jump,
Yes,
right?
it does matter because
Wait,
you've been
wait, whatever.
caught.
Just can we
You're
boil it
lying.
down?
Yeah,
Can we
let's
boil it
move
down real
on.
fast or
Boil it
something?
down. If you're headed south-southwest, then they're not trained to catch up to this eastward velocity, which they would never be able to do because they would have to gain 500 miles per hour.
Yep, you've said that
Eastward
1,000
momentum.
times. Right.
Yeah,
I just
that's
want to
exactly
get
what I was saying.
this
Why are you
simple.
saying I'm saying they're not trained to bank left? Of course, they bank left, they
Just
bank right. That's not the point. You're
all right, I
trying to
just want to get this
simplify it to
clear.
some kind of misunderstanding I'm having, which isn't the case, and it's obvious to
Okay.
everyone here.
Okay, I just want to get this clear. When I jump up in the air, my velocity is up, my acceleration is down. Right? If you reject that,
Non-sequitur.
I would love for a flat earther to correct you, and then maybe we'll have a useful
Non-sequitur. I
conversation.
told you the answer to that already. I told you the
You
answer to
denied
that
it, bro.
already. I knew the
Did
answer
you
you were
accept it?
looking for. I said you would accelerate down, even though you're going
Okay.
upwards. It doesn't have anything to do with a plane that's accelerating westward and somehow gaining momentum eastward.
I don't know.
You can't explain
If
how that would be possible.
not accelerating westward, my velocity is westward.
Well, if he's headed west,
can I
he would be
accelerate to
accelerating
the
west.
east? Can I accelerate to the east? If my
That's what you
velocity
have to explain.
if my velocity is west, can I accelerate east?
You tell me, can you? How do you?
Yes.
How do you do that?
Yes, that's why I'm asking you that jumping up in the air question.
Yeah, because you want to take that example